Hi there, welcome to Simplilearn's YouTube channel. Today we bring you Python Full Course, a complete learning program designed to take you from absolute Python basics to advanced real-world programming skills. Python is one of the most popular and versatile programming languages used today. It is widely adopted across domains such as data science, web development, automation, artificial intelligence, testing, and backend systems. What makes Python powerful is its simplicity. Python allows you to focus on solving problems rather than struggling with complex syntax. In this course, we start right from the fundamentals, understanding Python syntax, data types, and control structures, and gradually move into advanced concepts like object-oriented programming, file handling, and real-world applications. You'll learn not just how to write Python code, but how to think logically, structure programs, and solve practical problems using Python. By the end of this course, you'll be confident in writing Python programs, working with data, automating tasks, and building a strong foundation for advanced roles such as data analyst, data scientist, backend developer, or even automation engineer. Having said that, let's take a look at the agendas for today's course. We will be having a total of 12 modules in this full course. We'll start off this course with Module 1, which is Introduction to Python. In this module, we'll understand what Python is, where is it used, and why it's become one of the most popular programming languages across industries. Once we have that foundation, we'll move into Module 2, which is Python Basics. Here we'll learn core concepts such as variables, data types, operators, and basic input-output, which forms the building blocks of any Python program. With the basics in place, we'll transition into Module 3, which is Control Flow Statements. In this module, you'll learn how to control the flow of the program using conditional statements and loops to make your code dynamic and logical. Next, we'll move on to Module 4, Data Structures in Python. Here we'll explore lists, tuples, sets, and dictionaries and understand how to store, organize, and manage data efficiently. Once you're comfortable working with data structures, we'll step into Module 5, which is Functions and Modules. In this module, you'll learn how to write reusable code using functions and how to organize your programs using modules. Building on that, we'll move on to Module 6, which is Object-Oriented Programming or OOP. Here we'll understand concepts like classes, object, inheritance, and polymorphism, which help in building structure and scalable applications. After learning how to design programs, we'll focus on handling errors with Module 7, which is Exception Handling and Debugging. In this module, you'll learn how to identify, handle, and debug errors to make your Python program more readable. Next, we transition into Module 8, which is File Handling. Here you'll learn how to read and write to files and how Python interacts with external data sources. Once file operators are clear, we'll move on to Module 9, which is Working with Libraries and Packages. In this module, you'll understand how to use Python standard library, install external packages, and work with popular libraries used in real projects. With that knowledge, we then move on to Module 10, which is Automation and Scripting. Here you will learn how to automate repetitive tasks, write scripts, and use Python to improve productivity. After that, we bring everything together in Module 11, which is Real-World Python Projects. In this module, you'll apply all your learning to practical projects, strengthening your problem-solving and coding skills. Finally, we conclude the course with Module 12, which is Python Career Readiness. Here we'll focus on interview preparation, best practices, and next career paths, where Python skills are highly in demand. Hope I made myself clear with the agenda. That said, if these are the type of videos you would like to watch, then hit that subscribe button with the bell icon to get notified whenever we host. Also, just so that you know, if you want to upskill yourself, master data science and data analytics skills, and land your dream job to grow your career, and then must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers a variety of masters, certification, and postgraduate programs in collaboration with some of the world's leading universities like Purdue University, IIT Guwahati, and many more. Through our courses, you will gain knowledge and work-ready experience in skills like Python, Tableau, Power BI, Generative AI, and over a dozen others. That's not all, you'll also get an opportunity to work on multiple projects led by industry experts working in top-tier data and product companies. After completion, these courses, thousands of learners have transitioned into data science and data analytic roles as a fresher or moved to a higher paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and in the description box to find a data science and data analytics program that fits your experience and areas of interest. So let's get started with our data science full course with a small quiz. Which of the following best describes the primary goal of a data science? Writing complex code using Python, storing large amounts of data, extracting insight and making predictions from data, creating dashboards only. Please let us know your answer in the comment section below. Now over to our training experts.
Let us try to install Python. So for this tutorial, I'm using Windows as operating system to install Python. Go to the official website of Python and you can see Python downloads will be there. Just click all over here and you will be directed to this URL. Now click on download Python install manager and you can see this is going to get downloaded. After this, click on all over here and let's maximize this. So guys, since I have already installed Python, so it's showing me reinstall Python, but for you, it is going to show install Python. So you have to click all over here. Since I won't be doing it, so I'll be directly launching my Python. Now you can see you're going to get some terminal like this. So you can click on yes and start it. But I won't be doing it because I have already installed Python. And the next step that you need to do is go to your given command prompt. And here you need to type Python-version. And you can see all over here, you're going to get the required Python version. Now guys, I hope so you have got a brief idea like how we have installed Python. Now let us try to run some of the given code in Python. Now for running the given Python code, I would suggest you to install PyCharm, which is an amazing IDE for the Python based projects. So go all over here and type PyCharm download. And this is powered by JetBrains. So all you can do all over here, click on download. So accept all, click on download and it is going to be downloaded for you. Very amazing IDE guys. Do try this out and let us know how do you feel about this IDE in the comment section. Now guys, let us create one folder all over here. Click this folder and let's say it's a Python folder. So Python demo you can type. Okay. Now open this folder and let us try to create one file. Let's go to new and create a file. And you can give this name as a hello.py. Okay. Now open this given file in the terminal. So now guys, after that, you need to type python hello.py. So we have created hello world from the command prompt only. Now just click all over here and you are going to see a hello world written. Now this ensures that you have successfully installed Python and you have tested your first command.
So let's begin. What are tuples? A tuple is a collection of immutable heterogeneous Python objects. So the extra term that comes in case of tuples are that they're immutable. So over here, we have a tuple that's X, and within X, we'll store various elements, 1, 89, a single letter A, which is a string, also a word, which is again a string in Python, hey, O, and B. So as you can see, this tuple here may not be necessarily completely filled with integers, completely filled with floats or strings. It can be a mixture of all of these data elements. So that is one advantage we have when it comes to tuples and lists as compared to arrays. Because with arrays, you can have only one data type elements within it. Now we look at indices. So every element in a tuple takes up a position. And this position is what we refer to as an index. In plural, that's indices. So tuples positioning or the indices for tuples and list strings also in case of Python and most other programming languages starts with 0. So your element 1 is at the 0th position, your element 89 is at the first position, and so on, where B is at the 5th position. So in a way you can say that the length of your tuple x is 6, but then the last index of your tuple x is 5 because it starts from 0 onwards. So now that we have a basic idea of what a tuple is, let's begin with creating tuples. Creating tuples. Now the first thing that we are going to do is we'll create an empty tuple. So say my empty tuple's name is EMP. All you have to do to create an empty tuple is give these curved brackets with no elements inside. So this is a lot like lists, but in case of lists, we had square brackets. In this case, we have curved brackets. So that's the only difference. Now, if I print the type of EMP, you'll see it's of class tuple. I can also print out just EMP. And since EMP is an empty tuple, there's no element within it. But then, of course, the brackets are still printed because that's a list, because that is the basic characteristic of a tuple. So even if it's empty, these brackets would still be existing. So we saw how to create empty tuples, but how often do we actually use empty tuples? So let's put some elements into our tuple. So let's start with creating a tuple with just one element. So say my tuple's name is city and I'll have one element, Pune. If you're creating a tuple with one element, if you're not putting the brackets, it's completely valid as long as you have a comma after that particular element. So with this kind of a syntax, you can create a tuple. So I'll create a tuple, say city, and I'll just have one element within this, which is Pune. Now, if you're not putting this element within these curved brackets, that's very characteristic to tuples. It's completely okay while creating a tuple as long as you have a comma after your element. So although you have no element after this comma, that one single comma is important. So let me run this and just type of city. As you see, city has been stored as a tuple. Now, in the most standard way of creating tuples, you'll say city and within brackets, you'll pass your element. Also print out city after that. And the same syntax can be used. And then you can also combine these both, although that's completely unnecessary effort, but it's possible. It does not result in an error. So you have your brackets and the comma. Works just fine. Now I want to add more elements to city because clearly Pune is not the only city we know. So Pune, Bangalore, these are some of the cities in India if you're from another country and wondering. So after this demo, you not only know tuples, you also know a few cities in another country. So I have 4 elements in this tuple and this is how you create it. All the elements separated by commas and within brackets, print out city. Now I can do the same thing without the brackets too. Just the commas indicate that this is a tuple. Now those are the various ways you can create a tuple. Of course, all these ways do not come handy. Usually you use this method to create a tuple with n number of elements. And when it comes to one element, you usually go for this. Just put one element within the brackets. This is also used sometimes. Now another thing we saw while learning what a tuple is or looking at the definition of a tuple is the word immutable. So we said lists are mutable, which means that they can be changed, and tuples are immutable as in they cannot be changed. So here we'll see a small example as to what the difference between tuples and lists are when it comes to the execution of these both. So say I have a list 1, and that has elements 1, 2, 3, 4. And then I have a tuple, say tuple 1, which has the same elements 1, 2, 3, and 4. Now with list 1, I'll use this method that you probably have encountered before called append. So I say list dot append of 5. So what this function does is it adds 5 at the end of this list, which is list 1. Now we'll print out list 1. Run this code. And as you can see here, 5 has been concatenated to our list 1. Now let's try the very same thing in tuple. So tuple 1 dot append 5, and I'll run this and see you get an error here. So the tuple object has no attribute append. In fact, it has none of the functions which you usually use with lists because these functions aim at changing the original list and not giving back a new list. In tuples case, you cannot change the original list. Once your tuple is set, that is how it's going to be as long as it exists. So that is the main difference between lists and tuples. List is mutable, whereas tuple is immutable. And other than that, of course, you must have noticed the syntactic difference, which is lists are with square brackets, and tuples may or may not use parentheses or the curved brackets. So every time you print out a tuple or you view a tuple, it's always got those brackets. But as you saw while creating a tuple, sometimes a comma is enough. So now let's access these elements in a tuple. If you want to print out the entire tuple, we already saw, just put it in a print statement, put the tuple list, put the tuple name in a print statement, and you'll have your tuple printed. Now, if you want to access some particular element of the tuple, say I want to take out Bangalore. So in that case, we use the indices as we saw earlier. Indices start from 0 and Bangalore is therefore at the first position. So I have to just say city and within square brackets 1. So this particular line or this syntax is exactly the same as you would use for a list or string. Just run that and here we go. We have Bangalore. Now we can also extract elements from the end of the string, just like we did in case of list. So if I do not know the length of the string, now suppose I want to access the very last element of my tuple, but I have no clue as to what the length of my tuple is. In that case, what index do I use? Well, I can just go with -1. Now, every time you give this minus sign, it starts accessing elements from the end of the tuple. So -1 means the first element from the end of the tuple, which is Mumbai. And that's what we got as our output. Now, although lists are immutable, there are a number of operations you can still perform on them. For example, the very first thing we look at is concatenation. So I already have my tuple city. We'll just print it out once again here to see what it consists of. Now we'll create another tuple, say num, and this will have the elements 1, 2, 3, 4. Now sure, I can't modify tuples, but I can definitely concatenate these two. So how do you do that? Extremely simple, city plus num. The plus sign works perfectly fine for concatenation. So I will print this out. And we have an error here. That is because we have not compiled our num list first. So our num list is not existing right now. I ran my line 19. Now I can run the next line. We have one complete list which has all the elements of city followed by the elements of num. Now you can also nest tuples. That is, you can have one tuple within another tuple. So far we have a tuple city and num. Now I will create another tuple. So first, now we already have our tuple city and num. What I'll do is I'll create a new list, say nest. So this is going to be a list. So we have our brackets here. So what I'm going to do is I'm going to create a tuple within another tuple. So we have a new tuple. I'll call it nest. And since this is a tuple, the basic syntax, I'll have the brackets. Now what will be the elements within this? The elements would be my other two tuples, which are city and num. So I put in both my elements here and let's see what nest contains now. So nest is a tuple which itself contains of other tuples which are city and num. So that is how you nest tuples. Extremely simple, isn't it? Now here's something else. Say I want to create a tuple rep which has an element Python, but that element is repeated 5 times. So what you would generally go for is type out Python 5 times. But thank God for Python, there's a much simpler way of doing this. Type in Python once and multiply this 5 times. Let's print out rep now. And as you see here, Python exists within this tuple 5 times. 1, 2, 3, 4, 5. Now maybe this is not how you want to create your tuple. You want your tuple to just have that one element Python initially. But later on, while printing, you decide, you know what? I want Python to be printed 10 times within this tuple. Not a problem. Put your tuple name here and then go for it into 10. And as you see here, the tuple has now 10 elements within it. So guys, remember, when you're putting the statement here, it's not actually modifying the tuple, it's just printing it this way. So if I say rep once again and I run this tuple just has one element. So next we look at slicing in tuples. So we created our tuple num previously. I'll just print that out once again. So it has the elements 1, 2, 3, 4. Now suppose I want all the elements from 2 up till the end of this tuple to be printed. In that case, what I do is I go for slicing where I will mention my beginning and my end index. So my beginning index starting from 2 is of course 1 and my end index is basically the position 4 is at or till the end of this tuple. Now when I want all the elements up till the end, I do not need to mention my end index. It's by default taken so. So if I just say num of 1 up till blank, run this, your tuple sliced, it gives out the elements at the first, second and third position. Considering 0th is our first position, of course. Now you can also print this num tuple in reverse using these indices. So you say num, I leave my start and end index empty, give 2 colons, and then in the end I have -1. So when you put this -1 here, so it basically prints out the reverse of your tuple. Let's check that out. And as you see, your last element is now your first element, and your first element is now your last element. If you have any doubt regarding how slicing works, please check out our video on Python lists. Over there, we have a detailed description on how slicing is, and there will be no confusion since in case of slicing at least, tuples and lists are exactly similar. So let's look at this string that I have here, Simplilearn. Now I want every letter of the string Simplilearn to be an element of a tuple. How do I do this? Well, pass the string as a tuple. So write tuple of, and within this, you have your string, which is again within quotes, right? We'll run this command. And as you see here, every character is now a separate element in a tuple. So this procedure is called unpacking. Now I'll just print out my num tuple once again so we can see what's in it. Okay, so I want to put these elements which are inside a tuple into various variables. Now in this case, I know that my tuple has 4 elements. So I can have 4 variables A, B, C, D, and I'll put this equal to num. Run this and then I'll print out A, B, C and D. So every element of the tuple has gone into one of these variables. The first element went into A, second element into B, and so on. Now what if we had no clue how many elements are there in num? In that case, I could say A, I want my first element to go into my first variable A no matter what. And I want my last element to go into this variable C no matter what. Now all the elements in between, I'm not very concerned about where they go. So in that case, I can have another variable B, but this variable will be a list. So the star indicates that B is a list. And then this is equal to num. We print out A, B and C. So you see what happens here is my first element went into A and my second element went into C because these were clearly indicated. But every other element in between went into my list B. So that is how unpacking works. So since tuples are immutable, it's impossible to delete the elements within it. But that does not mean you cannot delete the tuple entirely. So that is what the del keyword does. We'll implement this. So I'll create a tuple, tuple 1, and put some elements into it, 1, 2, 3, 4. Now I'll use the del keyword. Now I'll just print out this tuple. So we know it exists and what all elements are within it. So great, our tuple is created. It has the elements 1, 2, 3, 4 within it. Now I'll use the del keyword to delete this tuple. So I say del space followed by your tuple name. Run this command. Now let's try printing tuple 1 once again. Of course, since we did it all right, hopefully, this tuple should not exist and this should result in an error. And it is resulting in an error. It says tuple 1 is not defined. So you can completely delete the tuple if not delete elements within the tuple. So as I mentioned previously, most of the methods that you have with lists does not work with tuples because these methods change the original list itself. But there are a few built-in functions which do work with tuples. They return values or new lists and they do not have any impact on the original tuple, so it works just fine. We'll explore some of these built-in functions. I'll continue using the tuple I created before, that's num. So I'll create a new tuple, num1, which has the elements 3, 5, say 4 2s, 6, 5, 8. And now we'll perform our built-in function operations on this num1 tuple. So the first one that we look at is counting the number of occurrences of a particular element. So that is the count function. So you give your tuple name dot count of and the element whose count you wanna know. So I want to know the number of 2s in my tuple num1. Run that. And as you see, there are 4 2s. Now you can also find the sum of all the elements within your tuple. So that is sum of num1. You just have your function sum, pass num1 to it. Now this sum function works for tuples, lists, everything. It's not a function particularly for tuples as such. So the sum of all the elements within a tuple is 35. And in a similar way, you also have the len function, which is in fact even used for strings. So len of num1 gives the number of elements within num1, which is 9. We have 9 elements. But remember, our last index is 8, not 9. Our element is 8 too, coincidentally. Now we have the max function for finding out the maximum number in your tuple. So say max of num1 which is 8. And we also have a function for checking the minimum of the numbers within our tuple, which is 2 in this particular case. So now list and tuple are very similar in the sense of what they hold. So what if I have a list, say LST, which holds the elements 1, 2, 3, 4, and I want to convert this list to a tuple. So we'll see how that is done. First, I stored my list 1, 2, 3, 4. So I'll just check the type of the variable LST, ensure that it's a list, which it is. Now we can convert this to a tuple. So to convert this to a tuple, enter your variable name and then pass your list name within these braces for the method tuple. Run this code and now let's print out TPL, and as you see, our list LST has been converted to a tuple. We can also check its type. So yeah, our conversion has worked out fine. Now this kind of a situation often arises when you put certain elements into a list. So you create a list that you desire and then you realize that you don't want this to be changed at all throughout the program. So then you can convert the list to a tuple. You cannot convert a tuple to a list though. So we previously saw how we can have nested tuples, that is tuples within tuples. Now we can also have tuples within lists. So we'll check that out now. Say I have a list LST. And within this list, I'll define my tuples. So 2 of the elements of my list LST will be separate tuples. I have a tuple 1, 2, 3 and I'll have another tuple as the second element of my list as 4, 5, 6. So I'll run this code, print out LST. So LST is created just fine. It's a list which holds 2 tuples. Now tuples are immutable, but lists are mutable. So we can add as many tuples as we want inside this list. So we can make modifications to the list. So I could say list.append and to this I'll pass another list which has 3 elements. Say tuple inside list. Run this code. Now if I print out list, you'll see that the third tuple has also been added to the list. Now we can also remove tuples from the list. Just use the remove function. So lst.remove and within this I'll pass the list that I want removed, which is my first list in this case. So run that code and print out the value of lst to check what's in it right now. So our first list has been removed. Now we just saw how you can nest tuples within lists. Now we'll check out how we can nest lists within tuples. So I'll create a tuple TPL and within this tuple I'll have 2 elements, each of the elements being a list. So they have A, B, C in my first list and D, E, F in my second list. Run this and print out the value of tuple before we proceed. Yeah, so that's our tuple with 2 elements, each element a list. Now we cannot modify tuples. So initially when we had tuples within lists, we could add more tuples to that particular list. But now we have lists within tuples and we cannot add more elements to this already defined tuple. But what we can do is we can modify the list within the tuples. So I can add elements to the first element and the second element of my object tuple. So I'll try that out. If I say tuple 0.append. So when I say tuple 0, it's accessing the first element of the tuple and the first element of a tuple is a list. So to this I can use the append function and I'll append an element z. Run this code and then check out the elements within tuple. And in the similar manner, we can also remove elements from the list within this tuple. So I can say TPL of 0.remove z and then print out TPL. So you see z has been removed here. Now just for the sake of it, let's see what happens when we try to add another list to this tuple. So I say TPL.append and pass a list x, y, z and then print out TPL. So we get an error because this time our object was a tuple, not a list, and tuples cannot be changed. So with that we saw the many concepts that is used with tuple along with what tuple is. We'll quickly now have a very short exercise where we'll recall some of the concepts that we previously saw in this video. So what is this exercise that we're planning on doing? We'll initially create a tuple which has the digits from 0 up till 9 called tuple 1, and then we'll create another tuple by adding an element to this tuple 1. So we are not adding an element to tuple 1 and modifying the original tuple, but we are creating another tuple using the elements in tuple 1 and adding another to it. Then we'll create a tuple by adding the reverse of tuple 1 to this tuple. So first we have tuple 1 which has all the elements, then tuple 2 which has all the elements of tuple 1 plus another number, and then we have tuple 3 where we have all the elements of tuple 2 plus the reverse of tuple 1. So let's move on back to the Jupyter notebook. I'll create my tuple which is called series 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my first tuple and I'll print this out. So tuples created. Next thing we do is we create a second tuple which is series 1. Now series 1 will have all the elements of series plus another element which is 10. So how can we add another element to a tuple? So how can we add another element to this tuple without manually typing it out? Now, as we saw previously, we can concatenate tuples. So we can say series 1 equal to series, and we'll add the second element as an element of another tuple. So instead of just saying 10, which is not possible because series is a tuple and 10 is an integer, we can say a tuple which just consists of 10. Run this code and print out series 1. So we have successfully been able to add another element to series and create another tuple series 1. Now we have to create a third tuple series 2 which will have all the elements of series 1 plus the reverse of series. So again we are going to use concatenation to bring both these tuples together. Say series 3 equal to series, and of course I can just say series and plus, but just for the sake of recalling once again how slicing works, so I'll put an 11 here, and now to that I'll add the reverse of series and not series 1. So I'll just make this correction in the previous one. It's supposed to be series 1 here and not series. And here I need to reverse it. So as we previously saw, I'll put -1 here and leave the beginning and end indexes empty. Run this and print out series 3. So we have all elements of series plus the 10 which makes up series 1 and then the reverse of series. So here's a very simple statement, x equal to 100. A variable's definition is basically an entity of a program that holds a value. So in this case, x would be our variable and 100 would be the value it holds. To better visualize this statement, let's consider a box. Now if this box holds a value, say 100, then the name we give to this box, which in our case is x, would be the variable name. And 100, that is the content within the box or within the variable, would be the value of the variable. Now this is the basics of what a variable is. As we'll go through the various topics today, you'll have a better understanding of why we use variables and how to use them. So let's move on to the next topic, which is the various data types of variables. Before we move on to this, let me explain to you what data types are. If you have dealt with other programming languages before, you probably already know what data type is. But just in case you haven't, data type is basically the type of value that you assign to the variable. So in our previous example where we said x equal to 100, in layman terms 100 is a number. So the data type would be number. But when we come to programming languages, there are two types of numbers. There are integers and there are floats. Integers are basically numbers without decimal point. Floats are numbers with decimal point. Other than this, a very common data type that we have in Python and other languages is string. So string is any word. In technical terms, we call them a collection of characters. Python also has a few of its own data types, as we will see. So let's move on. So I'll move on to my Jupyter notebook. So the first data type that we'll be looking at is integer. As you saw in our previous example, x equal to 100 is an apt example for this. Let me run this statement. As you can see, there's no error. That means this assignment is proper. Now we'll check the type of this variable. So type, and within bracket, you enter x. Run this. And as you can see, the type is int. So int is the short for integer. Any number without a decimal point comes to int in Python. Now this is not the only way you can assign values to variables. You can also assign values to variables while simultaneously performing arithmetic operations on them. So 654 into 6734, enter. Now let's check out the type of this variable, which would be int again. Now if you print the value of this variable, you'll see that the value x stores is the product of these two numbers. So now let's move on to the next data type, which is float. x equal to 3.14. As you can see, this is a number with a decimal point. If you run this, there won't be any error. So this is a proper assignment statement. You print x and the value is printed. Now you print the type of x, run, and it's float. We'll move on to our next data type, which is strings. So string is any word, it's a collection of characters. So x equal to, and within quotes, so I'll type Simplilearn and run. So no error, print x, and the value of x is printed, which is Simplilearn. So guys, whenever you're assigning strings to a variable, it's important that you do them within quotes. Now you can do them within single or double quotes. I'll show you how it's done within single quotes. And the exact same output. So it does not matter whether you use single or double quotes. Now let's check out the type of this variable. Type x and str, which is a short form for string. So now that we had a look at integers, floats, and strings, let's move on to some of the data types specific to Python. The first one we look at is lists. So a list is basically a collection of values. So far we assigned a single value to a variable. With lists, we can assign multiple values. And this is how it's done. So give the variable name equal to, open square brackets, and within this you type your values. So 14, 67, 9. Run this, no error. Now let's print x and see what this results in. As you see, when you print x, all the values you stored within it is visible. Now let's check out the type of x. And the type is list. Now with list, since there are multiple values stored within a variable, you might be wondering how you can extract a single value. So this is simple. Each value in a list has an index. So you always start with 0. This is the 0th position, first position, second position. So if you want to extract 14, then you type print x0 and that will display 14. If you want to print the last value, print x2 because we start from 0. So this is 1 and this is 2. So that should print 9. Great. Now we'll change the values which are stored within the list. So if I say x2, which right now is 9, but I want to change this to 67. So that is a simple statement how you can do so and run. Now let's see what x holds. So when you just type x, you're printing every value within x. And when you give a particular number within the square brackets with x, you're printing the value at that particular location. So print of x, run. And as you can see here guys, previously x held 14, 67, 9. Now it holds 14, 67 and 67 again because we changed x of 2 to 67. So now that we are done with lists, we'll move on to another data type in Python. This is called tuple. So with tuple 2, it's about the same thing. You can store multiple values in a single variable. The syntax for doing so though is slightly different with tuples. So instead of square brackets, you now have round brackets. And within that, you type in your values. So I'll just put 4, 8, 6. And let's print x. So all the values within x is printed. Now let's check the type of x. And the type gives tuple. So you might be wondering what is the difference between list and tuple. Now the core difference between list and tuple is that tuples are immutable. So what I mean here is that in case of tuples 2, you access each value within it in the same way you do with lists. So if I want to access the value 8 in x right now, I'll just give x within square brackets 1. print this. And it outputs 8. But now, if I want to change this value, so the way of doing that, as we saw with list, is x of 1 and the value I want to change it to. So let's say 5. And I run this, we get an error. So you cannot change the values in case of tuples. Once you have stored the value within the variable for a tuple, it remains that way right till the end. And in technical terms, this means that tuples are immutable, while lists, for which you can change the values, they are mutable. So now we have something slightly different. When we deal with files, we need a variable which points to a particular file. So in general, these are called file pointers. The advantage of having file pointers is that when you need to perform various operations on a file, instead of providing the file's entire path name or the file's name every time, we can just assign it to a particular variable and use the variable instead. So this is exactly the advantage variables have with all other values too, but the syntax for doing so with files is slightly different. So I give x equal to open and within brackets, open quotes, enter your file name. So I want to open, say, a file called variable_com, and this is IPYNB, so it's my Python notebook, and the mode I'd like to open it in, so R. Let me run this. No error, so it's fine. This kind of an assignment is completely legit. Now we'll check the type of x. So as you see here, the type for x is _io.text io wrapper. So in Python, this is the particular type assigned to this variable. But in general terms, you can refer to them as file pointers. Now suppose you want to assign values to multiple variables. What you can do here is, instead of having statements like x equal to 5, enter, y equal to 10, enter, z equal to 7, instead of having 3 such statements, delete, open bracket, x, y, z, within bracket, equal to 5, 10, 7. And this works exactly the same. So now if you print x, y, and z, you'll see that they have been assigned their respective values. Of course, the number of variables and the number of values on either side should match. So if you put x equal to y, so if you give x comma y equal to 5, 10, 7, this would result in an error because you have only 2 variables on your left hand side while you have 3 values on your right hand side. Now suppose you want to assign the same value to multiple variables. In that case, you can do, now suppose you want to assign a value to multiple variables. Say x equal to 1, y equal to 1, z equal to 1. A short form to this, as you saw previously, would be x comma y comma z equal to 1 comma 1 comma 1. But then again, you'll have to type the same value 3 times. Instead, what we can do is x equal to y equal to z equal to 1. And this would work perfectly fine. So if I print the value of x, y, and z now, they all have the value 1 stored within them. So we have covered the various data types in Python and how you can assign values to a variable in multiple ways. We'll next move on to the various rules for naming the variables. Now there are certain rules that you must follow while naming the variables. We'll go through each of these rules, and simultaneously I'll also demonstrate to you in our notebook the validity of each variable. So our first rule is variable name must begin with an alphabet or an underscore. So let's move on to our notebook. So ABC equal to 100. This should be valid because it starts with an alphabet. At the same time, underscore ABC would also be valid. So if the variable starts with an alphabet or an underscore, it's a valid name for the variable. But if we say 3A equal to 10, this would result in an error Of course, because the variable name starts with a number, and this is invalid. Same way, we cannot start the variable name with a special character other than underscore. So if I say @ABC, this would also result in an error. As you see, the error is invalid syntax because that is the invalid syntax for a variable name. Let's now look at the second rule for naming variables. The first character can be followed by alphabets, numbers, or underscore. So our first character must be an alphabet or an underscore. And after this first character, we can have alphabet, we can have numbers, or we can have underscore. So back to our notebook. By the second rule, 100 should be valid as it is. And if we put underscore, which is a valid starting character, 984, so our first character is followed by a letter, 3 digits, and then another underscore. This should also be valid because at the end of the day, it only consists of numbers, letters, and an underscore. However, if our variable name is A9967, few digits, and then a $sign, would this work? Well, no, this would result in an error, invalid syntax, because as already mentioned, for variable names, the only special character you can use is underscore. What about XYZ-2? Again, this would be invalid because it includes a special character that is not underscore, can't assign to operator. Let's have a look at our third rule. Variable names are case sensitive. So what case sensitive means is that small letters and capital letters are treated differently. So let's move back to a notebook and say I assign a value 100 to a variable A100, small a, and I assign another value 200 to a different variable, capital A100. So as you see here, guys, between these two variables, the only difference is that the first variable has a small a and the second variable has a capital A. Let me just execute this. If I print the value of A100 and capital A100, you'll see that both these variables are recognized as completely different variables. They have their individual values. So now that we established that variables are case sensitive, we can also say that Python itself is a case sensitive language. Now a final rule is that reserved words cannot be used as variable names. Now if you have gone through any other languages like C, C++, Java, you know this is a common rule among all of them. You cannot use words which have special meaning to the language as variable names. So some of these words are break, class, try. You have other words such as continue, while, which is a loop, or if, which is a statement, a conditional statement. So let's go back to our notebook and see how assigning values to these reserved words can result in errors. So if I give break equal to 10, that would be an error. Similarly, class equal to 5 would result in an error. Try equal to 100 would also result in an error because these words, break, class, try, have special meaning to Python. And with that, we cover the various rules for naming variables. The next thing we'll check out is the arithmetic operations that you can perform on these variables once you have stored integer values in them. Also perform various arithmetic operations with variables that store integer or float values. So let's have a look at some of these operations that we can perform. We'll start with initializing two variables. So x equal to 20 and y equal to 10. And now we'll perform our operations with these two variables. So first, let's check out how addition works. Result equal to x plus y. So result is a new variable and it should store the value of x plus y. Let's print this out. And as you see, x plus y equal to 30. So now result stores 30. Similarly, we can perform subtraction. We'll print this out too. So 20 minus 10 is 10. We can also perform multiplication. We use asterisk for the multiplication sign. So 20 into 10, that's 200. Next, we'll check out division. So as you can see here, in case of division, the result is not an integer but rather a float. If you want your result in integer, what you can do is instead of putting just one slash, you can apply two slashes. So x / y and print the result. And there you go. Now you have the result in integer. So in this particular case, since 10 completely divides 20, the requirement of the double slash is not very visible. But if we do division for numbers that do not divide each other completely, for example, if we have result equal to 2 by 3 and we print the result, we get 0.66 and so on. But if we give double slash here and run this, we get the result as 0. So in a lot of cases, the result from double slash makes way more sense than from single slash. So this is an extra benefit you have with Python, which is not present in many other languages. We also have the modulus operator here, which gives the remainder rather than the quotient. So if I say x mod y, it'll give me the remainder of the division from x by y. And the remainder is 0 because 10 completely divides 20. On the other hand, if you do want to see the remainder, you can give numbers such as 3 by 3 mod 2 and then print the result. And as you see, the remainder of this operation would be 1. Now, so far we saw arithmetic operations with integers. All these operations can also be performed with floating point numbers. So if your x value is 3.14, and your y value is 5.7, let's just perform one operation using the new values of x and y to see what it looks like. So let's say result equal to x by y, print result, and there's your quotient. So arithmetic operations work both with integers and floating point numbers. Next, let's check out some of the operations you can perform on string variables. As I mentioned earlier, strings are basically a collection of characters. So let's look at a few string operations. First, we'll initialize a string variable. So var equal to Simplilearn. And we'll perform all our operations on this var variable. Now, the first thing we'll do with this string variable is we'll see how we can extract each character in string. So just like in case of list and tuples, every character in your string has an index and it always starts with 0. So the first character is at location 0, second at 1, third at 2 and so on. So if you want to extract the first character of your string, which is s in our case, we just do var of 0. And as you see, s is printed. Similarly, if we want to extract the fifth character of our string, we'll put var of 4. So if you want to extract nth character, your index for it would be n minus 1 because we start our index from 0. And that prints L. So as you can see here, S is 0 and then we have 1, 2, 3, 4 and that is L. So now that we learned how to extract a single character, let's see how we can extract multiple characters from the string. Suppose I want to extract the first 3 characters. In that case, I would say var of the first 3. So my starting character would be at 0. So if I want to extract the first 3 characters of my string, what I'm basically saying is that I want to extract the character at the 0th, first and second position. Then I'd say print of var of starting from the 0th location up to the 3rd location. We say 3 and not 2 because the last index is always excluded. So if I put 2 here instead of 3, then only the 0th and the first character would be printed. So I want my first 3 characters to be printed. So var of 0 to 3. And I'll run this. And as you see, the first 3 characters have been printed, capital S followed by IM. Now if you want to start from your first character, you can also just ignore the 0. So you can say var of :3. That is, we are not typing the 0 in this case. It's automatically understood that you start extracting from the first character when you miss out the 0. So you run this, and as you see, it's the same result. Now, if you want to print the characters starting from the 5th location until the end of the string, you can go with print of var of 5th character, so 5, and up to the end. In this case, you do not need to mention the last index. You can just leave it blank and it's automatically understood that you're printing till the very last character of your string. And as you see, from your 5th index to the very last character has been printed. Now suppose you give var of 0 to 20. And it's pretty obvious that you do not have 20 characters in this particular string. So you do not have 20 indexes. So what do you think would happen if I do 0 to 20? Well, the entire string is printed. So although we have only 11 characters in our string and we have given the ending index as 20, this does not result in an error, just our entire string gets printed. Now if you want to find out the length of your string without actually having to count it manually, you can use the function len of var. Len is an inbuilt function in Python. Now run the command and as you can see, we have 11 characters in our string. So those are the basic operations you can do with a string variable. I hope this is very clear to you, as in the end we have a small quiz which uses some of these concepts. So now that we have gone through the various concepts of variables, let's have a small exercise where we'll be using string variables. So we'll have two strings. One string says it's Sunday and the other stores have a great day. Using only these two strings, we need to build a third string which says it's a great Sunday. So let's have a look at how to do this. We move back to our notebook. The first thing to do is we store our two source strings in separate variables. So let's have variable var1 which stores our first string. It's Sunday. And we have the next variable var2 which stores our second string, have a great day. Now using these two strings, we create our third string which is var3. So first let's run these two statements. So now var3 needs to store it's a great Sunday. The word it's comes from var1. So var1 and it starts at the first location. So 0, which we can ignore because it's automatically assumed to be 0. And we require all the characters in var1 from the 0th position until the position just before our capital S of Sunday. So that would be 0, 1, 2, 3, 4. So our fourth position is the blank space. Since we want to include the blank space too, we give our ending index as 5. Now the next part of our string, it's a great Sunday, needs to include a great from var2. So var2. So the next part of our string is a great, and a great comes from var2. Now this subscript starts from the 5th position in var2. So our starting position would be 5. And at the 12th position in var2, we have the space that comes after great. Now we need to include the space too. So we'll go with our ending index as 13. And finally, our last word of it's a great Sunday, which is Sunday, will come from var1. So var1 and the word Sunday starts from the 5th location in var1. So our starting index here would be 5. And we'll take the entire string from the 5th location. So we leave the ending index empty. And that's it. So let's run this. Now let's just check if what we did so far is correct. So we'll print var3. And yeah, that's perfect. As you can see, we have it's a great Sunday in var3, which is exactly what we wanted. So now a short quiz for you. So if you're familiar with other programming languages, but for those who are completely new to programming languages, definitely try this out. So we have a variable a which holds a value 100, and we'll have another variable b which holds a value 200. Now the task is we want b to hold the value 100 and a to hold the value 200. So basically you're swapping the values between these two variables. So give this a thought and post your answers in the comment section below. We'll give out the answers soon enough. And with that, we come to an end of Python variables. So what are lists? A list is a collection of data, and this data could be of any data type. In fact, a list could hold data of different data types. As we can see in our example down here, we have a list named X, and X holds 1, 89, the single letter A, the string hey, another number 0, and the capital letter B. Now, another important factor with lists are its indices. Every element in the list has a position, and this position is called an index. The first position in a list is always 0. So 1 is at index 0, 89 at index 1, A at index 2, and so on. So this means that the position of your last element would be the length of your list minus 1. So now that you know what a list is, let's move on to how you can create a list. So this is my Jupyter notebook, and we'll start by creating the most basic list, which is an integer list. So my list name would be num, and then open square brackets, and within this, just put in your numbers separated by commas. So that is my first list. Run this, and there seems to be no error. Let's now print this list out just to see what it looks like. And as you can see, the elements that we inserted in this list are printed, which are 1, 2, 3, and 4. Next, let's create a list with just single characters. So my list name is letter, and the syntax is exactly the same. You open square brackets, and now that we have letters inside, which are characters, you type these within quotes. Let's print this too. And once again, after the run, you can see the letters that we inserted into our list letter. Next, let's create a list of strings. So I'll name my list stg, open square braces, and again strings should always be written within double or single quotes. And that's my list of strings. I'll print this too. Great, so now we have created a list of only integers, only letters, and only strings. Now, as I mentioned before, lists can contain a combination of different data types. So let's try that out. I'll name my list mix because it's going to be a mix of numbers, strings, two numbers, and then I'll follow this up with a few strings. And let's run it. So that works perfectly fine. Now lists have another format. If you have worked with any other programming language previously, you would have come across the term matrix. So usually in other programming languages, matrix are associated with arrays. So they are basically 2D arrays. In case of Python's, matrix can also be of lists. So you can have a list containing 2 or more lists. So let's do that. I'll name my list mat, as in short for matrix, open square braces, and since the elements of this list are also lists, put these two in square braces. So our first list would be 1, 2, and then comma, because our second list is basically the second element of our list mat. And our second list would be AB. And that's how you create a list containing lists. So our parent list is mat, and this contains 2 lists. The first list is 1, 2, and the second list is A, B. So let's print this out. And there you go. So we also created a list containing lists. So these are the different type of lists you can create. Next, we'll move on to how you can access the elements within this list. So there's no point of creating a list if you cannot access each individual element within the list. Now here, to understand how to access the elements of the list, We'll be using the list mix that we created previously. So before we start, I'll just print out mix so you can have an idea of what is inside. So we have 5 elements within mix. The first 2 are numbers or integers 1, 6, and that's followed up by 3 strings, Simplilearn, get, certified. We previously saw that every element in the list has an index position. So the simplest way of accessing an individual element in the list is by following the list name with square braces, and within the square braces, mention the index number of the particular element. So if I want to access the element get, my index would be 0, 1, 2, 3. So mix of 3. And I'll run this. We got our element get. Now in a similar way, you can also use negative indices to access the elements. So when you put a negative sign, the indices are basically counted from the back of the list. Now if I want to access the same word get, but all I know about this word's position is that it's the second last word in the list. I also do not know the length of the list. In this case, I can just say mix of -2. So 2 as in it's the second last element, and the minus signifies that you count from the end of the list and not from the beginning. So I'll run this and extracted get. Now as you probably would have noticed, in case of indices when counted from the front of the list, it starts with 0. On the other hand, when you count the indices from the end of the list, it starts with -1 and not 0. So now we saw how you can access a single element from the front of the list and from the back of the list. Now what if you want to access a range of elements? Say I want to extract the first 3 elements of the list mix. In that case, I could just type mix, again square braces, and within here I'll put colons followed by 3. So ideally there would be a number on either side of the colon, but in this case we are taking from the beginning of the list. So if the digit before the colon is supposed to be 0, you can just leave it blank and automatically it's interpreted as 0. Also, we know that our third element would be at the index position 2. But here we have written index position 3. This is because our last index position is always excluded. So if you give 2 instead of 3, then the only elements that would be extracted would be the ones at 0th and 1st position. Since we want the element at the second position too, we give the ending index as 3. So let's print this, and we received our first 3 elements of the list mix, which are 1, 6 and the word Simplilearn. Now what if we want to extract all the elements from a certain position of the list, say our third index position of the list up till the end of the list? In that case, again we have mix, square braces, and we have the same colons as we used previously. But now, since we want our starting index to be 3, we enter 3 and the element at the third index would be included. But now we want to extract all elements till the end of the list. So you can just leave the last position blank. When you do this, it's automatically interpreted that you're taking all the elements up till the end of the list. Let's run this. And we received get and certified. Now I want to extract the words Simplilearn and get from our list mix. In this case, what would be the parameters within our square braces? So Simplilearn is at the index location 2 and get is at the index location 3. So our starting index would be 2, but as we already mentioned previously, if I put 3 as my ending index, I would not receive the element at the index position 3. Therefore, I'll put my ending index as 4 and run this. And there you go. We received our 2 words Simplilearn and get. Now here's something slightly more fun. So what if I want to extract every second element of my list? In that case, I put 2 double colons followed by 2 because I want every second element of my list, and run this. So as you see here, 1 has been printed, which is followed by 6 in our list mix, but 6 is skipped, and then we have Simplilearn. Again, the word get is skipped, and we have certified. Now there's one more thing you can do with list indices. You can print them in the reverse order. So to do that, just 2 colons and -1. Let's print that. And as you can see, your list mix is printed in the reverse order. So now if we go back to line 16, these 2 double colons are basically positions for your indices. So suppose you want the second element from the first index and not the 0th index, you can write 1 here. And if you want every second element from the first index up to say the 5th index, you can put 5 here. But in our case, we do not have a 5th index. So I'll just leave it at this. You can obviously try that out. In fact, we'll be using a variation of this in our exercise later on. So now that we saw how you can access the various elements of the list, let's look at the various operations you can perform on the list. Suppose you want to create a list of 100 zeros. If we go by the traditional methods, we'd literally have to type in 100 zeros separated by commas within the square braces. And this gets very tedious. So a short way of doing this is type in that one element that you want repeated multiple times within your list, and outside the square braces, follow it up with asterisk, digit, and the number of times you want this element to be repeated. So 0 into 100, and let me print this. And as you see, 100 zeros exist within our list Z. Now we can also create a new list concatenating 2 or more lists. So let's create a list concatenating the 2 lists that we previously created, letter and stg. So I'll just print these lists out first. That's our list letter. And that's our list stg. Now we'll create a new list called conc, a short form for concat. And how do you concatenate 2 lists? Well, you just add an addition sign between them. So letter plus stg. And that's all it takes to join 2 lists. Let's print out conc. And there you go. So the first 4 elements in our list conc is from the list letter, and the last 4 elements is from the list stg. Now there's another operation with list called unpacking. So here you basically give a string as an argument to this function list, and that unpacks each element of the string as a separate element in the list. So I'll show you this with an example. If I name my list var and list of within the brackets, I enter the string, I say hey there, and now I'll print var. So as you can see, every letter of this string hey there has become a single element in the list var. Now let's check out another operation on list using the list num that we created previously. So once again, I'll just print num out so we can recall what was within it. We had the 4 numbers 1, 2, 3, 4. Now suppose I want the first element of my list num, which is 1, to be in a variable 1, and I want the rest of the elements to be stored in another list called say others. How do I do this? I can just put 1, which is my first variable, a comma, and then star other equal to num. So what happens here is that the star signifies that every element that has not been put into the previous variable or variables is put into this list other. So let's print out the variable 1 and the list other separately and see what they contain. And as expected, 1 contains the value 1, which is the first element of our list num. And the following elements of our list, which are 2, 3, and 4, are stored in the list other. Let's now look at a few methods specific to list. So for the following few examples, we'll be using the list that we created previously called num. I'll print the list out first. So num has the elements 1, 2, 3, and 4. Now the first method that we'll be using is the append method. And the syntax for that is the list name, which is num.append, followed by brackets. And within these brackets, you basically insert the element that you want to add to the end of your list. So suppose I want my list to be 1, 2, 3, 4, 6. All I do is enter 6 here, and that should ideally add 6 to the end of your list num. So now let's print out num. And there you go. So previously our list contained the numbers 1, 2, 3, 4. And after we executed the num.append method, 6 was added to the end. Now what if we do not want to add a single element to the end of the list, but an entire other list? So in this case, we can use the method extend. The syntax for this is num.extend. And within the brackets, you'll enter the name of the list you want to add to your previous list. So here I want to add the list stg that we created previously to the end of my list num. Now before I execute this command, let me just print out stg so we know what's in there. So within stg I have get certified get ahead. I'll just delete this cell and now I'll run the command. So let's print out num. And as you see, num previously had 1, 2, 3, 4, 6 from here. And then we added get certified get ahead to the end of this list num. Now these kind of additions only take place at the end of the list. What if we want to insert an element somewhere in between the list? For this, we use the method insert. And the syntax is your list name num.insert, and within brackets, you first enter the position or the index at which you want to enter the new element. So I want to insert the string Simplilearn just before get. So this is my 5th position. So my first parameter here would be 5, followed by the element I want to enter, which is a string Simplilearn. So I'll type it within quotes. And let me run that. Let's now see what num looks like. And as you see here, we have 1, 2, 3, 4, 6. And then we have the new element that we just inserted, Simplilearn, followed by the elements which were previously in our stg list alone. Now there's another method you might come across regularly, which is the remove method. So this method, as the name suggests, removes an element. It basically removes the first occurrence of that particular element. So the syntax for this is num.remove. And within the brackets, you enter the element that you want to remove. So I'll remove the element Simplilearn and run. Let's now see what num holds. So as you can see, Simplilearn has been removed. Now, if there were 2 occurrences of Simplilearn, one here and maybe one after ahead, only this word would be removed and not the one later on, because it removes only the first occurrence of that particular word or that particular element. Okay, so now let's create a new list, say var1, and we'll just insert a few letters in here. Now imagine you receive a list like this where there are few elements but in a jumbled order. You want to sort out this list. One simple method, sort, is all you need to do. var.sortof, run it. And now let's print out what var1 holds. So all your elements in var1 are now sorted. Python also provides a few built-in functions that can be used with lists. So we'll have a look at the most basic ones. So before we begin, let's create a list, x, and I'll fill my list with just integers. So that's my list, and we'll use this list throughout all our built-in functions. Now the most basic built-in function and the most commonly used is len. What len does is it tells you the length of your list. So len of x, and the length is 6. Our next built-in function that we'll try out is min. Min gives you basically the minimum of all the elements that's present in your list. So min of x and the minimum element in our list is 4. Similarly, we also have max, which gives you the maximum of the elements present in the list, max of x, which is 90. Now we also have a function sum, which basically gives you the sum of all the elements present in your list. So sum of x, and that's 189. Now in Python, we do not have a function which gives you the average, but it's very simple to calculate this. We do so using the sum function. So you find the sum and then you divide that by the length of the list. So sum of x by length of x would give you the average of x. So with that, we covered the basic built-in functions for Python lists. We also covered the methods in lists, a few operations in lists. We saw how we can access the various elements in list. So for our exercise, we need to create a list of numbers from 1 to 10. We'll call this list 1. And then we'll split list 1 into two lists, odd, which contains all the odd elements of the list 1, and even, which contains all the even elements of list 1. So now let's move on to a Jupyter notebook and see how this is done. So let's first create our list 1, which will contain all the elements from 1 to 10. Now you can use the traditional methods and enter all your numbers from 1 to 10 within these square braces separated by commas. Or we look at a simpler way of doing this. Just say list, and to this you pass the function range, and within range you specify the range of the elements you want within list 1. So I want all the elements from 1 up to 10. So my ending index would be 11 and they are separated by commas. Let's run this and let's print list 1. And there you go. So all your digits from 1 to 10 is stored within list 1. Now the next thing we need to do is, as I mentioned earlier, we need to split list 1 into odd and even. And odd list will contain all the odd elements and even will contain all the even elements. So let's start with odd. So my list name is odd and the elements will be taken from list 1. And now the tricky part, how do we specify the indices in this case? So if you remember previously, we had gone through an example where we want to access every second element, in which case our index was mentioned like this, where the 2 indicated that every second element would be taken from the list. So in this case too, since odd numbers occur after every second element, our interval is still 2, and we'll start from the 0th position of the list, which is 1, and go up till the end. So this is our command. Let's see what odd holds. And as you can see, odd has all the odd numbers from list 1. Now we need to store all the even numbers from list 1 into this list even. Again, our interval would be 2, but this time if we just skip every second element from the beginning, even would have all the odd numbers. So what we do is we'll start skipping the second element from our second element. So from index 1 onwards, we'll start skipping every second element. Let's print out even. And there you go. So our list even has the even numbers 2, 4, 6, 8 and 10.
So the very first notebook talks very basic things about what are variables, how to use them, how to print, how to get an input, okay, and then very basic programming. So I plan to go ahead finishing with the notebook number 1 and the notebook number 2 with all of you. Don't worry, I would be sharing both the notebooks with all of you. So don't worry on that. In fact, I will share my entire drive link with you. Forget 1 or 2 notebooks. I'll share the entire drive link with you. You will have access to all the 6 notebooks, which I plan to do in 3 sessions. So sessions are also very few. No, we just have 3 sessions, 1, 2, and 3. Today 1, tomorrow, and day after tomorrow. So I'm saving on time. Instead of calling everyone on audio and getting introduced, hence we got this Google form filled up, right? So we're trying to actually save time there so that I can devote more time in the teaching learning process, you see, right? So this is another notebook which talks about a few more things and exposes us to a few more types of functions and built-in variables, you see, and it has few more programs here. Okay, now friends, I'll tell you one thing very honestly. It is immaterial whether you program in .NET or in Java. Python programming compared to other languages, trust me, is easier. You see, it is easier. The learning curve of Python is shorter compared to .NET, compared to Java, compared to React. So if any one of you is working in web development or in Java development, you will have a bigger and longer learning curve. Learning curve is here is much shorter, where you very quickly, you yourself will feel that, you will feel that you are with Rocky or with any other good trainer. It just took about 3 to 4 hours and you came in sync. You see, so that is what is going you're going to experience. So that's not because of that we are training you good. The idea is that the language is easy. We know that Python is a high level language, and all programming languages which are high level, it becomes easy for us to code because we code English like, be it Java, be it JavaScript, be it Python. We write English statements. We use English words. So it's a high level language. Of course, the language was created way back in 1980s, but it has become popular in the last 10-15 years a lot, because Python is being heavily used for a lot of machine learning, deep learning, NLP, CV work. So therefore, it's become more popular. There are a lot of IDEs, that means integrated development environments, which we can use for running our Python code. So we can use PyCharm to run our Python code, but I don't advise this, because as you progress ahead, you're not going to do too much of Python coding. You are going to use a lot of Python libraries. So it becomes a little difficult to keep on installing libraries one by one. And tomorrow, if you change your PC, you're working in office, you're working at home, you may be working at at some college or whatever. So then when you change your PC, again, the reinstallation of libraries is required. So you can save your time by using some kind of collab environment like this, where you install it so that it becomes easy, and because you haven't to keep code on one PC. See, in PyCharm or in Visual Studio Code, the code is in my PC. Yes, if you're carrying a dedicated laptop, cool. Then PyCharm and VS Code Editor are very good. No doubt about it. Okay, and if you're doing some confidential work for your company, you're making your own project for your own startup, or maybe for your own proof of concept, then yes, working in PyCharm and VS Code Editor is a good idea, because you don't want to share your code. You have no intentions to share your code with anybody else. Then I think this is a good idea. This is a good one. Okay. Now, for the sake of simplicity, for all learners, at Simplilearn, not restricting to IIT Madras or IIT Bombay or IIT Kanpur batches. No. I'm looking at in generic sense. Across students at Simplilearn globally, we all use Google Colab so that all of us are at the same page to use it. And this is the easiest tool to use. Even for a fresher to actually start who's not been coding at all, this is the easiest tool to take a grip on. Okay. Now, friends, like every programming language, Python programming language also has something called as language constructs. What are they? Literals and variables. Let us say this way. Suppose if I'm asking my friends Harshit and Suresh their names. So how would I say, I would say, okay, myself, Rocky Jagtiani, what's your good name? So when I'm asking you this question, in my mind, there is a variable called name, and my friend Suresh says, Rocky, my name is Suresh. So I'm going to hold his name into his variable, but his name called Suresh is a literal. His enrollment ID at Simplilearn is literal. His age is literal. His years of work experience is literal. So what is a variable? Variable is something which is going to hold. So I can think it this way. If I draw a box in front of you, this box is my variable. Whatever value you write inside the box is my literal. So this becomes the literal, and this placeholder becomes the variable which is holding something for us. Okay, this could hold their age, years of experience, the company for which you work, XYZ. Great. Let's move on next. Data types. Very basic question I'd like to ask all of you friends. Is our age and our name data of the same type? Is our name and our age data of the same type? They are not. Good. Therefore, data types indicate what is the type of data. We all know that if I'm fetching somebody's age and somebody says that Rocky, my age is 25, somebody says my age is 50, cool. So I don't hear anybody saying that my age is 25.37. I've not heard of anybody saying that. Or somebody coming in saying me that, okay, Rocky, my age is 50.13. I'm sorry, I've never heard this. And therefore, when anybody is giving me an age, they don't give me decimal points. They only give me whole numbers. You see, they only give me whole numbers like 25 and 50. And because they only give me whole numbers, 25 and 50, therefore, my data type is int, int. But tomorrow, if I'm trying to ask that when we get paid our salaries and our offices got our taxes, so a tax may not be exactly a whole number. A tax can be 10,050 paisa. Am I right or wrong, my friends? Am I right or wrong? Right? So direction of tax can be a floating point number. Calculation of tax can be a floating point number. Your Uber ride from the place I stay in Bombay to the Bombay International Airport could be costing, let's say, 250 rupees and 50 paisa. It's possible. So your Uber rides can have floating point numbers. In fact, they mostly have. Your tax can have floating point numbers. So when you have floating point numbers like this, that means you use decimal precision. We say our data is either float and the data is in a smaller range, and if the data is of a larger range, we say it's double. But don't worry about in Python. In Python, we don't have float and double stuff. We only have float data type. So float data type itself is very, very vast. And in Python, for God's sake, like people coming from Java and .NET background have a habit of remembering the range of data types. Don't do that ever in Python. Python data type ranges are almost infinity. Trust me. You see? So in Python, without decimal point, int. With decimal point, float. Simple. Two data types. Similarly, whether the data is a single character or the data is a few set of characters, it's immaterial. Both the data for me are string, whether single character or many characters. Immaterial, consider both to me as string. Now, with this very basic knowledge, friends, let me move on to the next thing. Operators indicate the different set of operations you can perform on a data. So when somebody is writing 3 plus 4 into 6, I know you will say that, Rocky sir, it's obvious, 4 into 6 is going to be calculated first because it's been given in the brackets, and then you're going to add 3 to it. I know, but the idea which I'm trying to tell you is not the calculation here. The idea I'm trying to tell you is that the bracket, the multiplication, the addition, all this are simply said operators. So you have literals like 3, 4, and 6. You can place them in any order, right? If I change the position of the literals, I put 3 inside, 4 outside, my calculation will change. Exactly. Obviously. So, or I put the plus inside and multiplication also, my calculation will change. So you can play around with these numbers, that is literals, and these operators to get different answers. Now, question is, how do I run this? How did I get a green tick? Now, there's a play button here. There's one option. Second option, come to the cell, click. And if you're using MacBook, you can use Shift Return. If you're using a Windows-based laptop, then you can use Shift Enter. So when it's a Shift Enter, you can see the cell actually ran. And all these cells are super simple. As you can see, some calculation is happening. and we're getting the answers. Now, you would notice that when an answer leads to a decimal point, you get that right? So this is the floating answer. This is an integer answer. It's very simple. If my answer is having, or my value or number is having no decimal point, it's immaterial whether it's positive or negative. No decimal point, simple. It's integer. Decimal point means it's float. Okay. Now, what is next? Friends, in every programming language, you must have a facility to print your answer, to print your question, and to get the answer from the user. So print is so simple in Python. Print means it is going to print for you. So you can see that I'm printing two values here. And here I am declaring two string variables. The beauty is that in Python, you can declare strings in double quotes. You can declare strings in single quotes. You can also declare strings in triple quotes. We will come to a point where we use triple quotes. I know you will say why we should use triple quotes when we can do things in double quotes and in single quote. Friends, there is a time that you may not have to assign only one or few words, but you want to assign a whole paragraph. If you want to assign a full paragraph, so if you want to assign something like this, follow me along. Okay, how have you been doing? So I ran this code. Now I press an enter here. See the red line that is coming. I'll show you again. No red line coming, huh? That means the declaration is correct. Okay. When I press an enter, I brought it to the next line. How have you been doing? Long time no see. I'm just asking you, saying long time no see. You'll say, Rocket, there seems to be something wrong. Yeah, exactly. There is something wrong, my friend. Therefore, you're seeing the error. No. Otherwise, why all this stuff is coming in red line? Now, see what I'm going to do next. Okay. I am putting triple quotes here. I am putting triple quotes here. Red line gone. Oh, so if you want to assign multiple lines, correct. If you want to assign multiple lines or the whole paragraph, we're just going over multiple lines. Then use triple quotes. Either it can be triple double quotes or it can be triple single quotes. No difference. Both will work. Don't worry. Okay. Now I say run. Oh, green tick. Wow, this ran. So let's see. Okay, before this print, shall I put print B3 also? Let's have a look. So first print B3 prints this entire para. Cool. And the second print statement is printing B1 also and B2 also with a concatenating between. Now, with this print statement B1 and B2 with a concatenating in between, like in many languages, you can concat strings by using plus symbol. Same applies for Python also. It's a way to concat. Concat means join two strings. Okay. Now, very nice thing, sweet thing about Python is if you want to repeat a string, you can multiply it. Strange, huh? Yeah, but this is the way it is. So the variable A above was declared as 3. So when I say B1 into A, you would see that B1 value was Python. So notice that B1 into A has repeated the value of A. If you think you want to remove A, fine, remove A. Okay, remove A. Just keep it as actually A was 7. I'm so sorry, I'm mistaken. I just showed you this. A was 7 actually, because A was redeclared no? As 7. So it was coming in 7. So this is easier to understand. So B1 into 3, I'm repeating for 3 times. So the multiplication operator, you know why I'm putting hashes? This is the way you write comments. So what I showed you right now was multiplication operator. The beauty is that all these operators are so simple. One time you see them, you get them, what they do. Now, printing was throwing output. Natural question which comes to your mind is, Rocky, what is the opposite of it? How do I get input from my user? That is more necessary for me. Exactly. So to get input from a user, you will use the input function. So input function, you are asking me your question, whatever you want to ask here. Please remember this thumb rule. Never forget. I've given a comment here. That's my thumb rule. Input always accepted as a string. Input always accepted as a string means whatever input you give me, look at the way I'm running this code. This input is waiting here. So I say my name is ABC and I press enter. You know what has happened? ABC has gone into the variable name. So wherever I use the variable name, I see ABC coming in the output. You get me? Wherever I use the variable name, I will see ABC coming in the output. So hello ABC, congratulations on your first Python program. You see, right? So you get it. You got the output. Now I'm writing the next piece of program. I want to recall the rule. I hope all of you remember the rule that the input function returns to us a string. You see, whenever I use an input function, it returns to me a string. You see, so when the input function, my friend, returns to me a string, I need that we should appreciate this, that I can't take a string and divide them among each other. Strings are not numbers, no? So to do any mathematical operation, I need numbers. And therefore, an input function is going to be accepting your input as a string. You put the whole input function as a parameter to a typecasting function. This typecasting function here will convert your input into whatever you want. If you say float, he will convert to float. If you say int, he'll convert to int. I have set float. So obviously, this whole input gets converted into a float. And that data is coming into the variable called dividend. The next data is going into the variable called divisor. I'm doing nothing big. I'm just kind of dividing the two and getting my result into the quotient. And then further, I am printing the quotient. And I've given both the options here. Converting to integer will be int, converting to float is a function called float. Now, let us all experience how this code is going to run. Let me run the code for all of us, friends. Let's say 50. And let's say the divisor is 3.5. Cool. So the answer is 50 divided by 3.5 is 14.285, so on and so forth. Now, I would, and I'm not so comfortable seeing the output of quotient coming. Oh my God, so many floating point digits after the decimal. Doesn't make sense, right? Nobody wants such precise answers. It's okay if you give me the answer up to 2-digit precision. So, but natural is that after this normal print statement, you and I may feel, can we round the quotient, right? We should. So we put as rounded quotient is equal to, we use the round function, put the brackets there, comma 2, let me close it, and let's try this, friends. I'll this time give the same inputs like I gave last time, so that we have a quick comparison of our answers. 14.28, and this is like too clumsy to look at, so many digits, and 14.29 looks more decent, easier to comprehend for us. Now, friends, I'm quite confident, and I'm feeling confident of my batch that they would have understood this very simple program. Now let us do one small thing, friends, very, very small thing. Okay. So I would like to first tell you two things. First, how do you use Gemini? Like you can use Copilot. Similarly, you can use Gemini or ChatGPT or Claude for helping you to generate code. That's good. But I always insist people who are learning to program in this language don't immediately get used to using it. When you get stuck, you use. So if you get stuck, how do you use? Directly, you need not go outside to any other tool. From here only, click on generate with AI. See, this is a code block, right? How do you get this code block? You click on code here. You see, if you click on code, you get a code block. Okay. So click on generate. He'll ask you for a prompt. Simple as prompt engineering. You give a prompt, he'll write the code for you. Okay. So let's say I'm writing a prompt here to generate a code for printing 10 prime numbers. Wow, done it. So he says that he has a function called isPrime, which is responsible to check if a number is prime or not. And if it is prime, obviously I'm going to return true. And if it is not prime, I'm going to return false. The function print primes is asking us for a count. If the count is 10, then I will print 10 prime numbers. If the count is 20, but naturally I will print 20 prime numbers, so on and so forth. I've set up a while loop here, which will go on up till the count value, as you can see. Understand the code logically. Don't put too much of stress. If you are new to Python, don't put too much of stress. Oh my God, Rocky, I don't know what is while loop, I don't know what is if. No. So don't take stress, because there are also pre-recorded do-it-yourself videos on Simplilearn's portal, which you need to go through. So you need to always understand the program logically. You see, logically you should be clear of the program, but while loop means I'm going to run that steps for a certain number of times. But I need to check whether my condition is getting satisfied or not. So for that purpose, okay, if structure has been used. You see, so I hope this program is giving you a kind of an idea that generating code is super easy. But the problem is, friends, if you keep generating code like this, then as a senior trainer in this field, I have a fear that when you actually have to code, in front of somebody, you may get stuck actually. You see, so to seek help, don't give him the whole code to code. Okay, later on, yes, but not at this starting phase. Okay, now what I want you to do is two things. First is to use this kind of a prompting. Do not generate 10 prime numbers. You do whatever prompting you want to and get the code here and try running the code. Oh, I didn't try running this code. No, my mistake, my bad. Let me try running the code. Have a look. You can check yourself. 2, 3, 5, 7, 11, 13, 17, and 23. Yeah, this is all prime numbers. Is that correct? Okay, now I'm putting a comment here. And I want all of you to think with patience how you write this kind of code. So I want you to accept different salary components. What could be the salary components looking like? We could have an HRA. Okay, of course, I'm so sorry. We're going to have the basic first, obviously. Okay, first is going to the basic. 30% of basic, let me take it as HRA. Of course, HRA will vary from state to state. Go to 30%, go to 35% also. Vary from state to state. Okay, what other components would you like to suggest me? Come on, come on. Other components, basic, 30% of basic is HRA, of course. PF, 12%. Should I keep 12%? Come on, 12%, 15%, what? 12%, okay. PF 12%, okay. So 12% of basic is PF. One more component, please. One more component, only one more. Be specific, which allowance? Should I keep traveling allowance as 5,000 rupees? Is it okay? Petrol allowance, traveling allowance, 5,000 rupees is fine. Okay, sure. Okay, DA, I forgot DA, right? DA, what percentage should I keep DA? 10%. 5%. Okay, performance allowance. You want me to keep Gurjit performance allowance? Okay, I will. Performance allowance. Actually, it's a variable component. I don't know. What percentage? What, 5%, 6%? What? Tell me, Gurjit, tell me the percentage, please. 5%? Okay. Let me not keep both. I'll keep 6%, Gurjit, because I just want to avoid confusion. This is 5% to 6%. Okay. Right? Now, so friends, you have these details in front of you. Now, what the logic could be? First thing, the logic. Only then code. You're not able to code, I don't have a problem. But if you're not able to think of the logic, I have a problem. Okay? Without logic building, you're going nowhere. Even the prompt engineering tool cannot help you. Because in the prompt, you have tried the logic. So that he gives you the correct program always. Otherwise, he will keep giving you the wrong program, which you will feel is correct. You get me? Right? So what the logic could be? Logic could be accept my basic. Of course, you're going to accept my name also, no? So you'll accept my name and the basic component. Salary we have to calculate. Then the next logic is going to be calculate what? This all what is? Calculate this all. 30% HRA, 30% of basic HRA, 12% of basic PF, 5% of basic DA, 6% of basic performance allowance. So what next? Add up all components, right? Add up all components. That's it. Print final sum. That's my logic. So friends, I want you to think. If I miss some step in the logic, you can please correct me. So my first step is going to be, there is a name and there is a basic. Again, if you notice, see what happened. See what happened in front of you. You say, Rocky, this is helping you. Ah, exactly. This is going to help you. So you haven't to use Copilot or Gemini or ChatGPT or Claude externally. You are having everything here. That's it. You just built the logic. He learned what logic I built. Now he will keep guiding me according to logic. I have no problems. I find this is good. So I say tab. Moment I say tab, he has accepted your name, put into the name variable. Accepted your basic salary, convert to float, you put in the basic variable. Very nice. So remember to type the logic first so that you can get help. And I'll tell you one thing very good. One thing is when you are coding here, Collab Notebooks uses internally Gemini. Gemini learns what kind of coding you're doing. So the more you code yourself here, the more the better the help he can give you because he understands you. You see, right? Okay, Gurjeet, you are asking me that I've taken performance. I've taken every component here as monthly to calculate monthly salary. Okay, at the moment. So name something, basic something, cool. What I want to do now is calculate. You'll say, Rocky, that's simple. Exactly. Where I'm saying this is complex. Did I ever say that? No. So I want to calculate 30%. 30% means 0.3 of what? Obviously, of the basic friends. And okay. So that's your basic here. Now I can do the same logic for Provident Fund. See this? See this? I'll type it again now. See this? What happened? You'll say, wow, this is nice. That is the advantage of having logic above. If I had not typed the logic, then please remember what you see on my screen as a hint would have never come. Now I have to only type tab and he completes the whole thing for me. This is Rocky. This is HRA. This is Provident Fund. This is DA. Okay. And this is performance allowance. Cool. Makes sense to me. So now I have to calculate the total salary. So I say final sal, or if you say no, Rocky, no final, say only salary. Cool. I have no problem. I'll say as you say, sir. So salary is equal to, obviously I need to have basic first, sorry, plus, wow, this is nice. He's having brains, huh? Tab. So I press tab, he comes and brings in everything. Now I would like to run this code, friends. So I say shift enter. See, he's asking me your name. So I'm entering your name as ABCD. He's asking what is the basic salary. So I enter basic salary is, let's say, 1 lakh. Now he says, Rocky, if your salary is 1 lakh, then your take away home or your gross salary should be 1,53,000. With me? So friends, did you learn the way I am coding? I'm not teaching you this program. I'm teaching you the way of coding. I want you to cultivate this habit. In this 3 sessions, you have to cultivate this habit, because we're not going to sit back and code in the class. As the time progresses and as you move ahead with courses which are machine learning, deep learning, Gen AI based, you will have very large programs. So if you code like this, your Gemini in Colab notebook will learn you more and more and more and will help you more and more. Now I'm closing this notebook and I'm going to the next notebook, which is very similar. It's very similar to the next previous notebook. Okay. So there are a lot of examples here. Some examples, of course, I'm going to skip because they are very, very simple. Friends, now if I look at this piece of code, the initial part is very straightforward of what is an integer, what is a float, what is a string, and what are Boolean types. Boolean types means true or false. So I think something which I can, skip, something which I can skip and keep it for all of you to investigate is the first few programs, the first few code snippets. By the way, one small thing, double asterisk in Python means raise to. So this means I am taking this number, raising it to 100. I'm taking this number, raising it to 100. Okay, right? So you'll say, Rocky, this number itself is so big, raising it to 100 is going to be phenomenally big. I told you some time back, friends, never ever bother about data ranges in Python. If you start bothering, you're wasting your time. Don't do that. See the number output I got in Python. See, this is like phenomenal. This seems to be like weird. See this. The number flows unknown. So Python is not going to give you an exception, of a number out of range and all that stuff like Java or JavaScript does. Don't worry about all those things in Python. Okay. So you have these good examples here. Then this is something which I always tell my batchmates to scan it yourself, where you should know that there is something called as a scientific notation to represent numbers, in which we use the term called E. E here means base 10. The term E here means base 10. So something which is a number like 4E2, it actually means 4 into 10 raised to 2. And something like 7.38 E minus 3 corresponds to 7.38 into 10 raised to minus 3. So on and so forth. Right? So I hope I'm not confusing anyone, friends. So this seems to be clear. Now, obviously, you should feel to ask me that, Rocky, when will I do scientific notation? That's a good question. So you should do scientific notation when the number is too big or too small. You see, when the number is too big or too small. So if the number is too big or too small, then the idea is that it's going to be it's good that we use the scientific notation. You see, right? Okay. Now we move further, friends, to look, which I'm giving you the work is to go through all these programs. So in strings, we have all these data members are of type string. I can have single quotes, I can have double quotes, I can have triple quotes. You see, all of them being used for the purpose of holding strings. Idea is very simple. If you have a single line data, you can use double quotes or single quotes. Okay. And if you're going to have multiple line data members, then you should use triple quotes, as you could see here. You see, right? I hope you're able to get this point very clear. Okay. Now we move further. All these are very one-liner programs, which are very similar to what we have done in the previous notebook. This is for practice, which I want you to just go through once and run it. one small thing. A is true, print A, which will actually be holding a data as true or false, and then go ahead printing that. Okay. We move further here. Application of Boolean indicates that when we use Boolean data, we are able to take a decision. So the application of Boolean is to take decisions. So whenever you use relational operator, the outcome is a Boolean data. So if is A equal to B, answer is no. So it printed for me false. Is A less than B? Answer is yes. So it printed true for me. So this true and false can be used for decision making. So you need to have a if-else construct to take a decision. And therefore, the outcome of this relational operator, which can either be true or false, will help if to take a decision. And thereby, a decision that is taken here indicates whether the data is equal or not equal. Okay, right? I hope up till this point, things are going very simple and very clear. Okay, right. So Shuntanu says, under the hood, what is the storage model? Storage models will not be discussed. This is not advanced Python class. And this is not a class for memory storage discussions. This is just 3 classes for getting you acquainted with programming fundamentals. So this will not be discussed. Akash, we have a function called log, which is separate. That doesn't apply here in the e base 2. So this e is not log. This e here is 10 raised to something. When talking of log, there are log to the base 10. There is natural log also. So there's a separate function called log in the math library of Python, which can help you doing that. Okay, right? So friends, I want all of you to take maybe maximum 3 to 5 minutes, not more than that, please. 3 to 4 minutes is good enough, trust me, to quickly run through these sample programs, which I just spoke about right now. Go through this and run them. So let us move ahead at the same speed what we move right now. But this is like too simple, friends. This is just too simple. Okay. The good part about Python, friends, is that Python is a dynamically typed language. Like if you compare with Java, you first have to declare a variable. Also with C or C++, you first declare a variable of a type and then assign value to it. Java is reverse. Sorry, Python is reverse to Java. It's dynamically typed language, which means whatever value you are assigning to me, A says, whatever value you are assigning to me, I will derive my data type. Nice, no? This sounds nice, no? So whatever value you are assigning to me, I'll derive my type. So type A indicates what is the data type of the variable A. Simple as this, right? So if I run this piece of code, I realize that what I'm getting is class float and class int, indicating that in this case, the type is float. In this case, type isn't. This is nice. Wow. Okay. Further, when I take an input, friends, it's immaterial. Whatever you input function will always return data of type integer only. Example, if somebody says that, no, Rocky, I have entered 23 and 67.8, please don't be under the wrong impression. You have not entered integer and float here, because input function by default will accept the input always as a string only. Okay, what you could do is, as an extra work, is find the type of both the variables to prove to yourself. You see, to prove to yourself. Like for example, please have a look what happens now. I'm entering a number 23 and it says that this is a type data string. I enter 45.78. It still says you have entered a string. Obviously, no, I have never converted it. When did I convert my input into an integer or into a float? I didn't do it. So it's going to be string naturally, right? The beauty of strings is they are concatable. So if I have this kind of data, I can actually concat them. Notice this is 23. Concatenated 45.78. right? So concatenation. You can find type like this also. Okay, this is simple concatenation. But if you wish to convert into an integer or a float, you will use a typecasting function, int or float, which you have already learned, my friends. Okay, right? We will discuss, if required, a few programs. Let me talk about one or two so that you can quickly go through them. And then obviously I plan to give you a freshening up break. Okay, because listening to somebody for continuously 1.5 to 2 hours is also difficult. So let me but discuss this. Okay, this first one at least. Okay, so there are some program written here. Find some difference product and true division of two integers. Okay, this is simple. Write a program to find area of a rectangle. Okay, cool. So let's do this. So we are finding area of a rectangle by accepting two inputs, both converted into float, reasons known to all of us friends. Area found, but area could be a very floating point precise number. So I don't want, a lot of digits to be printed here. So the best option is to go by rounding the function. Let's have a look. So 45.67. Okay. Next is 5.77, and it gives me the answer. But if I don't put rounding, then it will give me an answer which is like too heavy in terms of, right? Now, let's look at the next one. Over here, it's a very straightforward program. You have got the two inputs, A and B, and you are performing all the four operations. And in one shot, you are printing all the answers. I know, friends, you may have felt that, Rocky, don't you feel that we should give a choice of the input operation which we should make? I think that makes a lot of sense. So we can definitely add a code here instead of doing all the four operations. Okay, let us do that. Okay, let us say that, okay, we can do all the four operations, but we can also write, we can also add on our own the version 2 of the above code in the same piece. Let all answers get printed. There's no problem. The version 2 of the above code could be that, I could ask my user for an input option. You see, I could ask my user for an input option where we could ask him, option will not be a float, right? So I'll just put it as int only, and I'll say enter an option. See, there can be many permutation combinations for this. We can improve this program and sit for 1 hour and keep improving this. But the whole idea is that in a calculator, you don't do all the four operations. If you are taking two inputs, you always ask the user what choice he wants to have. So we're just trying to make it a little more realistic. So we're asking for an option, and he will enter an option, but he could enter anything, right? So if he is entering an option, oh, what is this? If he's entering an option, oh, this makes sense to me. He found out the whole answer. If I'm entering the option as plus, I'll do this. Else if minus, I'll do this. Else if multiplication, I'll do this. Else if division, I'll do this. But I see one thing is missing. It's not missing. He's leaving it to you. He's leaving it to you because he does not know what is a fail-safe operation. Understand? You have to decide the safety net. How can he decide the safety net for you? So if the option is none of these, then what we'll do is we have to decide. Now, how can he decide for us? So he's not suggesting also. And I think that is a wise decision. He should not suggest. We should do it ourselves. So I should say wrong operator. Okay. Or I can politely say to the person that please check your operator entered. I think that will help the user. Correct. So let us do this once, friends. I run the code. Oh, I forgot to put the colon symbol. See, I made a mistake. Okay. So let us enter some input, 45 and 4. Let's see. First, all answers got printed in front of you, but version 2 is running now. So version 2 is asking, what do you want to do? So let's say I want to do multiplication. and he says answer is multiply this 180. That's right. Okay. So I think this version 2, all of you can dynamically add right now. That's not a big deal. This is just too simple. Okay. So you can run all your code blocks, friends, up till this point. The very basic math module. So the very basic module is called the math module. If I import the math module, I will get all built-in math functions, which one can think and use, like sine, cos, log, various functions. To know how many functions or constants does a module has, you can try using the function called help. So help and math, you'll get the answer. But nowadays, people don't do this. What people do nowadays is straight away take the module name and ask a question on ChatGPT or on Claude or on Gemini, and they get the answer. And this is a trend which I've been noticing in everyone in the last 1 year, and it is absolutely okay. It is fine. No need to do this. Ultimately, you want to know about the module. So either way around, you can know about the module. That's okay, absolutely. Now, there is some small demonstration here of some math functions. So if I want to find factorial of some number, there is no need to write any program. There is a ready function, friends, called factorial. Please notice. Okay. And right, so you can use factorial function. You see? And factorial gives you the answer. So you can see the answer coming up here. Rounding is being done. You get the round answer. Seal means, let's say you're standing on, wherever you are right now. Let's say you stand up. So the floor you stand and there is a ceiling above you. So ceiling means I can't go above it, right? So if you write a number here, ceiling will take you to the next highest integer number, 5.001. The next highest integer is 6. Right? So math.seal, you get the answer as 6. And math.floor, you get the answer as 7. So I hope you kind of get this. It's very simple. And it's clear that seal is going to take you to the next integer, and floor will take you to the next lower integer. At a very basic level, we have now a decent knowledge of how we can print, how we can accept input, what are the different data types available in Python. And of course, we know a bit of math functions also. The idea is that, you see, I can go to the next notebook also, but the idea is not that. The idea is that you should be able to build on some logic and do some very basic coding yourself without the help of ChatGPT, without the help of any GenAI tool. Doing it yourself is also fun. Okay, so what is my requirement now? Let's think about it. Friends, we all know that there is a process of login in every application. And in login process, the login process requires one to verify their username and password. Am I correct or wrong, friends? I hope I'm correct, right? It requires to log in, verify your username and password. That's a login process. So verify username and password. So my requirement goes something like this. So sorry. My requirement goes something like this, that I want to accept the username. Okay, username can be small or big, that I can't control. User has a choice to choose his username. Okay. Similarly, we will accept the password also from the user. But friends, in password, you can put limitations and restrictions on the minimum size of it, right? So we want a minimum of a minimum length, you see, of the password to what? Let's choose what should we keep it, 8 or 9? Come on, you choose 7, 8, 9, 10. What do you want? You choose. Okay. Yes, 8. Okay, 8. Fine. So minimum length we want is 8, And should we keep some more constraint like alphanumeric? Come on, take a call. Should we get alphanumeric? It's fun, no? Yeah, we should, right? Okay. So password should be alpha numeric. Okay. And it should have, see, it can be at least one or it should be exactly one. Now, this is a call which we can take. So we'll keep at least one special character. Okay. Oh, spelling mistake, sorry. Right. So this is what the requirement is. If it is success, so if username, logical and password, you see, if username and password, both. Now, when you say Rocky, how do you say if username and password both are matching? Correct, you are correct. Now, how do I say if username and password both are matching? So what we can do is, before the login process, we can tell the user to register, and in registration, we will obviously accept the username, accept the password, you see, with the following constraints, which we have already discussed. There is no need to rediscuss it. So this is sorted. And during the login process, we will verify if username and password both are validated. So validation is different. Now, validation means the above steps. Validation means above, that it should alphanumeric and all that stuff. If username both are validated, then verify with the register details. Registration was done once, no? Registration will be done once at the start. And then you always compare with the registration. So there is difference between validation and verification, my friends. Validation means that there are some thumb rules or some input rules of your system. Example, password should have minimum length of 8 characters is validation, not verification. Verification would be that what password you have entered during the process of registration, I like to verify against that. Okay, so username and password both are validated, then verify with the registration details. In this case, any one condition can be true. That means, let's say you can log in or get an OTP either through a mobile number or through an email ID. I'm just giving a situation. You see, I'm highlighting this a greater than 0, but I'm giving you a practical situation. So let's say you want to get an OTP off on a website. The website says enter your email or mobile number. So either this or this. Anyone should work. If anyone works, great. You can log in. Not is actually to reverse things. That's it. Okay. Now, operator precedence is something you really haven't to study or remember, but because you're not supposed to go and give a theoretical exam here, but then, okay, you should be aware about it at least, that there are precedences in operators. In operator, we have a precedence which we called as PEMDAS. Look at the rule, PEMDAS, DAS, PEMDAS, where P stands for parenthesis, E stands for exponent, M stands for multiplication, D for division, either whichever division, A for addition, S for subtraction. That means in an expression, when all these things are given together, what is going to first work is what is given inside the brackets. You see, what's given inside the brackets is going to work first. Okay, so in this entire expression, first this bracket is going to get performed, right? After this bracket gets performed, then you will, actually, now if you notice over here, I don't see the comparison operator anywhere. Please notice, I don't see the comparison operator anywhere. That means comparison operator is going to be even after this. So after 4 divided by 2, I'm going to add 1 to it. Then I'm going to compare with greater than 2 or not. You see, same applies here. First, I will do 4 raised to 2, which is going to be 8. Then I will check is 3 greater than 8 or not. Okay, so the first answer is false. Second answer is true. False and true is obviously false. So when you solve a problem, you haven't to do that, friends. But then idea is if you solve the problem in your mind, then applying PEMDAS rule will help you to know how the expression is evaluating. One very simple thing, when you use comparison operator in Python, remember whether a number is an integer or is a float. Fundamentally, it is comparing a number to a number. So don't worry about the fact that I'm putting 3 here, I'm putting 3.0 here. So Rocky, this is not same. How I'm getting true? I appreciate, friends, this is Java or maybe C or C++. I'm assuming that you may not get true there, but in Python, you do get true. Because Python says both are fundamentally number data types to me. So he understands that both mean the same thing. No wonder I get the answer as true. Next, this is a very interesting operator, friends, called membership operator. It is used to check, is the left entity present in the right data? I repeat, is the left entity present in the right data? If it is yes, I'll get the answer as true. You'll say, Rocky, P is there in Python. There's capital P, there's a small p. Tomorrow, if you write capital P here, then you will definitely get yes. I'm going to say true. Similarly here, I'm trying to check whether 5 exists in this list of numbers, and it does. So I get the answer as true. I know in your minds, you will be wondering what is the use of this. Okay, imagine I have names of 5 people like Rocky, Chandra, Prabhu, so on and so forth. And I want to check is, let's say somebody called Seema, is she there in this list of people? If she's there, I'll get the answer as true. And if not, I'll get the answer as false. Simple, right? Okay, this is very simple. Augmented assignment operator means you're doing kind of a shorthand trick here. So initially A is 1, you're saying A plus equal to 1, A plus equal to 1, where A plus equal to 1 means you are incrementing A by 1, which gives you the answer, as you can see, as 2. Okay, similar examples here for other operators. Okay, now this is using the math library, which you saw yesterday also. Forget the practice problems, please. So, you can skip after this. Yeah, as a homework, you may go through. I'm not denying it. Like, for example, this is a nice program where I'm expecting you to accept your name, age, gender, occupation, your weight in kgs, and your height in inches. And I want you to calculate the BMI. Right? So the formula for BMI is, I'll take the weight divided by the height. Now, because friends, the height is given in centimeters. So I have to convert it into meters now. That's the formula, right? You divide the weight by height in meters. So I'm accepting your height in centimeters and I'm going to divide it into meters. And then I have to raise it to 2. So this is going to be like height in meters square. So weight divided by height in meters, the whole square. So I get the value of BMI. You see, somebody's data has been entered and I got the answer as this. Okay, now don't get confused here and don't take too much of stress. I've done all permutation combinations of all these operators. You may feel to ask me that, Rocky, why false or 1 is false? Please don't get into it. You will be wasting your time. Okay, so because you're not, please understand, friends, your objective is not to go ahead compete with an interpreter of Python. If you're a fresher and you think that you're giving a competitive exam that also based in Python somewhere, which is very rare, and then you need to go in with this kind of, so that's a different issue. Python certification exams have these kind of questions coming in, but not otherwise. No company is going to ask you these questions. But I've kept it here for the heavily inquisitive mind that, okay, can I do this? Can I do that? So I've kept it here. You see, so that, okay, they are relaxed. Okay, this is possible. By the way, I'll give you one simple trick. Friends, whenever there is an OR operator, please remember OR operator locates what is true. So whether I have a true on the left or on the right, OR will look at that. So if I look at 1 or false, I'll get the answer as 1. So Rocky, how 1? Why not true? Because understand, friends, OR operator does not goes for false at all. So if he does not go for false at all, then he has no option. You understand, he has no option. He has only one option to look at 1. So he takes up the value which is non-false. The non-false value can be 1 also, 10 also. If I put 10, I'll get the output as 10. 20, I get the output as 20. You see, so this is the whole idea. Okay, right? So friends, now I think I promised you 10-12 minutes. I took that time. I'm ready to give you 5-6 minutes. Kindly please go through the code block, whatever you find interesting. Some of you may find the PEMDAS rule interesting. Some of you may find the membership operator interesting. You see, so whatever you found something which you never knew about, you spend more time on that. Something which you already know, why you want to waste time there, right? So take 6 or 7 minutes, scan this node. If you wish to run all the cells in one shot, you can do it, friends. See this runtime here. Click on runtime, say run all cells will run in one go. Right, friends? So I hope you have gone through. Don't get into the trap of, I can give you maybe 15 more such combinations, which probably are a little trickier to, think about it. But please understand, you're not competing here with the Python interpreter, point number one, at least as a part of this course of where you're talking about Gen AI based applications. And you're not looking at a Python certification program. If this is a Python certification course, for example, there are some institutions at international level which conduct Python certification exams. Then they ask 1 or 2 questions of this kind. Okay, otherwise this is of no use, trust me. In machine learning, generative AI field of programming, this is of no use. Okay, but just to answer you, quickly on a few questions over here. So, see, get this idea very clear, friends. Whenever you have an OR operator, the OR operator always tries to pick an answer which is not false. But the problem is that 0 is also considered as false. Now, because 0 is false, so OR operator does not evaluates. So when you get an answer of 0 or false with false, I want you to self-realize this. Instead of somebody coming and telling you, as I told you, friends, there can be 15, 20, 30 more such combinations. How many will you keep remembering? So what is more important is self-realization that, okay, my trainer told me that whenever it's an OR operator, it tries to pick up a non-zero data, a non-false data, but 0 is false. Correct. So because 0 is false, the OR operator short circuits and does not checks what is ahead and simply picks up blindly what is ahead of it and throws in the output. This is what is done. Therefore, you see the output is false. You see, right? One way of thinking. Another way of thinking is this way. Rocky, 0 is false. False is also false. False with false obviously will be false naturally. So it is on you how you interpret it. Okay, right? So this is the way you need to think and introspect about it. Now, when you say this is string, you say C is a string. C must have a value, no? C must have a value, right? So C has a value like 0 and A has a value like 1, 0. So think about it, friends. If somebody is writing data like this in front of you and I'm writing like this, think about it. And if I'm asking you in very humble words, that is 0 contained in this string of characters, you will naturally say yes. How can you say no? 0 is contained in this character set 1, 0. You'll say, yeah, Rocky, it's yes, exactly. And therefore, I repeat, therefore, you see the answer coming up as 1. Okay, I'm to say true. Okay, right? So this is the answer. Like this, if you start interpreting every example, you would realize that, okay, but you need to have patience. You cannot do everything on earth in this 5 or 6 minutes which I gave you. This needs more patient interpretation. Okay, I think I gave you enough inputs that this needs to be interpreted with patience. Okay, so with OR, it's short circuiting. With AND, the entire funda is that if one of the input is false, it's immaterial. What the other input is, output is going to be false. Simple. Okay, right? So I think, can we move further from this notebook? Is this going good? At least the question which you have asked on the prompt, I think I've been able to answer them. But again, I'm telling you with my experience that this is not the end of your questions. If you start introspecting this more and more, you will have 5 more questions coming in. You see, but you need to just get the very basic rules which I just mentioned to you clear, and don't compete with the Python interpreter. It's of no use. Don't get into that circuit. You see, try to visualize with an example. Is it doing it or not? You see, so that I just explained right now that there are 2 ways of interpreting it. So 0 or false. 0 is also false. So false and false is always false. So answer is coming as false. You see, the one way of interpreting that way. Second way of interpreting is this way, that if my first input is false, you see, OR is going to short circuit. He's not going to bother what is ahead of it. He will just throw whatever is given here. Both the ways of interpreting is correct. You see, it depends on what you get accustomed with and interpret that way. Okay. Both the ways you will see the answer coming the same. Friends, whenever you write a program, the natural flow of the program is always sequential. You see, the natural flow of the program is always sequential. It goes one after the other, step A, then B, then C. But there are points of time it doesn't make sense. When I need to take a decision, should I execute the code block 2 or 3? So I can put that code block in an if else statement. That's decision control. At times I need to put a code block to repeat it for a certain number of times, let's say 5 times or 10 times. That's called as iterative control structure. Okay, so let's see this. Now, this is very simple. This is a sequential flow or flow of program. If I want to that the step C1 is getting, the value C1 is getting printed, I'm obviously making a reasonable assumption that all the steps up till C1 have got properly interpreted and executed by the Python interpreter. You see, I make the reasonable assumption. Obviously, friends, if any of these steps had an error, then I would not have reached and wouldn't have been able to print C1, right? This is sequential flow of my program. So in decision control structures, for all my beginner programmers, please understand this very carefully. And for people who have been programming, of course, this will be boring for you, but be here for a few minutes till we get into programming. So in my normal flow, I'll check with the condition. If the condition is true, I'll execute the part of the if block. But if my condition is false, I'm going to execute the part after the conditional block. Now, there are different types of conditional statements. I can have simple if statement. I can have an if else statement. I can have many if else statements nested inside each other. And I can also have if else statement. This basically, means that I'm looking at multiple ladder of if else conditions. Sometimes, friends, what you can do by this or what you can do by this, you can very easily, more neatly do it by something called as conditional expressions or ternary operator. This is very interesting. You will see this, you will feel fascinated. Oh, this is so nice. So for first time programmers, they will feel that Rocky, instead of doing step 3 or 4, styling, you find this is better. Many people find this is better, to be very honest. But some people find this very confusing also. So, it's person to person, but nevertheless, the effect is going to be the same. Whether I use 3 or 4 or 5, I can achieve the same, end target. Okay, look at the syntax. If you're going to put your condition here, put a pair of, put a colon over here, write as many statements as you want to, which is going to be part of the if block. Friends, in Python from yesterday, you would have noticed there is no concept of opening bracket and closing bracket. You see, Python works on the basis of indentation, where indentation means that you are having, I repeat, where indentation means you are having a certain left margin. So all these statements which are having the same left margin are put into, the block called if. Similarly, the statement X, which is not following the same indentation, but rather following a different indentation, is actually considered to be out of the if block. Have a look here. Now, I have assigned a variable A as -3. I am trying to check that is it greater than 0. Fact is, it is not. And therefore, these two statements will not get printed. So I'll not enter the if block, friends. I'm going to just print this statement. This statement is what? Else part? No. This statement is simply written outside the if block. So I say this is the if block. What I'm highlighting is the if block. And this is the part which is coming normally after the if block. Simple. Okay. Now, let's take a very simple example. You see, write a program to prompt user to enter their name, age, and amount to be paid by them. I'm going to ask you to modify this program and make it a little better. So first listen to me in terms of what we have coded, and then I'll give you some comments to improve. I've accepted 3 inputs here. Friends, a very quick question. May I know what is this int function and this float function doing here, please? Think and please answer. What is this int and float doing outside the outside the input function? Converting, typecasting. That's awesome, my class. You guys are Avengers. Before I could complete the question, you started answering. Prabhu, Chandra, and Balaji, Akash. Wow, that's very fast. Typecasting, you're right. So you're typecasting, you're converting the input taken by the input function, which is a string form, into the respective format, could be float or int or anything else. Okay. I'm trying to check if the age is above 55. If it is, I think I'm giving a 10% discount in your overall amount. But if the age is less than 55, then there is no discount. You pay the whole amount as is. Okay. Now, instead of we taking the discount coupon only on the basis of age, I want you to look at this as well. Let this code remain as is. Let this code remain as is. I have no problems. But I want one more condition to be, taken into regard, is this, that if your build amount is greater than 2000 and logical and, okay, I know I have only taken the name, age, and the build amount. I have not taken something like a discount voucher, but I am assuming that we will ask the user that, do you have a discount voucher as happy 10? So if you have a discount voucher called happy 10, or rather I should say, we will ask him a discount voucher code, and if it is equal to happy 10, then I want you to give him a 10% discount. So I hope you're able to connect the dots. If your build amount is more than 2000, okay, right, and the discount voucher code is happy 10, then you need to give 10% discount. You'll say, okay, will you modify this code? No. Why do you want to modify code? Let the code be there. No, let that code be there. You write your own code here below. You see, don't worry about it. No, there is no harm. ABC, name, age 56, build amount 2000, you become 1800. It's okay. Again, we'll print. What is the problem? We'll print all this factors again. Why to worry about it? So enter your build amount. Build amount is already accepted now. If it is more than 2000, I've written now. So if it is 2000, I'm not going to accept. It should be more than 2000. Okay. So if it's more than 2000, you'll get the first discount also, and you'll get the second discount also. You get me? Everyone is getting me on this, right? So come on, go ahead, friends. Try adding up this much part to the code. I think you should take about 4 minutes to scan the above part and think how to code this part. Friends, I'm moving ahead now. So the way we did with if, we can obviously have a similar condition called if else, where if else basically means that you will check for a condition. If it is satisfied, I will run the if block. And if the condition is not satisfied, I will move to the else and run the else part. After the if else block, I naturally have a statement for regular execution. You see, I naturally have a statement for regular execution. Now, what is next? So what I see here, friends, is that if my number is divisible by 2, obviously then it's an even number, else it's a odd number. Now let's look at, okay, this is not needed to do any introspection. This is just the same program. After collecting some details, The same program is written with an if-else structure that if the person's age is above 55, you give him 10% discount. But if he is not above 55, then you go to the else part and simply tell him to pay the entire bill. You see? And this is the next thing. Another example of finding which number is greater. So if A is greater than B, then I will print A greater than B. Else I would print B greater than A. Okay, right? This is simple, right? Now, this is a very interesting piece of code, and I'm trying to use a module called random, my friends. So I'm importing the module called random as any variable R. By the way, you can put any variable here. You can even put your name here. You see, you can put Rocky here, or you can put your name here. So importing random as R, wherever, suppose if I put instead of R, I put over here ABC, then I'll have to use ABC whenever I'm calling any method of random. I'll have to put ABC if I'm calling any method of random. Okay, so let's see. So R dot random integer 1, 5. This means I'm producing a random number in the range 1 to 5. You see, and I'm bringing that number into R_num. So I'm trying to build a very simple game where I'm telling the computer to choose a random number. Understand? I'm telling the computer, see, when I run this code, it's obvious when I run this code, my computer is choosing a random number. I do not know what number is come in R_num. Please understand, I do not know what number has come in R_num. And I'm asking the user, can you guess that number? It's a guessing game. I'm asking the user to guess that number, like gambling guessing game. So user is going to give me a choice. I'll take it in num. Therefore, I'm asking the user to enter a choice. Let's say I enter 3. He says, Rocky, better luck next time. The computer's choice was 4. Game is over. Thank you for playing. I tell, okay, this is fun. So whatever number I enter comes into num. If my num is equal to R_num, I will get printed as you win. Else I'm going to get better luck next time. Computer's choice was so and so. Let me run the code once again. Let me see if I'm lucky this time. I'll choose 5. Oh my God. He says, better luck next time. Computer's choice was 1. Game over. This is called as format printing. Now, this format printing over here indicates that in this entire statement, I'm going to use a placeholder or a variable for which I need the value. You see, so in a normally we in double quotes, like what we do. In double quotes, we usually just put a string, right? We don't put variables in it, right? So along with the string, if you are having a variable or a placeholder also, which or whose value you wish to derive, you see, whose value you wish to derive, then we need to put an F over here, which means format specifier. Okay, you are getting me on this, right, Nagdeep? Hope this is getting clear. Yep, thank you. Great, friends. So let's move further. So friends, we are going into if-else structure now, where we're looking at nested if-else, by the way. So if there is an if condition, this is considered as a true block over here. And in this true block, we have an if part and we have an else part. You get me, right? We have an if part and we have an else part. Okay. So please get this very clear. If the if condition, the outer if block, you see the outer if block condition goes true, then this entire part runs. If the outer if condition fails, then the else part's complete part runs. Okay, right? Yeah. So by the way, Nagdeep, your query is very appropriate. Format specifiers like %d for integer, %f for float, percentage s for string are also available to you in Python. You see? So they are available. So this is an easier way of doing things in Python. Yeah, so they're also available. And they also can be used. And you will see programs coming ahead where I've used them as well. Okay, so don't need to worry about it. Great. So this is a very simple program, friends, in which I'm trying to find the greatest of the three numbers. How are we going about? So I've got three numbers over here, that is A, B, and C. If A greater than B, if this condition is true, then I get into my inner if block. You get me? If condition is true, then I'm getting into my inner if block. So if this condition is true, then this part of my code executes. Else, if A is not greater than B, please get this. Else if A is not greater than B, this part will get skipped and I'll come to the else part and this part of the code will get executed. Okay. Now friends, I hold on this and I'm asking you, I want you to answer. Here also I've done the similar way of coding. How is this piece of code different from the above piece of code? How is this piece of code which I'm highlighting on my screen different from objective is same? Here also I'm finding the largest of all the numbers. How is that this different from this piece of code? What difference do you find in both? I want your theoretical answer. Very nice. Very nice, my class. In the first case, we all are using nested if else, while in this case over here, we're using a ladder of if else. And because we're using a ladder of if else, we would definitely need some operators like an AND operator or operator. So this is an AND or operator. Okay, right? Right. So you get me on this, everyone? Perfect. So I'm holding on this. I want you to execute up till task 5. You'll say, Rocky, task 5 is something which no, sorry, not task 5. So sorry. Task 4. Task 4 is this. Nested if else and this one. So execute all your programs up till finding largest of three numbers using logical operators up till this point. Perfect. Now let's see this. Let's make a program a little better. Last time we gave only one turn. This time we are giving two turns. You get me? Last time we gave only one turn, right? This time we're giving two turns. So let's have a look at this. So what I see here is import random. I'm generating a random number. Let the system get the random number. So this is a computer generated number which I'm supposed to guess. So the first guess here is the first chance computer is giving me to guess. I will check. In the first guess, if you go correct, you win. Else, the computer is giving me another chance to guess. That means my first guess was wrong. So obviously I won't get the first guess again. So I get the second chance. I'll check. If it's still there, you win. Else, it's that I have lost the game because I've got two chances and whatever is the correct answer. Let's try doing this. Let's see. So I've entered 4. Oh my God. So 4 didn't work. That means the number of the computer and my guess were different. Now I'll give 5. Oh my God. So you lose. The correct answer was 2. Game over. Thank you for playing. So this program is, trying to use if else in a smart way so that I can give 2 guesses to my user. Okay. Now, this is of course very clear, friends, that in if else ladder, you can have many conditions given. A very simple example is calculating a grade where I'm asking the student to enter his marks. I'm trying to check if his marks is greater than 90. I print grade A. Else if the marks is greater than 75, I print grade B. L60 grade C. 45 grade D, so on and so forth. You see, so on and so forth. So enter the marks of the student. Let's say the student got 98 marks. This is grade A. Next case, the student got 70 marks. That's grade C, right? So I hope you're getting this. It's very simple. This is a fun-loving example. The whole idea is that if the number is divisible by 3 and 5 both, you will print fizz buzz. If the number is divisible by only 3 and not 5, only 3 and not 5. An example could be 12. 12 divisible by only 3 but not by 5. I'll print fizz. Similarly, there are more conditions also given. And if none of these conditions are satisfied, do nothing, just print the number as is. Okay. So friends, instead of assuming a fixed number, I would suggest that you should modify this code where you will accept the number from the user and then start applying these conditions according to the rules that is given here. The same program of fizzbuzz written here has been rewritten here, but this program looks a little more neater because instead of nested if else, I have used if elif else ladder. Whenever you use a ladder, remember the program will look a little more neater. You see, nested will look a little more clumsy. Okay, so all the three programs are doing the same work. Oh, I have already done that over here. I have only accepted the input from the user, made it into an integer, and program it accordingly. Okay, right. I hope all of you are getting clear up till this point. Now I'm going to give you complete 3 to 4 minutes. Please take your time and run off all these codes by assuming different numbers here according to the condition that I mentioned here. You see? Okay. Shutanu says, is there a case construct in Python? No, there is not. I'm talking of switch cases construct the way it is in C, C++ and Java. No, it is not. What are the best practice in Python for deep if-else branching is to use if-else-if ladder. Or we go in for Pythonic way of coding, where a Pythonic way of coding is very similar to, it's not exactly same, but it's very similar to ternary operator or conditional operator coding. Move ahead into the next program. Next program is very simple and nice, no? Makes sense to us. So it says write a program to check if an employee is eligible for an appraisal and hike or not based on their total work experience. Point number 1, based on their total work experience and experience in current organization. You see, and experience in current organization. Okay. So I notice, look at the flow here. So enter your work experience in current organization in months. So whatever work experience you are entering in the current organization in months will be accepted because the input is going to be accepted always as string. So I'm converting it into an integer and bringing it into this variable. Friends, if the current experience is greater than 12, that means more than 12 months, then he's eligible for appraisal and hike. What you're doing next is enter your work-ex before joining this organization in months. Now you'll say, okay, well, I'll come to the else part. Exactly. So if the person has worked for less than 12 months, that means the person is just recently joined. So if will fail, I'll come to the else part. So I'm asking him, what has been your work-ex before joining this organization? Okay, maybe before joining your organization, his work-ex is, let's say, 3 years. So in months, it's going to be 36 months. So I will capture that into this variable. If 36 months is greater than 0, which is the case, then we would print appraisal and default hike. You see, we would print appraisal and default hike. Else, you print appraisal and no hike for freshers. So I think this makes sense. So if the person is working with your organization for a longer time, then obviously you would print this. Else, if the person is experienced in the previous organization, then he becomes a lateral hire, so you still give him a hike. but the person is just simply a fresher, just joined, no past experience, obviously appraisal may happen, but no hike is going to happen. Okay, right? So I hope you are able to get this. Okay. Okay, these are some questions which I think we have already solved about. So don't take too much stress on this. Okay, now this is just next question. I will give you time of maybe 2 or 3 minutes to go through both of them. Then I'm going to get into some programming mode where I'm going to give you some use case which you have to program. Okay, let's have a look now. So friends, the idea is that if your billing amount is in this range, you get a 10% discount. In this range, get 20% discount, and about 20,000 get 25% discount. So first I'm going to ask the price of the product, check up the range. So I'm just trying to look at the AND operator, give you a 10% discount. Else in this range, give you 20% discount and give you this thing. The whole idea is I want you to modify this code because this code is incomplete. I am only saying you got 20% discount, but where am I giving you 20% discount? You get me? Where I'm giving you? I should give you 20% discount, right? So I have to print that 20% discount value. Print here 25% discount value, which I have not done. So I think you need to complete this print and this print statement. Right. So we should calculate our taxes. Okay. And the rule that we need to follow, we're not going to go literally, into the rule of our ITR, but we'll make the rules very simple. Okay. Now the simplest format of calculating of our taxes could be, first of all, to know whether the person is salaried or business. Okay, that's the first thing which you should ask the user. So apart from calculating the taxes, I also want you to print his simplified, not simple, very, very simplified rather, simplified income tax returns, or maybe the tax payable. Okay. In case of less than 7 lakhs, there is no tax. That is good. So if it's between 7 lakhs to 10 lakhs, then it is 10%. But understand that if somebody is earning like 8 lakhs, so first 7 lakhs, there is no tax. Now above 7 lakhs, it is going to be 8 minus 1. You see, it's going to be 8 minus 7. That is 1 lakh. So on 1 lakh, he's going to pay 10%. Am I right in understanding this, my class? Right? So if you're earning 8 lakhs, you're not going to pay 10% on the entire 8 lakhs. You're going to pay first 7 lakhs goes free. So we put it this way. We put it this way for simplified. First 7 lakhs, there is no tax. Okay. Then above 7 lakhs to 10 lakhs, there is 10%. You see, it's incremental calculation, no? Right? It's incremental calculation. So next is 10 lakhs to 12 lakhs is actually 10 lakhs and 1 rupee is 10 lakhs and 1. So you understand, right? It's 20%. No, sorry, it's 15%. Okay. In a very similar way, if it is 12 lakhs and 1 to 15 lakhs, then it's 20%. And then lastly, if it's above 15 lakhs, you see, to what, infinity, correct? It's 30%, right? So I hope, friends, you are able to get this. So let's take an example. Let's take an example. If somebody is earning 13 lakh 15,000, how would you calculate his tax? You would say that, Rocky, for the first 7 lakh, it's free. So you will calculate it as 13 point so and so minus 7 lakhs, okay, is going to be equal to 6.5 lakhs. In that 6.5 lakhs, you see, in that 6.5 lakhs, you will calculate the first slab of 7 to 10 So, you are going above. Point is, are you going above 7? Yes, you are going above 7. That is true. So for the first 3 lakhs, you are supposed to pay 3 lakhs means this range. The first 3 lakhs is supposed to pay 10%. Then above that, the next 2 lakhs is supposed to pay 15%. You see, and for the balance, 1.5 lakh is supposed to be 20%. Please correct me if I'm going wrong in my calculation. Is this the way it goes? Can somebody verify that, please? Right? Or not? Can somebody please verify this? Prabhu verifies it. Thank you. So for the second calculation, it's going to be the second 2 lakhs. It's going to be 15%. You see? Now question is, what is balance? So balance is 1.5 lakhs. So the last 1.5 lakhs, it's going to be 20%. You see? Correct? That's the way you're going to work and calculate. So this is not easy. So you need to build your logic very well. You'll say, Rocky, how it will make a difference whether you're salary or business? To be very honest, here I don't want to make things complex, but to be very frank, the calculation does differ for salaried versus business people. You see? So let's not get into confusions at this moment. But I'm accepting whether salaried or business person, because while printing the details that, hello dear Mr. So-and-so, gender and age, type is salaried or business, your total tax payable amount is so-and-so, and it is calculated so-and-so. So show calculation also. When you print the whole taxes, you print the calculation also in a very formatted way. You print the calculation also. Print the calculation also in a formatted way, so that it's easy to understand. Okay. So friends, can I ping this comment to all of you? Will that help? Okay. So let's see whether this program works correctly or not. That the peer has to review, but then let me scan the code according to the logic that is given. First, some inputs are being accepted, which were to be accepted, like name, gender, age, and salary. If the salary is less than 7 lakhs, no tax, as simple as that. But in case if your value of salary is more than 7 lakhs, assume it is 9 lakhs. So it's going to be 9 lakhs minus 7 lakhs. That's going to be taxable salary. It's going to be 2 lakhs here. Now start checking. Is your salary 2 lakhs less than 3 lakhs? Yes. So you will be only 10% taxes. But tomorrow, if your salary was, let's say, 11 lakhs, so it's going to be 11 minus 7, which is going to be your taxable salary. That's going to be 4 lakhs. So is 4 lakhs less than equal to 3 lakhs? No, it is not. So I come to the else if part. So is 4 lakhs greater than 3 lakhs? Yes. And less than 5 lakhs? Yes. So I'm going to have 15% on the taxable salary. Now here is something which I am not, convinced, because is it so, friends? If my salary is 7 lakhs, then all the amount which is above 7 lakhs, have I to pay, I repeat, have I to pay complete 15% on that 4 lakhs? Think about it, class. Think about it. Right? You're not to do that, right? So so the calculation would have gone that we should have taken 30,000 as is. I'll tell you, we should have taken 30,000 as is. So if the taxable income is, let's say, greater than 3 lakhs, so what we will do is we can subtract 3 lakhs from here and add 30,000 outrightly, because for the first 3 lakhs you are supposed to pay 10% slab, isn't it, Nagdeep? I'm trying to communicate this to you, Nagdeep. So your logic is very good, trust me. But I think this is something which we overlooked on. So we can do like this. Okay. And similarly, your logic will flow ahead also. Same logic will be coming here as well. So let's say that let's say somebody's salary is 12 lakhs. Just imagine it's 12 lakhs or maybe 11 and a half lakhs. Okay, so you'll come to this part. 11 and a half minus 7 is going to be 4 and a half. So is 4 and a half coming in this slab? No. Is 4 and a half coming here? Yes. This is going to work. But what if my salary was, let's say, something and this amount is coming 5.5 lakhs? Now think about it. So in that case, 5.5 greater than 5, yes. Less than 8, yes. 20% of the whole amount? No, not 20% of the whole amount. You have to pay 20% on taxable value minus how much? Taxable value, how much minus? 20% minus 5 lakhs, if I'm not wrong. Okay, and what we can do is take this whole stuff. Friends, what we should add to this? Any idea what we should add to this? How much amount should we add to this? 30,000? No. 30,000 was added in the previous case, my friend. 30,000 is on the first 10%. Previous tax slab would be needing to recalculate. So what is the fixed? What is the absolute value? See, we're subtracting this. So I think we need to add 30. That is correct for the first 30. Then we need to add 20% of the balance. Sorry, 15% of the balance 2 lakhs. That's another 30,000. I think you're correct in saying that we need to add 60,000. Yep. So 60K needs to get added up. Similarly, if the taxable value is more than 8 lakhs, that is actually above 15 lakhs, then it is going to be 0.3 into taxable slab minus what? What should be the amount that I should be minusing from? It should be 8, right? And add to this, 60,000 is up till 12 lakhs. Then 20% of another 3 lakhs is another 30,000. So that is going to be 90. Okay, I'm doing a rough calculation. Huh? So I think this is the way it should be working. I've just modified with minimal changes. Okay, let's say you're accepting the salary. That's the most important thing. Subtracting 7 lakhs from here. If salary now is equal to 0, no tax, exit. You leave the entire code. So tax value is 0 at the moment, correct? 10% block. Now, whatever salary amount is there, you subtract 3 lakhs from it. If salary greater than 0, okay, whatever was the old tax, if there was any, in this case, no, you take a 10% of it. Okay, then you're subtracting further 2 lakhs from it. You subtract 3 lakhs from it. Now, further 2 lakhs from here. And then further 3 lakhs, 10, 12 to 15. Cool. Let's run this and enter 11 lakhs. So tax is 45,000, then 1,25,000, and then further 5,000 for 11 lakhs. So what is the total tax liability? You know what is, by the way, using so many exits is not a good practice. Total is the first one. You mean to this one, 45,000. Yep. So in that case, our logic is also correct, right? We are also getting 45,000 and we are accumulating. You can please notice that. So that slab of 7 lakh to 10 lakh rupees has a 10%. Yep. So it is correct. So it is right. Prabhu is also confirmed. Right. So yeah, but don't use exit so often because exit is a very harsh statement to, you know, exit the whole code. So avoid using exit. You see? Right. Anyway, so friends, let's move on. Save your work. Just control S, save your work. Yeah, exactly. You could not break because you're not a part of a loop. So when you are only part of a loop, you can break and continue. So you should use if else statements. So the idea is to use if else statements more. Yeah, great. So let's move on, friends, on to module number 5. I have to share. Friends, there are situations where we have to iterate. Iterate in simple sense means repeat. So when we have to repeat something in any programming language, we say we are creating loops. Every loop has to be controlled. It should not go infinite. It should be controlled. And for that, a loop will have a loop variable. It will have a condition for termination. And you and I as a programmer have to take care of updating the loop variable. Now, friends, there are two types of loops actually. There are more types, but right now, let's restrict ourselves to two types: a while loop and a for loop. These are most commonly used. In a while loop, we first check the condition and then execute all my statements inside the while block. And any statement which is coming like this is the statement which is outside the while block. So remember, all statements inside the while block are repetitive. That means they're going to keep running. Now, let's take a very simple example. I'm trying to find factorial. Friends, I know you will say, Rocky, why are you finding factorial? Factorial is a ready-made function in math. I know that, friends, but I'm just trying to put forth the logic of the while loop in front of you. So I'm asking the user to enter his choice of number. Initially, the variable fact in which I'm going to put the answer is 1, while number is greater than 0. So let's say the user enters a choice as 4. Is 4 greater than 0? Yes, it is. So I'm going to calculate. Initially, fact is 1, so it's going to be 1 into 4. And then the next time is going to be 4 into 3, because every time I'm reducing the number by 1. You see, number reduces by 1. So it's going to be first 4, then 4 into 3. That's 12. 12 into 2, 24. 24 into 1, so on and so forth. So that's the way it goes on. So if I just run this piece of code, it's running. Please wait. This logic can also be changed. And instead of going like 4 into 3 into 2 into 1, you could also go 1 into 2 into 3 into 4. You could do, instead of reverse logic, you can go forward logic also. You get me, right? Now, another very simple example, write a program to find sum of first n natural numbers. Again, very, very simple. So you are asking for user to enter a number. Okay, let's say 10. So till the value of num, which is at the moment 1, is less than equal to 10, I would take the sum plus num. So sum is 0, num is 1, I'm going adding. So first time is going to be 1 plus 1, then 2 plus 1, then 3 plus 2, so on and so forth. So in short, you're adding the whole sequence of numbers. Let's say I want to add up to 6 numbers. Okay, so it's 1 plus 2 plus 3 plus 4 up till 6 is 21. Okay, right. Now, friends, you will find for loop to be more convenient. So if you're a first time programmer, you will find for loop to be more convenient. And if you've been programming, then I'm 110% sure you know what a while loop is, you know what a do while loop is also, you also know what is a for loop. I'm not touching upon do while loop at the moment. That's not so necessary. So let's be using while loop and for loop. Now in for loop, friends, syntax is very simple. The first variable in for loop is the for loop variable, which is like continuously going to change. And after the in keyword, which you see here, you will say, Rocky, in is the membership operator. No, it is not. Here, in is not the membership operator. Here, in is a part of the syntax of for. So for I in, whatever value you've written here, it could be a string, it could be a list, or it could be a collection. So it could be any data structure here in which you want to check whether this value is contained in this. So if I is in Python, so I'm not, this is not a membership operator. See, membership operator means I will check whether the value of I is in Python or not. No, I'm not doing that. So for I in Python means I'll pick up every character of the string one by one into I. So first time I will pick up P, next time I will pick up Y, next time I'm going to pick up T, so on and so forth. And thereby I will get the output the way you can see on my screen. Now, just to, the reason I was insisting that I want to get into this notebook is because please have a look when you make a collection of data members in such square brackets. In other languages, this may look like an array, but in Python, this is not an array. This is a list. So we say this is a list of elements. You said, Rocky, how can between the numbers you bring in a string? Yeah, the beauty is list is a heterogeneous collection of elements. So I can have few integers, I can have a string, I can also have a floating point number. There is no problem. Please appreciate, there is no problem. You see, so you can have a collection, you get me? I can have a collection of different types of data members. And what I see here is what you see here on my screen. So one by one, every element was picked up, brought into I, and you got the answer. Okay, friends, you with me on this, right? You're with me. Now, this is one format of the for loop which you are being seen. But many times we may not have a collection ready-made, right? We have to make the collection at runtime. You can do that. So for I in range 1,6, range has two parameters, start and stop. It will start from whatever you say, but it will stop at one less. So 6 minus 1, it will stop at 5. So you're going from 1, you're stopping at 5. That is 1, 2, 3, 4, 5. No wonder this for loop is going to run and the value of I will vary from 1 to 5. If you see this in the first case, you will see output going 1 to 5. So if I say range 6, you'll say, Rocky, why is not starting with 1? That's because, friends, in range, if you only give me one number, then this means the end number. I will end at this point, but I will by default start from 0. So I'm starting from 0 and going up till 5. You see, going up till 5. Because this is the rule. Whatever end index you give me, I will go one less than that, my friends. Always remember, whatever end index you give me, I will go one less than that. Okay, right? That's the rule. So another example of factorial over here, but the only difference is instead of the while loop, we are using the for loop for coding it. Okay. Now I would like to request all of you to run all your codes up till this point. It should not take you more than 4 or 5 minutes. And also try your level best to code this. Write a program to, find the sum of first and natural numbers using for loop. Okay, because up we did with the while loop, you can use the same logic, friends, and replace the loop by the for loop. So we go slow and steady to the next. So friends, what happens now is when I'm using a while loop versus a for loop, very honestly, both are doing a good job for you. But personally, I believe that most of you may feel that for loop is more easier to code because you have not to bother about the incrementing or updation of the for variable. You see, but in the case of a while loop, you have to bother. Okay, now have a look at this piece of code. In the first code, my range function is saying I would like to move from 10 to 99. It's going to check every number 10, 11, 12, so on and so forth up till 99. While you see, while if I look at this case here, this is the range function in which you have a start value, You have a stop value, you also have a step value. This is another form of range function. So there are many forms of range function. One form, you only give me the end value. Other form, you give me start and end. Other form, the third form is you give me start, stop, and step. In this case, I'm starting with 10, stopping at 99 minus 1, that is 98, and stepping every time by 2. So my values are going to be like 10, 12, 14, up till 98. While if I look at this here, 11, 99, 2, then you are starting with 11 and you jump in with all odd numbers like 11, 13, 15, so on and so forth. Okay, so let's have a look, right? You will see, Rocky, what are these answers? These answers are summation, no? You have summed up. What you're doing exactly is that you're finding all the even numbers like 10, 12, 14, 16, and you're summing them up. As simple as that. Okay. This is a shortcut if notation where I am not, bothered about indenting and taking it to the next line. I'm just putting the single statement after the if block. I'm putting the single statement after the if block. You get me, right? Everyone? Okay. Now, look at this. This is another simple code. I'm asking for an input from the user. You see, whatever user gives me an input, maybe your name. You're running a for loop over your name to find the index position of your name. So let's say that your name is Prabhu. So you enter this. Yep. So we get the index of P is 0, index of A is 1, so on and so forth. So what usually is done is, if you're using format printing, then you would write an F over here, you see, and thereby skip writing the word called format. You see, you with me, right, on this? And this whole thing will come in double quotes here. So this is one way of doing it, or one way of looking into it. But the whole idea is, when you have many placeholders, then people prefer to be very specific and make things more readable. They write format x comma I. So the value x will go into the placeholder 0 and the value of I will go into the placeholder 1. But this is an equivalent way of doing it, which you've already learned. Okay, great. So friends, I am believing most of you have finished up till this point. Can I talk about break and continue? I need your permission, friends. Can I talk about break and continue? Yes, perfect. Thank you. This is the last thing and most important thing which I wanted you to take away today. Friends, whenever you are in a loop, there can be a situation that you may not run the loop completely. So let's say that I'm having a loop which is having a range of 10, but I don't want to run the loop completely. So I can have an if condition. If this if condition goes true, my loop will break. Have a look. See, if the break condition was not there, this loop would have printed values going up till 9, 0 to 9, but it broke at 5. Why? Because after printing 5, you check, is it 5? Yes, I break. But you will say, right, Rocky, what is the deal of you breaking? Now, think in a more wider way. Suppose you are accepting multiple inputs from the user and you want to break when you find a particular name or a particular ID. You see, so you're accepting inputs and you will break when you find a particular ID or a particular name. That's it. That's the idea. You see, I spoke about nested if else, right? In the same way, you also have nested loops. So one loop can get nested in the other. So this is called as the outermost loop. This is the outer loop and this is the innermost loop. So the whole idea is, if I do not put this break statement, then this high all would have got printed for 4 into 3 into 2. 4 into 3 into 2, that is 24 times. You see, so that's the way the loop would actually break. Right. So I hope you got this. Now, Continue further. So what I notice now is the continue statement, where in the continue statement, what I have is I have a for loop for I in range. If I is equal to 4, I say continue. What does it mean? Friends, break is very evident that you're going to break out of the loop. But continue is not so evident. Continue basically means that I will skip every line of code which is after me. So when the value of I is 4, I will not print it. Please notice, I'll get every output except 4 in the output. 0, 1, 2, 3. Where is 4? 4 is got skipped. Then comes 5, 6, 7, 8, 9. You see? So fundamentally, what I'm going to tell you, friends, is whenever continue executes, the step after it is skipped. Whenever continue executes, the step after it is skipped. Okay, right. Now, let's have a very simple code example here. Let's say I'm trying to find all characters, not numbers, only characters in this alphanumeric sequence. So for loop is going to pick up every character, first 1, then 2, then 3, then A, then L, so on and so forth. But if the character in I is any one of the numeric digits, I say continue. Continue means I will not print. But if I read A, then I'm sorry to say A is not in this sequence, right? A is not in this sequence. Therefore, you will print it. So let's have a look. Yep, this makes sense. So from an alphanumeric sequence, I could pick up and find all the characters. Correct? That's the application of continue. This, I think, should not be difficult for anyone. I'm accepting some choice from the user. Could be 10, could be 20, could be 30, whatever user wants to enter. And while true is the way you run an infinite loop. This is very interesting. I'm running an infinite while loop. So when I run an infinite while loop, my friends, I'm trying to check, is the number initially 0? Is it even? Answer is yes. 0 is of course even. Then would come 1, then would come 2, so on and so forth. So let's say the first number is 0, it's even, I'll print it. I increment the count, I increment the number as well. Is if count is equal to choice. If I enter choice as 6, so I want 6 numbers in the output. Till I don't get 6, I will go on finding numbers, but I will only print even numbers, no odd numbers. You see, so this is another good example of an infinite loop. You see, let me explain to you on my whiteboard of why I would actually make a class. Let me ask you this very basic question. I'm showing you something on my screen. Let me show you something like an ice crate. You see, ice crate. Just ice cubes, sorry. Now, my friends, I wish to ask you one very small question. May I know from all of you, what you see on my screen is of course, ice cube tray, which you can see here. My question to you is, can this ice cube tray be used only once to make a ice cube, or can it be used for n number of times? Your answer, please. 1 or n? Absolutely. Absolutely. Very good, everyone. It can be used for n number of times. So it can be used for multiple times. It's a reusable product. Correct. This is exactly what I mean to say when I say you about the word called class. So this ice cube tray actually is a class, and we can use it for n number of times to make cubes. The cube is actually the object. You see, so the cube is an object which is being made out of this class. So the whole idea is, once we know the characteristics of something, you see, what we do is that we define it once and for all. Okay, and later on we go ahead instantiating it. We go ahead instantiating it to make an object. You see, we go instantiating it to make an object. You see, right? So the whole idea is very simple. You see, the whole idea is very, very simple, that once, let's put it this way. See, all things around us, my friend, all things around us, you, me, our laptop, a glass of water beside us, a mobile phone, all have attributes. They have characteristics. Let's think about, maybe a car. So a car probably would have a characteristic like number of seats, the model number of the car, the engine capacity, okay, the type of the car, and a few more. These are all attributes of the car. Every car will have it. You see, and there are only methods of the car. Example, change gear, okay, then accelerate the car, brake the car, okay, that is stop the car, okay, and then maybe, some more things which you can do with the car. Okay, so these are all methods. These are all functions. These are all things, how will you use a car? You see, the car's color is not what you're going to use. You can use the car for driving. You can use the car to reach to a place. You can use the car to pick up somebody and drop somebody. So those things are my methods or functions on how I'm going to use my car, or how the world will use the car. And these are attributes which are static. So this set is static, you see, and they will have values. So example, the model of the car. So I put a model, and then you put the model name over here. Now this part over here, friends, becomes attributes. So we say this is the attributes of the car class. And this here is the methods of the car class. Okay. So this is the methods and this is the attributes. Now, once you have the class in place, you go ahead instantiating n number of objects. You see, you go on instantiating n number of objects of my class. You see, you go and instant n number of objects of my class. Now, because you're instantiating n number of objects of the respective class, that means once a class is defined, I can make objects. You said, okay, why making an object? The reason is I have a class over here, but all of us have different cars. You see, so I have a different car. My friend Sanjeev has a different car. My friend Nazrul has a different car, and probably my friend Prabhu has a different car. But ultimately, all our cars have the same attributes, have the same functionalities. You see, so you make objects of it. So that's the whole idea. Now, how do we do it in Python? Well, in Python, we do like this. We write the keyword called class and give a name to our class. That's it. In this class, this is an empty class. This is no use. This is an empty class, to be very honest. So when you want to make an empty class, you need to write the word called pass. Example, suppose you and me are playing a game of cards, and you're not taking your turn. What will you say? You'll say, Rocky, pass. Pass means you're passing your turn to the next person. So you didn't take your turn. Same way, class demo has no internal body, and therefore we say the word pass. Okay, object is equal to demo, which fundamentally means that you are creating an object of the class. This is the way you make an object. And if you print an object, let me show you. First, I make an object, then I print an object. And if you want to know information about the object, you can say help. Although this is not really helpful, to be honest. Okay, not really helpful. Hence, I'm saying this takes you too much in detail, not much helpful. So print object shows that this demo is an object and it is stored at so and so memory location on your computer. Remember, this location is going to be different for all of us. Now, I spoke about attributes, right? Have a look, please. So I'm making a class over here, and I'm trying to hold some information about your, let's say, health card. So let's say I have a class called health card, like Aadhaar card, similarly health card, which is issued by health companies to us. So I make a class called health card. I hope that health card should have minimum this information about each one, about the name of the person, about the age, about the location. And with respect to the health card, I can only know your information. So using it, I can only print your individual information. Now, let's have a look of what am I doing. Now, just imagine this. Suppose, my friends, okay, I put my details. Obviously, you can verify, sorry, you can alter these details later on when you're going to run your code. Okay. So what I'm doing is I'm creating a class, then I'm instantiating an object of the class. So h1 is my object, and I say print info. I'm calling the method print info. It's going to print these personal details which are there inside the card. Imagine the card is digital, and when you swap the card, you get the details. So you got these details. Now, let me explain to you from theoretical perspective of what all is seen on my screen. Friends, what happens now in the class health card or any class, when you want to make attributes, you can define those attributes inside a constructor. A method which starts like this, underscore underscore init underscore underscore, is a very special method in Python, and it is used only inside a class, and it is called as an initializer or a constructor. It is called as a constructor, okay, or initializer. Although we don't use the word initializer that much, we use the word constructor, okay. So this is called as a constructor or initializer. Now, having said that we are having a constructor or initializer, please have a look. And in this case, I have name, age, and location, which you can see here. And you can see that I printed it here. So you said, okay, how to get the information? Exactly. So when I write the name of the class and I pass some information, those information goes in these variables. I know you will probably, who's the self here? I will come to it. This is a little complex, so give a little time. I'll come and talk about self a little later, not right now. So whatever data you pass here will go in these three variables. Please leave self aside. And these values get assigned over here. And this is exactly what I'm printing here. Okay. I repeat once again, please leave the self for rest for some time. In the next 15-20 minutes, you will be very clear of what self is. I'm requesting everyone to go ahead, putting comments, like I'm putting comments here that this is a constructor or initializer. In this case, you are making a object. You see, you are making a object, right? And in this case, you are calling method of the object. Okay, right? So I hope you have got this. Very simple and very clear. So friends, can I request you to please run all your codes up till this point? You may have doubts, but I would request you to please have little patience on the doubts, because there are a lot of things which I have to build up. You see, once I built up on those things, most of your doubts will automatically be cleared. If not, I'm here to clear them. Be rest assured. Okay. I'm revisiting the same class called health card. Okay, I'm modifying it because I see health will have many more parameters, right? So health card seems to be a more appropriate name. Okay, so my init here is my constructor, to which I have got three parameters. You see, so whatever number of parameters you give me here, my friends, in the constructor, please remember that many number of parameters you are supposed to pass me. You get me? That many number of parameters are supposed to pass me. You see, so you need to pass me all those values. So if I've got three values there, you need to pass me all the three values here. You cannot just, kind of leave, you cannot say that, okay, Rocky, I've got 3 here, I'll pass 2. No. Or I've got 3 here and I pass 4. No, once again, as many here, you have to pass that many. Okay. Now you can notice that I have assigned name, age, and location. And here, and this is the tricky part here. Friends, what happens now? There are two types of attributes that we can make inside a class. One are called attributes which are going to be starting with a word called self. And those attributes which start with a word called self are actually called as object attributes. Okay, or object variables. They are attributes which are going to be in every object, be it a name, be it age, be it location, or be it counter. Be it a name, age, and location. Three of them, because they start with a word called self. They're all object attributes. But attributes which do not start with a word called self, instead they start with a name called class, are called class attributes. Now, what is the difference? When difference diagrammatically, in a very simple schematic way, the difference is this. Suppose if I have a class attribute, then I'm going to put this value over here, and all object attributes I'll put 3 dots. Now what happens now, friends? Let's see if I make 2 objects of this particular class. In both of these objects, you can assign value to the object attributes. You see, you can assign values to the object attributes. Okay, but not to the class attribute. Class attribute is going to be common. Class attribute is going to be common to all the objects. You see, if you want to change it, you can change it at the class level. But moment you change it here, it is going to be the same change will be seen by each of the objects. I'll give you one very simple example. Suppose you are a owner of one of the vehicles. Let's say you're an owner of Audi Q3. So Audi Q3 is the type of the vehicle which I put at the class attribute level. But who is the owner? The person's name will come here. What is the type of the color? It is your choice. You have taken some particular color type, which could be different from me, different from Akash, different from somebody else. So our name, our registration number, the color of the car, or cars have a lot of variations, no, lower model, mid model, higher model kind of, no. So what you have taken is here, but what you have taken is Audi Q3. So let's respect that fact. So let's say 10 people have taken Audi Q3. So Audi is my class attribute, but internal details of the owner, registration number, registered which state, which city will be different, no? So those are going to be my object attributes, and the name of the class, you get me, will be on the so-called top over here as the class attribute. Okay, that's the difference between class attribute and an object attribute. So class attribute remains firm for the class, and every object will be able to see the same value. So you'll say, okay, Rocky, you're trying to tell me that you're having one attribute called counter here. So as many times you call the constructor, counter increments by 1, correct? So you are keeping a count. In short, you are keeping a count of how many people have taken the health card. Just to give you an example, I have made one object of health card here with my details. I print my details. Then I make a health card for some other person, you see, and I print his details. You will please notice carefully that the number of objects now is 2. Wow. So as many more people go on purchasing the health card from the insurance company can keep a track of how many people have yet till date purchased their health plans or health cards, and I see the number of objects going on incrementing. It was 1 year, my friends. See this. Now it is 2. Right. I hope you're able to understand the essence of class attributes, that it remains at the level of a class and not goes to the level of the object. And one more essence what I felt personally is that, okay, Rocky, I see that class attribute is always accessed by a class name, and object attributes are usually accessed by, not usually, always accessed by the self attribute. Now I'll tell you what self means. Friends, when you make an object over here, you see, you are assigning this object to a variable called object1, isn't it? And thereby when object1 calls print info, I wish to ask you, when object1 is calling print info, why details of Rocky are getting printed? And when print info is being called by object2, why details of Dave is going to be printed? We'll say, okay, it is simple, because object2 holds details of Dave, correct. Object1 holds details of Rocky, that is also correct. But how does name know? How does age know? How does location know that it has to print details of Rocky or Mr. Dave? How? Exactly. That is where self comes in the picture. So whoever calls the function print info, the reference of that object goes into the variable called self. Hence, you will always notice whenever I use a constructor or use any method in Python inside a class, first attribute of the method or the first parameter of the method will always be self. Because when I call print info by object1, object1's reference internally by Python is passed into self. No wonder it is object1.name, object1.age getting printed. So I get the correct details of Rocky. Here I get correct details of Mr. Dave. You're with me? Friends, are you all with me? Yep, great. So this is something which you can do on your own. This is so simple and straightforward. This is like object one accessing name and age, object two accessing name and age, and object one, object two counters are being printed. Remember, both will be two. You say, no, Rocky, a counter of object one will be one. No, counter is one single universal variable, my friend. It's a global variable. How can it has two different values for each object? By the way, counter does not come to the object only. Counter is stored in the class. And therefore, each of the variables, as you can see, are going to hold values, which you're seeing here. You see, right? So up till this point, I don't see there should be any trouble. You have done some operator called is operator last time. I wish to tell you what is in case you've forgotten, no worries. Okay, is means basically you're trying to check that is the name of the person in object one same as the name of the person in object two. If it is same, it's going to give you true. And if it is not the same, it's going to give you false because the names are different in both. Hence, I see it's giving false. Counter is same, no? You say, Rocky, use equality operator. Another way of doing it. Instead of using equality operator, you have one operator called is. Let's accept it. What is the big deal? Another thing to do. You see? So I hope this is getting clear. Up till this point, I wish to give you about 3 to 4 minutes to run and put comments from your side. So for is operator, and for some reasons, you may have to use ChatGPT or OpenAI also, OpenAI ChatGPT or maybe Google, just to get some quick sentences which you can copy paste here. Like example, what is operator in Python? So if you don't want to type, you can pick it up from Google and that's it, paste it here. Cool on that, right? So please do that. Right. So friends, now we are moving a bit ahead on to understanding of what we're going to do next. We're looking at access modifiers now. Things go a little more complex, you see. So friends, now quick questions I'm going to ask you. Please do answer them. Notice that I have accepted 3 values from my user. Okay, values are name, father's name, and age. All 3 values have been assigned. There is a class attribute which has also been incremented, and I'm trying to derive the roll number and the file number. Whenever you are going to give any variables, these kinds of symbols, a single underscore and a double underscore, you are actually making them as private variables. You see, that means you're not going to allow these variables to be openly accessed outside. They have private access specifiers. I cannot go too much in details because the time is very limited and this notebook is too long. But one thing you can understand is something which is personal to you and just you. Example, your wallet. That is not shared by everyone at home. That is your wallet. So you only going to use it, right? It's your watch, only you're going to use it. But what about the fridge and the sofa set at home? Is it only yours? No, everyone uses it. So the fridge and sofa set, yes, it is yours, but then everybody, the whole family uses it. So it is something which is usable by everyone. Okay. So the whole idea is that you can mark a variable as private and reserved within the class by marking it as underscore and double underscore. Okay. So no need to worry about any kind of coding here. This is just like, I'm just trying to pick up the first 3 characters of your name. Okay, and the student counter variable. If the first student, the counter variable will be 1. For second, counter variable will be 2, so on and so forth, right? And the name of your student's file is going to be upper 3 characters, upper characters full, your full name in upper characters, and a counter number attached to it. Just to show you this in running. Okay, let's have a look at this example for simple understanding. All right, so you can notice that you say, Rocky, how did you get onto A2202 Yep, to tell you that's over here. Okay, this is academic year 25, so I should make this 25. So academic year 2025. Okay, then this first placeholder is going to hold this much part. The second placeholder is going to hold this much part. So in the second placeholder, I'm saying that I want a number to come as 0, 0. Okay, 3D means I will maximum accept 3 integer digits. That means our file number will go to maximum 999. I'll not pick up any number beyond 999. Okay, so the whole idea here is, okay, now how does this John come up? JOH, because I took the first 3 characters of the name, you see, in uppercase. Okay, next case, why the whole John Davis came is because we said we want the whole name in the uppercase, right? And further the counter variable, which you can see here, right? 001. Okay, so I hope this is getting simple and clear. Don't take too much of stress about this formatting part. That's just done for, kind of good looks. Idea is that you're trying to make some variables. Usually beginner programmers are not supposed to do all that stuff. So you haven't to really worry. Most of the times you're going to work is in this space, but at least be aware that if you wish to make variables, which is going to be completely private and usable only inside the class or through its methods, then you can make such variables by using double underscore or a single underscore. Okay, right. Now I have another function over here called display, but now I'm entering into a territory in which I wish to talk about something called as inheritance. Friends, all of us take qualities from our parents, right? And we call that term as inheritance. So I may inherit looks, skin color, body frame from my parents, right? So inheritance happens in all object-oriented programming like this. I make a class called science because a science student should also have the same qualities as a generic student. So I straight say class science is inheriting attributes of a student. So what all student has, all things will come to science. Now, when I try to have a look, when I try to make this class, you will say, Rocky, this class science is having a display function. Okay. And you're trying to print all this, but where have you defined name, father's name, and age? Exactly. So I have not defined name, father's name, and age. They have come to me from student. You see, I have not defined roll number and file number. They have come to me from student. Now I would like to create an object of student and I like to say print info. Please notice. Oh, I should have redefined this, right? Because we changed it to 2025, no? Yep, so academic year 2025. All details in place. Now this is print info, huh? Don't feel confused. I've called print info. So print info is the inherited method. I've got this function from my parent. Inherited means I've got from my parent. But this function is my own function. Who says that? The science student says that. You see, this is the function. This is, so I'll put it in more simpler words. This is the science student function. This is a function which belongs to science student. That means it is not coming from student. It is not inherited. It is not inherited. It's very important to note it down. Okay, let me run this code and see what it gives me. Oh, wow, it gave me an output which says that there is an error. Now, what is the error looking like? See this, it printed name, father's name, age, and roll number. It gave you error at what point? It gave you error at the point where you tried to print. Roll number is all okay. But moment you went on to this variable, he says, I'm sorry, I don't have this variable. Science object has no attribute underscore file number. Why? Because underscore will make the variable private. Single underscore, no problem. Double underscore makes the variable private. So I go up here. This is private variable, my friend. This can only be used by an object of student. Nobody else can use it. If you try to use it, you're going to get an error. So let me cut this from here and mark it private up at the point where it was defined. Private. So when you say private, that means only you can use it. Only the owner can use it. Who is the owner? Student is the owner. Only student can use. Student cannot inherit it. If you want to inherit, that means you want to make variables which are type protected. That means inheritable. Then you can go in for this type of variables which are having protected, which means inheritable, sorry. Oh, it's coming in my prompt. Hold on. What's up? What's wrong? Focus is not changing. Which means it's inheritable. You see? Right? So this was single underscore inheritable. Double underscore is private, not inheritable. Not inheritable. You see, these are some rules, friends, of Python. So I'm so sorry if you feel that Rocky underscore is not very intuitive, that is private. Like in Java or in C++, we literally write private. I appreciate that, friends, but we need to respect the grammar of every language, right? And quickly adopt it and move further. So, yep. So I would request you to run these codes, and even you should get this error the way I got the error for the private variable, please. And you can click on explain error. It'll explain you also. So there is no need even to you type too many things. You can explain error, you'll get the whole answer. You can copy paste the whole answer here as a comment, right? You can be smart in doing that. Okay, Mohammed, there's a question coming in. If science class also has its own constructor, then how to access the science class attributes? So the whole idea here, Mohammed, is that the constructor which I have defined in the class student does not goes down. Please understand, I'm not pushing the constructor. Constructor doesn't get inherited. You see, so when you say class science is extending or inheriting properties of class student, then automatically first the student object gets created and is assigned to the science. Therefore, I'm able to use these attributes. And what you're trying to ask is, if I were to make my own constructor in class science, then how I'm going to call the constructor for student? That is a more common practice in Java. It is not a common practice in Python to do so. Okay, but although we can, but that's not a common practice. You're talking of super usage of the variables where the child class calls the constructor of the parent. That's a good thing to do in C++ and Java. That's the bad practice here in Python. So avoid doing it. There is a way of doing it, but that's I would not I would request you don't do it, because that's not a good practice here. You see, yeah, we don't do that in Python coding. We don't call the constructor of the super classes. You see, so if you learn that and do it, it will look very unprofessional if you program that way to other Python programmers. But the point is that if I simply answer to yes, and then if I show back to in programming, this notebook is going to become impossible to cover up. You see, so I think you probably need to have a different forum where we are learning data structures or learning advanced Python programming to get into that forum, not for Python fundamentals. You see, I'm anyway going one step ahead, little beyond Python fundamentals, because I believe that the batch should know this. You see, so if you're trying to ask questions because you have experience in some other programming language, then I don't think so that's going to help the batch at an overall. Why? Because some of them don't have any programming experience also. You see, so we need to go at the common page. We have to think of everyone in the batch. Right. So friends, let's move on ahead with respect to inheritance. Now, formally, I'm looking at inheritance. I gave you some examples of inheritance. Now I'm formally getting into a small breakup of it. Okay, let's have a look. Friends, we know one thing of inheritance is there must be a parent class, you see, and from the parent, the child inherits. Now, the best part is when a child is inheriting from the parent, you need to do nothing, right? You say class child and write the name of the parent, like we did class science inheriting from student. At the moment, my class child has nothing of his own. Everything what he has come from his parent. Therefore, You see, everything what he has come from his parent, and therefore, please notice, I am printing this line. Why did this line get printed? Because, my friends, moment you make an object of a class, no, by default, you call constructor. You see, you call the constructor. And who is the constructor? This fellow. Init is my constructor, isn't it? You call the constructor, that is the init function. See, I may use the word function and method interchangeably because I have done a lot of work in Java. So Java, we have the culture of speaking methods, but from last 6-7 years being doing a lot of work in Python. So you may find that Rocky has a slip of tongue at times. He uses the word method, uses the word function, but I intend to mean the same thing. Method or function, I intend to mean the same thing. Okay, don't get me wrong. So I'm calling the constructor, that is init function. Okay. Further, friends, please notice that using my child object, I'm calling a function over here. You will say, Rocky, from where this function come? This function comes from the parent? No. Parent is given his function. Remember, parent, no function, no class will give my constructor. Constructor is whole and soul. You know, I'll put this comment here. Constructor only for self means only for yourself. You see, I told you your wallet example, your wallet, your shoes, only for yourself. You will not share it with your homemates. You see, no. Your wallet, your clothes, your shoes, only for you. But other things, car keys, car, fridge, sofa set, everybody, whole family uses. That's okay. Fine. So this is like yours, but everybody in the family uses. This is only you and you. Nobody else will use. Only for self, not inherited. So remember this rule. It is great if you can jot it down. Constructor is never inherited. Never. Okay. Now I'm coming to question like types of inheritances. So we need to understand that, friends, there are different types of inheritances. I like to show you some diagram before I move further. I'm looking for a diagram is a little more clearer. Okay. All diagrams are very small. They're so tiny. Okay, let me see. Is this clearly visible? Hope so. Okay, so this is a single inheritance, friends, where I have got one single parent and a single child. This is multi-level inheritance. You see, multi-level inheritance, where I see class C is extending B and B is extending A. So this is a multi-level inheritance. You see, what I see here is a hierarchical inheritance where I have got only one parent and there are two children. So there can be what two? There can be n number of children. So n children's inheriting from one parent class. That's okay, no? Right? So let's say I have got a generic class called banking rules made by RBI, whether it's SBI Bank, whether it's ICICI Bank, or whether it's HDFC Bank. My friend, no bank has an option. They all have to inherit the RBI banking rules class. You see, they don't have an option. So there can be n number of banks, all of them inheriting the same protocol of the same class, isn't it? Right? How can I give an example of multi-level inheritance? Imagine this is a class called student. Okay. This is a class called engineering student. Fine. And this is a class called electrical engineering student. So I have got electrical engineering student who inherits properties from overall class called engineering students, and engineering students will naturally have characteristics like any other student. Student may be of science, commerce, arts, but student is a student. So they will have some certain characteristics. So that's the way we specialize. And this is a case where one of you were asking me that, Rocky, how will my class C inherit from class A and class B? Trust me, in Python, it's a cakewalk. It's very simple. You just write the class. Let's say the class is a multi-printer. It's a multi-printer and multi-printer class, or a combo printer, and the combo printer class is inheriting properties from a scanner as well as from a printer. Okay, so I have a class called copier. Let's say a class called copier. So my class called copier is inheriting from two classes, A and B, where A could be scanner and B could be printer. Right? You get me on this? So with that point understood, let me not close this, but let me move here. So this is a simple case of single inheritance where this is my base class, which holds information like name, age, gender. And this is the class called learners, you and me friends. And all of us are inheriting information. Because we're inheriting information, automatically you and I have got 3 attributes: name, age, and gender. Okay. Over and above that, I repeat, over and above that, every learner may have some experience, okay, and will definitely have some qualifications. You'll say, okay, what are the none stuff here? Friends, in my function called set learner data, I have actually gone ahead giving a default value to experience and a default value to qualification. This is a nice way of doing things, because if you don't want every learner to specify his experience or his qualification, you want to keep it, let's say, hidden, then you can keep these parameters as default value as none. So if you don't pass me any experience or a qualification, I'll hold it as null. I'll hold it as none and keep it. And the further is a function called display, where I'm displaying these details. So let's see this now, how this works. So first I make object of learners, and in learners, I'm only passing 3 attributes. Notice I didn't pass anything for experience and qualification. You see, when I say print info, I will get details for John Davis. But now what I'm doing is I am calling set learner data. And you would notice now if I call display, I will be able to display all the 5 details. How that happened, friends? Please notice now, I've called my print info function. Where is print info? Print info is with my parent. It has come from my parent. This print info is there in the class, but you can't see it. It has come from the parent. No, print info has come from information into learners. You see? So therefore I'm able to call it. Now, one of you may feel it, Rocky, how about you making a constructor over here? No problem. But a problem that is going to happen, no, if I make a constructor over here, then I have to do 2 things. 2 things I have to do. First, I'll have to get 5 values, 3 values of this and 2 values of this. The 3 values of this which I'm getting, I'll have to pass it to my parent. Now that programming style is not bad, but that programming style is old. It is an older style which C++ and Java programmers follow. Python programmers in the modern days don't follow that style, because Python says that moment I make an object of learner, by the rule of inheritance, how can a child be created without the parent? I'm asking you in terms of nature. How can you and I exist without our parents? So our parent has been created before by God, therefore we have come, right, into it by the rule of nature. So when I make an object of learners, automatically the Python compiler makes the Python virtual machine internally makes an object of information. So you really haven't to worry about it. You see? So notice when I made an object of learner, I passed these parameters. Automatically these parameters were transferred by learners to the constructor of information. So there is no need to think in that C++ and Java style, where we use super call to make a call to our parent constructor. So you don't need that stuff actually here. You see, right? Because it automatically happens. Hence, we don't code in that style where we coded in C++ or Java, right? I hope you're able to appreciate what I'm trying to bring to you. Right? So friends, I want everyone to actually scrutinize up till this point, put your own comments and run up till this point. Please change the details to yourself. The same concept of single inheritance is going to get extended in multi-level inheritance. I say this is grandfather, father, son concept. You see, this is grandfather, father, and son concept. Why? Because this fellow is the grandfather, information, where I have name, age, and gender. Okay, so print info is a function of my grandfather. So I just put over here grandfather, easy to remember. No, in human sense, it is easy to remember this, right? and then this fellow is the father over here because he is inheriting from information. Okay. Now I notice one thing, that this programming is same as the above. Exactly. Why will I change? I'll keep it same, no? And this fellow over here is the child or the son. You see, this fellow here is a child or the son. So if you think that you want to keep the child, you want to code nothing new in it, but whenever, now look at this piece of code. Whenever I make a class of, profile, who is my child to the father, okay, or maybe you can say son or daughter, whatever you wish to, then this constructor over here, please notice, is calling. This is a constructor here. See, instead of, if I leave it pass, this is invariably happening. Please understand, even if I write pass, do nothing, this is invariably happening by default in Python. But if you wish to see it or what is happening, please have a look what is happening. So in the constructor of profile, you will say, Rocky, why are you asking me for name, age, and gender? Friends, I am not asking for name, age, and gender. Name, age, and gender is asked by one of the senior classes of profile. Maybe learners, maybe information. So if you go on backtracking, you will see, yeah, it is asked in information. Exactly. The grandfather is asking the son that, see, I need name, age, and gender. So please notice what happens carefully. Learners is my parent. I'm calling the constructor of, you get me? I'm calling the constructor of the parent, which is learners, and I'm passing him these three values. But now you'll get confused. You'll say, Rocky, come on, where does learners has a constructor? Friends, if you do not code a constructor, that doesn't mean it is not there. It is there by default, and the constructor of learners is doing nothing. It is doing nothing. It is simply calling the constructor of the parent. Please appreciate it. It happens by default. So you haven't to literally sit back and code. Okay. Suppose, see what I'm trying to tell you, my friends, is that if I were to code underscore in it here, I haven't to really do any hard work. If I code this or I don't code this, it is invariably there. Moment you wrote class learners is inheriting from information. If you think, no, Rocky, I want this to be there, keep it. I am nobody to stop you. Keep it. So I was talking about super making call. So this is what is happening. So the constructor of learners is doing nothing. He is saying that if you pass me these three parameters, I will do nothing except for the fact that I will call my parent, super means my parent, and call its constructor. Simple as that, right? And you can get this by, your help, or you can, sit back and type from my screen if you wish to, but that's not necessary. Please trust me. There is no difference in functionalities. Now, okay, now what I'm doing next, please notice, I am, wait, hold on. Let me run the codes, no? What does pass mean? That means I have nothing more. That's why I written pass here. Okay. So what you see here is I called profile. Okay, and I pass three parameters here. So these three parameters are taken by this fellow. They go to learners. Learners is using the passing game, nothing big. Learners takes it and passes it to the parent, that is to the information over here. See, in Java, this style of programming is compulsory, but not in Python. So Python, if you skip all this stuff, it's okay. He understands that this is invariably there. Okay. The further is print info. We print the details. Set learner data will set more data, which I can display as you can see here. Okay, right? Shutano has a question coming in. Is there any field hiding concept in Python? Yes, by keeping underscore. So when you're declaring variables in self, Shutano, you can keep underscore, but usually not much used until unless you're doing something which really needs the functionality of a private variable. Otherwise, not much. Right. So friends, at the moment, I think we have done up till this point. Let us move ahead with hierarchical inheritance. Now, what does hierarchical inheritance mean? It means you're creating a hierarchy where there is one superior, one boss, and there are many subordinates. So there is one super or one parent class inherited by many subclasses or many child classes, right? So let's see this. Friends, I have got a class called information, which I'm taking it as the father class or the base class. Okay. What I have here is the class called learners, who are inheriting property from information. I've got another class called trainer, who is also inheriting properties from information. Because ultimately, learners, that is all of you, also have a name, age, and gender. Me also, no? I also, the trainer, have the same attributes, name, age, and gender. So both of us can inherit the same class. But although there are more attributes or a different attribute for learner data, which I'm trying to set through a function. Instead of using a constructor, I'm trying to set this. For trainer, also I'm trying to set this. You see, so let me run with the three things. I'm not adding the constructor here because now you have understood the trick of constructors. You've understood that Python virtual machine, which is an internal thing to Python, does the work of calling the constructor automatically. So you haven't to really do anything, even not thinking of the fact that I need to add constructors. And the best part is that Python does it the most efficiently, more than what you and I can think of doing. You see? So what we're doing here is I'm making object of learners. I am setting its data. Then I'm printing an information. You see? Right? And I am also displaying some information here. Further, I am making an object of trainer. You see? So trainer data, and I'm printing its information over here. You'll say, Rocky, how is it different? Different is because when I display the details of a trainer or use display function of learner, then I'm printing all details. Why? Because display trainer first is going to call print info. So all data parameters of the parent will get printed. Then the data of specific to trainer will get printed. On the other hand, in the case of simply display function of learners, first we are printing with details of the common part, which is name, age, and gender. And then I'm printing details specific to the learners, right? Now, I wish to now give you a small impromptu class work. Let me see. I'm giving an easy work so that you don't try permutation combinations and go in the confused state. Okay. I wish that you should add one attribute of own into each. I want one common attribute which you wish I wish you should have in information. Okay, obviously you'll print it then. I want in set learner data to have one very specific thing for a learner added up and one very specific thing added up for the trainer also. You get me, friends? You are getting me? I want you to think properly. Add one new attribute in the constructor of the parent class, that means information. Print it here in the print info. Okay. Similarly, think of one third parameter, which I wish you should add. That is one extra parameter in learners, as well as one extra parameter in trainer. Naturally, to go without saying that whatever extra you have added, you will, of course, print it in the display, respective display methods. Okay. Fine, friends. Obviously, when you call it also, you will have to pass an extra value. Please go ahead and share me your experience that what did you add in information class, what do you add in learner class, and what do you add in trainer class. Again, different people can think in different ways, but think logically, realistically correct. Okay, go ahead. Now, let me give you a small heads up of what is there after the break. Hold on. There is still time for the break to come. Please listen to me very carefully. I will talk about multiple inheritance. Okay, then talk about little confusing concepts like polymorphism. Idea is not to make you masters or make you do a lot of practice on this. So don't get me wrong. But the idea is just to tell you about polymorphism and terms like method overloading and operator overloading. Because if you tell to somebody in the market that I know oops, he's bound to ask you, okay, you know oops now, then what is overloading? What is overriding? And if my student says, no, I'm not heard of overloading and overriding, then it is going to be my insult. You see, I will feel bad. So I want you to at least know it conceptually. May not be in a position of altering the code and coding it yourself. So that is not what my expectation is. Trust me. You see, because so many concepts you learn in about 1-2 hours is not easy to digest. If I was at your position also, I would have been saturated. Then I'll talk about this thing called as abstraction. And to know the concept of abstraction, we will use a package called ABC. You say, okay, this is for, you're just calling it for fun. No, I'm not calling it for fun. ABC is a package in Python. How can I write from ABC for fun? So it is working, you see. So ABC stands for abstract classes. So we are doing this. Okay, so this is the last thing which we'll be doing in this notebook. And by the time we finish with this notebook, trust me, even if I touch that last topic, abstract, it'll be great. If I don't touch it, no problems. This is completely optional for me, but not overloading and overriding. That is not optional for me. Okay, so friends, are you with me? Are you with me in my thinking process of what I want to deliver to you? Right? This is not actually Python fundamentals, what I'm trying to talk about, but I know as a programmer, when you move ahead and you look at some program of machine learning or deep learning, every program you will see is importing from a package, some class, making an object using his methods. That point of time, if my student does not know basics of object-oriented programming, then he will not be able to leverage his understanding to make his own codes. You see, that is a point. Then that point, backtracking and learning this will not be a good thing. You see, once we move ahead, we move ahead. We should not look back. Okay, where the idea is very simple. I have, let's say 2 or more parent classes, and I wish to inherit from all of them. Okay, so let's try to look into it. Very first, I have a class called information, in which I'm holding information of a student or a trainer. You see, so I'm holding the student or a trainer information because name, age, gender are human information. Okay. The next is I have a class called course information. And in the course information, we have some weekend batches and some weekday batches information over here. Sorry. Okay. You would notice that I have not done really too much of hard work in course information. We have just made a dictionary where in a dictionary, I have a key, colon, I have a value. The value itself is a dictionary. This is called as a JSON format. Just for your information, friends, if you wish to kind of research more on it, this is called JSON formatting. And to do JSON formatting here in Python, what we do is that we make a dictionary of dictionary. Okay, dictionary of dictionary. By the way, dictionary in Python is nothing but a set of key value pairs. Okay, so this is something which you should research on your own after today's session. But you should note this down so that you know that I'm asking you to research on JSON formatting and dictionary of dictionary. So in Python, we achieve this. You see, in Python, we create dictionary of dictionary, which you can see above. You see as above. Okay, right now. So this is my key. This is my value. In the value, also this is the key and this is the value. Okay, maybe 12, 8, 6, and 5 are indicating the number of weeks or number of overall sessions required. Fine. Now, look, this is very interesting. So any learner, any student, at Simplilearn would have both the things. He will have his personal information, that is his name, age, and gender. And he will also have, I repeat, and he will also have information about the course in which he is enrolled. Let's be honest. How do you become a student of Simplilearn? You have enrolled in some course, right? Right. Otherwise, you're not a student of Simplilearn, right? So a student of Simplilearn will have his own information and also the information of the course in which he has enrolled. Therefore, please notice, I'm doing a traditional way of programming, so things look simple and nice. I've asked for 4 information: name, also age, gender, name, age, gender, to fill the information into the information, course and preference to feed course info. Okay. I remember one of my friends asking me this. Now it is the right time. I should tell you that, Rocky, how would you call the constructors of my super classes? But notice now I've got 2 super classes, not 1. So in Python, whenever I do multiple inheritance, this is the pattern of coding. I can't leave it to super. Understand? Super will not know whom to call. Super means parent, but I've got 2 parents. Whom should I call? Whom I'm calling? A or B? I can have 3 parents, A, B, C. Who I'm calling? So you need to specify the name of the class dot the name of the constructor which you're planning to call. Self is compulsory, friends. There's no question, no doubt about it. Don't even think twice. Self is compulsory. Okay. Use it, Rocky. In information, you're calling the constructor and passing some data. In course info, also you are calling the constructor, but why not passing parameters? Friends, please appreciate the fact that in course info, my constructor is not requiring any parameter. So why should I pass anything? Isn't it? It's not requiring no anything. So hence I'm not passing any parameter. Okay. The next comes is self.course is equal to course. Why? Because once you have done with, you see, once you have done with creating an object of the class course info, you see, now you have got 2 parameters which you want to assign, no? One is a course and one is a preference. So course is being assigned to course parameter, preference being assigned to preference parameter. These 2 parameters are being created. These 2 parameters are not parameters of course, no. These 2 parameters are parameters of my learner. That is of you, my friends. This is the parameter of every learner. He is enrolling into one of the courses of these 2, and he is having a preference. Let me show this in running to you so that it becomes very clear. Please give me a minute. Let me see. Have I run the above cells? No, I am not. First cell running, second cell running, learner's cell running. Okay. Display information is very straightforward. I'm calling the class informations print info function. I'm printing all parameters here. Further, I can notice self.info. I am picking up the preference and course parameters, assigning to the variable weeks, and I'm printing weeks. I'll show you how it works. This will go into the name of the person. This is going into age. This is going into gender. Data science with R has been the course which the person has selected, and weekend has been the preference. There are 2 choices, weekday and weekend. That has been the case. And further, what I do is I call a function called display. Display calls this thing where I go on printing. So print info will print these 3 information. When I'm printing course and preference, as you can see, course and preference, I printed these 2. Okay. Now what I'm doing is I am finding the number of weeks. So first I go to self.info, that is this fellow here. Then from here, I'm trying to find what has been your preference. So your preference has been weekend. So I go here. So this whole dictionary is loaded. In this dictionary, I am trying to find the index or the key called data science with R to get this final value, which I come to understand as 5 weeks. So after all this step, I get the number of weeks in this variable, which I'm printing here. I get the number of weeks as 5. You get me, friends? Right? I hope I not confuse anybody. So friends, I request your attention once again on my screens. We're looking into a little difficult topic called polymorphism. By the way, what does polymorphism mean? Poly means, by the way, all of us are polymorphic. At the moment, we are student or learners. After the session finishes at 10 p.m., we are brother, sister, husband, wife, mom, dad to our family, right? You play different roles, right? So all of us play different roles. We are the same person, but this is Rocky only, this is Akash only, this is Racha only. You are the same person, but you're playing different roles when your environment changes. Right now, your environment is a classroom, a virtual classroom. So you're behaving as a student or learner. Once the class finishes, you could be husband, wife, father, mother to someone. So you see, so your role changes. Hence, I say that we all are polymorphic. So polymorphism means one person or one object, but behaving differently in different environments. Now, how do I demonstrate that to you? Have a look. So I've got a class information here, same as above, no difference, which is holding information for anyone, maybe a learner, maybe a trainer. Then I have a learner in which, if you notice carefully, I'm doing repeat work. This is like C++ and Java style of programming. You see, not a very optimum style of programming, but I'm doing it for purpose of simplicity. Please notice, I'm accepting some parameters here. The class learners, and the class learners is accepting name, age, gender. You will say these things were there above. So, but I agree, but learner is having no connection to the information. No, please understand, learner is not inheriting information. So learners have no idea about information class. So obviously every learner must have age, name and gender, and he may also have experience and qualification. So I use a constructor, accept all data parameters, printing it here, and kind of using them here. So let me run this 3 code cells. By the way, nothing polymorphic has happened up till now. I repeat, nothing polymorphic has happened up till now. So please wait. Now, let me bring a very simple notion of polymorphism. Please notice that the function called print info has the same name in both the cases, you can see. But one who's calling it decides the output of print info. If object one is calling, which I say is the environment of print info, my output is changing. The print info function, I agree the body's definitions are different, but the name is same. If my environment changes here, then my output changes. This is a very raw example of method overloading, because you don't have method overloading concept actually in Python. You see, like unlike Java and C++, this is very common. It is not common here. It's not common to overload methods in Python. So the whole idea here is that I can define in my same project, I can define multiple classes, all having the same function name called print info. Think it this way. I have a class called savings account where I'm printing details of my account, print info. I'm having another class called current account. I'm also printing same function, print info. Name of function across various classes in a single project can be same, but output may not be same. It totally depends who is calling the method. Accordingly, that version is being called. You see, here, you know it, friends, very well, that the version of information is being called, right? So this is the version of information being called. I mean to say information class. Version of information class being called. And what is here? This is the version of the learners class being called. You get me, friends? Right? If you're wondering that Rocky in Java, it was very beautiful to overload. No, that's not as beautiful as here it is. You see, it's not. Prabhu, when you say print info is a part of parent and child, that is overriding. It will not be overloading. Overloading has to be, you know, you see, that is overriding. If I define a print info different version in a child, it overrides that of this thing. So in the case, normally what happens, Prabhu, overloading means what? Overloading technically means this, that this is a class. Okay, let's say I've got a function called a with no parameter. I define another function called a with, let's say, 2 parameters. Okay, this is called overloading in the same class. So if I call a with no parameters, this fellow will be called. If I call a with 2 parameters, then this fellow will be called. But the problem is that, Prabhu, this is not allowed in Python. So if I cannot code 2 methods with the same name, but difference in parameters, then technically I'm not allowed to do method overloading. So the definition has got little twisted in Python or for Python programmers. So here we have a diluted version of overloading, and this diluted version of overloading means that in a single project, let's say I've got 5 classes, and all those 5 classes have the same method name. Then no need to worry. One of them will be called depending upon its environment. And to be very honest, the environment here is nothing other than the object name which is being used to call it. Okay, because the object name gets trapped in the variable called self, which decides its environment. And thereby it prints all the details according to the environment. Hence, this is a diluted version. So if you look at Java perspective or C++ perspective, this is a diluted version of overloading. But for Python programmers, this is not diluted. This is okay version. This is the fine version of overloading. Yeah, but honestly speaking, because most of us have come from backgrounds of C++ and Java, yes, this is very much a diluted version of it. You're correct, bro. I'm with you on that. Okay. Yeah. So friends, I now request you to look at what is operator overloading. And this is very simple. This is like childish because I can use the plus operator not only for adding numbers. So it depends what is around the plus. If the left and the right operand of the plus symbol is numbers, then it is going to add. But if the left and the right operand of the plus symbol is supposedly strings, and is not going to add, it's going to concat. So the idea is that the same operator can do work differently depending upon its environment. And the environment of an operator is nothing but its left and the right operands. You see, it's called polymorphism. That's called operator overloading. Right now, friends, I'm giving you maybe 3 to 4 minutes where if you wish to add something the way I have added things here, so it will be great if you can do that. And then we proceed further to the concept of overriding. Nagdeep, I'll come to your question. You're asking in Python, can we give a custom meaning to an operator like we do in C++? I'm sorry, we cannot do that. Yep, we cannot do that. Yep, explicit operator overloading is not allowed because we have something called as magic operators, Nagdeep, here, but we don't have kind of time to get into that factor. But then there's something called as magic operators. Do Google on that and get that information. You see, so that will give you an idea of what magic operators are. But yes, you can create your own operator overloading through class programming. It is not as easy as it is in C++. It is a little tricky here in Python, but if you want to have your own special operators, which will have its own meaning, yes, absolutely possible. We can. Yeah, that's called magic operator operators. One is there, and then it's called user-defined operator overloading. Yeah, but you need to make a class and then write very detailed class-based programming for that. Yeah. Okay. The next, friends, is the point that gone through all this stuff. Hold on. Overriding. Okay. So, friends, now after finishing an operator overloading, I'm coming to the word overriding. Read this carefully, please. It's overriding, not overloading. Overriding means that you are redefining something. Think it this way. For all beginners, please consider the word overriding as redefining. Okay. So in my class information, you see this piece of code, which is standard. We have been doing this code for long now. Now imagine this now. Suppose you say, Rocky, my class learners is definitely inheriting information, due to which I will be able to access name, age, and gender. I'll say naturally yes. But what I'm doing is, in my class learners, I'm making an explicit constructor. Okay. Name, age, and gender, which I'm accepting from the outside world, that I'm accepting to pass it to my parent, as you can see over here. You see, as you can see over here. And the other two parameters I'm accepting from the outside world for myself. Okay. Now, a very humble, simple question I'd like to ask you. Friends, the print info function of the parent class, that is information, is only capable of printing three things, isn't it? It's only capable of printing three things, namely age, name, and gender. But I want the print info now in learners, not only to print name, age, and gender, but also to print experience and qualification. So what will I do? Simple. You redefine. I'm redefining print info. Do not forget, because of inheritance, you already have got one print info from the parent. Don't forget that, please. But you don't want to use it. Hence your overriding. Notice my comment here. Print info function, this print info function of derived class being child class is overriding, means you're redefining the print info function of parent class. Now remember the trick here. Huh? Even if you tell me that, Rocky, I would like to print name, age, and gender, I'll say, I'm sorry, I can't print it. I can only print qualification and experience. Let me just show you. I made an object of learners, okay, and I'm calling print info. You see what it prints. You'll say, oh my God, it's printing only qualification and experience. It's not printing the other parameters. It cannot, because you have overridden it. You see, you have overridden it. Now I'm giving you an impromptu question. I'm giving you an impromptu question. I'm not asking you for to code an answer, just logical. If I want to call this print info from this child print info, question is, can I or I cannot? Question is, can I or I cannot? Answer is yes, I can. Absolutely, Prabhu. Very good. Very good, everyone. If you wish, you can definitely do that. Yes. Yeah. Okay. Syntax is not a problem. There is a whole world of Gen AI tools to give you the syntax. That's not a problem. Question is that logically, can I? Answer is yes, we can. Okay. Okay. Now, please have a careful look. That is exactly what I did. Therefore, I asked you this question. Exactly what I did in the next piece of code. Again, I redefined class learners, inheriting for information, same constructor, no difference. Print info once again is overriding, but now I realized my mistake now. I told Hari, what is the use of printing only qualification and experience? Where are the name of the student? So I need to call print info of my parent, but that is all anyway overridden. It is like recoded. So how do I call? I can call no. I can give the name of the class. So I give the name of the class information, and then I am calling print info ahead of it. Simple, sorted. By doing so, now if you notice very carefully, you would get the information of both. So I really appreciate Akash and Prabhu. What you answered is absolutely correct. Instead of super, just one correction. No super over here needed. Just name the class and call the function. So simple. Okay. Right. So friends, I am giving you about maybe 3 minutes. Can you please execute all these code blocks? I'm holding on. Great. So friends, I hope you have also taken down, this comments. I hope you have read this very carefully. Okay, right. So we move on further into the next thing called abstraction. First, look at the coding syntax, and then I will tell you what exactly are we trying to indicate. So from abstract AB, abstract C class, from abstract class, from ABC, I import abstract method and ABC. So we are importing this. By the way, ABC is actually a super class. By rule, whenever you make an abstract class in which you just declare methods, you don't define them. I repeat, when you make an abstract class, you are only declaring methods, you don't define them. The one who is inheriting, you see, one who is inheriting the class, that is the abstract class, will take responsibility by compulsion to code the methods. So the idea is that I think in real time, you have beverages in the menu, but there could be many beverages. You probably could have, tea, coffee, mango shake, orange juice, whatever. All these are beverages. So, or whatever category they are in the menu. So all these things in the category of beverages will have to specify their ingredients and will have to specify their taste. So in simple words, I am having methods which I'm forcing my children classes to code. Now, how do you force? I don't want to override, I say. I want to force them to code. So the simplest way is you make a class which is abstract in nature. And the easiest way of doing it is you write a class, say it is extending ABC. Okay, and from the package ABC, I've imported two things. I've imported the super class ABC, which means abstract class, and I've imported indicator. This is called actually as a modifier or an indicator or a qualifier or a decorator. So many words Python programmers use. This is, okay, more common word is decorator. So this is a decorator where I'm writing a decorator over the function called ingredients, and this is an abstract method. You see? So, okay, is it necessary to write? Well, it's a good practice to write. If you don't write, nothing is going to happen. You see, but then it is a good practice to write this. You get me? Right? So, because anyway, both of these are abstract methods by default because this class is extending ABC. So by default, it has to have abstract method. Now you'll say, Rocky, if I declare a method, if I make a class which is abstract, how? Okay, fine. It has got all abstract methods, is fine. But then what else? What else? You cannot make a direct object. You see, you cannot make a direct object of an abstract class. You will get an error. Cannot instantiate abstract class beverage with abstract method ingredients. In fact, you can mark the other method as abstract too. Try doing it. Making this, running this. Your error still remains the same, but you will get both of them now, ingredients and taste both. Now, other things are going to work. You see it, no? Why should I say anything? You see it for yourself. You see? So mango shake is extending beverage. So mango shake has to take responsibility to code two functions now. This is one, this is two. Same applies for any other beverage, orange juice, tea, coffee, whatever. Now, can I make objects of mango shake and ingredients? Yes, of course, of course. You can make object of mango shake, you can make object of orange juice. Welcome. All child you can make objects. Okay, Nagdeep, ABC is not a dummy word. ABC means abstract class. Okay, ABC in Python means abstract class. This is a keyword. I'm importing this class and I'm importing this decorator from the package ABC. You get me? It's not dummy ABC or XYZ. Okay, right. Everyone will please try out this code from here up till the end. Please try out this code and please make sure you write down abstract methods for both.
Let's see what operators are in Python. Now, operators are generally used to perform operations on values and variables in Python. These are standard symbols used for logical and arithmetic operations. The value that the operator operates on is called the operand. So here on your screens, you can see the different types of operators available in Python. First, we have arithmetic operators. So arithmetic operators are used to perform mathematical operations. It returns either true or false according to the condition. So these are the comparison operators. You have less than, greater than, less than equal to, greater than equal to. We have not equal to, and we have equal to equal to. Third, we have assignment operators. So assignment operators are used in Python to assign values to variables. So these are the assignment operators. You have equal to, you have plus equal to. So for example, you have a variable called x, and if you say x plus equal to 7, this means it is x equal to x plus 7. Similarly, if you say x minus equal to 7, this means x equal to x minus 7. And similarly, you can see the other assignment operators here. Next up, we have the logical operators. So logical operators are used in the expression evaluation to make a decision. If both the expressions are true, then the condition will be true for an AND operator. For an OR operator, if one of the expressions is true, then the OR condition will be true. Now for NOT, if an expression A is true, then NOT A will be false. We also have bitwise operators. So bitwise operators act on operands as if they were strings of binary digits. It acts on bits and performs bit by bit operation. So hence it is called bitwise operator. So here each value is evaluated as zeros and ones. Then we have identity operators. So identity operators are used to check if two values are located on the same part of the memory. Two variables that are equal does not imply that they are identical. We'll understand each of these operators in the demo session on the Jupyter Notebook. And finally, we have membership operators. So membership operators are used to test whether a value or variable is in a sequence. So you have is and is not as identity operators. In membership operators, we have in and not in. Now let's head over to our Jupyter Notebook and we'll see and explore all these operators one by one. So I am on my Jupyter Notebook, operators in Python. So let's first start with arithmetic operators. I'll just give a comment here saying arithmetic operators. Okay. First up, we'll see the addition operator. For that, let me assign two variables. So I have assigned a variable x to a value 10, and let's say we have the second variable y equal to 4. Now if I say print x plus y, it will perform an arithmetic operation, that is addition, and will sum the result of x and y and gives me 14, because 10 plus 4 is 14. Now let's say I'll write print x minus y, that gives me 6 because 10 minus 4 is 6. Similarly, you can have multiplication as well. So I'll write x asterisk y, that gives me 40 because 10 multiplied by 4 is 40. Similarly, let's say x divided by y. It gives me 2.5, which is basically the quotient of these two operands. Alright. Now, if you were to find the remainder, you can use the modulus operator. So I'll write x modulo y. It gives me 2. So you divide 10 by 4, the remainder is 2. Now you can use the double asterisk operator, which is basically known as power. So the left operand is raised to the power of right. I'll write print x, give 2 asterisks, and then say y. It gives me 10,000. So what basically Python does is it will raise 10 to the power of 4. So 10 is multiplied 4 times and the result is 10,000. You can also try out another example. Let's say 2 raised to the power of 4. This gives me 16. If I say 2 raised to the power of 3, that is 2 cube, and the result is 8. You can also perform floor division. So floor division results into whole number adjusted to the left in the number line. So if I write print x, and floor division is given by 2 /, then I'll write y, that gives me 2. So it returns a whole number. A generic division gives me 2.5, that has the floating point value, but a floor division will give me a whole number adjusted to the left on the number line. Alright, so these are some of the basic arithmetic operators that are very popular in Python. Next, we'll move on to assignment operators. I'll give a comment as assignment operators. Okay. Let's assign a value x equal to 7. So here we are assigning the value of 7 to x, and your equal to is an example of assignment operator. Now if I print x, it will give me 7. Now let's say I'll again write x equal to 7, and in the next line I'll write x plus equal to 3, and will print x. So what Python does is it adds 3 to my original value that x holds, that is 7. So here x plus equal to 3 means x equal to x plus 3. So x equal to x plus 3 can be written as x plus equal to 3. Similarly, you can also write x minus equal to something. Say x equal to 7, and then I write x minus equal to 3. Then we'll print x. This gives me 4 because we are subtracting the original value of x by 3. So here x minus equal to 3 means x equal to x minus 3. Okay. Similarly, let's say I'll write x asterisk equal to 3. If I run it and print the value of x, it gives me 12 because our previous x value was 4, and now we have multiplied x by 3. So x value now becomes 12. Let's say I'll write x divided by 3, and I'll print x. It gives me 4.0. This is a floating point number. So we are dividing 12 by 3, and the result is 4.0. Cool. If you want, you can also perform an exponent operation or a power operation. So let's say I have x equal to 7, and then I write x double asterisk equal to say 2, and then we'll print x. Okay, there is an error here. Let's debug the error. I have put a space here. Let's delete that space. You have to keep this in mind. Now let's run it. There you go. So 7 raised to the power of 2, which is basically 7 square, is 49. You can change the values and run other examples. Let's say 10 raised to the power of 3. We have 1000 as the result. Okay. Now moving ahead. Now we'll understand about comparison operators. So I'll give a comment as comparison operators. Okay. Let's say I have x equal to 7, and then I have y equal to 3. If I print x equal to y, it will give me false. The reason being, the value that x holds is not equal to the value present in y. These are two different values that x and y hold. So x is not equal to y, and if we print x equal to y, it will give us false. Now I'll just copy this code. I'll print it here, and instead of equal to, I'll give not equal to. So not equal to is represented by an exclamation mark followed by an equal to. If I write x not equal to y, this gives us true because x and y are two different values and they are not equal. I'll print my code again, and this time let's say I'll write x greater than y. It gives us true because 7 is greater than 3. If I write x less than y and hit shift enter, that gives me false because 7 is not less than 3. I'll print the code again. This time we'll see if x is greater than equal to 3. If I run it, it is true because 7 is greater than equal to 3. And now let's check for less than equal to. This is false because 7 is not less than equal to 3. Okay, so these are some of the basic comparison operators that are available in Python. Now moving ahead, we'll see how logical operators work in Python. Okay, first we'll look at the AND operator in Python. Suppose I have a value of 7 stored in x and then I have a value of 12 stored in y. If I write print x greater than 2 and y less than 10, let's run it and see the result. It gives us false. Now AND logical operators will return true if both the conditions are true, and it will return false even if one of the condition is false. So here x is greater than 2, which means 7 is greater than 2 is true, but y less than 10, which is 12 less than 10 is false, and hence our entire expression becomes false. Next, let's say I have x equal to 5 and then I'll print x greater than 3 or x less than 10. If I run this, it returns us true. The reason being x greater than 3 is true, which means 5 is greater than 3, that is true, but 5 is not less than 10. But since one of the conditions is true, so the OR operation in Python returns us true. Now let's see another example. I'll write x equal to 5 and y equal to 10. I'll print x greater than 10 or y less than 20. If I run this, it returns true. So let's see our expression. X greater than 10, that is 5 greater than 10 is false, but y less than 20, so 10 is less than 20 is true. So our OR operation will give us true since one of the condition is true. Now moving to the next logical operator, we have NOT. I'll give an comment here as OR, and now we'll see NOT. Let's say I have x equal to 5 and then I'll print x greater than 3 and x less than 10. This should ideally give us true. The reason being x is greater than 3 and x is less than 10. Let's run and verify. Okay, so this is true. Now let me copy this and I'll paste it in the next cell. Now I'll replace my above print statement with a NOT operator, and we'll close our print function with another bracket. Now let's run it. So this will give us false because my expression evaluates to true, but not true is false. Okay, now moving ahead, let's discuss identity operators in Python. Alright, so we'll start by assigning a value of, let's say, 505 to x, and then in y I'll have 500 plus 5, so which is also 505. So x and y hold the same value of 505. Now I'll print x comma y. So you can see here both the values are same, 505 for x and y. Now I'll use the logical operator, that is double equal to or equal to. I'll write x equal to y. This will give us true because x and y hold the same value of 505. But let's check with the identity operator. So I'll write x is y. If I run this, it gives me false. The reason being, x and y both refer to objects whose value is 505. They are equal, but they are not referencing to the same object. Now this you can verify using the id function in Python. If I write id of x, this will give me the memory location that x has. You can see this is the memory location of x. If I write id of y, there you go. So this is a separate memory location in which y is holding the value of 505, and hence x is y is different, and hence it is false. Now suppose I write x equal to 100 and I have y equal to 200. If I write x is not y, this gives us true. The reason being, x and y both are holding different values, so x is not y is true. Let's see another example. This time we'll define two lists. So I have a list called A that has value, let's say 5, 6, 3, 7, 1, let's say 9. And then I'll have another list that will also have the same elements. I'll copy this and I'll paste it here. Okay, if I write C equal to A, and then we'll print A is C. If I run this, it gives us true because we are assigning the variable A to C, and hence the memory locations are the same for both, and hence A is C gives us true. What if I write A is B? Now this gives us false. So here A and B are both less. They are equal but not identical. It is because the interpreter in Python allocates them separately in memory although they are equal. Okay, now let's talk about membership operators in Python. I'll give a comment as membership operators. Okay, let's say I have a list A that has the above values 5, 6, 3, 7, 1 and 9. I'll copy this and I'll paste it here. Okay, I have another list B that has different types of elements. We have 4, next element is Python, then we have 2, 7, let's say Simplilearn, and then I have 9. I'll run this first. So I have my two lists A and B. I have printed them. Let's explore how the membership operator works. So we saw in the slides, in and not in are two membership operators. If I write 5 in A and run it, it returns me true because you see here 5 is present in A, and hence 5 in A will return true. What if I write 55 in A? This gives us false because you see here in the list A we don't have an item 55 in A. So it gives us false. What if I write 4 in B? This gives me true. You see here in B we have the element 4, so 4 in B is true. One thing I wanted to show you is what if I write Python in B? You see here it gives us false. Though we have Python in our list B, but the Python I'm trying to check is not present in B. The reason being here Python is written in lowercase, but what I am checking, Python P is in uppercase, so it is case sensitive, and hence this gives me false. Let's say I'll declare a dictionary y equal to, and within curly braces I'll give my key A and I'll assign the value of India. Let's say I have another key B and that has a value, let's say USA. Now if I check A in Y, it gives me true because your key A is present in Y. Now what if I check India in Y? Now this gives me false. So here the membership operator won't work on the values, it only works on keys in a dictionary. Now let me go ahead and change the keys to numbers. I'll give 1 that has India and the second key I'll have 2. Now if I change A to 1, it will work fine, it gives me India, but if I write USA in Y, it gives me false. As I said, the membership operator won't work on the values, it only works on the keys in a dictionary. Cool. Now coming to the final section of our demo, we'll explore about bitwise operator. Okay. So Python bitwise AND operator returns 1 if both the bits are 1, otherwise it will return 0. So first let's see 7 ampersand 2. If I run it, it gives me the value of 2. So what Python does is it will first convert the numbers 7 and 2 to their binary equivalents, that is in the form of zeros and ones, and then it will perform the bitwise AND operation. So 7 ampersand 2, the value is 2. If I write 3 ampersand 5, the value is 1. Again, it will first convert 3 and 5 to binary equivalents in the form of zeros and ones, and then it will perform the AND operation, the bitwise AND operation. Now the Python bitwise OR operator returns 1 if any of the bits is 1. If both the bits are 0, it will return 0. So if I write 10 or 5, it gives me 15. So first it will convert 10 and 5 to binary equivalents, and then it will perform the bitwise OR operation. Let's see another example. I'll write 4 or 8. I'll run it. So the bitwise OR operation gives us 12 as the result. Alright. Conditional statements in Python perform specific operations and take actions depending on whether a specific Boolean constant evaluates to true or false. Conditional statements are handled by blocks of if statements in Python. Now, conditional statements are also known as decision-making statements. So Python provides different types of conditional statements that you can use to make decisions. We have the simple if statement, then we have if-else statement, elif statement, the nested if statement, as well as nested if-else statement. We will learn them one by one with the help of their syntax and code examples. So this is how the syntax of if statement looks like. So you pass in the if condition and then we have a set of statements inside the if condition. So on the right side you can see the flow diagram how the if statement gets evaluated. So first we have the test expression, that is the if condition. Now if this expression evaluates to true, then we go inside the body of the if statement. So this is basically the body of the if statement that contains a list of statements or blocks of statements. Now if the test expression evaluates to false, we execute the statements that are present after the if condition. Alright, now let me take you to my Jupyter notebook where we'll understand if statement with an example. Okay, so here I am on my Jupyter notebook. I'll just rename this to conditional statements. I'll see it as demo and we'll rename it. Okay, I'll just expand the screen size. Alright, okay, so first of all let's write a simple if statement. I have given a comment here. Suppose we have a variable called grade and the value of grade is 80. Then I'll write my if statement as if grade is greater than equal to 50. Then I'll give a colon. Then I'll write a print statement, print passed in the exam. Now this is how you write a simple if statement. So you have the if keyword followed by the condition. So here my condition is I'm checking whether the grade is greater than equal to 50. Now here I have already defined my grade to 80. So this if statement or the if condition will check whether 80 is greater than equal to 50. Now this is true. Then my print statement gets executed. Let me run it and show you the result. There you go. Here you can see we have our printed message as passed in the exam because 80 is greater than equal to 50. Now what if I change this to, let's say, 30? If I run this, there is no output here. The reason being 30 is greater than equal to 50 is false. So my print statement did not execute. Okay. Now if you want, you can also print another statement outside the if condition. I'll give the message as execute statement after if. Now one thing to remember that this print statement is outside the if condition. So if I run it, only my last print statement gets executed, which is outside the if condition. Okay, now let's write another simple if statement. Now this time we are not going to define the grade value or predefine the grade value. Here we are going to take the grade value as an input, that is a user input. So I'll write grade equal to, now the way to take a user input is by using the input function. So first of all we need to convert our entry into an integer. So I'll write int function and inside that I'll pass in my input function. Then I'll give my message as enter the number. Alright, so this statement will take the number from the user. Now I'll write my if statement if grade is greater than equal to 50, then it won't give a space here. Let's delete the space. Then I'll write print you have passed in the exam. Okay, let's run it. You see here my program is asking for the user input. It says enter the number. I'll give my number as, let's say, 60. If I hit enter, that gives me the result passed in the exam. Now let's run it again. This time I'm going to give as, let's say, 35. If I run it, there is no output here. The reason being our grade 35 is not greater than equal to 50, so our print statement did not execute. Alright, okay, now let me give a space here. We'll run it again, and this time we'll pass our grade as, let's say, 75. Let me run it. You can see here it gives me the message passed in the exam. Now moving to our next statement, we have the if-else statement. So this is how the syntax of if-else statement looks like. So first you have the if condition followed by a colon. If this condition evaluates to true, then we execute the list of statements that are present inside this if condition. Else, we have the else block here. If this condition returns false, then we execute the list of else statements. So here is the flow of how the if-else statement executes the different statements. So first we check the test expression. If that evaluates to true, then we have the body of if, and if it is false, then we have the body of else, and later there are any statements that are present outside the if-else block, we'll execute those statements. Now let's head over to our Jupyter notebook and we'll see how the if-else statement works by example. Okay, so here I'll show you another example of using two if statements. So I'll define my grade as 40. I'll write if grade is greater than equal to 50, then we'll print, let's say, pass. Then I'll write another if statement. I'll say if grade is less than 50, then we'll print fail. Now here I'm using two if statements. Let me run it. You see here I have my result as fail. The reason being our grade 40 is less than 50 and hence it has printed fail. Now instead of using two if statements, you can use the if-else statement. So in this case, we'll have our if statement checked for if grade is greater than equal to 50. If this is true, then we'll print whatever is there inside the if statement. But in case this evaluates to false, we have another else block that we are going to write. Let me show you how to write the if-else statement. So I'll give a comment as if-else. Okay, I'll say grade equal to 40, then we'll check if grade is greater than equal to 50, print pass. Then instead of using the if statement again, I'll write else followed by a colon, and then I'll write print fail. Make sure this fail is inside double quotations. If I run it, it gives me the result fail. The reason being 40 is not less than, repeat, 40 is not greater than equal to 50, so hence it has printed fail. Now instead of taking the value as 40, we can have the user give the input. So we'll use the input function. I'll say enter the grade. Let's run it again. You see here my program is asking for the user input. Let's say I'll give 80. We'll run it. It says pass because 80 is greater than equal to 50. Let me run it again. This time let's say I'll pass my grade as 45. We'll run it. It gives us fail. Alright. Now moving to our next conditional statement, we have the elif statement. Now this is how the syntax of elif statement looks like. So here first we have the if condition. Now if the if condition evaluates to true, we have the body of if. That is basically a set of statements. Now if the first test expression or the if condition evaluates to false, then our elif condition gets executed. Now if our elif condition is true, then we have the body of elif. So this is the elif statement body. Finally, if the elif condition also evaluates to false, then we have the block of else statements. You can see here we have body of else, and later if there are any statements outside this if, elif and else block, then those statements get executed. Now we'll see this with the help of examples. Okay, so here on my cell I'll give my comment as elif statement. Okay, suppose I have a variable called score and this take the value as integer from the user. So I'm using the input function. I'll say enter the score. I'll give a space. Then I'll write my if condition. I'll say if score is, let's say, greater than equal to 90, give a colon, then we'll print our message as passed the exam with, let's say, A grade. I'll just copy this statement because we are going to print similar statement below as well. And now I'll have my elif condition. I'll write elif. Elif is actually else if score is greater than equal to, let's say, 75. I'll give a colon, will print passed the exam with B grade. Then I'll again have my elif statement. I'll write if score is greater than equal to, let's say, 60, will print pass the exam with C grade. Next, let's write another elif condition. I'll write elif if score is greater than, this should be greater than equal to, okay, is greater than equal to, let's say, 40, then we'll print pass the exam with D grade. And finally we'll have the else condition. I'll write print, let me just scroll down, failed in the exam. Okay, so this is how you write a elif conditional statement. So first I'm taking the user input of the score, then I'm checking if score is greater than equal to 90. I'm displaying my message as pass the exam with A grade. Then I have a list of elif statements to check for different scores. If all these evaluates to false, I am having my else statement printed. Let's run it. Okay, so we'll try out different scores. Let's say someone scored 95. If I run it, so that candidate has passed the exam with E grade, because if you see the condition, my score 95 is greater than equal to 90, and hence we have passed the exam with A grade as the message. We'll run it again. Let's say I have 80. If I run it, it says pass the exam with B grade. The reason being, 80 is greater than or equal to 75, and hence we have this message printed. Let's run it again. Suppose someone scored, let's say 25. If I run it, okay, it throws me an error. It says name score not defined. Okay, so this should be score actually. Here there was a spelling mistake. I'll run it. I'll pass my score as 25. It gives me failed in the exam. The reason being my score 25 is less than or equal to 40, and hence we have failed in the exam. Cool. Now you can also use a for loop and then have a list of if-else block or if-else statements. Let me show you how to do it. Suppose I write for x in, I'll use the range function. I'll go till 10, which means from 0 to 9. Then I'm checking if my x is less than or equal to 3. I'll print x is less than or equal to 3. Okay, now we have the elif statement. If elif x greater than 5, I'll print x is greater than 5. Then we have the else condition. Will print, let me just scroll down. I'll print x must be 4 or 5. Okay, so here I have used a for loop and I am checking for each iteration from 0 to 9, and then we have a set of if, elif and else statements. Let's run it. There you go. You can see the output here. So first in my range I have 0, so it will check if 0 is less than or equal to 3, which is true, so it has printed 0 is less than or equal to 3. So it will go till 3, and then when 4 comes, it will check if 4 is greater than 5. Now this is also false, so it will skip executing the elif statement, and it will print whatever is there in the else block, which is 4 must be 4 or 5. So you can see the message here, 4 must be 4 and 5. Similarly for 5 also the same message will be printed, the reason being 5 is not greater than 5. And then for the rest of the numbers from 6 to 9, we have 6 is greater than 5, 7 is greater than 5, 8 is greater than 5, and 9 is greater than 5. Alright. Now moving ahead, next we have the nested if statement. So here is the syntax of nested if. So you have the if condition, and inside the if condition you have another if condition, and hence it becomes the nested if condition statement. And inside this condition you have the list of statements or the blocks of statements. So here is how the flowchart or the flow diagram looks like. So first we are evaluating the expression 1, which is this condition. If it is true, we are going inside and checking the second condition. If that is also true, then we are running the body of if, which is this part of the syntax. And later, if there are any statements that are present outside the if condition, we are executing those. So in case the first test expression evaluates to false, we are coming outside and directly printing whatever is there outside the if condition. Let's see this with the help of an example. Okay, so I'll give my comment here as nested if. Cool. So first of all, I'll declare a variable called num. Now this num will have a user input value, So I'll write input, enter the number, then I'll have my first if condition. I'll say if number or NUM is less than 250, I'll give a colon, then we'll use the print statement num is smaller than 250. I'll write my second if statement and we'll check if num is less than 180 and we'll print num is smaller than 180 as well. Finally, I'll have my else statement as print number is greater than 180. Alright, let's run this, and first we'll check with the number 100. Okay, there you go. So here I'm checking whether 100 is less than 250, which is true. So we have printed 100 is smaller than 250. Again we are checking if 100 is less than 180, which is true again. So we are printing 100 is smaller than 180 as well. There's a spelling mistake. Okay. Now let's see for, let's say, 150. Again we have 150 is smaller than 250, 150 also smaller than 180. Let's run it. This time let's say we'll pass 300. Okay, you can see our result here. 300 is less than 250 is false, so we'll skip printing this. Again we'll check whether 300 is less than 180, which is false again, so we'll skip printing this statement as well. We'll only have our else block printed, which is 300 is greater than 180. Okay, now coming to the final section where we'll see about nested if else. So here you can see we have the syntax for nested if else statement. So we have an outer if condition, and inside that we have another if condition. Then we have the list of statements or the body of the if condition. If this is false, then we execute the else part, and after that we also have an outer else statement. So this is how the flow diagram looks like. We'll check for the test expression 1. If that is true, then we'll go inside and see the test expression 2, and if that is true, we'll execute the body of if statement, which is this part of the syntax. Then if these are false, then we'll see the body of else 1. If the second expression is false, then we go to the body of else 2, and after that if there are any more statements, we'll execute them as well. Alright, we'll see an example here. So I'll give my comment as nested if else. Okay, so I'll declare a variable a which will take a user input of type integer. I'll say enter the number. I'll write if a is less than 50. So this is my first if condition. If this is true, this should be less than 50. Okay, so if my first if statement is true, then we'll check for the second if statement, which is, let's say, if a modulus 3 equal to 0, which means if the remainder of the division is 0, then we say print a is divisible by 3 and is less than 50. Okay, then we have our else statement as else print my number A is not divisible by 3 but is less than 50. Finally, I'll have my last else statement where I'll print my number A is greater than 50. Okay, so this is how you write a nested if else statement. So I'm taking my number as a user input. First I'm checking if that number is less than 50. If that is true, I'm again checking if that number is divisible by 3. If it is divisible, I'm printing my message as the number E is divisible by 3 and is less than 50. If this is false, I'm saying the number E is not divisible by 3 but it is less than 50, else I'm saying the number is greater than 50. Let's run this and we'll try out different examples. Let's say I'll say my number is 12. My message is 12 is divisible by 3 and is less than 50, which is this part of the code. So my number 12 is less than 50. This is true. Then I'm again checking whether 12 is divisible by 3. It evaluates to true and hence we have this result printed. Okay, let's say this time I'll say 30. So I have my message 30 is divisible by 3 and is less than 50. Let's run it again and this time let's say we'll say 72. So here I have my message 72 is greater than 50. The reason being 72 less than 50 is false. Hence this part of the code is not executed. It will directly come to the else part which says 72 is greater than 50. Okay. So that brings us to the end of this demo session on conditional statements in Python. So first we learned how to write simple if statement. You saw how to take inputs from the user. We also learned how to write if else statement. Then you learned about elif statement. You also saw how to use a for loop, and inside that you can use your if statement, your elif, your else. Later on we saw how to write nested if statements, and finally we learned how to write nested if else statements.
Let's glance at the topics. Object-oriented programming in Python, some major principles of object-oriented programming, and then we will touch upon topics like class in Python, objects, methods, inheritance, the concepts of inheritance, the different type of inheritance, then the definition and examples of polymorphism, encapsulation and abstraction. So all these topics will be supported with examples and the relevant terminologies and definitions. Now, what is object-oriented programming? Python is an object-oriented language like any other programming language like Java, C++, and the object-oriented programming language concept is not new, and each and every mature programming language has these concepts imbibed in it. Now, the concept of object-oriented programming in Python focuses primarily on creating objects and making reusable codes. So whenever we start programming at a large scale or for a big project, it is very important to identify the objects within that particular project which you want to define. Now, for example, in this presentation, what you are seeing is that we are covered with full of objects like car, dog, tiger, tree, or a balloon. So these are typical examples of objects which you encounter in day-to-day life. Now, what are the major principles of object-oriented programming? So these are the different kind of terminologies. Classes are there. There are objects. There are methods. Then on these classes and objects, you apply inheritance, polymorphism, encapsulation, and abstraction. Now, what is a class? Class is nothing but a collection of objects, or we can say a user-defined data type, right? So basically, it's a complex data type which has a collection of objects, and within the objects, you have primitive data types like int, string, float, etc. So a class also holds the methods, the functions which basically perform operations on these objects, right? And also it also holds on to the attributes of the objects. So let's see with an example, right? So if you have an employee class, then it would contain attributes and methods such as email ID, name, age, salary. These are the attributes. And on the methods like, perform tasks, give presentation, increase salary, etc., etc. These are will be the methods. Now let's talk about what are objects in Python. Now, object is known as instantiation of a class, right? An object is a group of interrelated variables and methods. So when a class is defined, only the description for the object is defined. Therefore, no memory or storage is allocated at that point. So for example, if you see in this, motorbike is a class, but the different objects of that class are different kind of bikes by different brands like BMW, Suzuki, Royal Enfield. So they all have inherited the attributes of the class motorbike, and then on top of it define certain variables, additional variables and methods on top of it to enhance the motorbike and make it look different or function differently. Now, what are methods in Python? Methods are functions defined inside the body of a class, right? So basically, methods are something which you perform on a attributes of a class, right? Method is a function that is associated with an object. So you create an object of a class, and on that object, then you can execute those functions. In Python, a method is not unique to class instances. Any object type can have methods. And the methods define the behavior of an object. So that's why a BMW motorbike will be different from Royal Enfield, because the behavior is different. The methods are different. So if you see the example over here, you have a class bike, and in that there is an init function which will get invoked when you initialize the object of class bike, and then you can set the brand name and the year of manufacturing for that particular object. Now, inheritance. What is inheritance? Inheritance is something which you derive from a parent. So inheritance is like creating a new class that uses all the properties and behavior of another class. Now the new class is called the derived class or the child class, and the existing class whose properties are inherited is known as a base class or parent class. It provides, and the basic functionality, the usage of inheritance is that reusability of code. So if anything is defined in the parent class, then you don't need to rewrite that particular code in the child, you can just inherit it. So as I mentioned, let's take a look at the different types of inheritance which are available. You have single level, in which only one child is inheriting the properties and the attributes from the parent. Then you have multi-level, in which first child has inherited from the class A, class B has inherited, and then you have another class C which is inheriting from class B. So this is an example of multi-level, and we will be supporting all these concepts with an example in our Python notebook. Then there is hierarchical. Then there are two different classes which are inheriting from a single class, and then multiple inheritance, that single class is inheriting from two different parents. So these are different set varieties of inheritance basis what is the demand, what is the business requirement, you can define. Now what is polymorphism? Polymorphism in Python, what does it means? Polymorphism consists of two words, poly and morphs. Poly means many and morph means shape. So basically it means many shapes. So it means using a familiar interface for multiple forms, right? So you can use a single name of the method and which can perform different behavior based on the object in which it is invoked. So in simple terms, we understand that a task can be performed in various ways. Let's support it with an example. Like you have a plus operator. Now the plus operator can be used for integer data types to perform arithmetic operations, whereas when you use plus operator to in string data types, it can be used for concatenation. So it's a very typical example, very good example in terms of how an same operator can behave differently basis what data types are being used. Now let's talk about encapsulation. Using OOPS in Python, we can restrict access to methods and variables. So basically in Python, you can create something like as private variables, but of course you can't use a private keyword unlike Java. So in Python, we use underscore or double underscore in order to define private attributes. So basically, these attributes can be only used within the class and cannot be exposed outside a particular class. So we will see this with an example. Now, what is abstraction? Data abstraction and encapsulation are often used as synonyms. Abstraction is used to hide internal details and show only functionalities. For example, you know how to turn on or off a light using a switch, but you don't know what is happening behind the socket. Similarly, an abstract class cannot be instantiated, which means you cannot create objects for this class. You can only define the methods which have to be implemented by the classes which are inheriting the abstract class. So basically, abstract class provide only the method signatures and rest the other functionalities, and the implementation has to be done by the child classes. So let's now move to our Jupyter notebook and we will start performing certain examples. Now, as we are saying, like Python has objects. So let's create an object. We will create a class bikes over here. And within the class, we will define the init method. And in the init, we will instantiate two variables, brand name and year. Now we will create an object of bike which we are calling as BMW, and another we will create an object called Ducati. So what we are doing in this two scenarios is that we are just instantiating the bike object with variable BMW and Ducati. We are instantiating. Now let's print the year in manufacturing year, the brand name and the year for BMW and for Ducati, and let's see. Right, so what we have done is we have created an object for bikes. One we are calling BMW and one we are calling Ducati, and how we are differentiating between these two bikes is basis the brand name and the year of manufacturing. Now let's take a look at the example of methods. I'm going to rewrite my init method, and now I am creating a function, a method of top speed and a function of type now I'm going to create an object of bike. Now this method, this object bike can invoke methods top speed and type because they belong to the same class bikes. So initially when I created my object bikes, I'm instantiating it with BMW and the year, and then I am making a call to the method top speed, and then I'm making a call to the method type and printing. So basically I'm printing the output of the function top speed and output of the function BMW, form the object BMW which is of class bikes. Now let's take a look at an example of single level inheritance. Let's create a parent class called animal and create a method called sound, and let's create a child class cat which inherits animal, and let me just put a method over here. Here's the indentation. Okay, so now I have object parent class animal, child class cat which has inherited animal, and the parent class method is sound and the child class method is meow. So now I'll create an object called cat, and with this object I'll be able to invoke both child class method and the parent class method. And as you can see, the child class has inherited both parent and child class functions, methods. Now let's take a look at multi-level inheritance example. I'll start off with creating exactly the same parent class called animal. Then I'm already created another class. I'll create same child class cat, and now I'll create another class which will inherit cat class. So cat has inherited animal and cat child has inherited cat. Let's validate its syntax. And similarly now I'll create an object for cat child, and this cat child now can invoke the same methods which are in child, parent and the super parent. So this is an example of multi-level. This is an example of single level inheritance. Now let's take an example of polymorphism. We are going to create a class parrot and define the function fly and swim. Now we are going to create another class. Mind you, there is no inheritance here. We are just creating an independent class called penguin, and same methods now, the same name, fly and swim. Okay. Now let's make a function in which we will pass an object, and basis that what is the instance of the particular object bird, the corresponding method will get invoked. So let's see. In the method flying test, whatever instance of the bird object will be, the corresponding of method will be called. So now let's create a object of parrot class, and then let's create a object of penguin class. Now in my flying test method, first I'll send a object of instance parrot, and then I'll send the object of instance penguin. So now basis the instance type, when this bird.fly method will be called, it will be called basis the instance. So in the first case, the parrot, it will call this method, and in case of penguin, it will call this method fly. So please note what is the output. The output is a parrot can fly, but a penguin cannot fly. And it has been decided by the Python at the runtime that which particular method to be invoked basis the instance. So it's a very important concept. Now let's take an example of encapsulation. I'll make a class cars, define its init method. Now within that init method, I have created a private variable with underscore underscore max price and given a value of 9 lakh. Now I am creating another function called sell, and in that I am printing the max price. And then I am creating another function in which I am modifying the private variable set max price. So I will pass any value in the set max price, and it will replace the max price which I have set during the initialization at this point. Now let's create an object of class cars and see if I sell this, then the selling price is 9 lakh, what I had set at the time of initialization. Now what I'm trying to do is I'm trying to modify a private variable directly, c underscore underscore max price, and I want to check if I'm trying to create modify a private variable, will it still show me 9 lakh or 10 lakh value? And it's still showing me the 9 lakh value. It means that I can't directly approach or access the private variable. I can only modify it if I access it through a method which is set max price. In this, now I am setting the max price to 1000, and now if I print what is my max price, it will print as 1000. So this is the concept of encapsulation. You have a private variable which is accessible within only the methods of the class. You can't access it directly. Now let's take a look at hierarchical inheritance. I'll create a class employee and create an init method Within that, you have three variables: name, age, and salary. So an employee has name, age, and salary. Now I'm going to create a child class called child employee 1, which is inherited from employee, and child employee 2, which is also inherited from employee. So what I'm going to do is I'm going to create a object per child class and print. So this is a typical example in which you have two child classes which have inherited from the single parent, hierarchical inheritance. Now let's take a look at our last concept, which is abstraction. So now I'll create a class car and define a method mileage, but I am not giving any definition to it. I'm just giving a signature mileage. The child classes which will inherit abstract class will be giving the definition. So I'm creating a class BMW, which has inherited the car ABC car, but given the definition now. Similarly, I am creating another class Jaguar, which has inherited the class car, but now it is giving a different definition. It's printing mileage 25 km/h, and another class Range Rover, and another class Renault. Okay, so 4 classes which have implemented the abstract class method mileage in a different way. Now I'll create an object of first BMW and invoke method mileage. So it has invoked the method mileage on BMW car and printed mileage is 30 km. Similarly, I'll do for Renault. Jaguar and Range Rover. So if you see, the parent class, abstract parent class, has not implemented the method but just given the signature of the method, and all other classes have implemented it, and that's the concept of abstraction.
So what is a lambda function? A lambda function is one of the simplest ways to define a function in Python. A lambda function is an anonymous function defined without a name and does not have the def keyword. It can accept any number of arguments but can only have one expression. So the function is always defined using the lambda keyword, which you can see it here. So here we have the syntax for lambda function. We use the lambda keyword followed by the arguments, and then we have a colon. After that we have the expression that we want to evaluate. Cool. Now moving ahead, let's look at an example of using lambda function in Python. Now if you were to add two numbers in Python using a function, you would ideally use the def keyword followed by the function name and then pass in the arguments. You can see the arguments here, a and b. Then use the return statement to get the value of the addition. So we have return a plus b. And finally, you will call the add function and pass the argument values to get the result. Now this operation can be done using the lambda function as shown here. So we have defined a variable called add, which is equal to, and then we have used the lambda function followed by the two parameters or arguments. So here a and b are the arguments, and then I have my expression a plus b. See, all this you can do it in one line. And then to call the function you use print followed by the variable which is add, and then you have the arguments 3, 8. So the addition of 3 plus 8 would be 11. Now you can see that instead of using the def keyword, we have used the lambda keyword, and there is no parenthesis required. Anything after the lambda keyword is treated as a parameter or argument. So we use a colon to separate parameters and the expression. In our case, the expression is a plus b. Now moving ahead, we'll look at the pros and cons of lambda functions. So lambda functions are suitable for simple logical operations. So when we want one expression in return, we can use the lambda function. Now lambda function is used as a parameter to different functions such as map, filter, reduce. We will see all this in our demo session. Now coming to the cons of using a lambda function. So lambda functions can only evaluate one expression, as I told you earlier. You cannot write a docstring to explain all the inputs, operations and outputs as you would do in a normal user-defined function that uses the def keyword. And finally, lambda functions are generally not preferred when you have to declare a function with multiple lines of code. Now let's head over to our Jupyter notebook where we will learn about lambda functions and how to use it in different ways. So I'm on my Jupyter notebook. Let me just go ahead and will rename the notebook as lambda functions in Python. Okay, I'll just click on rename. Cool. First of all, I'll write a general user-defined function using the def keyword. Let's say I want to add two numbers. So this example we have already seen in our slide. So the way to do is I'll use the def keyword followed by the function name, and then I'm giving my arguments or the parameters. After that, let's say I want to store the addition of a plus b in a variable called result. So I'll say result equal to a plus b, and then I want to return my output, that is result. So I'll say return result. So this is how you will normally create a function in Python. If I run it, and then I'm going to call my function using the function name, that is add, and then I'll pass in my parameters a and b. Let's say my a is 3 and b is 4. If I run this, I will get the result 7, which is fair enough. Now if I want to do the same operation using a lambda function, I would do something like this. Let's say I'll create a variable called add, and then I'm going to use the lambda function followed by the arguments a comma b. Then I'll give a colon and say a plus b. After that, I'll just say add and then pass in my parameters 3, 4. If I run it, you have the same result, that is 7. Now let's see another example using lambda functions to add a number. This time I'm going to pass in only one argument. So I'll say add equal to lambda, my argument is x, I'll say x colon x plus, let's say I want to add x with 100. I'll say print add, let's say I want to add 50 with 100. If I run it, I have the result 150. Alright. Now in Python, there is no need to assign a lambda to a variable. You can directly call it. Let me show you how to do it. I'll say lambda a comma b, which are my arguments, Again, this time I'm going to use a multiplication operator since I want to do a product of A and B, and after that, using another parenthesis, you can directly pass in the arguments. So there is no need to explicitly assign a lambda to a variable. So if I want to find the product of, let's say, 15, 30, if I run it, I have the result 40. Let's change the arguments. Let's say I want to find the product of 5, 7. The answer is 35. So this is known as an immediately invoked function expression, or IIFE, which is often pronounced as IFE. Now you can also use keyword arguments using lambda functions. Let me show you what I mean. I'll create my lambda function and assign it to a variable called product. I'll say lambda. Let's say my arguments are x, y, and z. After that, I'll give a colon and say x multiplied by y multiplied by z. Next, I'll say print my variable, that is product, and here I'm going to use keyword arguments. So I'll say, let's say, z equal to 5, x equal to 10, and y equal to 4. You can see here this need not be in an order as you have defined the arguments. If I run this, I have the result. The product of 5 multiplied by 10 multiplied by 4 is 200. Now you can also use default arguments. Suppose I say add equal to, I'll use the lambda function and say x, comma, y I am assigning a default value of, let's say, 15, and z, let's say I'll assign a default value of 24. Then I'll give my colon followed by the expression, that is x plus y plus z. Now I'll say print add. Now here I'm going to only pass in my value for x, since I've already given a default value for argument y and z. So my function only needs one argument, that is x. So let's say I want x to be 20. If I run this, you see the result here. So 20 plus 15 plus 24 is 59. Now you can also use the asterisk args parameter, or args. So this allows you to define as many arguments as you want. So I'll say addition equal to lambda, then I'll say asterisk args. So this will allow us to pass in as many arguments as you want, and I want to find the sum of args. So I'm using the inbuilt sum function in Python. Now I'll say print my variable name, that is addition, and let's say I want to find the sum for 4 values or 4 arguments, let's say 20, 2, 40, and let's say 50. If I run it, so the value is 112. So 20 plus 2 plus 40 plus 50 is 112. Cool. Now lambda functions are also used with higher order functions, which take one or more functions as arguments or return one or more functions. Let me show you. So I'll define a variable called higher underscore ord underscore fun, which stands for function, and ord stands for order. So I'll declare my lambda function. Suppose the parameters are x, and then I have a function, and then followed by a colon, I have my expression as x plus function of x. Now I'll say higher underscore ord underscore fun, and I'll pass in my 2 arguments. Let's say my x is 20, and for this function I'll have a lambda function defined. I'll say lambda x colon x multiplied by x. Now Let me just run this and I'll show you the result. Okay, so what it did was it added my value of x, that is 20, with function of x or fun of x. What is fun of x? Fun of x is x multiplied by x. So 20 multiplied by 20 is 400. So this becomes 400 plus x, which is 400 plus 20, hence the result is 420. So this is known as a higher order function. Now let me show you another example. Let's say I want to display odd or even by taking the value of x. I'll say lambda x colon. Here I am going to pass in my expression. If x mod 2, give a space here, I'll say and odd or even. Now I'll give my argument value, let's say 30. The result is even because 30 is divisible by 2. I'll just change this to, let's say, 15. If I run it, the answer is odd because 15 is not divisible by 2. Let's say I have 150, the answer is even. Now moving ahead, so let's write a lambda function that checks if a string is a substring of the given string. So I'll create a variable called sub underscore string. Now I'll assign this variable with a lambda function. I'll say lambda, my argument, let's say string. I'll give the colon and pass in my expression string in. Let's say my string has this message, welcome to Python functions tutorial. Okay, so we are going to check if a string, let's say in, to, welcome, Python, Java, anything, whether it's present inside this string which is welcome to Python functions tutorial. Now let me go to the next line. I'm going to print sub underscore string, and let's say I want to check for my string, let's say Java. If I run it, it gives me false because the word Java is not present inside my string welcome to Python functions tutorial. Suppose I write Python. Now one thing to note here is the P is small and here the P is in capital letter. If I run it, it again gives me false because Python is case sensitive. Now if I make this as capital P, it will result in true. Let's say I want to say, instead of tutorial, let's say I have training. If I run it, it tells me false because this word training is not there in the string welcome to Python functions tutorial. I'll change this to tutorial. You see here I have my result as true. Alright. Now let's see how to use lambda functions using filter function. So we are going to filter a list of numbers using a specific condition. So I'll create a list called num. Let's say it has values 40, 10, 40, then we have 56, 27, let's say 33, 15 and 70. So this is my list. Now I am going to use my lambda function along with the filter function. So I'll pass in my variable as greater. I'll say list, then I'm going to pass in the filter function, and inside the filter function I'll use the lambda function, and I'll have my argument as num and my expression. Let's say I want to filter only those values which are greater than 30. So I'll say num greater than 30. This is my expression or the condition that we want to check. I'll give a comma and I'll have my next argument as num, and let's go ahead and print the variable greater. If I run this, there you go. You can see here we have all the values from the list, or the numbers from the list, that are greater than 30. So we have 40, 56, 33 and 70. So 10, 27 and 15 are less than 30, and hence those three values were not printed. Now let's say you want to filter a list of numbers that are divisible by 4. So I'll create another list called list1, and let's say I'll have the same values in the list, so I'll just copy it and I'll paste it here, and I'll create my variable, let's say divide. I'll say divide equal to list1. I'll use the filter function followed by the lambda function. I'll say x colon, then I'll have my expression x mod 4 should be equal to 0. I'll give a comma and pass in my next argument as my list1. Now I'm going to say print divide. Okay, I'll remove the bracket here. There is no need of a bracket here. Cool. And we'll delete here as well. Now let's run it. Okay, there is one error here. This should be list1. Let's run it again. Okay, there is some error. Let's debug it. Okay, so this should be the function list. Cool. There you go. So here you can see we have two numbers, 40 and 56, that are divisible by 4. The remaining numbers are not divisible by 4 and hence were not printed. Alright. Now let's go ahead and explore how you can use the map function along with the lambda function. So the map function accepts two arguments, a function and a list. It takes that function and applies it to every element of the list and returns the modified list. So we'll create a list called list2. I'll say equal to, and again we are going to have the same values in the list as above. So I'll just copy those values or the numbers and I'll paste it here. Okay, now let's say I want to find the value of a number multiplied by 2. So I'll say, let's say the variable name is double the num or double the number. I'm going to use the list function followed by the map function this time, and then we'll have our lambda function. I'll pass in my argument as x colon followed by the expression, so x multiplied by 2. I'll give a comma and then we'll have the list, that is list2. There's a spelling mistake here. This should be list2. Alright. Now I'm going to say print double underscore the underscore num. Make sure there is no space in the variable name. Now if I run it, you can see here we have multiplied every number in the list by 2. So 10 multiplied by 2 is 20, 40 multiplied by 2 is 80, similarly 30 multiplied by 2 is 66, 15 multiplied by 2 is 30, and again we have 70 multiplied by 2 is 140. So this is how you can use map function with lambda functions. Now suppose you want to find the power of a number. Let's say I want to find the power of a number raised to 3. So I'll create a list called list3. Let's say I have values 2, 5, 10, 6, 4, and then let's say we have 12. I'll say cube. So I want to find the value of a number raised to the power 3. So for that I'm going to use the map function followed by the lambda function. I'll pass in my argument x, and then here I am going to use the inbuilt power function in Python. So POW, my argument x, and this x I want to raise it to the power of 3, and then I'll have my next argument, which is list underscore 3 or list 3. Okay, now let's print the list. So I'll say list of cube. I'll run it. You can see here, so 2 raised to the power 3 or 2 cube is 8, 5 cube is 125, 10 cube is 1000, 6 cube is 216, 4 cube is 64, and 12 cube is 1728. Now coming to the final section of the demo, where we'll see how to use the reduce function in Python along with the lambda function, and then we'll use a lambda function within a user-defined function. So first let's look at how to use reduce in Python. So reduce applies a rolling calculation to all items in a list. You can use it to calculate the total sum or to multiply all the numbers together. So reduce function is a part of functools module. So to use the reduce function, you need to import the functools module first. So I'll say from functools import my function, that is reduce, and then I'll say, let's say I have my list 4 this time. I'll create a list. I'm going to take the same values as above, and I'll pass in within a list. And now I want to find the sum of all the numbers that are present inside this list called list 4. So I'll do that using my reduce function followed by the lambda function. So I'll say x comma, and I'll give my expression as y colon x plus y, give a comma and pass in my last argument, which is my list itself, which is list 4. Alright, and then I'll say print sum. Let's run it. There you go. So 2 plus 5 plus 10 plus 6 plus 4 plus 12 is 39. So this is how you can use the reduce function in Python. Suppose you wanted to find the product of all the numbers present inside the list, so you can just use the asterisk instead of the addition operator. Now if I run this, you have the product of all the numbers that were present inside the list, that is list 4. We have 28,800. Now let me show you the final demo, that is using a lambda function in a user-defined function. So first of all, I'll create a user-defined function to calculate the value of a quadratic equation. So for some of you who don't know the formula of quadratic equation, it is ax square plus bx plus c. So we are going to use that formula in our function and find the value using lambda function. So I'll create a user-defined function called quadratic, and it will have 3 arguments, a comma b comma c. I'll say return, and here in the return expression I'm going to pass in my lambda function. I'll say lambda x, which is my argument. I'll say x colon, and then I'll have my equation, which is a x square. So I'm saying a multiplied by x raised to the power 2. So I'm using double asterisk plus b multiplied by x. So this becomes ax square plus bx plus I have my constant, that is c. Now just go to the next line. I'm going to create a variable, let's say f. I'll have my user-defined function name quadratic. I'll pass in the values for a, b and c. Let's say a is 2, b is 3 and c is, let's say, 5, and I'll call a of 1. The value of x is 1, the value of a is 2, the value of B is 3 and the value of C is 5. Now let's run it and see the result. So ax square plus bx plus c for a equal to 2, b equal to 3 and c equal to 5, the result is 10. Now let's change it to, let's say I want the value of x as 2. If I run it, you have the equation evaluated and the result is 19.
Now, a Python module is nothing but a simple Python file with .py extension, including the statements and the definitions. So basically, you need to prepare a module file with all the functions which you want to import into your regular Python code across all the modules. Now it contains codes that you can reuse in several programs. So it's like saying you write once a piece of code like common utility methods, calculation methods, rounding off, addition, subtractions, or some common business rules which can be reused across your project. Then you keep it at one place. Now this helps in such a scenario where you have a large team, different set of developers are working on different modules, different specifications, but one single utility module file .py file will contains all the common and reusable functions which not each and every individual developer will go and change. It's only few set of administrators or the senior developers can maintain and pass it on to the team. Now, for example, a file containing Python code demo.py will be called as a module, and its module name would be demo. So you need to take care that whatever the name of the file is, that is what will get imported in your Python code. So we will see that with our certain examples on our Jupyter notebook. Now, why do we need to use, as I have reiterated, it provides flexibility to organize the code in a logical way, and it enables reusability, which is the most important factor. So one, of course, you can organize the code, you keep the reusable code at one place, or you can keep a modular approach and also reusable. So not all the developers have to go and rewrite that code, and it is easy to maintain and helps in debugging the code easily. So if you know that there is an error coming, there is an issue coming in one of the modules which is imported or which is lying in the common file, then it becomes easy to debug. You just have to go and check that particular function. You don't need to go and check in each and every piece of code. Now there are two types of Python modules. Definitely there are built-in modules which Python library provides, which you don't need to import explicitly. But there are certain user-defined modules which you create on yourself for your own custom development, for your own custom programming. So built-in modules are predefined modules and are part of the Python standard library. For example, random, datetime, sys. So we will take a look at these examples also. And of course, the user-defined modules, which is the primary objective of this session, where we're going to show you how do you create your own defined modules and then import them. So the user creates the user-defined modules to ease complex tasks in a project. So you program the complex piece of the code in a common module and give it to everyone. You can define your own functions and classes. Now, what are the different ways? There are 5 different ways you can import modules. So you can just say import module name, and all the classes and functions within that module will get imported. You can give an alias. So basically giving an alias makes it simple, and you can refer that alias throughout your code. Then if you want to import anything specific from the entire module, you don't want to import all the functions and classes, then you can just import the specific functions and classes and give their name. Then fourth is from module, you want to import any address as an alias. You can import and give an alias to the specific function name or the class name. And then of course, similar to the first syntax, you can module everything. So first and the last syntax are almost having the same meaning to import everything in your module. Okay, so with this background, let's first take a look at the Python file. So what we have done is we have created a module calculations.py. So just please focus on the part where the name of the file is calculations, and in this python file.py file we have created a couple of functions and the relevant logic related to those functions. So very simple functions like addition, add. You pass two variables and you send the result, add the variables and send it back. Basically we are overriding the python internal operator add in our python module, and we will be invoking this one. So we'll show you how to invoke. Then you will have, I have written multiplication, division, remainder. So you pass two variables, divide them and find the remainder. Then now a custom function where I'm adding 10 to both the variables which are being passed to this function and returning the result. Then there is a function which checks whether the number is a prime, and if it is not a prime number you will get this output, and if it is, you will get a prime number. Okay, and then another function which says check anagram. So we will just sort the two strings which we will send and check both are equal or not. If both are equal, then the strings are anagrams, otherwise they are not. So these are the set of functions which we have written. Now we will see how will we use them in our code. Now first syntax which I am writing is import calculations. So this is the name of my .py file which is residing in the same folder where I am writing this piece of code. And now if you see in my .py I have a variable y whose value is 6. So I'm just using that value and running it and printing it. I'm just going to show you how explicitly I'm invoking the functions in the calculations class in the calculations.py file. Okay, now let's invoke another function remainder passing 140, and then I should get 20 as an output. Okay, so this has gone back and executed this particular function. Now what I'm going to do is another example of my addition. I'm saying calculations.add. I'm going to initialize and pass two variables, and my expected output is 35. Okay, so it has gone and executed this function. Now I'm going to show you another syntax of importing. So from calculations, I'm just importing the add function. So I'll ask for user input to enter for 1 and 2 numbers, and then I'm just going to add it. Two and 5, so I got my output as 7. Now the difference to be noted over here is that in the previous syntax I was making a call like calculations.add, but now I don't need to make a calculations.add syntax invocation. I just need to say import add, and I just need to use the add function. That's all. Now let's use another syntax to import modules. So I'm using import calculations as cal. So all the modules are imported, but the alias uses cal. And similarly, like the previous example, I'm going to take two inputs and print the sum. Now the difference in this syntax and this syntax is I'm using the alias cal dot add, but my output should be same. Okay, similarly I can call prime, whether it's not a prime or prime number. I can call the check anagram using the same alias, and I can call the remainder function. Okay, so I hope you have noticed that the difference in importing, the way of importing the module makes a lot of difference, right? Now let's take another example of importing some functions or variables. So I'm going to I'm importing my variable y and functions multi, prime and check anagram explicitly. And I'm going to print y. Okay. And I'm going to multiply two numbers. So if you see, I'm using these aliases over here. Okay. I'm using these variables directly as I've already imported. Now I'm going to say prime 9. Now it's printing none. If you see, it's because of the statements which are not executed, right? So that's why you are seeing. Now let's check anagram. And now another thing to be noted is I'm trying to invoke a function remainder, which I have not imported over here. So let's see what error Python throws. Okay, so yeah, so Python has throws an error that name remainder is not defined because I have not imported it over here. So now in order to import remainder, what I'm now doing different is importing all the functions. Now if I use remainder, it should run. Okay, I'm using divide. Okay, cool. Now I'm going to show you another function, which is a utility function, directory function, which will show me all the functions, variables as part of the Python file: add 10, check anagram, divide, multi, prime, remainder, y. And of course, these are some inbuilt packages which are already there in the Python file as part of the Python loader. But these are the ones which I have created. So you can actually see the list of all those functions in one go. Okay. Now I'm going to show you an example of inbuilt modules. So this import math is an inbuilt module of Python. And I'm going to show you how you can see all the relevant functions within the math module. All these are the math module functions which are available for you to use. I'm going to show you one or two. So like print math 2 to the power 8 and you get the answer 256. Print math remainder. So I'm not invoking my module function. I'm invoking the math inbuilt library function remainder, and the remainder is 0. 40 divided by 2, remainder is 0. And square root of 81, 9. Then very important, another very interesting utilities of date time, which you can use, and you can print today's date and time. Then another utility is random utility, and I'm going to create a list L1 and write a piece of code which will choose a random element from this list and just print it. Okay, so if first time it has chosen Oppo, again if I run it, it will choose OnePlus. If I again run it, it might choose something else. So it will randomly pick. Okay. Okay, so with this, we have seen that you can create your own utility functions, import it, write it in a piece of code, .py file, import it in your code as an alias or all the modules and use them. Or you can use the Python inbuilt modules, right? Today, we are going to discuss how exception handling is done in Python. This concept is not new in any programming language. It is pretty prevalent in Java and other programming languages, and it's on the same lines how we can do exception handling in Python. So let's take a look what are the nuances and what are the syntaxes for exception handling in Python. So what are we going to discuss today? We are going to start with discussion of need of exception handling, what is exception handling, the types of errors you can handle in exception handling, and how exception handling works, and in the end, certain points to be remembered. And also, we will support our slides with a Python Jupyter Notebook examples. Now, what is the need for exception handling? Any programming language or any program you write, there is definitely a need in order to have a clean execution of the program, even if the program throws errors. So you need exception handling for cleanly logging the exceptions or throwing meaningful errors to the users. So when does exception occurs, right? Whenever the program gets terminated, right? The program terminates whenever an error occurs, right? So it could happen that an error could be a fatal error and the program gets terminated in between. Or there could be a sudden termination which can corrupt the program, right? So you need to handle exceptions. Or there might be a data loss because of those exceptions, and you need to take care that that doesn't occur or the data loss does not happen. Or even if data loss happens, then you pass on a meaningful message, or you capture a meaningful message in the logs at the right point. Now, what is exception handling? An exception is a runtime error that terminates the execution of a program. So basically, whenever an exception occurs, the program gets terminated, you are thrown out of the running program. Exception handling means you generate a message in correspondence to the occurrence of the error and take the right step to handle it. So now an exception has occurred, but you need to handle it. Now, by handling, we mean that you need to throw a meaningful message, as I said earlier, and then you might need to navigate the program into the right direction or take some certain corrective actions in order to handle the error. So all that comes under the exception handling criteria. Now, in general, there are three types of errors: compile time errors, logical errors, and runtime errors. Now, compile time errors are the errors which any programming compiler or Python compiler will show you while you are compiling your program. So, it could be because of the syntax, spacing, indentation, or you are using wrong keywords. All those will get captured at the compile time. Logical errors, you have not used the correct syntax around logical operators like and or your if else conditions are incorrect and you are expecting an output, but it is not coming as per your expectations. So those are logical errors. And the most difficult ones to capture and track and handle are the runtime errors. So imagine your program is compiled and as per your expectation, you are expecting an output, you have written a logic, but at the runtime it does not get executed, it does not run as per your expectation, and the program gets terminated unexpectedly. So the runtime errors are the most critical and important in order to handle them. And if you talk about runtime errors handling in production scenarios, then it becomes very critical that you have handled the exceptions correctly and captured the logs correctly so that the team can point out where the error has exactly happened. Now, how exception handling works. There are certain syntaxes in Python which you need to follow. Now, you generally put the exception handling code, the code for which you want to handle the exception, under a try block. So you run that piece of code under a try block, and then you put an except keyword where you basically throw an error message. And then if there is no exception, right, then also you can handle the code. Okay, if there is no exception in my code, then how the code will behave, yeah, right? So it could be possible that there is a runtime error, but if there is no, then you might want to do some logical calculations, or you want to put something over there, you can put in the else block. And then finally is a code block which will always get executed irrespective of you had an exception in your code or not. So basically, generally, if you go by the legacy programming, if you have opened a database connection, or if you have opened a file and it is essential to close those connections from your program, then those close connection code are written generally in the finally block, irrespective of the exception coming. You need to close those connections, otherwise you will run out of your connection pools. Now it's a pretty straightforward flowchart of an exception and handling. You start with a try block, and then if an exception occurs in your code, then it will go to the except block. Otherwise, it will go in the else section. And then finally, you have the finally block where the code will finally get executed and stop. So as I said, you put that piece of code in the finally block, which is mandatory, and generally the block, the code which is essential to release the resources which the program has consumed, the CPU resources, the memory resources, hardware resources which the program is using, you have to release that in the finally block. Except block you have to use for capturing the error and throw a meaningful message or do any other logical operation, and else block if you want to continue your program as is. Now, what are the points to remember? These are very important points which you should consider. You can write a try block without any except block. So it's not essential that you put a except block always, or you can write several except blocks for a single try. You might be expecting a null pointer exception or a divide by zero exception or a incorrect variable naming exception. So you can start off with one try, but you can have different except blocks to capture these different kind of exceptions and throw a relevant meaningful error per except block. Also, you can write multiple except blocks to handle multiple exceptions. It's almost the same thing. And you can write exception as an object. You can also print or capture an exception as an object, or you can write multiple exceptions within a tuple. You can capture the multiple exceptions, add it to a tuple and throw it away. Okay, so now let's take a look at certain examples which we want to run in order for better understanding of exception handling. Now, throughout my exercise, I am going to focus on divide by zero error, which we are easily able to simulate. So I'm going to mostly show you how we can capture a divide by zero error. Okay, so I have declared a variable a and I have declared a variable b, a as 10, b as 0. Now I'm trying to divide a by b. Now I'm trying to divide a number with 0. So ideally, yes, this is not a correct mathematical operation. Divide by number 0 is not allowed. So I should get a zero division error. Now, this is an unhandled exception. My program has not handled it properly, so that's why you're getting this error on the trace of the Python trace. But if I handle it properly, then I can very cleanly throw this error and capture this error. Okay, so I am going to take input in B, enter A and B, and I'm just going to print a generic except block. So 10, 0, and I have got an exception and I've printed it. Now there is no stack trace, there is no trace, but at least I'm able to cleanly throw an error, a meaningful error. Now again, I'm differently going to handle the exception. I'm going to create the same exception, but going to handle it differently. Now there's a try block. Now I am writing an except block to capture the specific exception, zero division error exception. in the earlier code block, I had just written except, so any exception would have come to this block. But in this except block, only zero division error will be captured. So as you can see, I cleanly handled the exception. Of course, I gave the name except zero division error, and then my code got executed later on. Now, in another example, what I'm going to do is I'm going to show you that if my code runs cleanly, then it's not necessary my except block will get executed. Definitely, because if there is no error, then the except block will remain redundant. Now here you see what I have done is I've taken genuine two numbers, divided them, printed a new line, and then completed. So as there was no exception, the exception block did not got executed. So the point to be highlighted over here is that it is not essential that exception block will get executed always. It will only come into picture when there is a relevant exception getting generated. Now let's take an example of how we can print an exception object. So I'm going to take my previous code, and here I am capturing the exception but also printing the exception object. So what has happened is I have printed the exception of a message, a custom message, plus I have printed the exception object. Okay. Now I'm going to take the same example, but I'm not gonna generate an exception. So my exception block did not got executed, and I was able to simply print Simplilearn. Now let's take another example where I am capturing my exception in a variable. So do not divide number by 0, and in this I have captured my exception division by 0. So in the exception, the Python generated exception name is this, and I have printed over here. So division by 0 is the Python generated exception which I have appended in the print command. Now I'm going to take another example where I'm saying is that I will print exception as A, plus I'm going to also capture another exception. So it's like one try and two exceptions. So one exception is do not divide number by 0, and second exception is name Z is not defined, right? So as I said earlier, you can have one try but two except blocks, which is permissible. Now one thing is that this exception print A by Z went through both the except blocks, except this exception and this exception, though this exception is not divide by 0 error. So therefore in this A variable nothing came in, but in the B variable the name error was definitely captured because it's a name undefined, name Z is not defined error, and that's why you can see that do not divide number by 0. After that we do not have any relevant, meaningful message. Okay. Now let's take another example where we are going to have two accept blocks, and out of these two, only one will get executed. Okay, so there is no type error exception, so that accept block did not got executed, but only zero division error is there, so only that got printed. Now you can explicitly also raise an exception. It's not like you just have to wait for a runtime exception. You can also raise an exception from your code and execute it. So if you see this, what we have done is just created a variable with a negative value and just checking that if the value is less than 0, then raise an exception. So that's what we have done. Similarly, you can also raise an assertion error. It is called assert, and you can run this message. You can throw this message compatible with Linux only. How to handle files in Python. Though this concept is not new and is pretty common in languages like Java and C++, but we are going to see the syntaxes which are being used in file handling in Python. Now let's see what's in it for us today. We will understand what is file handling. We will go through certain file handling operations. Then we will understand how to open a file in Python using various modes, which are pretty important. And then we will discuss the file handling process, the different types of files which we can create, and advantages of using files. Now, what is file handling? A file contains a collection of data and information. It is just like a data storage. So the data can be updated and shared through files with multiple stakeholders. Now, file handling in Python performs functions such as creating, reading, updating, and deleting. So you can perform the basic CRUD operations using the file handling functions and operators. Now, in Python, file operation takes place in the following order. In order to work on a file, you have to first open a file. That is the first and foremost step. And then you can perform any read or write operation. And then you have to close the file. So these three primary steps are involved in order to do any operation on a file. Now in Python, we can work with files using the open function, and it takes two parameters, the file name and the mode. So here you can see the syntax. If you do not give the mode parameter, then it takes the default values, which we're going to see in our next slide. But at least you need to give the name of the file with the extension. Now, what are the various modes in which you can perform operations on a file? Let's go through them one by one. You can open a file, first of all, in the read mode, which is the default mode, and it opens a file for reading. But if the file does not exist, it throws an error, right? Second is append A. It opens a file for appending, creates the file if it does not exist. So in this mode, if the file does not exist, it gets created. Similarly, in the write operation, it opens a file for writing and creates the file if it does not exist. So A and W will create the file. X, it creates specified file, returns an error if the file exists. So you cannot create an already existing file, you need to give a different name. Then the next mode is the T mode, the text mode, which is the default value. So by default, when you open a file in Python, you are basically opening it in default read text mode. And the next mode is the binary mode. If you specify B, it means that you're trying to open an image or any binary mode related file, which cannot be opened in a text mode. So we will see certain examples of these modes in our Jupyter notebook when we will run certain examples on a sample file. Now, what is the file handling process, right? So in a plain vanilla process, first of course you will create a file and then you will open a file, update and close the file. So the first thing which you can do, but from the function standpoint, like we saw in our previous slide, even if you have to create a file, you have to call the function open, then you have to read it, you write in it, and then you close it. First thing which you have to then do in order to interact with the file is always make a call to the open function, and then you pass the file name and the mode as a parameter. Now, as we discussed, there are two modes. There are two types of files in Python: text file and binary file. So in text file, the data is stored in characters and string, and in binary file, the data is stored in the form of bytes. But the bytes file which you store, you can store in a different extension, and it can be read by other utilities or tools or softwares which are meant for reading the binary files. But you can interact or you can perform certain functions using the Python operators and the open functions which are available. Text file is a simple concept. You open the file, you can write, append, update the data, and you can open the file in your operating system and see your changes. So we are going to perform our examples on a text file where we will show you how you can view your changes by opening a file real time. Now there are some preliminary advantages, basic advantages of using files. This data is stored and is permanent. Basically it resides in the file, and then it is up to you how do you save the data in the file in the operating system, or you persist that data in some secure area, and that is up to you. And the stored data can be shared. Definitely you can mail the data, you can share it in a hard drive, you can share it on a network drive, etc. And you can update the data in the file. So you can append, you can override, you can remove, you can delete the file. All those operations, all those possibilities are there. So now let's create our Jupyter notebook with certain examples. So what I have done here is I have already created certain sample files where I have some predefined context there. So I have a Simplilearn.txt file in which I have written today is Thursday in one line, tomorrow is Friday, and I am waiting for weekend. Now I'm going to read this file. So I'll import the package in order to read the file. I'll create the file object. Now in this, I have given the path where my file is residing, today.txt. The same content is there. And I'm going to be opening it in the read mode. Though it's the default mode, but I'm calling it out explicitly for a better understanding. Now, this is the read command, file.read. This operator, this will read the entire file. So if you see in my file, all the contents are printed. Now, if I want to read the first 7 characters of my file, so what will this do? It will read the first 7 characters of the first line of my file. So in the first command, my file.read printed all the contents, but here I have passed a parameter to the read function to print only the first character, 7 characters. So that's what it has done. Now I will ask my function to read line by line. So now what is the difference between this and this? The difference is that the file.read read the entire file in one go, but here it is allowing me to read only one line at a time. Okay, so this function of read line will only go and read the line. Now, if I have to read all lines one by one, right? Now, here I have printed one line. Now I want to print all lines one by one. Then there is a different function which is file.readLines, and it will print an array. And of course you can see there's a /n operator because it's a different line. So it will print my three different lines in an array. Today is Thursday, tomorrow is Friday, and I'm waiting for weekend. Now, like I gave this example of file.read 7 characters, in the similar fashion, I can also provide how many characters to read from the line. Correct? So from the first line, it has given me the first 3 characters, and here in the file.read, it was starting to read the entire file, but I only limited to the 7 characters. Now let's take a look at the write function, write method. So now in my today.txt file, I now pass the mode w, and I'll override it with my new content, which is the Sunday and Monday, and say file.close and run it. Now I can go and check it's been overridden. Now I'm going to create a new file. Let me create a new file and add contents to that. I'll create Simplilearn2.txt and run, and a new file has got created with the content sunshine. So here I have passed the mode as X. Now I want to delete a file. I will just simply pass os.remove. There is no open function to be called, and just give the name of the file, and my today.txt file is gone. Even I can put a check before removing a file whether the file exists or not. If it exists, then remove, else print that the file does not exist. There is no file. Now if I want to print line by line, I'll show you another example. If I want to print line by line, then the example is you import and file dot in the loop, and you print the output. So basically you can, if you want to print the lines in a loop, then you need to put the for command, for loop, and put the read lines call in the loop.
Let's get started. So first we'll see what are Python libraries, and before we delve into the details, let's understand about it. In Python, Libraries are sets of pre-written code that provide various functionalities, making it easier for us to perform tasks without having to reinvent the wheel. They are like toolboxes filled with functions and modules designed to handle specific tasks such as data manipulation, visualization, web scraping, and much more. And now we'll see some of the essential built-in libraries. That is, Python comes with a rich collection of built-in libraries that provide fundamental functionalities. Here are some essential ones you need to know. The first is Math Library. This library is essential for mathematical operations, including complex arithmetic, trigonometry, and more. Then, Datetime Library. It allows you to work with dates, times, and time intervals, making it handy for various applications. Then we have String Library. This library offers a wide range of string manipulation functions, making working with text a breeze. Then we have Random Library. Need random number generation or shuffling? The Random Library has got you covered. Then we have Data Manipulation Libraries. Data manipulation is a crucial part of any Python project, especially in data analysis and machine learning. Here are some powerful libraries for data manipulation. The first is Numpy, short for Numerical Python. This library provides support for large multi-dimensional arrays and matrices, along with high-level mathematical functions to operate on these arrays efficiently. Then we have Pandas. Pandas is the Go library for data manipulation and analysis. It offers data structures like data frames and series, making data handling and cleaning a breeze. Then we have data visualization libraries. Presenting data visually is key to understanding patterns and insights. Here are two popular data visualization libraries. The first is Matplotlib. This library provides a flexible and comprehensive set of plotting tools for creating static, interactive, and animated visualizations in Python. Then we have Seaborn. Built on top of Matplotlib, Seaborn offers a high-level interface for creating stunning statistical graphics. Then we have web scraping libraries. Web scraping is a technique used to extract data from websites. These libraries help you gather data from the web effectively. The first is Request. This library allows you to send HTTP requests effortlessly, making it easy to fetch web pages. Then we have Beautiful Soup. Beautiful Soup helps parse HTML and XML documents, extracting valuable data from web pages. Then we have machine learning libraries. Machine learning is an exciting field and Python has some fantastic libraries for it. The first is Scikit-learn. This is a powerful library that provides simple and efficient tools for data mining and data analysis. It's great for implementing machine learning algorithms. Then we have TensorFlow and Keras. If deep learning is your thing, TensorFlow and Keras are your go-to libraries. They are widely used for building and training neural networks. And after this, we have GUI development libraries. Creating graphical user interfaces is made easier with these libraries. The first is Kinter. Kinter is Python's standard GUI library, simple to use and allows you to create basic windows, dialogues, and buttons. Then we have PyQt and PySide. These libraries offer more advanced GUI capabilities and are perfect for building complex desktop applications.
Python is the most widely used programming language today. When it comes to solving data science tasks and challenges, Python never ceases to surprise its users. Most data scientists are already leveraging the power of Python programming every day. It's an easy to learn, easy to debug, widely used, object-oriented, open source, high-performance language. And there are many more benefits of Python programming. Python has been built with extraordinary libraries for data science that are used by programmers every day in solving problems. Now, before talking about top Python libraries, let's take a look at what a library is. Python has produced a number of open source libraries, each with its own root source. A library is a previously combined set of code scripts that may be utilized iteratively to save time. Now, in contrast to languages such as C++ or C, Python libraries are not context specific. Now, a library in this context refers to a collection of essential components. A library is a collection of modules that can be installed with the help of a package manager such as pip. Now that we know what libraries are, let's take a closer look at some of the most popular libraries in Python. First on the list, we have Numpy. Numpy is an open source Python library used for scientific computing and data analysis. It provides powerful numerical and mathematical functions that enable efficient computation of large multi-dimensional arrays and matrices. Numpy is an essential library for data manipulation and analysis in fields such as machine learning, image processing, and scientific computing. Now, some of the key features of Numpy include multi-dimensional arrays. Numpy provides a powerful n-dimensional array object that can be used to store and manipulate large datasets. Mathematical functions. Numpy provides a wide range of mathematical functions that can be applied to arrays and matrices as well, including linear algebra, Fourier transforms, and random number generation. Numpy is widely used library in the data science and machine learning communities and is often used in conjunction with other libraries like Pandas, Scikit-learn, and TensorFlow. Second on the list, we have Pandas. Pandas is an open source data manipulation and analysis library for the Python programming language. It provides easy to use data structures and data analysis tools for handling and manipulating structured data. Pandas provides two main data structures. One is series and other one is data frame. Now, a series is a one-dimensional labeled array that can hold any data type, while a data frame is a two-dimensional labeled data structure with columns and potentially of different data types. Some of the key features of Pandas include data cleaning. Pandas provide tools for cleaning, filtering, and transforming data, such as filling missing values, removing duplicates, and replacing values. Data manipulation. Pandas provide powerful tools for manipulating data, such as grouping, merging, and reshaping data. Integration with other libraries. Pandas integrate with other popular libraries such as Numpy, SciPy, and Scikit-learn to provide a complete data analysis and machine learning environment. Pandas is widely used in data science and analysis and are particularly useful for working with tabular data such as data in CSV and Excel files. Next on the list, we have Matplotlib. Matplotlib is a Python library used for data visualization. It provides a wide range of tools for creating graphs, plots, charts, and other visual representation of data. It is a highly customizable library that allows you to control every aspect of visualization you create. You can customize the style, color, size, appearance of elements such as lines, markers, axes, titles, and legends. It also offers several types of plots including line plots, scatter plots, bar plots, histogram plots, pie chart, and many more. Matplotlib is built on top of Numpy, which makes it easy to work with arrays and other numerical data. Matplotlib also integrates well with other Python libraries, such as Pandas for data manipulation, SciPy for scientific computing, and Seaborn for statistical data visualization. Fourth on the list, we have Scikit-learn. Scikit-learn, also known as sklearn, is a popular open source machine learning library for Python. It provides a wide range of algorithms and tools for building and evaluating machine learning models. Scikit-learn is built on top of Numpy, SciPy, and Matplotlib, which makes it easy to integrate with other scientific computing libraries in Python. It provides a comprehensive set of tools for various machine learning tasks such as classification, regression, clustering, dimensionality reduction, model selection, and pre-processing. It also includes popular algorithms such as decision trees, random forest, support vector machines, logistic regression, k-nearest neighbors, and many more. Scikit-learn provides a consistent API for all algorithms, making it easy to switch between different models and algorithms. Scikit-learn also provides a wide range of pre-processing tools for cleaning and transforming data, such as scaling, normalization, and feature extraction. Fifth on the list, we have Scrappy. The next known Python libraries for data science is Scrappy. Scrappy is one of the most popular, fast, open source web crawling framework written in Python. It is commonly used to extract data from web pages with the help of selectors based on XPath. And talking about its application, Scrappy helps in building crawling programs that can retrieve structured data from the web. Scrappy is also used to gather data from APIs and follow a don't repeat yourself principle in the design of its interface, influencing users to write universal codes that can be reused for building and scaling large crawlers. Sixth on the list, we have Keras. Similar to TensorFlow, Keras is another popular library that is used extensively for deep learning and neural network modules. Keras supports both TensorFlow and Theano backends, so it is a good option if you don't want to dive into the details of TensorFlow. Talking about its features, Keras provides vast pre-labeled datasets which can be used to directly import and load. It contains various implemented layers and parameters that can be used for construction, configuration, training, and evaluation of neural networks. Next in the list of top Python libraries for data science is PyTorch, which is a Python-based scientific computing package that uses the power of graphics processing units. PyTorch is one of the most commonly used preferred deep learning research platforms built to provide maximum flexibility and speed. Talking about its application, PyTorch is famous for providing two of the most high-level features. First one is tensor computations with strong GPU acceleration support, and building deep neural networks on a tape-based autograd system. 8th on the list, we have Beautiful Soup. Beautiful Soup is the next Python library for data science. This is another popular Python library, most commonly known for web crawling and data scraping. Users can collect data that's available on some website without a proper CSV or API. And Beautiful Soup can also help them scrape it and arrange it into required format. Now, Beautiful Soup is widely used in web scraping applications and is considered as one of the most popular and powerful web scraping tool available in Python ecosystem. Next on the list, we have PyGame. PyGame is a set of Python modules designed for writing video games. It provides functionality for working with graphics, sound, and user input, as well as tools for handling events and timing. Now, Python game is built on top of the SDL library, which provides a low-level interface for accessing hardware and input devices. Some of the features provided by PyGame include support for 2D graphics, rendering, including image loading and manipulation, sprite handling, and drawing primitives. Support for playing sounds and music, including playback control and volume adjustment. Support for handling user input, including keyboard, mouse, and joystick events. PyGame is often used for prototyping and developing small to medium-sized games, as well as for educational purposes. Its ease of use and flexibility makes it a popular choice for game development beginners and hobbyists. And finally on the list, we have Theano. Theano is a Python library for numerical computation designed for deep learning and machine learning applications. It allows users to define, optimize, and gauge mathematical expressions, which includes multidimensional arrays, the fundamental building blocks of many machine learning algorithms. Now, talking about features, Theano is designed to efficiently perform numerical computations on both CPU and GPU, which can significantly speed up the training and testing of machine learning models. Theano provides automatic differentiation functionality, making it easy to compute gradients and optimize parameters while training machine learning models. And some of its applications are scientific computing, simulation, optimization, and deep learning. In addition to these top 10 Python libraries for 2023, there are many other helpful Python libraries, ones that deserve to be looked at.
If you're interested in learning and mastering data science with Python, head on to Simplilearn's professional certificate program in data science. Do explore the frequently asked data science interview questions and unlock your career as a data scientist.
Python GUI frameworks. The first question that should arise in your mind should be why to use Python GUI frameworks. Python GUI frameworks are used to create graphical user interface for applications. GUIs make it easy for users to interact with an application, and they are a critical component of modern software. There are several reasons to use Python GUI frameworks for building GUI applications. The first reason is cross-platform support. Python GUI frameworks are often cross-platform, which means that they can run on multiple operating systems, including Windows, macOS, and Linux. This makes it easy to build applications that can be used by a wider audience without having to create separate versions for different platforms. Second is rapid development. Python GUI frameworks can speed up the development process of building GUI applications. Many frameworks come with pre-built widgets such as buttons and text boxes that can be easily customized and incorporated into an application. This can reduce development time and allow developers to focus on the functionality of the application. Third, easy to learn. Python is a popular programming language that is known for its simplicity and ease of use. Many Python GUI frameworks are also easy to learn and have extensive documentation and tutorials. This makes it easy for beginners to get started with building GUI applications. And the fourth is large community. Python has a large and active community of developers who create and maintain GUI frameworks. This means that there are many resources available, such as forums and libraries that can help developers solve problems and add new features to their applications. And the next feature is integration with Python libraries. Python GUI frameworks can integrate with other Python libraries, which makes it easy to add functionality to an application. For example, a developer can use a GUI framework to create a user interface for a data analysis application and integrate it with a data analysis library like Numpy or Pandas. In summary, Python GUI frameworks provide cross-platform support, speed up development time, and easy to learn, and have a large community and can integrate with other Python libraries. These benefits make Python GUI frameworks an excellent choice for building modern applications. Now, we'll explore some of the popular GUI frameworks. There are numerous GUI frameworks available for Python, each with its own advantages and disadvantages. We will start with Kinter. Kinter is a Python library for creating graphical user interfaces that is included in the standard library. It provides a set of tools and widgets for building applications with a graphical user interface
and is based on the TK GUI toolkit, which was originally developed for the TCL programming language. Kinter provides a wide range of GUI components including buttons, labels, text boxes, menus, list boxes, checkboxes, radio buttons, and more. These components can be used to build complex user interfaces with multiple windows, dialogues, and panels. One of the key features of Kinter is event-driven programming model. When a user interacts with the Kinter application, events are generated by the user's actions, such as clicking a button or selecting an item from a list. These events are then handled by the application code, which can update the user interface or perform other tasks in response. Kinter also provides support for creating custom widgets and dialogues, as well as for drawing graphics and animations using the Canvas widget. Additionally, Kinter can be extended with third-party libraries and modules, such as Matplotlib for plotting data and Pillow for image processing. And if we talk about the advantages, the first advantage is it is easy to learn and use. The second is cross-platform. And the third is it has large community and has many resources available. And now we'll talk about some of the disadvantages. So the first disadvantage is default look and feel is not modern. The second is limited set of widgets. And the third is does not support threading. Now we have our second GUI framework, that is PyQt. PyQt is a Python binding for the Qt GUI framework, which is a popular and powerful cross-platform GUI toolkit that provides a comprehensive set of widgets and tools for creating modern and responsive desktop and mobile applications. PyQt allows developers to use Python to create Qt-based applications and user interface with ease. PyQt is distributed under the GPL and commercial licenses, which makes it suitable for both open source and commercial development. It provides a wide range of modules that cover everything from basic GUI programming to advanced multimedia, network, and database functionality. Here are some of the key features of PyQt. The first feature is cross-platform support. PyQt supports multiple platforms including Windows, macOS, Linux, and mobile platforms like Android and iOS. Second is easy to use. PyQt is easy to learn and use, especially for developers familiar with Python. Its API is well documented and provides a high level of abstraction that simplifies GUI development. Third is rich set of widgets. PyQt provides a wide range of widgets and tools that allows developers to create advanced and modern GUIs. Some of these widgets include buttons, labels, text boxes, tables, menus, and many more. The fourth is customizable styles. PyQt allows developers to customize the appearance and behavior of widgets using style sheets. This makes it possible to create unique and visually appealing user interfaces. Signals and slots. PyQt uses a signals and slots mechanism to handle events and communication between widgets. This mechanism allows developers to create complex interactions between widgets with minimal code. Now we'll talk about the advantages of PyQt. The first advantage is modern and customizable look and feel. And the second advantage is large set of widgets and tools. The third is well documented with many resources available. And if we talk about the disadvantages, it has the steep learning curve. And the second disadvantage is not as lightweight and fast as some other frameworks. Third is requires licensing for commercial use. And the third GUI framework is Kiwi. Kiwi is an open source Python GUI framework designed for building multi-touch applications and user interfaces. It allows developers to create cross-platform applications that can run on Windows, macOS, and Linux. Kiwi is based on a natural user interface and uses a graphic engine to render user interface that are touch-enabled. This makes it ideal for creating applications that use touch, gestures, and other forms of natural user interaction. One of the key benefits of using Kiwi is that it enables rapid development and prototyping. It has a straightforward syntax that is easy to learn, and it supports a wide range of widgets and UI elements. Developers can use Kiwi to create rich, interactive applications that incorporate multimedia, graphics, and animations. Kiwi also includes support for a wide range of input devices including touchscreen, mouse, and keyboard. It also includes support for multi-touch gestures such as pinch to zoom, swipe, and rotate. Kiwi is built on top of OpenGL, which provides hardware acceleration for the graphics engine. This means that Kiwi applications can be highly performant and responsive, even when running on low-power devices. In summary, Kiwi is a powerful GUI framework for building multi-touch applications and user interfaces. It is easy to learn, supports a wide range of input devices, and enables rapid development and prototyping. Its use of OpenGL provides hardware acceleration and high performance, making it an excellent choice for developing cross-platform applications. Now, talking about the advantages of Kiwi, the first advantage is it is designed for building modern and dynamic user interfaces. The second is easy to use with a large community. The third is cross-platform and runs on Windows, macOS, Linux, iOS, and Android. And now talking about the disadvantages. The first disadvantage is not as widely used as some other frameworks. The second disadvantage is widget set is not as extensive as some other frameworks. And the third disadvantage is some performance issues on older hardware. And our next GUI framework is PySide. PySide is a GUI framework for Python. It is a set of Python bindings for the Qt application framework and runs on all major platforms including Windows, Mac OS, Linux, and mobile platforms such as Android and iOS. PySide allows Python developers to create sophisticated and interactive graphical user interfaces for their applications with ease. It provides a rich set of libraries, widgets, and tools that allow developers to create applications with complex and intuitive user interfaces. The framework includes a number of features such as the first feature is cross-platform support. PySide is designed to work on all major platforms so developers can write code once and deploy it on multiple platforms. The second is high performance. PySide applications are fast and responsive, even when dealing with large datasets or complex visualizations. And the third feature is extensive widget library. PySide provides a rich set of widgets including buttons, labels, text boxes, sliders, and many more that can be easily customized and arranged to create intuitive user interfaces. And the next is easy to use designer tools. PySide includes a visual designer tool that allows developers to drag and drop widgets onto a form and then customize their properties, styles, and behaviors. And the next feature is MVC architecture. PySide follows the Model View Controller MVC architecture, which helps developers separate the user interface from the application logic, making it easier to manage and maintain code. And the next feature is support for internationalization. PySide provides built-in support for internationalization, allowing developers to create applications that can be localized to different languages and regions. In summary, PySide is a powerful and flexible GUI framework for Python that provides a rich set of libraries, tools, and widgets for creating sophisticated and interactive user interfaces on multiple platforms. And talking about its advantages, the first advantage is it has similar set of widgets and tools as PyQt. The second is LGPL licensed, and the third is cross-platform. Now talking about the disadvantages, the first disadvantage is smaller community than PyQt. The next is less documentation and resources, and the third is some performance issues on older hardware. Now we have our next GUI framework, that is WXPython. WXPython is a popular open source GUI framework for Python programming language. It is a wrapper around the C++ based WX widgets library that provides a native look and feel to GUI applications across different platforms like Windows, Linux, and Mac OS. WXPython is a cross-platform toolkit, which means that you can create GUI applications that can run on different operating systems. It provides a wide range of widgets that can be used to create complex GUI applications, and some of commonly used widgets include buttons, text boxes, checkboxes, radio buttons, list boxes, and combo boxes. Additionally, it also supports creating custom widgets to suit specific needs. Now we'll talk about some of the features of WXPython. The first is native look and feel. WXPython provides a native look and feel to GUI applications across different platforms. It supports the standard look and feel of each operating system. The second feature is object-oriented. WXPython follows the object-oriented approach, which makes it easier to write and maintain code. And the next feature is event-driven. WXPython follows an event-driven programming model, which means that the code is executed in response to user events such as button clicks or key presses. The next feature is customizable. WXPython allows you to create custom widgets, dialogues, and frames to suit specific needs. And the next feature is extensive documentation. WXPython has extensive documentation including API references and tutorials. And the next feature is rich set of widgets. WXPython provides a rich set of widgets that can be used to create complex GUI applications. Now talking about the advantages of WXPython. The first advantage is native look and feel on all platforms. The next is large set of widgets and tools. And the next one is easy to use with a large community. And now we'll talk about the disadvantages of WXPython. The first is not as lightweight as some other frameworks. The next is documentation is not as extensive as other frameworks. And the third is widget set is not as modern as other frameworks. PyGTK is a Python binding for popular GUI toolkit GTK, which is used to create graphical applications for desktop environments. PyGTK provides a set of Python modules that allow developers to create GUI applications in Python programming language. GTK provides a set of widgets that can be used to create user interfaces such as buttons, labels, text boxes, sliders, and menus. These widgets can be combined to create more complex interfaces. PyGTK also includes support for event handling, which allows developers to respond to user input such as mouse clicks and key presses. Event handling is done through callbacks, which are functions that are called when an event occurs. Another important feature of PyGTK is its support for internationalization. PyGTK provides tools for translating applications into different languages and for displaying text in the appropriate language. It is based on users' locale. PyGTK also provides support for theming, which allows developers to change the look and feel of an application by changing the visual styles of the widgets. PyGTK applications can be run on multiple platforms including Linux, Windows and macOS. The GTK toolkit and PyGTK library are both open source software and are freely available for anyone to use and modify. Overall, PyGTK is a powerful GUI framework that allows developers to create rich graphical applications with Python. Its ease of use, flexibility, and cross-platform support make it a popular choice for developers to develop desktop applications. Now we'll talk about the advantages of PyGTK. The first is native look and feel on Linux and Unix-based systems. The second is easy to use with a large community. And the third is large set of widgets and tools. Now we'll talk about the disadvantages of PyGTK library. The first disadvantage is limited cross-platform support. The second is limited set of widgets compared to some other frameworks. And the third is documentation is not as extensive as other frameworks. Now we have our next GUI framework, that is PyForms. PyForms is a Python-based GUI framework for creating desktop applications with minimal effort. It is a powerful and flexible tool that simplifies the process of creating graphical interfaces for data management and visualization. PyForms offers a range of features that make it an excellent choice for developers looking to create desktop applications quickly and efficiently. Some of these features include: the first is cross-platform support. PyForms is compatible with multiple platforms including Windows, Linux, and macOS. PyForms offer a drag-and-drop GUI builder that enables developers to create user interfaces quickly without writing code. And the third is customizable widgets. PyForms includes a wide range of customizable widgets that developers can use to create advanced graphical interfaces. And the next is MVC architecture. PyForms follows the model view controller architecture pattern, which separates the user interface logic from the data management and application logic. The next feature is data visualization tools. PyForms include powerful data visualization tools that make it easy to create charts, graphs, and other visual representation of data. And the next feature is multi-language support. PyForms support multiple language supports including English, French, and Spanish, which makes it a popular choice for international developers team. And the next feature is built-in testing tools. PyForms include built-in testing tools that enable developers to test their applications easily. And the next feature we have is active community. PyForms has an active community of developers who contribute to the framework and provide support through forums and other channels. PyForms is a great choice for developers looking to create desktop applications with minimal effort. Its cross-platform support, drag-and-drop GUI builder, customizable widgets, MVC architecture, data visualization tools, multiple language support, built-in testing tools, and active community make it a powerful and flexible tool for creating desktop applications. Now, if we talk about its advantages, the first advantage is easy to use with a modern look and feel. The second is large set of widgets and tools. The third is cross-platform. Now, if we talk about its disadvantages, the first disadvantage is smaller community than some other frameworks. The second is less documentation and resources than other frameworks. Overall, each of these libraries has its own strengths and weaknesses, so it's important to choose the one that best fits your needs and skill set. Long story short, the best GUI framework for you depends on your needs. For absolute beginners, PySimple GUI is a great starting point, while those looking for more advanced features might prefer WXPython or PyQt5. If you need a touchscreen UI, Kiwi is recommended, and for form-driven applications, PyForm is a good choice. If you are still using Python 2, you can try PyGUI, PySide2, or WXPython, but you should be aware that Python 2 is no longer supported.
This session will introduce you to the tkinter module, its widgets, and their uses. After that, using these widgets, we will create a dollar to rupee converter. I will move to C drive, and in Python projects, I will create a folder with the name tkinter tutorial, and inside I will open the command prompt and write the command code space period and press enter to open my IDE. That is, I am using the Visual Studio Code. You can use any IDE you want or you have your hands on. So now we will make a file and name it as tt.py. You would be amazed to know that there are various GUI frameworks for Python, but only tkinter is included in the standard library. That is, if you install the Python, it would come along with that only. You don't need to install it again or write any command to install it again. And tkinter has a number of advantages. The same code runs on Windows, Mac OS, and Linux since it is cross platform oriented. And in contrast to other frameworks, tkinter is lightweight and generally simple to use. This makes it an appealing option for creating GUI apps in Python. So, starting with, first, we will import tkinter module. For that, we will write the command import tkinter, and we'll use an alias here, and we'll import it as tk. So first we need to create a tkinter window, and we will add a single widget in that and show you guys how we'll create that window. So first you will get your Python IDE open and just import the tkinter module as we have imported here. And now to make the window, we'll write a command window equal to tk, what we have imported, and we'll write tk and enclosed circle brackets. Here window is an instance of tkinter's tk class. Now we will create a new window and assign it to the variable window. So this is the tk class. Now when we write window.main loop, so it will repeat the loop, and when we add widgets in it, it will keep on repeating and it will show you the window with all the widgets. So first we'll save this file and run it. You can see that we have the tkinter window here. So this is how you create a tkinter window. Now moving on. Now we will set the title for the tkinter window. I will show you again as it was showing tk. It's showing tk. So we will change the title for the tkinter window, and to change that we'll write a command window dot title, and in the circular brackets we will write the title we want for our tkinter window. I will write Simplilearn tkinter tutorial. So yeah, I will save this and run this file for you guys. So you can see that it has shown the title. So we'll just stretch it and you can see the title here. So we can stretch the tkinter window till we have not set the resizable method false. If we set it as false or 0, it would not be able to stretch the tkinter window as we are able to stretch it now. So this arrow, it won't be available after we set it as false. Now moving on, after setting the title, now we will set the geometry. That means the dimensions for the tkinter window. For that we'll use the geometry method, and it's a fundamental method which decides the size, position, and some other attributes of the screen layout we are going to create. So for that we'll write a command window dot geometry, and inside you could write the dimensions. First we will set the width, that is x-axis. We'll set it as 600 pixels. Then we'll write small x. Then the y-axis or the height of the window, we'll set it as 500. And after that we will add plus What this indicates is 290 pixels. That is, the window will appear on the screen 290 pixels from the x-axis, and for y-axis we will add 10, so it would appear 10 pixels from the y-axis. So we'll save this and run it. You could see that 290 pixels from the x-axis and 10 pixels from the y-axis, and we've set the geometry, that is 600 pixels, that is the width or the x-axis, and 500, that is the y-axis, the height. So now moving on, now we have created the window. Now we'll add a widget and show you guys how we add a widget. Before that, let us know what kind of widgets we have in Tkinter. So in this tutorial, we will be learning around 5 widgets. So we will start with label. And label, it's a widget that is used to display text on the Tkinter window or your screen. And next, we would be having the button widget that can contain text and can perform an action when clicked. It could have any action or it could have just a text without any action. Then we will have the entry widget. It's used to get any entry from the user or a single line of text. It also get multi lines of text. For that we have to set other attributes. And next we would be seeing the frame. So a frame, it's a rectangular region used to group related widgets or provide padding between widgets. So these are the 5 widgets that we would be learning. So I counted you 4, but here you will learn other widgets, that would be canvas, and you would see the photo image object and other things. So moving on, we'll use many widgets. First, we'll create a single widget and show you guys how we'll create it, and we'll start with the label widget. So for that, we will call the label class for that, and I will set you greeting for you guys. So greeting equal to label. So here we will use tk.label class to add some text to a window. We will create a label widget with the text hello learners, welcome to Tkinter tutorial, and assign it to a variable greeting as we have started assigning it. And the window you created earlier doesn't change. You just create a label widget, but you haven't added it to the window yet. There's several ways to add widgets to a window. Right now we can use the label widget, and then we'll use the grid method or the pack method or the place method to show that widget on your window screen or on the Tkinter window. So starting with creating the widget, now we'll set the text for it, and text that would be equal to hello learners and welcome to Tkinter tutorial. And by the way guys, some people call it as Kinter. I call it as Tkinter, and many call it as TK Inter. So you guys can pronounce it at any way. Okay, so welcome to Tkinter tutorial. Now here we will use the place method. So for that we'll use greeting the dot place, and here we'll use tk dot label, and we will place it at here. We will assign the coordinates as we have created a window with x-axis and y-axis. Here we will assign our x coordinate as 190 and y coordinate as 210. As we have the window and in that we have x-axis, at full length of 600 and y-axis with 500. So we are placing it at 190 and at y-axis at 210. And similarly with the place widget, we have like Takinter has 3 built-in layout managers that use geometric methods to position widgets in an application frame. First we have pack widget that organizes widgets in horizontal and vertical boxes that are limited to left, right, top, bottom positions and many other positions. Each box is offset and relative to each other. And here we are using the place. So place places widgets in a two-dimensional grid using x and y absolute coordinates. Then we have the grid. So grid method locates widgets in a two-dimensional grid using row and column absolute coordinates. One thing is important when you use this pack, place or grid, you should not be combined these all in the same master window. Instead choose one and stick with it. Further you will know why we should stick with one only. So here we have created a label and placed it in a variable greeting. So we'll save this and run the window. You can see that the Tkinter window has appeared and we can see the text that is placed on a label, and the text says hello learners, welcome to the Tkinter tutorial. Now moving on, we will comment this and now we will add some functionalities to the label widget only. So for that we will create label and here we'll not assign it to any variable, like we will assign it to a variable and name it as label only. Tk dot label, and this would be capital for label, and inside we'll add the text and that would be same, that would be hello learners, welcome to Tkinter tutorial. After setting the text for our label, here we can set the foreground and the background color. So for that we will write fg, that is foreground, and that would be equal to white color, and we'll set the background for the label as green. For that we'll write the command bg equal to green. And now to get this label showed on your Tkinter window, you have to use any of the three methods, that is pack, place or grid. So now we will use the place method only. So first we'll write the variable name, that is label, and the place method, and inside we'll set the coordinates, that is x equal to 190 and y equal to 210. Now we'll save this and run the file for you guys. You can see that the label has got the background color as green and the foreground color for text as white. So now moving on, we can add other attributes to the label widget, and that would be the width and the height. So for that we'll write width, that would be equal to 30, and height we'll set it as 10. So now we'll save this and run the file again. You can see that it has expanded itself. So we have set the width equal to 30, that is the x-axis, it has expanded to 30 pixels, and height equal to 10 pixels. So I have told you that label widgets are used to display text or images, and the text displayed by a label widget can't be edited by the user. It's for display purpose only. Label widgets display text with the default system text color and the default text background color. These are typically black and white, respectively, but you may see different colors if you have changed these settings in your operating system. And you can control label text and background colors using the foreground and background parameters, as we have seen that. So moving on, as you have set the color with the words here, you could also set them with the hexacode. So to set them with the hexacode, you could just write the hexacode for the color, and here I will use this purple color, or what there would be a specific like the dark blue, magenta, what you call this color. So I will save this and run it for you guys. First I will close this. So here you can see that I have set the color with the hexacode, and like the text, it's coming out of the width. So for that, we'll set the width as 50. Oh, I will set it as 500. Set as 50. Close the previous window, save the file, and run it again. Here you can see that we have set the width as 50 and y-axis, that is height, as 10. So moving on, we will start with button widgets. So we'll close this, take into a window, and command down this. Now we'll start with button widget. So button widgets are used to display clickable buttons. Like there would be text, and those buttons would be clickable. You can configure them to call a function whenever they are clicked. And in many ways, a button is just a label that you can click. So as we have set the height and width for the label, we can set it with the same parameters. And the difference is you can just click, and that turns out to be a button widget. So to make the button widget, we will start with a variable, and to set the button, we'll use tk.button, and inside we will set the text that would be click me to say hi. So when you click it, I will have to set a function to get its functionality. So click me to say hi. So this would be the text that would be displayed on the button, and then we'll set the width for the button, and we'll set it as 25 pixels, and then the height, and that would be 2 pixels. So width, that would be equal to 25, and height, that would be equal to we'll set it as 2 pixels only. And then we'll set the background color, that would be white, and we'll set the foreground color as black. Background color is white, and for foreground we'll use FG, and that would be equal to black. And now if you want to add some functionality, you can add it in the command. So first we will declare the function and add the functionality for a button, and after that we can use the command. So we'll just pack it and see how a button looks in a Tkinter window. So for that we will use, okay, we have written it here. Sorry for that. So we are set with the button. Yeah, we'll save this file and click on the run button. You can see that the button is displayed on the Tkinter window, so it's clickable. So that's what make it differentiate from the label. It's clickable. Now we'll add functionality so that we can have some text when we click on this. So for that, first we'll create a, and we'll create the function here and name it as hello. And here we will create a label in this function, and inside we will place a text, and that would be, hi learners, welcome to Tkinter tutorial. And now in this function only we will set, like in the label, for the label we'll set the foreground color. Foreground color we'll set it as white, and background color we will set it as green. Okay. Now we will pack it so that it gets visible on a Tkinter window. So we can also pack it here. We will just use the pack method and it will get showed up in a Tkinter window. So now we have created a method or a function, and we have that functionality. Now we have to set that this functionality to a button. So for that we will write command, and that would be equal to the name of the function, that is hello, and it's capital H. Okay, and we have packed the button, so no need to do it again. So we'll save this and run it. So you can see that we are seeing a button here, and that says click me to say hi. That is what we have set the text for it. When we click it, we see the functionality, that is it has displayed a label with background color that is green and foreground color that is white, and it displays the text as hi learners, welcome to Tkinter tutorial. So this is about the button widget. Now moving on, now we'll start with the entry widget. So for that, oh sorry, first we'll comment this, and we'll also comment this function. So now we'll start with the enter widget. So why we use enter widget? When we want to get text from a user, like a name or an email address, we use an entry widget. It's a display that display a small text box that the user can type some text into. So creating and styling an entry widget works pretty much exactly like the label and the button widgets. So we will start with the enter widget, and for that first we'll create a label only, and on that label we'll place the enter widget. So first we'll create a variable and name it as label only, and after that we will go with this, like creating a label, and then we will add some text to the label. That would be, it will ask for what is your name, or we'll just add name to it, and here we will create the enter widget. For that we will create a variable and name it as entry, and now we'll create the entry widget. So this is the simple method to create any entry widget. We have created that, and now we have to place or pack or grid it to get a display on a tick enter window. So here we will use pack label.pack, and we'll also pack the enter widget. So we are done. Now we'll save it and run it. You can see that we have created a label and placed the text there, that is name, and beneath that we have packed an enter widget, and inside we can enter anything. That's my name Abhisara Huja, and you can enter anything. So these are the basic functionalities for the enter widget. You could see our other videos to get the hands on this enter widget and other widgets to get the other attributes and functionalities and use them in any app you want to make. So moving on, we will comment this, or I will give you another example for the entry widget. So for that, first we will create a label only, and inside we will place the master, that is the window, and assign text to it, and that would be name only. Here we will create a form, and it won't be having some functionalities to store the information, but it would be a form for name, email, password, and for that we'll use the enter widgets. So we have created a label here, and here you will, so we will use the place method to get it displayed on the tick enter window, and we'll set the x coordinate as 30 and y as 50 pixels. And moving on, we will set the entry widget and a label. First we'll set the label for email, so for that we'll also create a label, and inside we'll pass the master, that is window, and set the text as email only, so it get displayed on the label. Now we'll use the place method only to get it displayed on our tick enter window, and for this I will use x equal to 30 and y equal to 90. It would in the same x coordinates, and in y direction it would be shifted downwards, and that would be y equal to 90. Now I will create another label and store it in a variable that would be password. And to create it, I will write tk dot label, sorry, and here the small n for label, and inside we will pass the master window, that is window, and set the text as password only. And now we will place this label and we'll set the x coordinate as 30 and y will shift it downwards and set it as 130. Yeah, so these would be the labels. And now see these labels, like how they're placed. So you can see name, email, password, and now we will place entry widgets in front of them. So to get the entry widgets, first we will assign a variable, and inside that we will create an entry widget that would be tk.entry, and inside we will pass a master window, and now we will place this at x equal to 80, like it would be sufficient, I think so. We will see when we will get this displayed now. Okay, so we have set the x coordinate as 80 and y is 50. Now we will make another entry widget for email and then for password. So for this we will name the variable as e2, and here we will just a second. Okay, we have to, okay, we'll do it tk.entry, and e would be capital for that, and that would be the master window, and we'll place this at x equal to 80 and y will shift it downwards, that would be same for the label email, that was 90. And now we'll create another variable that is e3, and for that we have created an entry widget, and now we will place this and set the x coordinate as 80 only, and y coordinate that would be the same for the label, that was 130. So we will save this and run it. You could see that name, email, password, that are the labels, and we have got our enter widgets and it's overwriting. So we will set this as 100. We'll save it and run it. You could see that it has shifted 20 pixels apart from this from its previous position. So this is about the enter widget. So this is a basic tutorial, so I won't be getting into the get method, delete method, or the insert method. So there are three main operations that you can perform with entry widgets, that is retrieving text with get method, that is dot get method, and deleting text, that is with delete method, and inserting text, that is with insert method. So we will do this much only in this basic tutorial. And moving on, now we will create some frames. So frame widgets are important for organizing the layout of your widgets in an application. Like you have many widgets and you have used around 3 to 4 widgets and you want to organize them. So you have to create widget that is frame, and inside that frame widget you can organize all the other widgets. So an empty frame widget is practically invisible. You won't be able to see that if you haven't placed any widget in that. So frames are best thought of as containers for other widgets. You can assign a widget to a frame by setting the widget's master attribute, as we have set the master attribute as window in the enter widget, and in the label as we have seen in the enter widget example. So here we will start with creating frames, and for that first we will assign a variable frame underscore a, and that would be equal to tk.frame. We will create a frame, sorry, and now we will create a label for that, and we will assign the variable as label underscore a, and that would be equal to tk dot label, and inside we would get this label fixed into the frame. So for that we will set the master as frame. So we have set the variable as master here, and this variable contains the frame. Now we will add the text to the label, and that would be, this is frame A. We will name it as A, and here we can set the background color also. So here we will use the hexacode for that. We won't write the simple name of the color, so here we will write the hexacode, and have taken its inverted comma. So now we have to set the background color, and that would be in the inverted commas only. So we will start with hash, and we'll set the color as, I remember the hexacode for 468 to be 4. To color. So you will get the background color, and now we will pack this label so that it gets displayed on your Tkinter window. Okay, so for that we will write the variable and use the pack method, and now we'll create another frame and store it in a variable frame underscore b, and inside we will create a frame tk dot frame, and here we will create another label that would be label underscore b, and that would be equal to tk dot label, and here we'll set the master as frame only, as we would be setting this label into the frame. So for that we'll write frame underscore b. Now we'll set the text, that would be, this is frame b. Okay, now we'll set the background color, and we will set the background color different from the above, so you can differentiate that. So I remember E9967A, and for the hexacode you have to use hash. So what you call this color, like light red, light orange, or anything, so just get that sorted. So we'll pack this widget. For that we'll use the variable label underscore b, we'll use the pack method, and we have packed it. Now we will save this, showing the red. Okay, we have not placed the inverted comma here, so we'll save this and run it. Okay, label is not defined, so we have written label. Okay, so sorry for my silly mistake. So we'll save this and run it again for you guys. So here we are not able to see it. So what? Oh, we have not packed the frame here, so we would not be able to see that. So we'll pack it here only. So first we'll pack frame underscore a dot pack, and then frame underscore b dot pack. Now we'll save this and run it again. You could see there's two frames displaying, that is, this is the frame A and this is the frame B, and this is the label on above the frame. And if we just swap these packs, what would happen? Let's see. We'll save this and run the file again. You could see that the frame has been shifted. So the pack method, it just pack the widgets line by line in a layer form. So you must be careful with that. Okay, so now we'll see some appearance for the frames. We have seen how to create a frame. Now we'll see how these frames can be displayed, how its appearances are. Like we have the 5 appearances. We'll discuss it and we will adjust these frames according to their appearances, and these appearances can be called out with the method or with the attribute that is relief. So frame widgets can be configured with a relief attribute that creates a border around the frame. You can set relief to be any of the values, that is the flat value that we have seen that has no border effect, the default value. Then there is sunken, that is SUNKEN in the capitals, that it creates a sunken effect. I will show you like what that effect is. Then we have the raised, then groove, and the ridge. So for that, we will see a simple example. And one important thing, to apply this border effect, we must set the border width attribute to a value greater than 1. This attribute adjusts the width of the border in pixels. So for that, we will create the frames and we will start with border, and that would be equal to, we will create a dictionary here. So for the flat keyword, we will create a, in the capital letters we have to write flat. Okay, and for the sunken, we will create tk dot sunken. Okay, and in dictionary we have to place the commas, and after sunken we have raised, groove, and ridge. So for that, we'll write raised and we'll create tk. I have done a mistake above. So this would be tk dot sunken, comma, and now we will have the groove border. That is tk dot groove, comma, and after that reg. That is tk dot reg. Okay. So now we will run a loop for relief underscore name, comma, relief in, you set the border, and that is, we will iterate these items one by one. And now we will create a frame that would be tk dot frame and set the master as window and relief equal to relief and set the border width. That's also the point, and we'll set it as 5. Okay, and now we will pack this frame. So for that we'll use the pack method, frame dot pack, and now we will create a label that is tk dot label, and inside we'll set the master as frame and text. We'll set the text as relief underscore name, and then we'll pack this label. Okay, now we'll save this and display it for you guys. So you could see that first we have the flat frame, then sunken, then raised, then groove, then ridge. Okay, so if you want to set these frames on the left side, for that you can use tk dot left attribute. We'll save this and run it for you guys. Oh, we have to assign it inside. Sorry, I will save this and run it for you guys. So you can see that it has shifted to left. Like all these are packed in the left direction, all the frames. So now moving on. Now we will see the frames with different colors. I will just comment this down, and now we will get the frames. We'll start with a variable and name it as frame1 and create a frame tk dot frame with capital F, and inside we'll set the master as window and width as 100 and height as 100, and background color we'll set it as red. And now we will pack this frame. So this frame would be of the red color. So to pack this, we will write frame1, that is the variable in which the frame has been stored, and we'll use the pack method. So we have packed it. Now we will use fill to fill this frame in the whole window. For that we'll write fill equal to tk dot capital S X. So it will get this frame fulfilled in the window in the X direction. And similarly we will create another frame. I will copy paste it and name the variable as frame2, and inside I will change the color, and I will set the width and height now. Okay, I will show you like how it will work. Pack this frame2 dot pack, and now we'll also set another frame and name it as frame3. Okay, and for this also we have to set another color so that we can differentiate that which frame is this. So we'll set it as blue. Now we'll save this and run it. So you can see that we have set the width and height, but we have used the fill attribute to fill it in the whole x direction. So it has got filled up. So these are the three frames we have created. Now we have seen the basics or the beginner for the tkinter module. Now using these modules, we will create a simple project that would be dollar to rupee converted, as I have told you earlier in the starting, in the introduction. For that, we will just create a new file and name it as dollar to rupee converter.py. So if like rupee, so here we will use the current value of what $1 is equal to rupee. We will set it as current value, so we will search it in the web and use it in a function. Okay, so we'll make this project a simple one, or just a simple app to get you hands on with these widgets. Okay, so starting with importing, so first we'll import tkinter, and as we have seen earlier, we've used alias for that, and here also we'll use that. And after that we will create window that is equal to tk dot tk class and window dot main loop. Okay, now we will set the geometry of the window. So for that we will write, and we will set the x-axis with 300 pixels and small x, and y-axis is 250 pixels. Okay, and we won't be adding some pixels to the x or the y direction. It will just come in the default section that this ideally would get it appear to. Okay, now we'll use the configure function and set the background color. So with configure you could set the background color and other attributes. So for that we'll write window dot config, and inside we'll set the background color bg equal to, and I remember the hexa code for that. Here we will use hexa code, or you could just write the name of the color. Okay, E9967A, we have used it previously, the light red color. Okay, now I have discussed with you that the resizable function, but we haven't used it in the former, that is the py file, but here we will use. So for that we'll write window dot resizable, and inside we will set the width equal to false and height also as false. So you won't be able to adjust its width or height, and you won't be seeing any arrow for that. Okay, like if you place the cursor on the border of the window now, you won't be able to see any error to get it stretched out in the x or y direction. So we have used the resizable function for that. Now we'll set the title for this window. For that we'll write window.title, and inside we'll write the title, that would be dollar to rupee converter. Okay, now first we will start with a label, and we will add the heading as dollar to rupee converter only. So for that we will create a label and place it inside the variable L1 tk dot label, and inside we will pass the master as window and set the text as dollar to rupee converter. And we can set the font also. Okay, for that we'll just use the font attribute, and inside we have to place these in a circular braces. So for that we'll write, we have taken its inverted comma. We'll use Arial here. Okay, and set the font size as 15. Now we'll close the circular bracket. Okay, we have to close one more, and we'll set the foreground color as white. Okay, and we'll also set background color, and that we would set as hexacode BC0. Sorry, C0. Okay, and that would be in the inverted commas, else it would be termed as the comment only. And now we'll close the circular bracket. Okay, and we will pack it at the last only. Now we will create another label, and for that we'll store it in L2 variable. For that we'll write tk dot label, and inside we'll pass window as master and text, and here we will set the label as enter dollar amount. Okay, so that will write text enter dollar amount. Okay, now we will add some functionality, and after amount we'll write the colon. Now we'll set its font. In the circular braces, and we'll set this also as Arial and set its size just smaller than the heading, that would be dollar to rupee converter. We'll set it as 10. Okay, and we'll set it as bold. This we have to place it in inverted commas, and after the font we'll set the foreground color, that would be equal to white, and then we'll set the background color. We have taken the inverted comma of the white. Now we'll set the background color, and for that we'll write the hexa code, and that would be A569BD. So we'll see this purple color, so I call it purple. I'm bad with color, so you can see what you want to call this color, or like what's the fundamental name of this color. So now we have created two labels, enter dollar amount, and now we will get another label, and that would be for amount in rupees. Like after we will execute the dollar to rupee, so that would be displayed in that label, that would be displayed just beneath this label that we will be creating, that would be L3, and for that we will write tk.label, and inside we will pass the master as window and set the text as amount in rupees. Okay, and now we'll set its font, and we'll set it same only as Arial, and with the font size 10, and we'll also set it as bold. Okay, so outside this font we will set the foreground and background color, and that would be foreground color white, and background color we'll write the hexa code for that only, and that would be same A569BD. Okay, now we will create entry widgets. So first entry widget, that would be for entering the amount, enter dollar amount. So this enter widget would be beneath the enter dollar amount label. So for that we will create a variable even and get an enter widget tk dot entry, and we have e capital for the entry, and inside we will pass master as window, and we'll set the font as Arial, the circular braces. Okay, and set the font size as 10 and no bold for it. Okay, and in the window first we have created the heading that was in the label, that is dollar to rupee converted. Then we have created a label enter dollar amount, and beneath that we have created an entry widget in which we will enter the dollar amount, and then we will create a button to convert this dollar amount into the rupee. So now we will be creating a button. So we will name the variable as button1, now we'll pass the window as master and set the font as Arial and font size as 10 only. No, but for button first we have to set the text now what it should display. So it should display convert to dollar. No, convert to dollar, convert to rupee. Okay, so we have set the text and we have set the font, and now we have to place a command, and in that command we have to place a function so that it should convert the dollar amount into the rupee. So we have to create a function. We will create it here. Okay, and name it as convert only. So for that we will write convert, and inside we will set a variable and integer type, and here we are using the get method to get the text that we have inputted in the entry widget that is stored in the even variable. And after that we will create a variable f, and inside we will write the dollar value against a rupee, that is 80.71 rupees is equal to $1. So that would be multiplied with the dollar amount, that would be C, but we will get it. Oh, sorry. Okay, so now we will create a text widget. So for that we will create a variable that is t1 and create a text widget tk dot text, and inside we will pass the window as master and set the state as disabled. I will tell you why. Disabled, and set its width as 15 and height as 0. Okay, so we will also configure this in the function. Okay, so we'll configure this and write as t1 dot config, and we'll set its state equal to normal. Okay, and t1 dot delete, that is if you want to delete you can delete it as one by one, tk dot end, and t1 dot insert, and set it as its state as disabled. Okay, Now we will pack all these widgets. First we'll start with labels. L1.pack, then L2.pack, then entry widget that is stored in even.pack, and then button dot pack, and then L3 dot pack, and then T1 dot pack. Okay, now we'll save this and run it. Okay, so we have to create empty text, like empty labels. We will create it here, empty underscore L1, and create a label that is tk dot label. Okay, and inside we will pass window and set the background color equal to, that would be E9967, oh sorry, E9967A, that is the light red color. Okay, and here we will create an empty label that is tk dot label, and now we will pass the master as window and background color as light red only. We'll write the same hexacode E9967A. Sorry, I press shift also with that. So okay, now we'll save our program and run it. So we're getting an error that is undefined at state equal to normal. Okay, able to find any error, so we'll just run it again only. Okay, we got that. So you can see that it's not resizable. We have created the convert method to create the dollar amount, that is we have entered the dollar amount, that is 1, and we click on the button that is convert to dollar, it would reflect us to 82.71. And if we get it deleted and enter the dollar amount as 56 and click on the button that is convert to dollar, it would display us as 56 into the value that is 82.71. So this is the small project that we have created using the widgets, that is the tkinter widgets. So I hope like you code these all the widgets. So this was the basic tutorial. If you want to learn more, you can just see the other videos that is in the I button. If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
Seaborn library in Python. In today's video, we will learn how to visualize data and draw insights with different charts and graphs using the Seaborn library. These visualizations are often referred to as plots in Python. So what is Seaborn in Python? The Seaborn library in Python is a widely popular data visualization library that is commonly used for data science and machine learning tasks. It is built on top of the matplotlib data visualization library and allows you to perform exploratory data analysis. Using Seaborn, you can create interactive plots to answer specific questions about your data. It helps you find trends in your data that you can't notice just by looking at the data. Now, to understand the Seaborn library in detail and how to create different plots and know the data better, we will be using two datasets in our demo. The first one is the empty cars dataset and the second is the popular iris flower dataset. Now let's head over to our Jupyter notebook and start with our demonstration. So I am on my Jupyter notebook. Let me go ahead and rename the notebook. I'll say Seaborn demo. We'll rename it. Alright. You can see I have the first two cells already filled in. So while working on an exploratory data analysis project using Python, you will need Numpy, Pandas, Matplotlib and Seaborn libraries for data manipulation and visualization. So let's import these libraries first. So I've already written import Numpy as NP, Pandas as PD, Matplotlib.pyplot as PLT, Seaborn as SNS. Alright. So I'll hit Shift Enter to run this first cell. Alright. Now, using the read_CSV function that is present in the Pandas library, I am importing my dataset, that is empty cars. I'll tell you what empty cars is about. This is a CSV dataset and here I have given the location where my dataset is present. Let's run it. Alright. Now, let me go ahead and print the first 5 rows of my empty cars data frame. For that I'm using the head function. If I run it, okay, you can see here it has given me the first 5 rows. The index starts from 0 till 4, so total 5 rows of information, and you can see these are the columns that are present in the empty cars dataset. The first is the model of the car. Now just let me give you a background about this dataset. So the data is taken from the 1974 Motor Trend US magazine. It has information about fuel consumption and 11 different aspects of automobile design and performance of 32 cars. Alright, so here we have the first column as the model of the car, and then we have MPG, which is miles per gallon. Then we have CYL, which stands for the number of cylinders in the vehicle or the car. Then we have DISP, which is displacement in cubic inches. So these all values are in cubic inches. After that we have HP, which is gross horsepower. Then we have something called as DRAT, which is basically the rear axle ratio. Then we have WT, which is the weight of the car in pounds. So think of it as weight multiplied by 1000 pounds. Alright, and then we have Cusec, which is 1/4 mile time. This is a measure for acceleration. Then we have something called as VS. This is the type of engine for each of the vehicles. So 0 stands for V-shaped engine and 1 stands for straight engine. Then we have AM, which is basically the mode of transmission. So 0 is for automatic transmission and 1 is for manual transmission. Then we have the number of forward gears present in the vehicle, and then we have something called as CARB or CARB. This stands for the number of carburetors. So carburetors is a device for supplying a spark ignition engine with a mixture of fuel and air. Alright. Now We'll use the info function to print the summary of the data frame. So the info function returns information regarding the index data type, column data types. Then we have the information about non-null values and memory usage. So I'll write my data frame name, which is empty cars dot, I'm going to use the info function. Let's run it, and here you can see we have all the columns. There are total 32 entries from 0 to 31, so data about 32 cars. Then here you can see the data types and the memory usage. Now moving ahead, let me just print the shape of the data frame. That will give you the number of rows and columns present. I'll use the shape attribute. You can see here there are total 32 rows and 12 columns in my data set. Now the Seaborn library provides a range of plotting functions that makes the visualization and analysis of data easier. So we'll cover some of the crucial plots that are available in Seaborn. So let's start with a bar plot. I'll give a comment as bar plot. Now first understand what a bar plot is. So a bar plot gives an estimate of the central tendency of a numeric variable with the height of each rectangle. It provides some indication of the uncertainty around the estimate using error bars. Now to build this plot, you usually choose a categorical column in the x-axis and a numeric column on the y-axis. So we'll create a bar plot between the number of cylinders and the miles per gallon. So let's start. I'll declare a variable called res, which essentially stands for result. Then I'll use SNS, which is for the Seaborn library. I'll say SNS dot followed by my bar plot function, and inside the function I'll pass in my data frame name, that is empty cars, and then for x-axis within the bracket using quotation I'll give my column name as cylinder. So this is going to be my x-axis, and for y-axis I'll say my data frame name empty cars, then the square bracket followed by my y-axis column, that is miles per gallon. Now to display, I'm going to use the matplotlib function. I'll say plt.show. Let's run it and we'll see the result. There you go. So here you can see on the x-axis we have the number of cylinders. So in our data we have vehicles with 4, 6 or 8 cylinders, and on the y-axis you can see the miles per gallon. Now what essentially this graph tells us is that when the number of cylinders in the vehicle increases, my miles per gallon on MPG for the vehicles decreases. And you can see these black lines. So these lines indicate the uncertainty around the estimate using error bars. Alright. Now you can create the same bar plot using another way. Now we will exclusively define the x and y axis columns and also pass the name of the data frame using the data argument. Let me show you how to do it. I'll use the same variable name res, which stands for result. I'll say sns dot bar plot. Now inside the bar plot function I'm going to exclusively define my x axis. I'll say x equal to, I'll pass in my column as cylinder, then I'll say y axis, which is miles per gallon, and then using the data attribute I'll pass in my data frame name, that is empty cars, and finally we'll write plt.show. Let me run it. You see here we have the exact same bar plot as the above one. So this is another way to create a bar plot. Now Python Seaborn allows the users to assign colors to the bars. So the bar chart that we are going to create will convert all the bars to a particular color. So for that I am going to use the color argument. So I'll say res equal to SNS dot my function, that is bar plot. I'll say x equal to cylinder. My y-axis will have mpg, and then I'll say data is empty cars, give a comma, and my final attribute I'll say color equal to, I'll say yellow. Close the bracket, and then I'm going to write plt.show. If I run it, you can see here all the bars have been converted to yellow color now. You can change the color argument. Let's say I'll make it to red. If I print it, you can see here all the bars have been changed to red color now. Alright. Now Seaborn library also has the palette argument, which you can use to give different colors to the bars. So if you go to Google and search for Seaborn palette, you have a nice link here. So here there are different palettes provided by Seaborn. You can see here SNS.color palette, and these are the names of the palette. You can use whichever palette you want. Alright, so I'll say res equal to SNS.barplot. We'll use our first method of assigning a bar plot. So I'm using my data frame empty cars, and this time we are going to change the x and y labels. Let's say I'm using my x label as transmission, whether automatic or manual transmission, and then in my y axis I'll have miles per gallon. Then I'm going to say palette equal to, I made a spelling mistake here. Let's say our palette is set2. This is the name of the palette. I'll write plt.show. If I run it, you can see here we have the two modes of transmission. 0 is for automatic transmission of the vehicle, 1 is for manual transmission, and you can see the miles per gallon for each of the modes of transmission. If you want, you can change the palette colors. Let me just copy this. I'll paste it in my new cell, and instead of set2, let's say we'll use another palette called as rocket, and I'm also going to alter my x and y labels. Let's say in my x label I'll have gear, and my y label will be horsepower. If I run it, you see here we now have a different palette, and the bars are of different colors. On the x-axis you have the gears, 3 gear, 4 gear or 5 gear vehicle, and on the y-axis you have the horsepower. So from the graph you can see the horsepower is low for vehicles that have 4 gears, while it is high for the vehicles that have 5 gears. Now let's understand how to create a count plot. So the count plot function in the Python Seaborn library returns the count of total values for each category using bars. We will create a count plot that returns the total number of vehicles for each category of cylinders. I'll just give a comment here as count plot. Alright, so I'll start SNS dot, I'll use the count plot function, and I'll define my x-axis as cylinders. My y-axis won't have any label or any column because y-axis will only show the count. Then I'm going to use my data parameter or the argument and pass in my data frame name, that is empty cars. Let's say I'll set the palette to set1. Let me run it. Okay, there is some error. Let's debug the error. It says str object has no attribute get. Okay, so this should be without the single quotes. Make sure the data frame name is without the single quotes. Let's run it again. There you go. So you can see here, this is a nice count plot that shows the number of cylinders on the x-axis, and on the y-axis you have the count. You can see here there are more number of vehicles that have 8 cylinders, and there are less number of vehicles or cars that have 6 cylinders, and actually you can count it as well. So you can see here there are 14 cars that have 8 cylinders, there are 11 cars that have 4 cylinders, and there are 7 cars that have 6 cylinders. Alright, now moving ahead, the next count plot will show the number of cars for each carburetor. So for that I'm going to say sns dot count plot. My x-axis will now have the variable carburetor. I'll say data equal to empty cars, and my palette I'll set it to set1, or let's say set2. Now let me run it. You can see it here. On the x-axis we have the different number of carburetors, 1, 2, 3, 4, 6 and 8, and you can see we have more number of cars that have 2 and 4 carburetors, and there are very few vehicles that have 6 and 8 carburetor. Cool. Now moving ahead, so the Python Seaborn library allows you to create horizontal count plots where the feature column is on the y-axis and the count is on the x-axis. Let me show you how to create a horizontal count plot. I'll say sns dot count plot. I'm going to define my y label or the y-axis as gear. I'll say data equal to empty cars, and set my palette to, let's say, rocket. Let me run it. Okay, you see here this is a horizontal count plot. If you compare it with the above one, these were all vertical count plot, as in the bars were vertically aligned, but here you can see the bars are all horizontally aligned, and on the y-axis you have the gear column, and on the x-axis you have the count. So if you mark here properly, you can see there are 15 vehicles with 3 gears, there are 12 vehicles that have 4 gears, and there are total 5 vehicles with 5 gear. Now you can also create a grouped count plot using the hue parameter. So the hue parameter accepts the column name for color encoding. Now let's build a count plot that shows the number of cars for each category of gears grouped by the number of cylinders. So we are going to group based on the number of cylinders. Let me show you how to use the hue parameter for that. I'll say sns dot count plot. In the x-axis I'll have my gear column. Then I am going to pass my hue parameter that will have the cylinder column or the number of cylinders for each vehicle. I'll pass my data frame using the data argument as empty cars, and say palette. I'll set my palette to set1. Let's run it. If I scroll down, you see here we have a count plot. On the x-axis you have 3, 4 and 5 gears of the different vehicles, and for each gear you have the bars that represent the number of cylinders. So for vehicles that have 3 gears, we have majority of the vehicles having 8 cylinders. Similarly, for vehicles that have 4 gears, we have most of the vehicles with 4 cylinders. And if you compare for the cars that have 5 gears, so we have equal number of vehicles that have 4 and 8 cylinders, and then we have one vehicle that has 6 cylinders. Cool. Now moving ahead, so the Seaborn library supports the distplot function that creates the distribution of any continuous data. Let's create the distribution of miles per gallon of the different vehicles or the cars. The MPG matrix measures the total distance the car can travel per gallon of fuel. So here I'll give a comment as distplot, which stands for distribution plot. I'll say SNS dot distplot. I'll pass in my data frame name, that is empty cars, give a period and say MPG, which is my column name. Then I'm going to define the number of bins that I want, let's say 10, and then I'll use the color argument and I'll say, let's say G, which is for green. Let's run it now. There you go. If I scroll down, you can see we have a nice distribution plot. So these are all histograms, and you can see we have a smooth curve, and this shows the distribution of miles per gallon that is present in our dataset. Alright, now moving ahead, you can also create heat maps using the Seaborn library. So the heat maps will let you visualize matrix-like data. The values of the variables are contained in a matrix and are represented as colors. You can create a correlation heat map, which is a graphical representation of a correlation matrix representing the correlation between different variables. So in our example, we will create a heat map where you can find the correlation between each variable in the empty cars dataset. I'll just give a comment as heat map. I'll say SNS and I'll use the heat map function. I'll pass in my data frame name, that is empty cars, followed by my function called CORR, which is for correlation. Then I'll say C bar is equal to true. So the C bar argument is used to draw the color bar. Then I'll say line widths, I'll pass it as 0.5. Let's run it. There you go. Here you can see we have a nice heat map, and on the right side you can see the color bar that starts from minus 0.8 and goes up to plus 0.8. So this ranges between -1 and +1, and the bars or the cube, you can say, that have a lighter color have a positive correlation, and the ones that are dark have a negative correlation. So for example, you can see here for cylinder and MPG, the color is really dark, which is around this region, -0.8. This means when the number of cylinders in the car increases, your miles per gallon decreases. And this we also had seen in our first bar plot, this one. You can see here, whenever the number of cylinders increased, your miles per gallon had decreased. And this is what has been depicted in our correlation map or the heat map. But if you see for cylinder and displacement, there is a positive correlation which comes around this color bar range. Similarly, there are other features in the dataset. For example, if you compare for the weight of the vehicle and the number of cylinders, there is a positive correlation, which means when the weight of the vehicle increases, the number of cylinders present in the vehicle also increases. And the others you can also compare and find out the correlation based on this color bar.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, now let's move ahead. The Seaborn scatterplot function helps you create plots that can draw relationships between two continuous variables. So to understand about scatterplots and other plotting functions, henceforth we are going to use iris flower dataset. So let's go ahead and load the iris flower dataset. I'll say iris equal to sns dot load underscore dataset. So this iris flower dataset is already inbuilt into the SNS or the Seaborn library. Now we'll go ahead and print the first 5 rows from the dataset. There you go. Here you can see here there are total 4 feature variables. You have the sepal length, sepal width, petal length and petal width of the 3 species of flower, that is Setosa, Virginica and versicolor. So using this dataset we are going to see the rest of the Seaborn plotting functions. First let me go ahead and print the different species of flower and the count for each of the species of flowers that we have in our dataset. I'll say iris, within square brackets I'll pass in the output or the target variable, that is species, and I'll use the function that is value underscore counts. Let's run it. There you go. So we have 50 flowers of Setosa type, again 50 flowers of versicolor species, and then we have another 50 flowers of type Virginica. So there are total 150 flowers present in our dataset. Alright. Now we'll create a scatter plot to show the relationship between sepal length and petal length for different species of iris flowers. So I'll say SNS dot followed by the scatterplot function. In the x-axis I'll say sepal length column, give a comma, I'll pass in my y-axis with petal length, then I'll say data equal to iris. Now let's run it. You can see here this is my scatter plot between sepal length and petal length. Now you can classify the different species of flowers using the hue parameter as species in the function. So what I'll do is I'm going to copy my above code, I'll just paste it here, and we are going to edit in this cell itself. I'll add a last parameter called hue, and this will have my species column. Let's run it and see the difference. There you go. Here you can see we have a nice scatter plot. The blue dots are for Setosa, the orange dots are for versicolor, and for Virginica you have the green dots. From this scatter plot you can see that for Virginica flowers the sepal length and the petal length are higher than your versicolor and Setosa, and this region is completely for Setosa flowers. So you can say that the Setosa flowers have lower sepal length and petal length. Alright, now you can also use another parameter known as the size that will differentiate the different species of flower in terms of the size of the dots. I'll say size as species. Let's run it. You can see the result. There you go. So here you can see the Virginica flowers are in green dots. The size is small, followed by versicolor with medium sized dots, and then we have Setosa whose size is large. Okay. Now the Python Seaborn library lets you visualize data using pair plots that produces a matrix of relationship between each variable in the dataset. So let me show you how to create a pair plot. I'll say SNS dot pair plot, which is the function. Then I'll pass in my data frame name, that is iris. I'll put this iris data frame within double quotes and we'll run it. Okay, there is some error here. Let's debug the error. Data must be pandas data frame. Okay, what I'll do is I'll just remove the double quotes and we'll run it. This might take some time to create the pair plot, so just wait for a while. There you go. Here you can see we have a nice pair plot. On the y-axis you have the sepal length, sepal width, petal length and petal width. Similarly on the x-axis also you have the same feature columns. All the diagonal plots are histograms and the rest of the plots are scatter plots. Now you can convert the diagonal visuals to KDE or kernel density estimation plots and the rest of the scatter plots using the hue parameter. This makes the pair plot easier to classify each type of flower. So I'll just copy this cell of code, paste it here, and I'll say hue equal to species. Then I'll say palette equal to set1. Let's run it and we'll see the new pair plot now. This might take some time. There you go. So here you have the pair plot ready, and on the right side you can see the different species. The red color dots represent Setosa flowers, the blue color dots represent versicolor, and the green color dots represent Virginica flowers. Now if you look at this graph, you will find that your petal length is the best feature to classify the three different species of flowers. The reason being, you can see here they are very well categorized and they are separated. All the red dots present here in the petal length represent Setosa flowers. Around this range, all the blue dots represent versicolor flowers and the green dots are all Virginica flowers. So out of the four features, petal width, petal length, sepal width and sepal length, you can take petal length as the best feature to differentiate between the three species of flowers. Alright, now coming to lmplot function. So the lmplot function in the Seaborn library draws a linear relationship as determined through regression for continuous variables. So let's create the plot to show the relationship between petal length and petal width of the different species of iris flowers. I'll just give a comment here as lmplot. I'll say SNS dot lmplot. In the x-axis we'll have petal length, give a comma. In the y-axis I'll pass in petal width and I'll pass in my data frame using the data argument or parameter, which is iris. Let's run it. You can see it here. We have a nice plot. The line you see here is a linear regression line. Now in this lmplot, you can use the hue parameter to differentiate between each species of flowers, and you can set markers for different species. Let me show you how to do it. I'll say sns dot lmplot. We'll say x as our petal length, give a comma. I'll write y as petal width. Then I'm going to pass the hue parameter. In hue, I'll say my column as species. Then I'll give data equal to my dataset name, that is iris. And now you can pass in markers argument to differentiate the different types of flowers. Let's say I want to represent setosa with dot or O. Then my next species, which is versicolor, should be represented with a star symbol, and the final virginica species of flowers should be represented with, let's say, this arrow mark. Now let me go ahead and run it. There you go. You have 3 different linear regression lines, and the circle dots in blue color represent setosa, the orange color stars represent versicolor flowers, and the triangles represent virginica flowers. So this is how you create a linear relationship between the different types of flowers using the regression line. Alright, now let's take a look at the final plotting function, where we will create a box plot. A box plot, also known as a box and whisker plot, depicts the distribution of quantitative data. The box represents the quartiles of the dataset. The whiskers show the rest of the distribution except for the outliers. Now let's see the distribution of the 3 species of flowers based on their sepal width. I'll just give a comment as box plot. Is the final plot that we are going to see in our Seaborn demo. I'll say sns dot box plot. In the x-axis, we'll have the species column. In the y-axis, we'll have sepal width. Then I'll pass my data as iris. Let's run it. There you go. We have this box plot created. At the bottom in the x-axis, you can see we have the box plot for setosa flowers, orange for versicolor flowers, and green for virginica flowers. Now this line represents median, which is inside the box. So this is also the median for versicolor flowers. You can compare the median sepal width for each of the flowers from the y-axis. This line represents the maximum sepal width value for setosa flower, and this line at the bottom represents the minimum length of the sepal width for setosa flowers. Now these dots that you see outside the box plot are called as outliers. The extended lines that are outside the box plot are known as whiskers. Alright, so that brings us to the end of this demo session on Seaborn library in Python. So first we imported our empty cars dataset. Then we saw how to create a bar plot. We learned how to use the color argument or the parameter inside bar plot. We also saw how to use the palette attribute or the palette parameter. Then we learned about creating count plots. Then we saw how to create horizontal count plot. Now moving ahead, we saw how to create distribution plot. Then we saw a correlation heat map. After that, we analyzed the other functions such as the scatter plot, then we had the pair plot, and we had the LM plot for finding the linear relationship, and later we saw the box plot using the iris flower dataset.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
So let's start with what is Numpy. Numpy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on Numpy. So the fundamentals of Numpy are so important to latch onto for the Python so that you can understand the other modules and what they're doing. Numpy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In Numpy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimension array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that Numpy's array class is called NDArray for Numpy Data Array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to jupyter.org, that's jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda Notebook, but this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython, and you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice, I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps. So you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate, so you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And where we go on here is we then have on the upper right, New, and from the pull-down menu you'll see Python 3, and this will open up a new window. And now we're in Jupyter Python, so this is a Python window, and we'll just do a print. And this, of course, is hello world. And we'll run that, and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our Numpy array versus Python list. Python list being the basic list in your Python. Why should we use Numpy array when we have Python list? Well, first, it's fast. The Numpy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today. And just like any modules, we have to import Numpy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our Numpy module inside our Python. And then the most common thing, of course, is to go ahead and create a Numpy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter Notebook. And just like all your other standard arrays, I can go A of 0, which is going to be a value of 1. Of course, we do A of 1. You go all the way through this. A of 1 has a value of 2 in it. So whether you're using the Numpy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0 and when we set on there. So let's take a look why we're using Numpy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do B equals range of 1. Yeah, 1,000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. We want system.getSize of. And we'll pick any integer because we have, 0 to 1,000. We'll just throw one in there, 5. It doesn't matter because it's going to, whatever integer we put in there is going to generate the same value because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the B. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong, comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in Numpy. And we'll go C equals NP. And this is A range. So that's the Numpy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of C for np.arange, let's go ahead and print. And we can do that by doing c.size times c.item size. And that's very similar to what we did before. We did get the size of, so the C size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and C size. And let's just take a look and see what that generates. And wow, Okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size, and we'll do an L2. I'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals NP dot A range size. And then let's do on A2 equals NP dot A range. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y, and we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print, and let's say Python list took, and then we'll do time dot time. We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because that's in milliseconds, so times 1,000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. We'll run that just so you can see what kind of data we're looking at. And we have the 02468. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again we see Python list took 46. A little different time on there depending on what core. Because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using Numpy is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part because I really am a lazy typer. And this isn't the Python list, this is the Numpy list, or Numpy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the Numpy. That's why a lot of people base so many other modules on Numpy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here, where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at A shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals. In this case, let's do np float 64. And so what we've done is we're converting all of these into a float, and we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just there's a 1 dot, or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times they've had to convert something from an integer to a float so that's going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do A shape with it set to 64. And it should be the same, 3, 2. So it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for Numpy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different Numpy data types. Shorthand, complex, we have complex, complex 64, complex 128. complex number represented by two 64-bit floats, real and imaginary components. One option on there, float 16, float 32, float, shorthand for float 64, most commonly used, and of course all the different ones that you can possibly put into your Numpy array. So we covered a basic addition up there when we were comparing how fast it runs, but some very basic components, how to set up a Numpy array, how many dimensions it has, item size, data type, again we went to item size, and there's also the shape. Probably one of the more used. I use the A shape all the time. Very commonly used. And then down here you can see where we actually created a Numpy complex data type. So let's look at some other features in Numpy. One of them is you could do Numpy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a Numpy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do Numpy ones, and we'll do the same thing, 3, 4. We'll run that. And you can see I've created an array of Numpy ones. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do L range 5. And we'll print the L. So that's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array, 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in Numpy A range, remember that from before, and if we do Numpy A range 5, and let's do L equals, or we can just leave it as Numpy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the Numpy A range 5. It generates the actual array. And for part 1, we're going to do just one more section on basic setup, and we're going to concatenation, do a concatenation example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, let's see, print. Let's do an np character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi. And in the brackets on there, let's create another one. And this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, you can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in Numpy, it takes the two different arrays that we set up in there, and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up. It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3. And we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20. And fill character equals, we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, We can do uppercase, we can split, split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So Numpy just makes it simple, and we like that. And so in this case, we did Python data. It's all uppercase. Python is easy, like shouting in your messenger. Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split. Are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces? And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, how are you doing? The two different lines are now split apart. And let's just review three more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from the 1920s and has gotten old. So there we go. We've covered a lot of the basics in Numpy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shape in there and setting them up. We also saw that you can create a zeros-based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in Numpy. And you saw how easy it was to add two arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have two different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also how to join the data sets. So here's a character join option for your strings. And finally we did the character replace. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under New and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also a markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we want to do is import. We're going to import Numpy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. Numpy is just something you bring in there. And let's go ahead and create our array, and we're going to do that as the np.arange. Remember, that's 0, well, we're going to do 0 to 9, and then we'll go print, put a little title on the original array. We'll just print that array A. Remember from the first lesson, so we have our array which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape, and then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I had too many brackets in there. Modified array, and then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15, that's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and they call it a flat because it's just a single array. And we can reshape it into a 3 by 3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing because they'll come in that I have an array that's xy, comma xy1, y1, comma x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into x flat array and a y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do b, do a print, and we'll do b dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days. I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the Numpy array page, you can see here that they have the flatten. I just open up the Numpy ND array flatten setup to look it up. And they have three different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, or originally worked, which is row major. Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is Numpy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course, the Jupyter Notebook even have a little extra print at the beginning. If we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you could call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this one is so important. We'll do np transpose A. Let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've swapped it. So we've gone from a 3 by 4 or a 4 by 3 to a 3 by 4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is X, Y, Z. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it, and if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up at the same exact thing. And let's play with the reshape. And you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do B equals np.arange. Let's do 8. And reshape. We'll do 2, 4. Let's go ahead and print B and then run that. And you'll see we have now the 2 rows. This is a bit more like, so we have 4, maybe 2 rows of 4 things. So this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis, and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with c comma 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits instead of rolling the 1 setup. We now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there. And we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this. But it's another way to manipulate the numbers on your Numpy. And finally, let's go ahead and swap axes. We'll do C. And let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over Numpy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. Alright, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9, and let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, we run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 11, 10, 11, 12. So let's change B's now, 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1 plus 11 is 12, 2 plus 12 is 14, 13, so 10 plus 3 is 13, 11 plus 4 is 15, and 12 plus 5 is 17, and so on. We'll put this back, since that's how the original setup was. Let's do 10 by 10 by 10, and run that, and get the original answer. And if you're going to add them together, we need to go ahead and subtract AB, and we run that. We get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB. And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide A by B? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. We'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And slicing means we're just going to take sections of the array. So let's create an array np a range. Let's just do 20. And if you remember, if we do a, we have a 0 to 19. And then we can do a, and remember that we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, it's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5 because that's the order they're in. And then this one's interesting because I can do s equals slice, and let's create a slice here, and let's do 2, 9, yeah, let's leave a 2 on there. So we'll create an s slice on here. And then if we take our array and we do array of s, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12. There we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward. It's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've accessed the different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in Numpy, they have some cool controls for that. So put this in as a markdown. There we go, and run it. And it's called the nd-iter. I'm not sure what the nd stands for, but nd-iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it a equals np a range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one, but it's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so we can do with this, we can also do a equals reshape. Let's go ahead and take and reshape this. And since there's 9 variables in there, we'll do a reshape at 3 by 3. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out. We get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4xn, our numpy nd-iter of a colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array, so you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for A and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the nd-iterator because it'll minimize the amount of resources needed to go through each of the different objects in the Numpy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type, and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming, and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A, and we'll do for x in np iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the nd iterator. I knew I was missing the nd part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Missed something up there. Let me fix that real quick. When I was reformatting it to go on separate lines, I messed that up. There we go, run. All right, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the key word we use is concatenate. And if you're familiar with Linux, it usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. Has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the 1 axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axis equals 1. So we have our concatenate, we have AB, and then axis 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, oh, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it will let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axis 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axis 0, 1, 2, 3, 4, 5, 6, 7, 8. Axis 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do np split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here. I'm just going to move the A split down here. Instead of the 3, let's do 4, 5, and put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split an A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first markers, this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here, 4, position 5. That's why we're splitting it in those 2 sections. We could also do it 7, just to see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different ways and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. Hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. And let's do b equals np dot resize. We're going to resize A, and let's resize it with 3 by 2. And then we'll just go ahead and print B and print B period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with a shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the to reshape it? I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2-3 to a 3-2, we can resize it to a 3-3. So let's take a look and see how it handles that. And when we come down here to 3-3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here, because that certainly you can picture all the different numbers on there, but let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the matplot library. So from matplot library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the matplot library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at Simplilearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to do plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the matplot library, they call them bins. You might hear the term buckets, or they put them in buckets. That's a really common term. And then we want to give it a title. So the way it works is you do your plt.hist for histogram, your plt title, and your plt show. And we're doing just a single array in here in the Numpy array of A. And let's go ahead and run this piece of code. Take it a moment to come out there. It says figure size, so it's generating the graph. And you can see we have, and let's just take a look at this. Let me go down a size. There we go. Okay, so now we can see we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range, least common between the 80 and 100. This looks like an age demographics, is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a Numpy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling them buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet, and a ladder going down. So the first would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of, I don't know what this would be, maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental, maybe it's knowledge, because as we hit a certain point and then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older you grow more. But you can see here we lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in Numpy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the Numpy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common Numpy array setup. Then a real common one is to do summation. So we'll do summation where you do, in this case, we create a Numpy array of two different arrays, 1, 2, 3, or two different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be underneath our math section. Square root and standard deviation, 2 very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, I probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And NP array is x, we're going to do x equals, hey, we changed it from A to x. X equals rabble. And this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical. But we also have the option of doing a rabble by column. And then another one is log. So you can do mathematical log on your array. In this case, we have 1, 2, 3. And we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions. So you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some Numpy practice examples. And let's start by figuring out how do you plot, say, a sine wave in Numpy. What would that look like? And so in this project we wouldn't have to do this because I've already run these. But we'd want to go ahead and import our Numpy as NP and import our matplot library pyplot as PLT. So we get our tools going here. And then we'll break it into 2 sections because we need our X, Y coordinates in here. So first off, let's create our X coordinates. And our X coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine, it's going to be between 0 and 0.1. And then we use our NP, and we actually can look up Numpy stores pi. So you have the option of just pulling pi in there directly from Numpy. It has a few other variables that it stores in there that you can pull from there. But we have Numpy pi. And we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what X looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times Numpy pi. Remember, pi is like 3 point something, something, something. So that makes sense. It should be about 9. And we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our Y variable. And so y is going to simply equal np, or numpy.sine of x. And then once we have our x and y, and if we print, let's go ahead and just print y. See how that, we'll do this. Let's do this so it looks print x, print y. So we basically have 2 arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot, because we're going to plot the points, and we'll do x comma y, and then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9, And here's our sign value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 two-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 two-dimensional, so the shape is 6x6 two-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole Numpy array with zeros or ones or whatever. So we're going to do NP, create a Numpy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down, and then the next diagonal will be 1s all the way across diagonally, and then the next one 0s, the next one 1s, the next one 0s, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here, and we'll do z1::2, ::2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2, so we're going to skip a row. So skip here, skip here, skip here. So we're going down this way, and we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row, like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows. And then in every 2 rows, we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every 1. This would just be 1s. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get 1s. So this notation allows us to go down each row, row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1, and again we go every other one going down. That's what that step 2 is. That's skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0, but it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different access on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. We're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a 5th one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers, size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nans at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just NP is nan of Z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. Now let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So NP argware NP is nan of Z. So we're going to create our own another NP array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 19204654. And then let's go ahead and run this again. Run. There we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do, it's very similar because we have np is nanz.sum. So we're summing the number of nans. And we can get the indexes and you can reshape the indexes. But you can also just do, we'll do an INDS where np is nan of z. And let's just print that. Print INDS. Let's see what that looks like. And it's very similar. We have 0130638693, but I've split it into 2 different arrays. So we have our x and our y kind of coordinates going there. And what I can now do is I can now do z INDS equals, and at this point you can also, instead of getting the sum, you can get the means or all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick up the average. That's very common in data science to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember F stands for Fortran, very strange connotation, but there's C and F. C is the standard, and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F, but when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4 by 3 to a 3 by 4. Oops, I did that the other way around. 3 by 4 to 4 by 3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And at this point it's so important we just look up the Numpy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There is all your different miscellaneous mathematical connotations. So, Google it, go to the main Numpy page and look at the different setups you can do on there. So we covered that. And we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in Numpy. Talked about the line space setup for doing numbers in a series. How to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in Numpy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some Numpy practice examples. We challenged you to create a sine wave in Numpy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, Numpy pi. And we're going to do intervals of 0.1, and then y just equals the Numpy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally, we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the Numpy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. Pandas really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. There actually sits kind of on Numpy, so if you've already had our Numpy array, hopefully you've already gone through the Numpy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about Pandas, and there is some connections. There's like an interface going on with that, so there is availability, but you really should know your Pandas, because if you're working in big data, you'll know there's data frames. Well, Pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into Pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said that it's a data frame. So the data structures in Pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a Pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from Numpy we studied, they had to be all uniform. Not in Pandas. In Pandas we can do a lot more. And Pandas actually kind of sits on Numpy, so you really need to know both of those if you haven't done the Numpy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just 2 columns, and we have a nice index label and a column label for the data. And then a data frame is a two-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this would look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel, So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows. So you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org, and then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in our I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3, and this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial, and we'll go up to Cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas. And usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our Pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In Pandas, you just use the, in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it. Take pieces of it, so query it. Delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series, and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with Numpy arrays is we can import our Numpy as NP. Remember that from our Numpy tutorials. We can go ahead and create a Numpy out of random with the random numbers of 5. And let's just see what that n looks like, so we can see what our Numpy looks like. So we have some nice random float values here, 2.33, so on. And that's from our last tutorial, the Numpy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create our, we'll just use S2 again. And here's our NP for Numpy, series, capital S, and N is our NP for Numpy. PD for Pandas, there we go, switching my anachronisms. So we have pd.series of n, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 is to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the Numpy array. So we used Numpy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for Pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1, the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable, or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on our basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a Numpy array. So you can put a Numpy array in there. It's all the same, pd.series, Numpy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the Pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing, most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output, so it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. And we can do the same thing by not having the A in there. I'll go ahead and take that out, but it's just a reminder that it's not actually changing S1. It's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1. And you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end. And likewise, we can do a 2 here. CDE to the end, so it starts at the second one. And another way we can do this is we can do a -2 over here, and that looks at just the last 2 in the slice. So you can see how easy it is to slice the data, and of course there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have ABCDE, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and ABCD, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. Alright, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next what we want to get into is we want to get into operations that happen on the series. Let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with the series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Pandas series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same, and we'll call this S6, and we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do S5.add S6. And let's see what that generates. And just a quick thing, if you've never used Pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this, there's nothing there. So it gives us a null return. Very different than the Numpy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add S5.add S6, and likewise we can do S5.sub for subtract S6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's the null values where it can't subtract the 2 because there's no values there to subtract. We can also do S5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this. And you can see how they're multiplied together. And then we can also do the S5 div, 3 letters again, S6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting, because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a Numpy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a Pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the Pandas that you can use. And next we're going to use Numpy to go ahead and generate some random numbers. In this case we'll do the np.random in 6,4. You can look at this as rows and columns as we move it into the Pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know what, before we do the next one, let's go ahead and just print out our Numpy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns. And we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame. And we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns. And you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our Numpy array, because that's what we're going to create our data frame off of, is the Numpy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looked like a jumble of data. We have our column names and everything else, our Numpy array kind of just a jumble array over there, 4 by 6. You can sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, this is our date, this is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. We have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our Numpy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, np.nan, numpy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas, data frame, and then we have our data, just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like, df2. So let's go ahead and run that. And again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats, and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df_tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is, the tail, I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. Looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a Numpy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a Numpy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the Numpy array, the index dates, and the columns. And remember, in our Numpy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then of course we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up dtype. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have def2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75%, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. And it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4x6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't deal, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2, and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun. Because remember, this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go to have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's I'll pick a spot. Let's go back up here where we had, let's do F age is, let's see, what was we looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to F and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location, and iLocation is null. Making a copy, here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this by, you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age. Look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, AA, BA, CA, popped in a null value, cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D, and it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we use the string function str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC, and Baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. And we'll go ahead and run that. And you can see we now have ACD, AAA, Baka. Everything's capitalized except for the null value, which is still null. Alright, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was, it's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4, I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the iris data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you what the folder is going into. Right now I have some untitled and a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. and it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read underscore CSV. I always have to remember it's to underscore CSV and read underscore CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head, we only want to look at the first 3 lines. So if I go ahead and run this, we'll see the first 3 lines and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet 1, and then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet 1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here, and we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2, there we go. And let's run that. Let's make this, no, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel, and one of these is a CSV on here. And so there's our 2 file types on there. And they have other formats. These are just the 2 most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at 2 different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because 1, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import Numpy as NP. We want to make sure we have our ampersand matplot library in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember for earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute cuddly creatures, versus pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the matplot library. Why? Because it's already in there. Pandas already has its built-in connection and interface with matplot library, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, and we're going to do 50 by 4. And then we'll go ahead and create columns A, B, X, and Y, just because we can. Index is a ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's put that in. And let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is. And you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models for testing them out. Now, there are a lot of features in Pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using Pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd. And it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame. Not a database. I keep saying database. It's a data frame. And we'll just make this data frame using our dictionary going in. This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A, 1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on the location, is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of a, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index dated setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, 1, the fact that you can add logic gates into here. And 2, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download. And I never really look too closely at all the downloads. But you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is a really powerful tool. All of this is really powerful tools for doing your data science.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning, in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
And we're going to cover the Scikit-learn tutorial, which has a lot of features and all kinds of API in it to explore data and do your data science with. In fact, it's probably one of the top data science packages out there. So, what is the Scikit-learn? It's a simple and efficient tool for data mining and data analysis. It's built on Numpy, SciPy, and Matplot library, so it interfaces very well with these other modules. And it's an open source, commercially usable BSD license. BSD originally stood for Berkeley Software Distribution License, but it means it's open source with very few restrictions as far as what you can do with it. Another reason to really like the Scikit-learn setup, so you don't have to pay for it as a commercial license versus many other copyrighted platforms out there. What we can achieve using the Scikit-learn, we use the two main things are classification and regression models. Classification, identifying which category an object belongs to. For one application very commonly used is spam detection. So is it a spam or is it not a spam? Yes, no. In banking, you might be, is this a good loan, bad loan? Today we'll be looking at wine. Is it going to be a good wine or a bad wine? And regression is predicting an attribute associated with an object. One example is stock prices prediction. What is going to be the next value? If the stock today sold for $23.05 a share, what do you think it's going to sell for tomorrow and the next day and the next day? So that'd be a regression model. Same thing with weather forecasting. Any of these are regression models where we're looking at one specific prediction on one attribute. Today we will be doing classification. Like I said, we're going to be looking at whether a wine's good or bad. But certainly the regression model, which is in many cases more useful because you're looking for an actual value, is also a little harder to follow sometimes. So classification is a really good place to start. We can also do clustering and model selection. Clustering is taking an automatic grouping of similar objects into sets. Customer segmentation is an example. So we have these customers like this, they'll probably also like this. Or if you like this particular kind of features on your objects, maybe you like these other objects. So a referral is a good one, especially on Amazon.com or any of your shopping networks. Model selection, comparing, validating, and choosing parameters and models. Now, this is actually a little bit deeper as far as a Scikit-learn. We're looking at different models for predicting the right course or the best course or what's the best solution. Today, like I said, we're looking at wines. So it's going to be, well, how do you get the best wine out of this? So we can compare different models, and we'll look a little bit at that, and improve the model's accuracy via different parameters and fine-tuning. Now, this is only part one, so we're not going to do too much tuning on the models we're looking at, but I'll point them out as we go. Two other features, dimensionality reduction and pre-processing. Dimensionality reduction is we're reducing the number of random variables to consider. This increases the model efficiency. We won't touch that in today's tutorial, but be aware if you have, thousands of columns of data coming in, thousands of features, some of those are going to be duplicated, or some of them you can combine to form a new column. And by reducing all those different features into a smaller amount, you can increase the efficiency of your model. It can process faster, and in some cases you'll be less biased because if you're weighing it on the same feature over and over again, it's going to be biased to that feature. And pre-processing. These are both pre-processing, but pre-processing is feature extraction and normalization. So we're going to be transforming input data such as text for use with machine learning algorithms. We'll be doing a simple scaling in this one for our pre-processing, and I'll point that out when we get to that. And we can discuss pre-processing at that point. With that, let's go ahead and roll up our sleeves and dive in and see what we got here. Now, I like to use the Jupyter Notebook, and I use it out of the Anaconda Navigator. So if you install the Anaconda Navigator, by default, it will come with the Jupyter Notebook, or you can install the Jupyter Notebook by itself. This code will work in any of your Python setups. I believe I'm running an environment of 3.7 setup on there. I'd have to go in here into environments and look it up for the Python setup. But it's one of the 3X's. And we go ahead and launch this, and this will open it up in a web browser. So it's kind of nice. It keeps everything separate. And in this Anaconda, you can actually have different environments, different versions of Python, different modules installed in each environment. So it's a very powerful tool if you're doing a lot of development. And the Jupyter Notebook is just a wonderful visual display. Certainly you can use, I know Spider is another one which is installed with the Anaconda. I actually use a simple Notepad++ when I'm doing some of my Python script. Any of your IDEs will work fine. Jupyter Notebook is Iron Python because it's designed for the interface, but it's good to be aware of these different tools. And when I launch the Jupyter Notebook, it'll open up, like I said, a web page in here. and we'll go over here to new and create a new Python setup. And like I said, I believe this is Python 3.7, but any of the three, the Scikit-learn works with any of the 3x's. There's even 2.7 versions, so it's been around a long time, so it's very big on the development side. And then the guys in the back, guys and gals, they went ahead and put this together for me. And let's go ahead and import our different packages. Now, if you've been reading some of our other tutorials, you'll recognize Pandas as PD. Pandas library is pretty widely used. It's a data frame setup, so it's just like columns and rows in a spreadsheet with a lot of different features for looking stuff up. Seaborn sits on top of Matplot libraries. This is for our graphing. And we'll see that how quick it is to throw a graph out there to view in the Jupyter Notebook for demos and showing people what's going on. And then we're going to use the random forest, the SVC or support vector classifier, and also the neural network. So we're going to look at this. We're actually going to go through and look at 3 different classifiers that are most common, some of the most common classifiers, and let's show how those work in the Scikit-learn setup and how they're different. And then if you're going to do your setup on here, you'll want to go ahead and import some metrics. So the sklearn.metrics on here, and we're going to use the confusion metrics and the classification report out of that. And then we're going to use from the sklearn pre-processing the standard scalar and label encoder. Standard scalar is probably the most commonly used pre-processing. There's a lot of different pre-processing packages in the sklearn. And then model selection for splitting our data up. It's one of the many ways we can split data into different sections. And the last line here is our percentage matplot library inline. Some of the Seaborn and matplot library will go ahead and display perfectly inline without this, and some won't. It's good to always include this when you're in the Jupyter Notebook. This is Jupyter Notebook, so if you're in an IDE, when you run this, it will actually open up a new window and display the graphics that way. So you only need this if you're running it in a editor like this one, with specifically Jupyter Notebook. I'm not even familiar with other editors that are like this, but I'm sure they're out there. I'm sure there's a Firefox version or something. Jupyter Notebook just happens to be the most widely used out there. And we can go ahead and hit the run button, and this now has saved all this underneath the packages. So my packages are now all loaded. I've run them, whether you run it on top or you run it to the left, and all the packages are up there, so we now have them all available to us for our project we're working on. And I'm just going to make a little side note on that. When you're playing with these and you delete something out and add something in, even if I went back and deleted this cell and just hit the scissors up here, these are still loaded in this kernel. So until I go under kernel and restart and clear or restart and run all, I'll still have access to Pandas. Important to know, because I've done that before. I've loaded up, maybe not a module here, but I've loaded up my own code and then changed my mind and wondering, why does it keep putting out the wrong output? And then I realized it's still loaded in the kernel and you have to restart the kernel. Just a quick side note for working with a Jupyter Notebook and one of the troubleshooting things that comes up. And we're going to go ahead and load up our data set. We're using the Pandas, so if you haven't yet, go look at our Pandas tutorial. A simple read the CSV with the separation on here. And so let me go ahead and run that. And that's now loaded into the variable wine. And let's take a quick look at the actual file. I always like to look at the actual data I'm working with. In this case, we have wine quality-red. I'll just open that up. I have it in my open office setup. I'm separated by semicolons. That's important to notice. And when we open that up, you'll see we have, go all the way down here. It looks like 1,600 lines of data minus the first one, so 1,599 lines. And we have a number of features going across. The last one is quality. And right off the bat, we see the quality is has different numbers in it, 5, 6, 7. It's not really, I'm not sure how high of a level it goes, but I don't see anything over a 7. So it's kind of 5 through 7 is what I see here. 5, 6, and 7. 4, 5, 6, and 7, looking to see if there's any other values in there. Looking through the demo to begin with, I didn't realize the setup on this. So you can see there's the different quality values in there: alcohol, sulfates, pH, density, total sulfur dioxide, and so on. Those are all the features we're going to be looking at. And since this is a Pandas, we'll just do wine head, and that prints the first 5 rows of data. And that's, of course, a Pandas command. And we can see that looks very similar to what we were looking at before. We have everything across here. It's automatically assigned an index on the left. That's what Pandas does if you don't give it an index. And for the column names, it has assigned the first row. So we have our first row of data pulled off our comma-separated variable file, in this case semicolon separated. And it shows the different features going across. And we have, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 features. 12 including quality, but that's the one we want to work on and understand. And then because we're in Pandas data frame, we can also do wine.info. And let's go ahead and run that. This tells us a lot about our variables we're working with. You'll see here that there is 1,599. That's what I said from the spreadsheet, so that looks correct. Non-null float 64. This is very important information, especially the non-null. So there's no null values in here. That can really trip us up in pre-processing. And there's a number of ways to process non-null values. One is just to delete that data out of there. So if you have enough data in there, you might just delete your non-null values. Another one is to fill that information in with like the average or the most common values or other such means. But we're not going to have to worry about that. But we'll look at another way, because we can also do wine is null and sum it up. And this will give us a similar, it won't tell us that these are float values, but it will give us a summation. Oops, there we go, let me run that. It'll give us a summation on here, how many null values in each one. So if you wanted to, from here you would be able to say, okay, this is a null value, but it doesn't tell you how many are null values. This one would clearly tell you that you have maybe 5 null values here, 2 null values here. And you might just, if you had only 7 null values and all that different data, you'd probably just delete them out. Where if 90% of the data was null values, you might rethink either a different data collection setup or find a different way to deal with the null values. And we'll talk about that just a little bit in the models too, because the models themselves have some built-in features, especially the forest model, which we're going to look at. At this point, we need to make a choice. And to keep it simple, we're going to do a little pre-processing of the data, and we're going to create some bins. And bins we're going to do is 2, 6.5, 8. What this means is that we're going to take those values. If you remember up here, let me just scroll back up here. We had our quality. The quality comes out between 2 and 8 basically, or 1 and 8. But we have 5, 5, 5, 6. You can see just in the first 5 lines of variation in quality. We're going to separate that into just 2 bins of quality. And so we've decided to create 2 bins. We have bad and good. It's going to be the labels on those 2 bins. We have a spread of 6.5 and an exact index of 8. The exact index is because we're doing 0 to 8 on there. The 6.5 we can change. We could actually make this smaller or greater, but we're only looking for the really good wine. We're not looking for the 0, 1, 2, 3, 4, 5, 6. We're looking for wines with 7 or 8 on them. So high quality. This is what I want to put on my dinner table at night. I want to taste the good wine, not the semi-good wine or mediocre wine. And then this is a Pandas, so PD, remember, stands for Pandas. Pandas cut means we're cutting out the wine quality and we're replacing it. And then we have our bins equals bins. That's the command. Bins is the actual command, and then our variable bins, 2, 6.58. So 2 different bins. And our labels, bad and good. And we can also do, let me just do it this way. Wine quality, since that's what we're working on. And let's look at unique. Another Pandas command, and we'll run this. And I get this lovely error. Why did I get an error? Well, because I replaced wine quality and I did this cut here, which changes things on here. So I literally altered one of the variables that is saved in the memory. So we'll go up here to the kernel, restart and run all. That starts it from the very beginning. And we can see here that that fixes the error because I'm not cutting something that's already been cut. We have our wine quality unique, and the wine quality unique is a bad or good. So we have 2 qualities objects. Bad is less than good, meaning bad's going to be 0 and good's going to be 1. And to make that happen, we need to actually encode it. So we'll use the label quality equals label encoder. And the label encoder, let me just go back there since this is part of Scikit. That was one of the things we imported, was a label encoder. You can see that right here from the sklearn.processing import standard scalar, which we're going to use in a minute, and label encoder. And that's what tells it to use bad equals 0 and good equals 1. And we'll go ahead and run that, and then we need to apply it to the data. And when we do that, we take our wine quality that we had before, and we're going to set that equal to label quality, which is our encoder. And let's look at this line right here. We have dot fit transform. And you'll see this in the pre-processing. These are the most common used is fit, transform, and fit transform. Because they're so often that you're also transforming the data when you fit it, they just combine them into one command. And we're just going to take the wine quality, feed it back into there, and put that back in our wine quality setup and run that. And now when we do the wine and the head of the first 5 values, and we go ahead and run this. You can see right here underneath quality 0, 0, 0. Have to go down a little further to look at the better wines. Let's see if we have some that are 1s. Yeah, there we go. There's some 1s down here. So when we look at 10 of them, you can see all the way down to 0 or 1. That's our quality. And again, we're looking at high quality. We're looking at the 7 and the 8s, or 6.5 and up. And let's go ahead and grab our, where was it? Here we go, wine quality. And let's take another look at what else, more information about the wine quality itself. And we can do a simple Pandas thing, value counts. Hopefully I typed that in there correctly. And we can see that we only have 217 of our wines which are going to be the higher quality. So 217, and the rest of them fall into the bad bucket, the 0, which is 1,382. So again, we're just looking for the top percentage of these. The top, what is that? It's probably about a little under 20% on there. So we're looking for our top wines, our 7 and 8s. And let's use our, let's plot this on a graph so we can take a look at this. And the SNS, if you remember correctly, that is, let me just go back to the top, that's our Seaborn. Seaborn sits on top of Matplot library. It has a lot of added features, plus all the features of the Matplot library. And it also makes it quick and easy to put out a graph. We'll do a simple bar graph. And they actually call it count plot. And then we want to just do count plot the wine quality. So let's put our wine quality in there. And let's go ahead and run this and see what that looks like. And nice inline. Remember, this is why we did the inline, so make sure it appears in here. And you can see the blue space, or the first space, represents low quality wine, and our second bar is a high quality line. And you can see that we're just looking at the top quality wine here. Most of the wine, we want to just give it away to the neighbors. No, maybe if you don't like your neighbors. Maybe give them the good quality wine, and I don't know what you do with the bad quality wine. I guess use it for cooking. There we go. But you can see here it forms a nice little graph for us with the Seaborn on there, and you can see our setup on that. So now we've done some pre-processing. We've described our data a little bit. We have a picture of how much of the wine, what we expect it to be, high quality, low quality. Checked out the fact that there's none, we don't have any null values to contend with or any odd values. Some of the other things you sometimes look at these is if you have like some values that are just way off the chart. So the measurement might be off, or miscalibrated equipment if you're in the scientific field. So the next step we want to go ahead and do is we want to go ahead and separate our data set, or reformat our data set. And we usually use capital X, and that denotes the features we're working with. And we usually use a lowercase y. That denotes what, in this case, quality, what we're looking for. And we can take this and we can go wine. It's going to be our full thing of wine. Dropping, what are we dropping? We're dropping the quality. So these are all the features minus quality. And we'll make sure we have our axes equals 1. If you left it out, it would still come out correctly just because of the way it processes on the defaults. And then our y, if we're going to remove quality for our x, that's just going to be wine, and it is just the quality that we're looking at for y. So we put that in there. And we'll go ahead and run this. So now we've separated the features that we want to use to predict the quality of the wine and the quality itself. The next step is if you're going to create a data set and a model, we got to know how good our model is. So we're going to split the data, train and test splitting data. And this is one of the packages we imported from Scikit. And the actual package was train, test, split. And we're going to do x, y, test size 0.2, random state 42. And this returns 4 variables. And most common you'll see is capital X train, that's what we're going to train our set with. Capital X test, that's the data we're going to keep on the side to test it with. Y train, Y remember stands for the quality or the answer we're looking for. So when we train it, we're going to use X train and Y train, and then Y test to see how good our X test does. And the train test split, let me just go back up to the top. That was part of the Scikit model selection, import, train, test, split. There is a lot of ways to split data up. This is, when you're first starting, you do your first model, you probably start with the basics on here. You have one test for training, one for test. Our test size is 0.2 or 20%. And random state just means we just start with it's like a random seed number. So that's not too important back there. We're randomly selecting which ones we're going to use. Since this is the most common way, this is what we're going to use today. There is, and it's not even an Scikit package yet, so someone's still putting it in there. One of the new things they do is they split the data into thirds, and then they'll run the model on they combine each of those thirds into 2 thirds for training and 1 for testing. And so you actually go through all the data and you come up with 3 different test results from it, which is pretty cool. That's a pretty cool way of doing it. You could actually do that with this by just splitting this into thirds, and then, or have a test set, one test set third, and then split the training set also into thirds, and also do that and get 3 different data sets. This works fine for most projects, especially when you're starting out. It works great. So we have our X train, our X test, our Y train, and our Y test. And then we need to go ahead and do the scalar. And let's talk about this because this is really important. Some models do not need to have scaling going on. Most models do. And so we create our scalar variable. We'll call it SC, standard scalar. And if you remember correctly, we imported that here, along with the label encoder, the standard scalar setup. So there's our scalar, and this is going to convert the values. Instead of having some values that go from 0, if you remember up here we had some values are 54, 60, 40, 59, 102. So our total sulfur dioxide would have these huge values coming into our model. And some models would look at that and they'd become very biased to sulfur dioxide. It'd have the hugest impact. And then a value that had 0.076, 0.098, or chlorides would have very little impact because it's such a small number. So when we take the scalar, we kind of level the playing field. And depending on our scalar, it sets it up between 0 and 1 a lot of times is what it does. Let's go ahead and take a look at that. And we'll go ahead and start with our X train. And our X train equals SC fit transform. We talked about that earlier. That's an Scikit-learn setup. It's going to both fit and transform our X train into our X train variable. And if we have an X train, we also need to do that to our test. And this is important because you need to note that you don't want to refit the data. We want to use the same fit we used on the training as on the testing. Otherwise, you get different results. And so we'll do just, oops, not fit, transform. We're only going to transform the test side of the data. So here's our X test that we want to transform. And let's go ahead and run that. And just so we have an idea, let's go ahead and take and just print out our X train. Oh, let's do first 10 variables, very similar to the way you do the head on a data frame. You can see here our variables are now much more uniform, and they've scaled them to the same scale, so they're between certain numbers. And with the basic scalar, you can fine-tune it. I just let it do its defaults on this, and that's fine for what we're doing. In most cases, you don't really need to mess with it too much. It does look like it goes between like probably -2 to 2 or something like that. That's just looking at the train variable. We'll go ahead and cut that one out of there. So before we actually build the models and start discussing the Scikit-learn models we're going to use, we covered a lot of ground here. When you're working with these models, you put a lot of work into prepping the data. So we looked at the data, noticed that it's separated, loaded it up. We went in there, we found out there's no null values. That's hard to say, no null values. We have, there's none null value. I can't say it. And of course we sum it up. If you had a lot of null values, this would be really important coming in here. So is there a null summary? We looked at pre-processing the data as far as the quality. And we're looking at the bins. So this would be something you might start playing with. Maybe you don't want super fine wine. You don't want the 7 and 8s. Maybe you want to split this differently. So certainly you can play with the bins and get different values and make the bins smaller or lean more towards the lower quality. So you then have like medium to high quality. And we went ahead and gave it labels. Again, this is all Pandas we're doing in here. Setting it up with unique labels and group names. Bad, good. Bad is less than good. That can be so important. You don't know how many times people go through these models and they have them reversed or something. And then they go back and they're like, why is this data not looking correct? So it's important to remember what you're doing up here and double check it. And we used our label encoder. So that was to set that up as quality 0, 1. Good, in this case we have bad, good, 0, 1. And we just double check that to make sure that's what came up in the quality there. And then we threw it into a graph because people like to see graphs. I don't know about you, but you start looking at all these numbers and all this text and you get down here and you say, oh, yes, here, this is how much of the wine we're going to label as subpar, not good. And this is how much we're going to label as good. And then we got down here to finally separating out our data so it's ready to go into the models. And the models take X and a Y. In this case, X is all of our features minus the one we're looking for, and then Y is the features we're looking for. So in this case, we dropped quality, and in the Y case, we added quality. And then because we need to have a training set and a test set so we can see how good our models do, we went ahead and split the models up: xtrain, xtest, ytrain, ytest. And that's using the train test split, which is part of the sklearn package. And we did, as far as our testing size, 0.2 or 20%. The default is 25%, so if you leave that out, it'll do default setup. And we did a random state equals 42. If you leave that out, it'll use a random state. I believe it's default 1. I'd have to look that back up. And then finally, we scaled the data. This is so important to scale the data. Going back up to here, if you have something that's coming out as 100, it's going to really outweigh something that's 0.071. That's not in all the models. Different models handle it differently. And as we look at the different models, I'll talk a little bit about that. We're going to only look at 3 models today, 3 of the top models used for this, and see how they compare and how the numbers come out between them. So we're going to look at 3 different setups. Oh, let me change my cell here to markdown. There we go. And we're going to start with the random forest classifier. So the 3 setups we're looking at is the random forest classifier, support vector classifier, and then a neural network. Now we start with the random forest classifier because it has the least amount of parts, moving parts to fine tune. And let's go ahead and put this in here. So we're going to call it RFC for random forest classifier. And if you remember, we imported that. So let me go back up here to the top real quick. And we did an import of the random forest classifier from sklearn ensemble. And then we also, let me just point this out. Here's our SVM where we imported our support vector classifier. So SVM is support vector model, support vector classifier. And then we also have our neural network. And we're going to, from there, the multi-layered perceptron classifier. Kind of a mouthful for the P, perceptron. Don't worry too much about that name. It's a neural network. There's a lot of different options on there in setups, which is where they came up with the perceptron. So we have our 3 different models we're going to go through on here. And then we're going to weigh them. Here's our metrics. So we're going to use a confusion metrics, also from the sklearn package, to see how good our model does with our split. So let's go back down there and take a look at that. And we have our RFS equals random forest classifier. And we have n estimators equals 200. This is the only value you play with a random forest classifier. How many forests do you need? Or how many trees in the forest. So how many models are in here. That makes it pretty good as a startup model because we're only playing with one number and it's pretty clear what it is, and you can lower this number or raise it. Usually start up with a higher number and then bring it down to see if it keeps the same value. So you have less, the smaller the model, the better the fit, and it's easier to send out to somebody else if you're going to distribute it. Now the random forest classifier, everything I read says it's used for kind of a medium-sized data set. So you can run it on big data, you can run it on smaller data obviously, but it tends to work best in the mid-range. And we'll go ahead and take our RFC, and I just copied this from the other side, .fit xtrain, ytrain. So we're sending it our features and then the quality in the ytrain, what we want to predict in there. And we just do a simple fit. Now remember, this is sklearn, so everything is fit or transform. Another one is predict, which we'll do in just a second here. In fact, let's do that now. Predict RFC equals, and it's our RFC model, predict. And what are we predicting on? Well, we trained it with our train values, so now we need our test, our X test. So this has done it. This is the 3 lines of code we need to create our random forest variable, fit our training data to it. So we're programming it to fit. In this case, it's got 200 different trees it's going to build. And then we're going to predict on here. And let me go ahead and just run that. And we can actually do something like, let's do predict RFC. Just real quick, we'll look at the first 20 variables of it. Let's go ahead and run that. And in our first 20 variables, we have 3 wines that make the cut, and the other 17 don't. So the other 17 are bad quality, and 3 of them are good quality in our predicted values. And if you can remember correctly, we'll go ahead and take this out of here. This is based on our test. So these are the first 20 values in our test, and this has, as you can see, all the different features listed in there, and they've been scaled. So when you look at these, they're a little bit confusing to look at and hard to read, but there's a -0.01, so this is 0.36, -0.01, so 0.164, -0.1 0.09, or no, it's still -1, so -0.9, all between 0 and 1 on here. I think I was confused earlier and I said 0 between 2, -2, but it's between -1 and 1, which is what it should be in the scale. And we'll go ahead and just cut that out of there. Run this. We have our setup on here. So now that we've run the prediction and we have predicted values, well, one, you could publish them, but what do we do with them? Well, what we want to do with them is we want to see how well our model performed. That's the whole reason for splitting it between a training and testing model. And for that, if you remember, we imported the classification report. That was again from the sklearn. There's our confusion matrix and classification report. And the classification report actually sits on the confusion matrix, so it uses that information. And our classification report, we want to know how good our y test, that's the actual values, versus our predicted RFC. So we'll go ahead and print this report out and let's take a look. And we can see here we have a precision out of the 0. We had about 0.92 that were labeled as bad that were actually bad. And out of precision for the quality wines, we're running about 78%. So you kind of give us an overall 90%. And you can see our F1 score, our support set up on there, our recall. You could also do the confusion matrix on here, which gives you a little bit more information. But for this is going to be good enough for right now. We're just going to look at how good this model was, because we want to compare the random forest classifier with the other two models. And you know what, let's go ahead and put in the confusion matrix, just so you can see that on there, with y-test and prediction RFC. So in the confusion matrix, we can see here that we had 266 correct and 7 wrong. These are the mislabels for bad wine, and we had a lot of mislabels for good wine. So our quality labels aren't that good. We're good at predicting bad wine, not so good at predicting whether it's a good quality wine. Important to note on there. So that is our basic random forest classifier. And let me go ahead, cell, change cell type to markdown and run that so we have a nice label. Let's look at our SVM classifier, our support vector model. And this should look familiar. We have our CLF we're going to create. We'll call it, just like we call this an RFC. And then we'll have our CLF.fit. And this should be identical to up above. X train, comma, Y train. And just like we did before, let's go ahead and do the prediction. And here is our CLF predict. And it's going to equal the CLF.predict. And we want to go ahead and use X_test. And right about now you can realize that you can create these different models and actually just create a loop to go through your different models and put the data in. And that's how they designed it. They designed it to have that ability. Let's go ahead and run this, and then let's go ahead and do our classification report. And I'm just going to copy this right off of here. They say you shouldn't copy and paste your code, and the reason is when you go in here and edit it, you invariably will miss something. We only have 2 lines, so I think I'm safe to do it today. And let's go ahead and run this. And let's take a look how the SVM classifier came out. So up here we had a 90%, and down here we're running about an 86%. So it's not doing as good. Now remember, we randomly split the data, so if I run this a bunch of times, you'll see some changes down here. So these numbers, this size of data, if I ran it 100 times, it would probably be within plus or minus 3 or 4 on here. In fact, if I ran this 100 times, you'd probably see these come out almost the same as far as how well they do in classification. And then on the confusion matrix, let's take a look at this one. This had 22 by 25. This one has 35 by 12. So it's doing not quite as good. That shows up here 71% versus 78%. And then if we're going to do a SVM classifier, we also want to show you one more. And before I do that, kind of tease you a little bit here, before we jump into neural networks, the big save all deep learning, because everything else must be shallow learning, that's a joke. Let's just talk a little bit about the SVM versus the random forest classifier. The SVM tends to work better on smaller numbers. It also works really good on, because a lot of times you convert things into numbers and bins and things like that. The random forest tends to do better with those. At least that's my brief experience with it. Where if you have just a lot of raw data coming in, the SVM is usually the fastest and easiest to apply model on there. So they each have their own benefits. You'll find though again that when you run these like 100 times, the difference between these two on a data set like this is going to just go away. There's randomness involved depending on which data we took and how they classify them. The big one is the neural networks, and this is what makes the neural networks nice is they can look into huge amounts of data. So for a project like this, you probably don't need a neural network on this, but it's important to see how they work differently and how they come up differently. So you can work with huge amounts of data. You can also, in many respects, they work really good with text analysis, especially if it's time sensitive. More and more you have an order of text, and they've just come out with different ways of feeding that data in, where the series and the order of the words is really important. Same thing with starting to predict in the stock market. If you have tons of data coming in from different sources, the neural network can really process that in a powerful way to pull up things that aren't seen before. And when I say lots of data coming in, I'm not talking about just the high lows that you can run an SVM on real easily. I'm talking about the data that comes in where you have maybe you pulled off the Twitter feeds and have word counts going on, and you've pulled off the different news feeds that business are looking at, and the different releases when they release the different reports. So you have all this different data coming in, and the neural network does really good with that. Picture processing now is really moving heavily into the neural network. If you have a Pixel 2 or Pixel 3 phone put out by Google, it has a neural network for doing, it's kind of goofy, but you can put little Star Wars androids dancing around your pictures and things like that. That's all done with the neural network. So it has a lot of different uses, but it's also requires a lot of data and is a little heavy-handed for something like this. And this should now look familiar because we've done it twice before. We have our multi-layered perceptron classifier. We'll call it an MLPC, and it's just as what we imported, MLPC classifier. There's a lot of settings in here. The first one is the hidden layers. You have to have the hidden layers in there. We're going to do 3 layers of 11 each. So that's how many nodes are in each layer as it comes in. And that was based on the fact we have 11 features coming in. Then I went ahead and just did 3 layers. Probably get by with a lot less on this. But I didn't want to sit and play with it all afternoon. Again, this is one of those things you play with a lot because the more hidden layers you have, the more resources you're using. You can also run into problems with overfitting, with too many layers, and you also have to run higher iterations. The max iteration we have is set to 500. The default's 200. Because I use 3 layers of 11 each, which is, by the way, kind of a default I use. I realized that usually you have about 3 layers going down and the number of features going across. You'll see that's pretty common for the first classifier when you're working in neural networks. But it also means you have to do higher iterations. So we up the iterations to 500. So that means it's going through the data 500 times to program those different layers and carefully adjust them. And we do have a full tutorials you can go look up on neural networks and understand the neural network settings a lot more. And of course we have, you're looking over here where we had our previous model where we fit it. Same thing here, MLPC, fit, X train, Y train. And then we're going to create our prediction. So let's do our predict and MLPC, and it's going to equal the MLPC. And we'll just take the same thing here, predict X test. Let's just put that down here, .predict X test. And if I run that, we've now programmed it. We now have our prediction here, same as before. And we'll go ahead and do the copy print again. Always be careful with the copy paste because you always run the chance of missing one of these variables. So if you're doing a lot of coding, you might want to skip that copy and paste and just type it in. And let's go ahead and run this and see what that looks like. And we came up with an 88%. We're going to compare that with the 86 from our tree, our SVM classifier, and our 90 from the random forest classifier. And keep in mind, random forest classifiers, they do good on mid-sized data. The SVM on smaller amounts of data, although to be honest, I don't think that's necessarily the split between the two. And these things will actually come together if you ran them a number of times. And we can see down here the amount of good wines mislabeled with setup on there. It's on par with our random forest. So it had 22, 25. Shouldn't be a surprise, it's identical. It just didn't do as good with the bad wines labeling, what's a bad wine and what's not. Let's see, yeah, because they had 266 and 7. We had down here 260 and 13. So it mislabeled a couple of the bad wines as good wines. So we've explored 3 of these basic classifiers. These are probably the 3 most widely used right now. I might even throw in the random tree. If we open up their website and we go under supervised learning, there's a linear model. We didn't do that. Most of the data usually just start with a linear model because it's going to process the quickest and use the least amount of resources. But you can see they have linear quadratic, they have kernel ridge. There's our support vector, stochastic gradient, nearest neighbors. Nearest neighbors is another common one that's used a lot. Very similar to the SVM. Gaussian process, cross decomposition, naive Bayes. This is more of an intellectual one that I don't see used a lot, but it's like the basis of a lot of other things. Decision tree. There's another one that's used a lot. Ensemble methods, not as much. Multi-class and multi-label algorithms, feature selection, neural networks, that's the other one we use down here, and of course the forest. So you can see in sklearn there are so many different options, and they've just developed them over the years. We covered 3 of the most commonly used ones in here and went over a little bit over why they're different. Neural network, just because it's fun to work in deep learning and not in shallow learning, as I told you. That doesn't mean that the SVM is actually shallow. It covers a lot of things, and same thing with the decision tree, the random forest classifier. And we notice that there's a number of other different classifier options in there. These are just the 3 most common ones, and I'd probably throw the nearest neighbor in there and the decision tree, which is usually part of the decision forest depending on what the backend you're using. And since, as human beings, if I was in the shareholder's office, I wouldn't want to leave them with a confusion matrix. They need that information for making decisions, but we want to give them just one particular score. And so I would go ahead and we have our sklearn metrics. We're going to import the accuracy score, and I'm just going to do this on the random forest since that was our best model. And we have our CM accuracy score, and I forgot to print it. If you remember in Jupyter Notebook, we can just do the last variable we leave out there, it'll print. And so our CM accuracy score we get is 90%. And that matches up here. We should already see that up here in precision. So you can either quote that, but a lot of times people like to see it highlighted at the very end. This is our precision on this model. And then the final stage is we would like to use this for future. So let's go ahead and take our wine. If you remember correctly, we'll do wine head of 10. We'll run that. Remember our original data set? We've gone through so many steps. Now we're going to go back to the original data. And we can see here we have our top 10 on the list. Only 2 of them make it as having high enough quality wine for us to be interested in them. And then let's go ahead and create some data here. We'll call it x new equals, and this is important. This data has to be, we just kind of randomly selected some data. It looks an awful lot like some of the other numbers on here, which is what it should look like. And so we have our x new equals 7.3.58. and so on. And then it is so important. This is where people forget this step. X new equals SC. Remember SC? That was our standard scalar variable we created. If we go right back up here, before we did anything else, we created an SC, we fit it, and we transformed it, and then we need to do what? Transform the data we're going to feed in. So we're going to go back down here, and we're going to transform our X new, and then we were going to go ahead and use the, where are we at? Here we go. Our random forest, and if you remember, all it is our RFC predict model right there. Let's go ahead and just grab that down here. And so our Y new equals, here's our RFC predict. And we're going to do our X new in, and then it's kind of nice to know what it actually puts out. So according to this, it should print out what our prediction is for this wine. And, oh, it's a bad wine. Okay, so we didn't pick out a good wine for our X new. And that should be expected. Most of the wine, if you remember correctly, only a small percentage of the wine met our quality requirements. So we can look at this and say, oh, we'll have to try another wine out, which is fine by me because I like to try out new wines, and I certainly have a collection of old wine bottles, and very few of them match. But you can see here we've gone through the whole process. Just a quick rehash. We had our imports. We touched a lot on the sklearn, our random forest, our SVM, and our MLP classifier. So we had our support vector classifier, we had our random forest, and we have our neural network, 3 of the top used classifiers in the sklearn system. And we also have our confusion matrix and our classification report, which we used, our standard scaler for scaling it, and our label encoder. And of course we needed to go ahead and split our data up in our mplot line train. And we explored the data in here for null values. We set up our quality into bins. We took a look at the data and what we actually have and put a nice little plot to show our quality, what we're looking at. And then we went through our 3 different models. And it's always interesting because you spend so much time getting to these models, and then you kind of go through the models and play with them until you get the best training on there without becoming biased. That's always a challenge, is to not overtrain your data to the point where you're training it to fit the test value. And finally, we went ahead and actually used it and applied it to a new wine, which unfortunately didn't make the cut. It's going to be the one that we drink a glass out of and save the rest for cooking. Of course, that's according to the random forest on there, because we used the best model that it came up with.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
In this video on PyGame, we will teach you how to develop games using the Python module called PyGame. So, let's get started. Before we dive into the video, let's get a general overview of what you can expect to learn from it, what's in it for you, and what will you know by the end of this video. The first thing that we will teach you is what exactly is PyGame. You will understand what exactly the PyGame module is and the various ways that you can use it to develop games. Next, we will teach you how to install PyGame on your system. Then, we will take a look at the basic components of PyGame. And finally, we will be using the PyGame module and Python programming to develop a Flappy Bird game, which you can play in real life on your own system. So, let's get started. So what exactly is PyGame? PyGame is a cross-platform Python software which was made specifically for video game designing. It includes graphics, visuals, and sounds which can be used to enhance the game which is being designed by you. Officially written by Pete Shiners to replace PySTL, PyGame is suitable to create client-side applications that can be potentially wrapped in a standalone executable. To learn PyGame, it is required to have a basic knowledge of Python. Now, how do you go about installing PyGame on your system? To install PyGame, you can use the standard pip install command in your command prompt. Then, you can import it into your program with the import command prompt in Python itself. Before installing PyGame, Python should be installed in the system. It is good to have Python 3.6.1 or above versions because it is much friendlier to beginners and additionally runs way faster. Now, what are the basic components of PyGame? The first and most important component of PyGame is the pygame.init module. This is used to initialize all imported PyGame modules. Using this, you can call all PyGame modules at once into your program. Before you can do much with PyGame, you need to initialize it. The most common way to do this is to use pygame.init. This will initialize all the modules in PyGame with just one single command. Not all PyGame modules need to be initialized, but this will automatically initialize the ones that are important and the ones that have to be initialized. You can also easily initialize each PyGame module by hand. The next thing that you need to know about is the display surface. The display surface is a black screen which acts as a canvas for you to design your games on. All the game components will appear on this very screen. Now, PyGame has a single display surface that is either contained in a window or runs full screen. Once you create the display, you can treat it as a regular surface. Changes are not immediately visible on screen. You must choose one of the two flipping functions to update the actual display. The PyGame display can actually be initialized by one of several modes. By default, the display is a basic software-driven frame buffer. You can request special modules like hardware acceleration and OpenGL support. Now PyGame can only have a single display active at any time. Creating a new display will close the previous display. Once the display surface is created, the functions from this module affect the single existing display. The surface becomes invalid if the module is uninitialized. If a new display mode is set, the existing surface will automatically switch to operate on the new display. The next concept is the game loop. The game loop is a piece of code that does three things. It will handle events, update game events, and draw game state to the screen. The game loop will basically run until a condition is met or until the game ends. And finally, you have pygame.quit. The pygame.quit function does the opposite of the init function and completely deactivates the pygame library. It will automatically uninitialize all pygame modules that have previously been initialized. When the Python interpreter shuts down, this method is called regardless, so your program does not always need it, except when it wants to terminate its pygame resources and continue. It is safe to call this function more than once, as repeated calls have no effect whatsoever. Now please do note that calling pygame.quit will not exit your program. Consider letting your program end in the same way a normal Python program will end. It will just help you break out of the game loop. Now, let's see how we can create a Flappy Bird game with the help of the Python PyGame module. So the first thing that you're going to need is to call all of your required modules. So over here, we have imported the random and the sys module. We've imported the PyGame module. And we've also imported all the modules which are present in pygame.locals. So let's run this so all the modules get imported into our program. There we go. So all of our pygame modules have been imported. Now the first thing that we're doing is that we're setting global variables for the game. The window width and the window height basically determine how big our surface is going to be. After that, we're going to display our window. Now you can call or create a window by using pygame.display.setMode. And within set mode, you set your window parameters. So you set your window width and your window height. So here we will be creating a window of width 600 and of height 499. The elevation will basically tell you how far up from the bottom of your screen the window is going to be. We're going to be creating an empty tuple of your game images, and we're going to be having an FPS of 32. You can obviously change your FPS speed. Now all of these images that we're importing have already been downloaded onto your system. So all of these images are already here, and they're in the same folder that we've stored our Flappy Bird game in, which is why to call them you simply have to write the name of the image and initialize it to a variable. So because we're creating Flappy Bird, we're going to have a pipe image, a background image, a bird, and obviously a base which is going to be a sea level and which you have to prevent the bird from touching. So let's run this and create nothing but our PyGame window. So here, as you can see, a new window has come up. This so far is just our PyGame window. Nothing has been shown on it because we haven't initialized any of these parameters into our window as of yet. So far, the only thing we've done is create a basic window which doesn't have any of the parameters on it, with a width of 600 and a height of 499. Now here we are going to be coming into our Python game loop. So the first thing that we talk about in our Python game is that you have to have some initialized variables, right? And you have to create some important components of the game. So the first thing that you have is the Flappy game, which is the game itself. The next thing that we have here is to check if our game is over. This is going to happen under two conditions. One is that the bird hits the pipe, and the second condition is that the bird falls into the sea. And finally, we will have a module to create pipes of random height as and when a bird goes further into the screen. So basically, the pipes will be created as the user keeps going and not beforehand. And finally, here we have our main game loop, which is going to be calling all of these various functions that we've created and which is going to terminate their runtime the second that the game gets over. And then following this, we're going to be exiting the Flappy Bird game. So here pygame.quit, as you can see, as we've already told you, will close all of the pygame modules that you've already initialized in your program and will uninitialize all of these modules, while sys.exit will exit the program itself. Now, as we said, the pygame.quit doesn't quit the program, it only uninitializes all the pygame modules, which is exactly why we're using sys.exist to close our window and exit our program. Now, the first thing that we're going to be looking at is the Flappy Bird game itself. The main things that are happening in our Flappy game is, first of all, we're initializing variables and creating two pipes by calling the create pipe function. So at any given point, we know that we want our bird to fly in between two pipes. That is the main challenge here, which is exactly why we're initializing two pipes here, the first pipe and the second pipe. And this is done by calling the create pipe function. Now after this, we're going to be creating two lists. One is of the lower pipes and the other is of the upper pipes. Now, as we already talked about, we are going to have two pipes consecutively. Yeah, the first pipe is going to be on top and the second pipe is going to be at the bottom. So that's exactly what these two lists contain. They contain the height at which the down pipes and the up pipes are going to be. Or basically, they contain the coordinates at which these down pipes and up pipes will be displayed at. Now, pipe vel x is basically defining the pipe velocity along your x-axis, and the bird velocity, which is along the y-axis, is defined over here. So basically, your bird is going to have two different parameters. One is that it's going to move up and down, which is its velocity along the y-axis. Another is it's going to move across, which is its velocity across the x-axis. Now at the same time, the pipes also have to keep moving and they have to exit this frame. So that's what all of this is defined by. The bird acceleration is defined over here. This is the parameter that you're going to be using to define your bird acceleration along the y-axis. That is basically going to happen when you stop clicking and the bird starts falling downwards. Now the velocity while flapping, or the x-axis velocity for the bird, is defined over here. Now the bird is only going to be flapping when you're going to be pressing the key. So that's basically what you're going to be checking here. If your event takes place, which basically means that if you have key events, and that's exactly what pygame.event.get is doing. It's going to be getting all the key functions that are taking place on your keyboard simultaneously. So for event in pygame.event.get will basically help you get the keystrokes which are happening. If event type is equal to quit, or event type is equal to key down, and event.key is equal to k.escape, you're going to quit your game and you're going to close down your program. So there are two ways that you can quit your game. You can either press quit or you can press key down and escape. Now if your event type is equal to key down and your event.key is equal to space or k up. So this is basically what you're going to be using to make sure that your bird is moving. There are two main keys which are going to be coming into play over here. You can press the key down as well as the space key, or the key down and the up key. So over here, this is going to move your bird vertically, and it's also going to make sure that your bird flaps its wings, which is where the bird velocity, which are all these parameters, will come into play. So this will basically help your bird move forward. So basically what is happening here is that we're going to be getting the keys that the user has pressed, and if they've pressed the quit key, we're going to quit the program, and if they've pressed key down and space or key down and the up key, we're going to make sure that the bird starts moving in the y-axis as well as it starts flapping its wings and moving along in the x-axis. Now this is the function that checks for whether your bird has crashed into pipes or not. This is basically also going to define whether your game is over or not, right? Because once the bird touches a pipe, the game is basically finished. So game over here is game over, which is another function that we are defining here. So basically what's happening over here is that you're going to be checking if the game is over by checking the horizontal and vertical position of the bird and the positions of the up and down pipes. If the game is over, then you will return over here and you will basically quit the whole game. Now after this, we need to keep track of the score of the player. Now how that can be done is that you get your position of your bird and the position of your pipe, and if the bird has crossed the pipe, then you basically increase your score by 1. If the current velocity of your bird is less than the maximum velocity and the bird has not flapped or you haven't pressed your key, in that case the bird is basically going to be tumbling downwards. Now another thing that you have to consider is that the user has stopped pressing the key, right? So the bird is not going to be flapping its wings. If this is the case, then the bird has to free fall towards the sea basically. So this is how we're going to be checking it. If the velocity of the bird is less than the max velocity and the bird has not flapped its wings, what we're going to be doing is we're going to be increasing the present velocity of the bird in increments with an acceleration speed that we've already defined over here. So if the bird starts flapping its wings, the velocity will steadily increase with this acceleration. Now if the bird has flapped its wings, after that we need to set the bird flap function to false again. Otherwise it will continue being true, which is not the case. So we have to keep switching it, right? The bird flap will only be true when the user has pressed the key. After that, it immediately has to go back to a false variable. So that is basically what we're doing here. We're going to change the bird flap to false immediately after it has become true. Now after this, your pipes will keep moving to the left. In this game, the pipes are the ones that are moving horizontally. The bird is not moving horizontally. The bird is only moving vertically. So basically what we're going to be doing is we're going to be increasing the x coordinate of our pipe, and the pipe is not going to randomly start increasing in height, right? So we're not going to be touching the y coordinates of the pipe. Of the upper and the lower pipe, we're going to slowly increment the x coordinate by the velocity factor that we've already initialized previously. So the pipes will slowly keep moving by this velocity factor towards the left hand side of the screen. A new pipe will be added when the first is about to cross the leftmost part of the screen. So basically each pipe is covering about 5 points on the x-axis, and once it is less than 5 but still greater than 0, we're going to create a new pipe and we're going to append it to our up pipes list. And we'll also be creating another pipe and we're going to append it to our down pipes list. Now if the pipe is out of the screen, we basically have to remove it, and this we're going to do by popping out the pipe from the up pipe list. So far we've looked at how we can generate pipes for our window, the velocity of the bird when it is flapping its wings, and what is going to happen when it stops flapping its wings, handling the key pressing events that the user is inputting, checking whether our bird has crashed or not, updating our score, moving the pipes to the left, and creating new pipes once the previous pipe has left the screen. Now, the only thing that's left to do is build a game image window, because we've dealt with almost all the game logic that we need. So now we're basically going to start building our PyGame window. So first we're going to be putting the image all throughout the screen. We're going to be rendering the up pipe and down pipe at the respective positions on the screen. And then we're going to be putting the sea level and the bird on the screen. Another thing that you need to do is fetch the digits of the score and display them on your screen. So the digits, again, all of the images have already been included in our Flappy Bird folder, and all you have to do is display them onto the screen. To do this, all that we have to do is loop through our numbers list and display the scoreboard images on the side of our window. And this is the position at which they'll be displayed. So here we're just displaying the images on the screen. The offset is again just a variable that we've created here, and that's the variable at which we'll be displaying the images. Now every time the score changes, you're going to have to update the game window. So that is exactly what you're doing here. You're just updating your display game window. And as we talked about, every time your display changes, you can't have two displays open at once, so the game will move on to this new display window. And again, we're just over here, we're just setting the frames per second. And that brings us to the end of everything that we need to do. This is the basic game logic that we're going to be needing. So this whole function just defines your game logic. Let's finish running this. And your game logic has been initialized into your program now. Now the next thing that we have to do is check if our bird is above sea level or if it has hit any of the pipes. So this is what you use the isGameOver function for. So the isGameOver function will have 4 different parameters as input. So the isGameOver function has 4 parameters. You're going to be giving the horizontal and the vertical height of the bird and the height and position of the up pipes and the down pipes. Now there are basically 3 conditions which lead to a situation of the game being over. If the difference between our elevation and a certain height is less than the vertical, it means that the bird has crossed its boundaries. And that is why the game is over, which is where you return true. The another thing is that the bird hits either the up pipes or one of the down pipes. And that's what we're checking here. Either the elevation of the bird has decreased and there's no way that it can rise up again, and hence the game will be over, or the bird has hit one of the pipes on top or one of the bottom pipes. So that's basically what we're doing here. We're getting the height of the up pipe and we're checking if the vertical height of the bird is less than the pipe height plus the pipe width. So basically it can hit the pipe anywhere, right? So if this vertical height is less than this parameter, as well as if the bird doesn't hit the pipe horizontally. So that's what we're basically checking here. We're checking to see if the bird has hit the pipe horizontally or vertically. Then you will return true. And the same thing will happen for the down pipes. You will check if the bird has hit the pipe horizontally or vertically at any point. So let's run this game over function. The next thing that you have to do is the create pipe function. Now creating pipes is actually quite easy. All we have to do is fetch the height of the pipe using the getHeight function, and after that generate a random number between 0 to any number such that the height of the pipe should be adjustable to a window height. So there's only a certain amount where you can have the pipe visible, and that has to be above sea level. So we're going to be generating like a random number between 0 and this number, like 0 and the width of your screen from height to just above the sea level. And then we're going to be subtracting it by 1.2 into offset, because there's a huge chance that we get like a pipe which covers the entire screen. So to prevent that, we're going to decrease the height of the pipes a little. And then after that, all we have to do is push our pipes into a dictionary along with their x-axis and y-axis coordinates. So this is basically what your pipe list is going to look like. It's going to be a dictionary which consists of an upper pipe and a lower pipe and along with their coordinate values. So let's run this. Now this is basically the game loop that we're going to be using. This is going to call our various functions again and again until the game basically gets over, which is defined over here. So this function is going to run, or this is your basic game start. It's going to keep running until a certain condition is met, and let's see what that condition is. So over here, the different things that we're doing initially is that we're initializing our program using pygame.init. We're basically calling all the modules of the pygame library. Then after that, we're just setting the frames per second, displaying the title of the game on top of the game window, pygame.display.setCaption. So far we only have a pygame window, right? This is basically going to initialize the background images and everything onto this window. We're gonna start loading all of our different images into our game. So we have different images for the scores, the Flappy Bird image, sea level, background and pipe image, and we're going to convert it into a form suitable to display onto our window. This is basically done using the image.load.convert alpha function. So over here, you're basically going to be loading your image and converting it into a form which is suitable to be displayed onto your screen. After that, we'll basically be doing a couple of basic startup things such as printing welcome to Flappy Bird game and press space or enter to start the game. And the second you see this, you know that this has started running properly. Now this is where you have the main game starting. So over here you're basically going to be setting the position of the bird, and horizontally we're going to be setting it at 1/5 of the window width. You can basically set the bird wherever you want to. Then after that we're going to be adding the sea level, and over here we've initialized ground as 0. While true for event in pygame.event.get. Basically, while we keep getting a keystroke from the user, this whole loop is going to keep running. And what exactly is happening in this loop over here, basically we are running the program until the user stops or exits the game. Otherwise, we have basically created an infinite while loop over here. So if the event type is equal to quit, we're going to quit the game and exit the program. If the event type is key down, then we are going to be calling Flappy game. So this is basically us initializing the game start conditions. If the second after the game starts, the user clicks on quit, then we're going to quit the game and exit the program. Otherwise, if the user has pressed the key down, the space key or the key up, then we're going to be calling our Flappy game function. If the user hasn't pressed any key and nothing has happened, then we're just going to have a basic game display, and we're going to be displaying the background image, the Flappy Bird and the sea level onto our screen. This is just to keep refreshing the screen, and this is basically to set the frame rate of our screen. So let's run this. Now, if we look at our Flappy Bird game, you can see that we have all of the parameters initialized. We have a background, we have a sea level, and we have a bird over here. We've typed Flappy Bird game on top, and I'm going to press the enter key to start. So far as you can see, our pipes have appeared here. So we already know the function behind this. We keep getting our pipes, and the second that the bird crosses a pipe, the screen gets refreshed and our score gets updated. So if you notice here clearly, if I go slow enough, and if you notice, the second I did this, the display window actually got refreshed. And the second the pipe goes out of screen, as you can see, it gets erased and a new pipe enters. So the second this one pipe goes out, a new pipe gets created. Now, as we've talked about, there are 3 basic conditions. One is you hit the bottom pipe and the game ends. Another is you hit the top pipe anywhere and the game ends. And the next one is your bird falls below a certain level and the game ends. So these conditions are working so far. Our scoreboard also keeps getting initialized. Another condition that you might want to check for. Oh yeah, and as you can see, another thing that you notice is the velocity, right? So the bird is technically not moving. The bird's position relative to where it started from remains exactly the same. As you can see here, the only thing that is moving is its position on the y-axis. Apart from this, the pipes are moving. And do you remember the acceleration parameter that we have? This is where you can see it come into play. So I stopped, and the way the bird free falls, all of this is because of the acceleration parameter that we set. So this is basically how you can use PyGame to, create a game. Now let us quit the game. I pressed the escape key and the entire game has quit. So over here, system exit took place, as you can see. So this is all the logic that we've used behind creating a Flappy Bird game. And as you can see, we've used the PyGame module to create it.
Let us have a simple question to brush up on our knowledge. And your question is, what command turns on a virtual environment? And your options are, the first option is source/script/activate, and the second option is python -m way environment virtual environment and the name of the folder, and the third option is source virtual/scripts/activate, or D, all of the above. Please answer in the comment section below and we will update the correct answer in the pinned comment. You can pause the video, give it a thought and answer in the comment section. Now moving on to our topic, that is virtual environment. Most Python projects have dependencies that we install and use. For example, we use Flask for web applications, and we use these libraries written and tested by many developers, so we don't have to write them again. These libraries change over time. They get new functionalities and bug fixes with some newer versions. For example, let's say you are a Python developer working on two different projects, and each project has different package requirements. Project A requires Flask 2.0 version, while Project B requires Flask version 2.2. You cannot have both versions installed globally on your system because they will conflict with each other and you might break one or both of these projects. This is where virtual environment comes in handy. And now we'll see what is a virtual environment. Virtual environments are isolated environments that allow developers to work on multiple projects with different dependencies without conflicts. This is crucial when working on multiple projects simultaneously, especially those with different dependencies, because the virtual environment ensures that each project has its own set of dependencies that will not conflict with those of other projects. In Python, virtual environments are created using the built-in virtual environment module, which creates a directory with a specific structure that contains a copy of the Python interpreter as well as other necessary files. Every virtual environment has a Python version and a folder of third-party libraries that you will install for a particular project. Python libraries are frequently updated with new versions that include bug fixes, new features, and performance improvements. Upgrading a library to a newer version can have various effects on a virtual environment. In general, it is a good practice to keep libraries updated to the latest version, but it is also important to consider the impact on the virtual environment and the application before upgrading. It is recommended to test the upgraded library in a separate environment before making changes to the production environment. This can help to identify any potential issues and ensure a smooth upgrade process. If we update the library, maybe our code should not work as the functionalities would have been changed with the update. Now we'll see why do you need a virtual environment. When you install packages globally, you run the risk of breaking other projects or applications that rely on the same packages. Virtual environment provides a solution to this problem by creating an isolated environment for your project that doesn't interfere with your system environment. Now, we'll see a hands-on demonstration to create a virtual environment on our system. So for that, we'll go to our projects folder and inside here we'll create a folder and name it as virtual environment. So inside this folder, first we'll open the command prompt. So creating a virtual environment is a straightforward process. We'll demonstrate how to create a virtual environment using Python's built-in module, that is virtual environment. And we have opened the command prompt and navigated into our folder that we have created, that is virtual environment. We'll write a command that would be python -m, the name of the module virtual environment, and now we'll write the name of our folder we want to create. So we'll press enter, and now we'll see that we have a directory here that is with the name my environment. Once the command gets executed successfully, we will have a new directory that is my environment what we have made. Now we have to activate our virtual environment. First we'll do that, but before that what we can see is in the script section we have pip and the Python files here, that is the python.exe file, that is the application file, pip file. So we have Python's version installed here. So if we ask the command prompt what version is installed in our virtual environment, we'll ask him. It says 3.10.2, but it's the global Python that is command prompt is showing. So first we have to activate the virtual environment, and after that it will show us what Python version is installed into our environment. So to activate our virtual environment, we'll write a command, that is the path we'll write, and this is for the Windows. For that we'll write the name of the folder my environment / you have seen the scripts folder / and then we have activate, and now we'll press enter. You can see my environment folder in brackets. This shows that a virtual environment is active now. Now if we ask him what is the Python version that is installed inside our virtual environment, it says that is 3.10.2. So we have the globally installed Python version that is 3.10.2, and in a virtual environment it's also 3.10.2, and we have a command to deactivate our virtual environment, that is deactivate. So it has been deactivated, that is you can see that my environment from the circular brackets it has been vanished. Now we'll check what packages are installed into our system. So now we are in the global system. For that we'll write pip phrase and press enter. So you can see these all packages are installed into a global environment system. These are many packages. So you can see these are the packages that are installed. We'll get back to our virtual environment and activate it. So to activate it, we'll get into the folder /scripts /activate and press enter. You can see that our virtual environment is active now, and now in here we'll write the command pip freeze and see what packages are installed. It says no packages are installed into our virtual environment. So here we'll install Django, pip install Django and press enter. So you could see that it has started installing it, and it is installing 4.1.7 version. Now you have seen that Django is installed into our system. Now you can work on any project without worrying about any package that conflict with other projects. Like if you name this as project A, then the Django is installed into this project, and if you want to work on project B, then you need to create another virtual environment for it using the same virtual environment command just above, and you can work on project B without worrying about any package conflicts or breaking project A. To deactivate, we have seen that we can just write deactivate and the virtual environment would be deactivated. So now if you want to give a particular project to another person, for that you have to ask him to install all the particular version of the packages. So to find all the packages installed into an environment, we've seen the command pip freeze. It has shown us all the packages that were installed into the system environment or the global environment. Now we'll write a command to see what packages are installed in our virtual environment. So for that you could use the previous command prompt, or we could just have a new command prompt here, and here we have to activate a virtual environment again, as we are not able to see the name of the virtual environment in circular brackets. So for that we'll write the name of the directory, then scripts, and then activate. Now you can see our virtual environment is active. Now we'll write the command pip freeze, and it has shared us all the packages that are installed into our system, and these are the packages that are installed with the Django package. So now if you want to share a particular project with another person, then you have to create a file that would be requirements.txt file, and you have to write all the projects with their version names installed for your project. So for that we'll write the command pip freeze and the greater than sign, and then we'll write requirements.txt and press enter. So what this will do is it will create a file requirements.txt, and it will get filled with all the packages with the particular and respective versions. So you can share this file to a particular person, and the particular person can install all the packages just by a single command. So what command he could write is pip install -r, then the requirements.txt. Sorry, it's .txt, and press enter. So you could see that the requirement is already satisfied, as in this virtual environment we have the Django installed, and with the Django these are the other packages that will be installed automatically. So the particular person has to run the command pip install -r requirements.txt, and all the packages with the particular versions that are mentioned in the requirements.txt file will be installed for him.
In this tutorial, we'll take you through 3 different aspects of Python automation. We'll start with automating Excel using Python. Then we'll see how we can use Python to send emails and automate WhatsApp messages using Python. So I hope you guys are ready to learn something new. Let's hand over this session to our experts who will ensure that you guys understand every bit of this session.
Hello everyone, I am Mayank and welcome to Simplilearn. Today we will take you through the hands-on lab demo of how you can automate Excel using Python. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes in the chat section. If there are any issues, do let us know in the chat section so that we can resolve them. I'm repeating again, before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. So I'm waiting for some more minutes to let other people join. Okay, till then, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great, I think we can get started. So in today's session, we will go through what is Excel, After that, we will see what is Python, and moving forward, we will see what is automation and where it is used. At the end, we will see a hands-on lab demo like how you can automate Excel with Python in detail. We already have dataset with us. We will perform different function and automate Excel dataset using Python. Before we move on to the programming part, let's discuss what is Excel first and importance of the same. So Microsoft developed Microsoft Excel, a spreadsheet for Windows, Mac OS, Android and iOS. It has calculating or computing capabilities, graphing tools, pivot table and the Visual Basic for applications. The Microsoft Office program package includes Excel. Users of Microsoft Excel may format, arrange and compute data in a spreadsheet. Data analysts and other analysts can make information easier to examine as data is added or altered by organizing data using tools like Excel. The boxes in Excel are referred to as cell and they are arranged in a row and column. The key features of Excel are the spreadsheet document in MS Excel can have headers and footers, and user can protect their data by giving it password protection. And the second one is filtering is supported, allowing you to locate the necessary data in your spreadsheet and replace it with the appropriate value. After discussing what is Excel, let's go through and see what is Python. So Python is the one of the most popular programming language available today. It is widely used in various sectors of business such as programming, web development, machine learning and data science. Given its spreadsheet use, it is not surprising that Python has surpassed Java as the top programming language. Python frequently used to create software, website and to perform data analysis and many more. Because Python is a general purpose language, it may use to develop a wide range of programs and isn't tailored for any particular issues. So the key features of Python are, it is open source and free. Python can be downloaded from the company official website. It is simple to download and install. Python is open source because allowing users with solid technical background to modify the code to suit certain business use case and product requirements. Since Python is a language for beginners, most anyone with a understanding of programming can quick pick it up and begin coding. So after seeing what is Python, let's move forward and see what is automating Excel with Python. We all know Python is dominant everywhere, and we also know that compared to other language, Python is beginner friendly and simpler to use. Automation is the one of the coolest thing you can do with Python. So how to automate an Excel sheet in Python? Imagine that you are asked to create accounts for 30,000 employees on a website. What would you think? You will undoubtedly become frustrated carrying out this task manually and repeatedly. Additionally, it will take too much time, which is not the wise choice. So just try to picture that what it is like for employees who work in data entry. Their responsibility is to extract the data from tables like Excel or Google Sheet and insert it in the another location. They read various magazines and websites, get the data there and they enter it into the database. Additionally, they must perform the calculation for the entries. In general, this job performance determines how much money is made. Greater entry volume, more pay. Of course, everyone wants a higher salary in their job. So, however, don't you find doing the same things over and over boring? The question is now, how can I accomplish it quickly? And how to automate my work? Spend an hour in coding and automating these kind of codes to make your life simpler rather than performing these kinds of things by hand. By just writing fewer lines of Python code, you can automate your laborious activity in simpler. So overall, Python Excel automation is a creative method that allows you to build visual reports on Python in a smoother manner, similar to how you would on Excel. Businesses can use Python Excel automation to streamline their operation in accordance with their requirements. So here is one question for you guys. I will give you 1 minute for this. You can comment or you can give answer in chat section so I can see the answers are given by you are correct or not. I'm repeating again. Here is one question for you guys. I will give you 1 minute for this. You can comment or you can give your answer in chat section so I can see if the answers given by you are right or wrong. So the question is, which type of programming does Python support? object-oriented programming, structured programming, functional programming, and all of the mentioned. So I'm repeating again, which type of programming does Python support? Option A, object-oriented programming. Option B, structured programming, functional programming, and all of the mentioned. So I'm starting the timer of 1 minute. Just type your answers in comment section or in chat section. Do let me know your answers, guys. So please, I want that everyone should participate in this. So I'm starting the timer. So your time starts now. So I want that everyone should participate in this, guys. Please do let me know your answer in chat section or in comment section, so I can see if the answers given by you are right or wrong. So 36 seconds or more. Please, guys, I want that everyone should participate in this. So let me know your answers in chat section or comment section. So you can just type the answers or A, B, C, D. Your wish, totally your wish. So 10 seconds are left, guys. Hurry up. Please, I want that everyone should participate in this. 5 seconds more. Okay, so time is over. We will give reply those who gave correct answers, and those who didn't give correct answer, we will give you a reply with the correct answer. Okay, so no worries. So now let's move to our programming part to perform Excel automation using Python. So first we will open command prompt to write command to open Jupyter Notebook. Jupyter Notebook. Yeah. So this is the landing page of Jupyter Notebook, and select open, select here new, open new file. So this is how the Jupyter Notebook UI looks like. So at first we will import some major libraries of Python which will help us in importing our workbook or worksheet. So the first one is, let me first rename this. We will write automating Excel using Python. Yeah, sounds good. Okay, so the first one is open PyExcel. Open PyExcel. Okay, I have to write import. Yeah, perfect. So a Python package called OpenPyExcel can read and write Excel 2010, XLX format, XLSM format, XLTX, and XLTM files. It was created since there was no library that could read and write Office OpenXML files natively from Python. Since OpenPyExcel was initially based on PHPXL, all praise to the PHPXL team. So OpenPyExcel does not by default provide protection from your quadratic blowup or billion laughter XML assault. Install diffused XML to protect yourself from these assaults. So we will write OpenPyExcel and then yeah. So then we will write for importing our workbook. So we can write here from OpenPyExcel import workbook load underscore workbook. Is capital here. So and this is for code for the importing our workbook. So let me write in comment like you can import workbook like this. So I can write you can import workbook this. Okay, perfect. Yeah. So here, so let me import workbook then. So I have to write WB for workbook equals to load underscore workbook, the destination of the workbook. So the destination is in like desktop, so I have to write C users LP 09375 stop dash automation dash learn dot cell sx format. Okay, cool. Users SLP, this one, desktop automation, Simplilearn.xlx. Fine. So our workbook is loaded to Jupyter Notebook. We can see, yeah, perfect, no error. So let's active this workbook for the use. So we have to write WS for worksheet. So worksheet equals to wb.active. Why active? Like import from OpenPyXL a workbook, there must be always been one worksheet in a workbook. It is accessible through the workbook.property active. So that's why we have write wb.active. So after making workbook active, so we will print our workbook, like we can print, so print ws. So here you can see the sheet 1. So it is showing worksheet sheet 1. Why sheet 1? Because if you open your workbook and see, here is your worksheet name, like I can, so this is my automation file. No. This is Simplilearn. So here you can see the sheet 1. That is why it is showing sheet 1 there. So okay, so let me just finish it. So moving forward, let's change the worksheet name. So I will write here import open pyxl. So like it's your wish that you want to write this import file or like this thing. This is not necessary at all. So now I will import the workbook. So I will write here wb equals to open pyxl dot load underscore workbook open pyxl, it is, my bad, sorry guys. So you have to give the path, so I can copy path from here. Yeah, perfect. Okay, sounds good. Yeah, here wb underscore sheet equals to wb and square brackets, then you have to write the sheet name. So there we have sheet 1. So sheet 1, okay, correct. So I can change with wb underscore sheet dot title equals to code with Simplilearn. Perfect. Yeah, seems good. Let me save this wd.save and the same copy here, paste. Yeah, so when a sheet is generated, it immediately receives a name. Like they have sequential numbers of names like sheet, sheet 1, sheet 2 and so on with the worksheet. You can modify this name whenever you want to, like using the title property. So here let me save this, and yeah, no error. So again go to Simplilearn. Yeah, you can see code with Simplilearn. First it was sheet 1 and now it is changed to code with Simplilearn. So let me cut this again. Okay. So if you want to change the color of your sheet name tab where is written code with Simplilearn, so you can write like here you can write WD, or okay, let me make this new one. Oh, okay, right, I will write here. So underscore sheet dot sheet underscore properties tab color equals to, here you have to give hex values, so 4 zeros. Okay, so let me save this. Okay, it is saying sheet 1. Why sheet 1? Because we already changed sheet 1 to code with Simplilearn. So what we have to do is, here we have to write code with Simplilearn. Okay, same Simplilearn, same code. Yeah. So what I will do here, I will just make W capital. So yeah, now it will work fine. Yeah. So if you save or run your code like this, let me show you one thing. Like color is already changed. Wait for 1 minute, guys. I will show you something crazy. So it will see like this W. Okay, so here I will small. So if you save or run your code, not actually save but run your code while your Excel sheet is open. So my Excel sheet is open, code with Simplilearn. Okay. So my Excel sheet is open. So it will give you error. Like which error? I repeat, like what error? This. Okay, let me do one thing. This is 1. Okay. It will give you Simplilearn 1 does not exist. Let me check. This is Simplilearn, code with Simplilearn 1. Code with, okay, W is capital there. Okay, see, this is a permission denied, then the location. It is showing permission denied. So this is something important to remember, that Excel file should be closed while running the code. And repeating again, so like this is something important to remember, that Excel file should be closed while running the code. So first what I have to do is close the Excel file, then I have to run it again. So no error now. So here you can see code with Simplilearn, that red color came. Yeah, perfect. So moving forward, let's create new workbook. Till we were working on the same worksheet which was present in my like desktop. So let's create new workbook. So for that I have to write import Excel SX writer. So I will write here in command to create new workbook. WB equals to Excel SX writer dot workbook, and where you want to save the workbook. So I will give the same path but with different name. So this time I will give only like coders simply. Okay, simply coders. Then I will write wd close. Okay, I will run it. Yeah. So the primary class export by the XLS writer module in the workbook class, and that is only class you will need to instantiate directly. So the workbook class represents both the whole spreadsheet as it appears in the Excel and the Excel file as it is stored on the disk internally. So you can see now, yeah, you can see now the workbook which is created in the desktop with the same name with like simply coders. So this is done. Let's move forward and let's retrieve cell values. So right now we are not having any data inside the workbook. So let's put some random values like names and all. So I will put some random values. I will put here names. Okay. Here Mayank, Kaushal. Okay. Wow. Like Jali. It. Roy. So let's save it. Let's save it. And let's move to our coding part. So here what I have to write to retrieve cells. Here I just write a equals to a is variable here. So I am assigning is ws that a1 value, the value which is presented at a1. So here I will write in comments like to retrieve cells. Okay. So here I will print a. Okay. What I have to do is like we have created this one file. So it is not giving the this is giving sheet1.a1. Why? Because it is taking from the simply coders one. So what I can do is I can import this file because we have saved data in this file. So let's paste this here and make it active. Yeah. So yeah, you now I haven't write here value. So that is why it is giving the cell name and that A1 name, cell name, A1 only. So now it will print names. Why names? Because at the A1 position we have names. So if you want to like print Anjali, so what you have to do is, okay, let me check this, B3. Okay. If you want to print Anjali, you have to just write here, just copy paste this code. Okay, just write here the location B3. You can see Anjali is printed. So this is how you can retrieve cells, and we can do the same for the other cells too. So there is one thing like retrieving, we can change the cells values too. So just we have to write here. So let me give first enter for the better visual. Yeah. So here what we can write is ws like I want to change the name of I will take this A4 Smith. Okay, let me close this. Okay, I will give here A4 dot value equals to, here you can give the value. So here you can write Smith, you can write John here as a replace value. So I will write here in as a command change cell value. Okay. So what you have to do is just save it, wb dot save. You have to give the path for the same. Yeah. Okay, fine. So let me save this and let me save this first and run this first. Okay, no error. And let's open our workbooks to see the changes. So here you can see the changes has been implemented in our workbook. First there it was like Smith and now John. So like this you can change the cell values, and let's move forward and see how we can merge the cells in a worksheet. So like just close this and yeah. So we are doing for the merging cells. So here I will write from open pyxl dot styles import alignment. So here I will write merge cells for your better understanding. Okay. So here I have to write wb equals to workbook Okay, let me active this workbook. wb dot active merge the cell. Which one? Let's take for a while A1 and B2. Okay, A and B should be in capital letters. So after that we have to save this. We will save in this only. So I can copy, I can paste it here. Okay, fine. Like using merge underscore cells, and after giving cell position you can easily merge the cell. So let's see the output. So let me open this Simplilearn file. You can see they are merged together, and like, but what if you want the values at the same times? So you can write here, I have to cut this. So you can write here like from open pyxl dot styles import alignment. A should be capital alignment. Okay, so the same thing you have to write wdb equals to workbook ws equals to wb dot active don't have to give parenthesis ws dot merge underscore cells a1 b2. So here I have to give the cell value equals to ws dot cell which row which column. So I can write row equals to 1, column equals to 1. So cell dot value equals to, here you can give the value which you want to print at the cell. So here I will write code with Simplilearn. Okay, fine. So what we can do this, we can give the alignment. Alignment equals to alignment horizontal equals to center, and from vertical the same. Center. Okay, let me save this file wb.save at the same location. So I can copy the path from here. Copy here and paste here. So I will. Yeah, seems good. Let me save this. Why it is giving error? Cell object has no attribute alignment. Okay, alignment spelling is wrong. Sorry, my bad. GNMENT. It seems good now. Oh, good to go. So here you can see, like by giving row equals to 1, column equals to 1, basically position, and after giving the value to what to print on that cell, and one more thing is alignment. Like it is not necessary to give alignments, like I just wrote it to cover it like in video. So you can give alignments like right, left. This time I gave the center to print in the center. So let's move and see the results. So you can see the value has been printed exactly at the center of the cell. If I will make it like this, you can see the value is printed exactly at the center of the cell because I gave the alignment center. So let's do one more for like to see what is the default place if you don't give the alignments. Okay, if you don't give the center alignments, what is the default value? So let me first remove this. Okay, save, no issues. Okay, yeah. So with alignments, or here what we can do is like from open py excel dot styles import alignment. It is not necessary to write import alignments. Okay, this is without. Okay, I can write is default value. Seems good. Okay, everything we have to cover from here, so I can just copy from here and paste it here. So what we will do here, we will change the cell value. We will use like C6 and B8. Sorry guys. So here I have to give row equals to 6 and column must be 8. So let's make it B6 B6. Okay, let's column should be 6. So code with Simplilearn, coders of Simplilearn. Like we are giving the value. So at the same time we have to just save it, wb.save. Save. Copy. Paste here. Okay. So this time we are not giving the alignments. You can see here we have gave alignments. Not now. So let's run this, and after that we will open our workbook. So this is saying merge cells. Okay, 2 must be greater than 3. Okay, so here what is happening? Okay, I can write here D6, right? So now it will run properly, I guess. Yeah, it's working. So let me open this. So you can see this is the default value of like uh, it. So here you can see the value is printed at its default location, not in centered or not in right, not in left. It is default location. So till now we know how to merge cell. So I repeat, I hope you guys understand till here. If you have any questions or any query regarding any code or question, just put as in comments. Our team will shortly provide you the correct solution. So moving forward, till now we know how to merge cells. So let's learn how to unmerge cell. Okay. So let me open the code. Yeah. Let me open the code and write for you. So let me quickly write the code how we can merge cells. So we can write open, okay, from open py excel dot styles. So just I can copy paste from here. I have to write here import alignments. Okay, alignment only. So what we are doing here, though we will not give any value or any this. So here I will remove like b6 6. Actually we can give like a6 b6 as a value. So let's see the cells are merged or not by running it. Okay, see permission denied because our Excel was open. So let me save this and close it and run it again. No error. So here you can see, let me zoom if I can. Yeah. So here you can see A6 and B6 are merged. So what should I do to unmerge? I have to write. Yes, you can write here like here you can write ws dot unmerge underscore cells. Okay, cells. Got it? And just give this same value a6 underscore b6. Okay, colon b6. Let me save this again. No error. Let me open the file. So you can see here a6 and b6 now unmerged. So by just using unmerged cells, you can easily unmerge the cells in your workbook. So let's move forward and see how can you set dimensions for a particular cell or column. So let me close this and go to the workbook again. This is something frustrating by regularly doing the same thing, going next. Oof. So like you need a particular column height should be something and width should be something. So that is what I'm like meant to be dimensions. So let's write code for it. You will see and understand by seeing. So import open py excel hashtag to set dimensions of a particular cell. Okay, wb equals to open py excel dot workbook worksheet equals to workbook dot active ws dot row underscore dimension. Okay, 1. I will explain you, don't worry. Height equals to let me give 70 for a while. Okay, ws dot column underscore dimension. Width. I will explain you, don't worry, 8. So let me save the file wb dot save and let me copy the path from here. Okay, everything seems good. Okay, y column. Okay, column name is like function no column dimension. Okay, dimensions. No error. So like 1 height 70 and b width is 8. Column 1, let me open the workbook. So here you can see by giving row dimension and column dimension and by adding height and width them, we can set the dimension for a particular cell. Y1 and B for this you can see here 1 for the column, like 2 for the column, 3 for the column. Let me zoom it. You can see now 1 for the all the 1 column row, 2 for the 2 row, 3 for the 3 row, like this. For you can say I use 1 for the particular row, or you can say 1 for denoting row, particular row, 1 2 3 4 5 6 like this. ठीक है, I repeat, and particular alphabet to denote the column. See, A for this column, B for this column, C for this column, D for this column, like this. Okay, so here you can see every cell of row 1 has the same height, this, and every cell of bit, and every cell of column B has same width. So like we can do one more thing, we can print value though in a particular cell, like, okay, let me close this and open this one. So what can I do is I can write here, like we can write at wd cell row equals to 1 comma column equals to 1. Okay, dot value equals to hello. Okay, and ws dot cell, here I will write row equals to 2 comma column equals to 2 dot value equals to coders. So I have to write it here, not below this. Yeah. Okay, cool. Let me give this space line. Okay, so let me save this and let me check. So here you can see hello is for the row 1 and coder at the column B. Okay, fine. So let me close this and okay, next I repeat, next let's see how we can move data to a particular row or column, or you can say a particular cell. Here we need data to make it move. So let's fill some random data on it. So what I can do is I can put some random data of like fruit, vegetables, and some names like Mayank, Anjali, Ubhav, Kaushal, Kahana, and we can give like anything Smith, John, and Chloe, Sarah, and I, Sachin. Okay, I think this much is enough. So let me save this, and yeah. So data part is done, and let's move to the this one and write import open pyxl. Okay. So let me write here move cell. You can say move or jump, whatever you want to say. So from open pyxl import workbook comma load underscore workbook will be equals to load can give the path like this, yeah, C and V. Okay, let's make it active. WS equals to WB dot active. Perfect, seems good. Okay, so I have to move WS dot move score range. This is I can give. Okay, let me see the data first. Okay, I will make Anubhav here and Mayank here or here. Okay, so let's see again. I forgot. It is B5 and A4. B5 A4. Okay. So what we can do it like O B5 comma like row equals to 2 and call B rows equals to 2 and calls equals to 2. So let me save this w.save and so here what I am doing is changing the position of the value which is present in the location A4 and B5. So and moving them by, you can say the value will jump by 2 rows and 2 columns because I gave here 2 rows equals to 12, columns equals to 2. So let me save this, run this. Okay, and so here you can see. So let me run this, and what you have to do is open this file. Yeah, so you can see A2 means 1 2, it comes, fruit comes here and coders come here. So this is how you can move your coding part. I repeat, so this is how you can move the cell values. So let's move forward, and so moving forward, let's see how we can insert a row in a workbook. Okay, so first what I will do is I will add some data like name here like fruits and something like car, and here I can write bike Footer. Okay, something here, coding. Okay, all the data is filled and all rows are filled by some values. So here we have no empty row present here till now. So what we will do is we will insert a row. Okay, so what we have to write is import open py excel hashtag insert rows. Okay, from open p excel import workbook comma load underscore workbook to load let me copy the path. See. Okay. So let me make it active. So I want to insert row the position 2 and one more row at the position 5. So let me save this. I will copy from here. Okay, I will make it like this. So let me save this. No error. Let's move to the workbook. So you can see here row 2 is created and row 5 is created with no values. So here you can see rows are added to the particular position, or you can say the indexes. So we have seen how we can insert the rows. Let's see the deletion of the rows. So what we can write is, let me open the code. So what we can write is, let me copy to save our time. Okay, just delete this. So we can write ws dot delete underscore rows, and which row? 2 5. I will delete row number 2 for a while. So let me save this and run this. So now you can see empty row 2 is deleted. So by using insert rows and giving them index, you can insert the row at the index position you gave, and meanwhile you can use delete underscore rows function to delete the particular row. So moving forward, let's quickly write code for the insert column. So for inserting column, I will copy from here. Yeah, insert row column, and this one is for deleting row. Okay, so I have to write here ws dot active, not active, sorry, insert calls at the position second. Okay, at the position 1, and okay, I will make it insert calls at the position 3. Okay, let me save this file by copying this path. Okay, saving. Let me do one thing. Yeah, perfect. So let me open the workbook. So here what I've done is insert call at second position. Here we can't give alphabet, we have to give a number for denoting a position. So here you can see the column is added at the position 1 and 3. So by using insert underscore calls and by giving index, you can insert column in your workbook. So let's do one thing, guys. Okay, first let me close this, and yeah. So what I was saying that, let's do one thing, guys. You will tell me how can I delete a particular column. Okay, let me write here the question. Comments like how can you delete a particular column. Okay, I'm giving you 1 minute for this. Just comment the code for this column deletion, or else you can reply on chat. I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answers at the end of the session, or our team will reply at your comment at the same time. So like for those who are watching this video, like we watch normal video, means you are not watching the live session. So what you can do is just pause the video right now and put the comment how you can delete the column. I'm repeating again, I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answer at the same time, or our team will reply at your comment at the same time. And those who are watching the video like we watch normal video, so that you can do is just you can pause this video and put the comment how you can delete the column. So I guess time is up, guys. I hope most of you gave the correct answers by putting comments. We will verify your comments and we will back to you soon. So okay, moving forward, let's see how we can style the font in Excel. Okay, this is something crazy and interesting, so you will not get bored. And writing from open PyExcel dot styles import font. So here I will write for your styling. Okay, so what I can do is like wb equals to open PyExcel dot workbook. ws dot equals to wb dot active. Don't worry, I will explain you. Row equals to 1 comma column equals to 1 equals to learn. Okay, and I will set the size of the cell. So ws equals to cell row equals to 1 comma column equals to 1 dot value. Okay, here I have to write font equals to font equals to font, and here I have to write size equals to 24. Okay, here I have to give dot value. Okay, now we can do it for the many others. What we will do it, we will change hello, not world again, we will write coder, hello coders, and here we will write code with Simplilearn, and here we will write hello YouTube. Okay, so what I will do is like it will 2 column 2 row 2 2 here. Here what I will do is font size equals to 24 and I will make it italic equals to true. Okay, fine, and I will make it bold. Bold equals to true, and here I will give 3 3 3. Okay, and at the end what I can do is okay by times new one. So let me save it quickly. wb dot save with a path. So let's run this and see the results. So let's run this again one more time. So here what I did is just gave the particular row and column value where we want to print the value, like Simplilearn, hello coders, hello YouTube, code with Simplilearn. Okay, and by using font I am giving the font size and font like italic, bold and so on. Like this is italic, this is bold. Okay, and here you can see at the end by using name, here you can see at the end by using name we are assigning the styles of the particular text like Times New Roman, and you can give the name of your choice. So why it is not, because I have gave the it is collapsing. So here I have write 444. Okay, now it is collapsing now. Hello YouTube and Simplilearn. So what I will do is now I will run. Now you can see. Yeah, perfect. So this is simple one, this is in italic, this is in bold, and this hello YouTube is in Times New Roman style. Okay. So okay, let's move forward and do something with cells. Like what we can do it, let's do color them. Okay. Let's write code for this. How we can like color a particular cell. We know how to color the particular tab of sheet, and now let's color it. So we can write is import open PyXL. Here I will write coloring particular cell. Okay. So I will first copy this thing here from here. Okay, I don't think I want this. I have to write from open PyXL styles port pattern fill. I want something like this. Okay, so wd dot open PyXL workbook. So here I can write open PyXL dot load workbook. Okay, workbook, and here I will give the path. Yeah, it seems good. So what I will do is make it active, and I can write here ws equals to wb square brackets. Then I can write name of working sheet. I don't remember. Only sheet. Sheet. So we can write here fill underscore cell equals to pattern fill patt pattern. Type should be, I will prefer solid. Okay, and comma here comma fg color foreground color equals to, I will write here f c 2 c 0 3. Okay, fine. We can make four cells. Four cells are enough, I guess. So we can write here cell 1, paste, copy, paste, copy, paste. So we'll 4, 3, 2. Solid. Yeah. So let's change color. We can give 0, 3, FC, F4. Here I will give 3, 5, FC, 0, 3. Perfect. Here I can give FC A03. So now let me assign the cells to them. WS, like I can assign A1, assign A2 dot fill equals to fill underscore cell. Okay, fill underscore cell 1. That seems good. This I can make it for 4. V. A2, A4, A5, A3. Everything seems good. Let me save this. So I will copy from here. Why error permission denied? Because it was open. So let me cut this. So let me see. So here I'm using the pattern fill to fill the color in solid style and giving the FG color like foreground color. And at the below you can see I'm like assigning the cells to a particular pattern fill cells. So let's see the output. Yeah, it's working. Here you can see the results. We colored these for the particular cell like A2, A3, A4, A5. So this is something you can style the color. So let's move forward and see how we can import the image in our workbook, like something here, something here, something here. Let's see. So let me first cut this. Okay. Let me do one more thing. Yeah, perfect. Coloring particular cell. So how we can import our file or image, you can say. So I will write from openpyxl port load underscore workbook. Okay, load underscore workbook, and I have to write here from openpyxl dot drawing dot image import image. Okay, fine. Workbook, write wd equals to load underscore workbook, and give, let me copy this and this whole. So logo is for variable used for the image. Okay, so I don't have any image for right now. Let me do one thing. Let me import one image, any kind of image for a while. So I can do like, so this is my image. What can I do is I can give the path like path would be same. We will change here something. Don't worry. Desktop. Don't remember name of the file. This is picture 2. Okay. P is small or capital? P is capital, so I have to write picture 2.png. Okay, so I will give logo dot height equals to 150, logo dot width equals to 150. A bit of resizing to not fill the whole spreadsheet with the logo, so that's why just for that. So ws dot add image to logo, comma, cell, in which cell you want to print. I will M2. Fine. So here we will save it by using this one. Okay, perfect. Cannot import name image from open file during this one. So might be there is problem. Open pyxl dot drawing dot image. Okay, import image. I think I is capital here. Seems logo image. Okay, I is capital here. Yeah, it seems good. Yeah, here is the picture. So what can I do is, so here we need one more library, drawing image, variable logo. This one is for the location of the image, and giving and height and width, because a bit of resizing to not fill the whole spreadsheet with the logo, like with the whole spreadsheet with the logo. So just a bit of resizing. And add image function is used to append image on it, and m2 is for like this m2 is for position, m2 like that. It's for in which cell you want to append it. So image is coming to the particular index m2. Okay, so this is how you can import image in Excel using Python. Okay, let's move forward and see how we can import date and time. So let's write code for that quickly. Okay, so what I will do is I will write here import date time. I will write date time from OpenPy Excel import workbook import time. So what can I do is make it wb equals to workbook. Okay, blue should be capital here, and ws equals to wb dot active. So what can I write is ws dot cell row 1 comma column equals to 1 dot value equals to date and time. It's something. So I can write, copy it, paste it. What I can do is, let me first change the 3 row equals to 3. Okay, column equals to 2, I guess, value. So here I can assign date and time. Date time dot date time dot now dot string format strf time. What you have to write it, %y %m for month, %d for days, %h, then %m for minutes, and seconds. So that should be in between this. Okay, yeah, perfect. So let me save this, close it. Import data time, not date time. It's date time. Okay, row equals to 1. Data time, not date time. Again, date time dot now, date time dot date time, date time. So date time objects has no attribute strf time. Okay, time it is, yeah. Okay, yeah, finally it's working, no errors. So here, like, okay, So here I have imported some libraries like date time and so on. strf time used for string formatter, and date time now used for the current date time. This date time now is used for the current date time. And so let's run this and see. So here you can see the correct time and date is coming. It can be different from which country you are watching this live session. So what if you want to print the time after like 2 seconds late? So for that we can write here quickly. So I will copy this whole. So like we have to copy this, and just what you have to do is let me make for to see the difference. V. Okay, 3 are enough. So what I will do is 4 5. Okay, fine. What I will add here is time dot sleep. How much second you want? Like 2 for this one, and something for this one, like 5 seconds for this one. Okay. So what we can do is let's save it and let's see the results. So here I've used the time.sleep function given parameter as 2 or 4, I guess 5, for printing the seconds difference. So here you can see the difference in seconds. Okay, the time is not coming. Wait, let me check. Okay, why permission denied? Sorry guys. Now I have to run it. Open it. And it is not coming. Why so? Permission denied. Okay. Let me run it again. Okay, because I am giving seconds difference, no? That is why it's giving permission denied. So let us wait for 5 seconds. Okay, I think 5 seconds are over. Now we can open it. Yeah, you can see 47 seconds and 49, 2 second difference, and 49, 54, 5 second difference. So here I've used the time sleep function given parameter as 25 for printing the second difference. So let's move to the workbook. I repeat, here you can see the difference in seconds. So I hope you understand till here. If you have any questions or any query regarding any code or question, just put as in comment. Our team will shortly provide you the correct solution. I'm repeating again. I hope you understand till here. If you have any questions or any doubt or any query regarding any code or whatever it is, so just put as in comments or our team will shortly provide you the correct solution. So moving forward, let's see how we can add values as an array. Okay. So what I will write, import xlsx writer wb equals to xlsx writer dot workbook. Okay, I will give the path from here. Okay, ws equals to wb dot add worksheet. W should not be capital here. Okay, so what I will do is row equals to 0 and column equals to 0. Okay, so I will write here data equals to, and take is the names, just names. Okay. Just random names they are. Above, let's take one more. Kisle. So for item in data, okay, ws dot write. I will explain you line by line. Don't worry. Row, comma, column, comma, item. Perfect. So here what I will do is row plus equals to 1, or you can write row equals to row plus 1 wb dot close. Okay, let's save this. Let's see our data is appended or not. Okay, first I will explain this code to you. So here I have created one new workbook, name. No, I haven't created. So let me create two. Okay, example. Okay, so I'll run this. Yeah, perfect. So here I repeat. So here I have created one new workbook name example. So at row 0, column 0, I am printing my content values, like for data values. Using for loop, I am moving to the next iteration of the values, like from Anju to Koshu and then Mayank, then so on. So let's see the results. Okay. Yeah. So here you can see all the values are printed. So using these codes of line, you can do things like this easily. So as we know how to write multiple values at the same time, what if we want to retrieve values of a particular row or column? So for that we need data for that. So let me add the full data of let me copy some data from somewhere. So just give me a minute. Okay. It's the blank worksheet. Let me give me 1 minute, guys. Okay, what I will take is this one. I can take this, some values we can copy, like 50 values. Okay, 50 is I know. See, yeah. Okay, we have data now. Simplilearn. We have data in the Simplilearn. Okay. Now we can write code for that, like how to retrieve multiple column. So the same I want. See. Let's do wb dot active. Okay, ws equals to wb write sheet column in worksheet A. Okay. So what I have to do is just print column values. Column dot value. I hope it will work. WB dot active workbook object has no attribute active. Okay, let me see. Okay, sorry. Import open PyXL. XLS writer is used for to create new workbook. Okay, open PyXL dot load underscore workbook. Now it will work, I guess. Still it is not working. Load. It should work, I guess. Open PyXL. Open PyXL dot load. Okay, sorry, my bad. Here dot. Now it will work. Okay, sheet. It's too much. This is sheet 1. You never know when the sheet will create sheet 1. Yeah, you can see all the list of column A is printed here, all the 50 values, and you can match from here to all the 50's values. Okay, till Travis Scott. So let me match this till Travis Scott. Okay, so I hope you understand till here. If you have any questions or any query regarding any code, so just put as in comment or our team will shortly provide you the correct solution. After doing importing, exporting the values and all, let's perform some basic operation like addition, average and all. Okay. So first we will start with the addition. So I will write here. So we need data in workbook for the addition. So let's take some data from which set? The same Insta data set. So I will take this 50 values are enough. Okay, copy it and let me paste here. So data we have, let's code for it. We have to write here import open PyXL. We are doing sum of columns, not column values. Yeah, like from open PyXL import workbook, comma load underscore workbook. So WB equals to load underscore not workbook copy the path. Okay, so I will make it active. So here what I'm doing is I will tell you shortly. So it is in C, I guess. C or B? Which column? Oh, B. So B 50 1, I guess. Yeah. B51. B should be capital, equals to, see carefully what I'm doing, like sum from B1 1 till B, I guess 50 values we have. 50. Okay, B should be capital. My bad. Sorry. Okay, this is what I'm doing. And wd dot save. Where is the save one? Okay. So here I have added all the values which are between in the range of B1 to B50. And what I'm doing is the result will be displayed on the B51th cell. Okay, so let's run this code. Okay, let's go to the B51. Yeah, result is coming. For verifying the result is correct or not, I won't use calculator for this. So we can use this code for the same for average, product and count. So let's do it quickly. Okay, so let me just copy paste this stuff. CV, this is will be for average. A spelling mistake, average. Okay, what I will do is just write capital average here. Okay, and I will print it to 52. Okay, code is almost same, just one change. Like you have to write, instead of sum, you have to write average there. And just, okay, let's see then. So now you can see this is the 137 point something 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 is the average of these all values. Everything look good. Let's see the count quickly. Let's we code is almost same, just we have to capital 53. Visible? Okay. This count will give you how many values are there between the range till 1 to 50. So let's check, let's run it again and check if it's working or not. Yeah, 49 values. Okay. So what I'm planning is, let's do one thing now, guys. You will tell me how I can find the product of a particular range. I'm writing question as a command as I did before. So how to okay, how to find product of numbers, like where the range is between A2 to A98. Okay, so I'm giving you 1 minute for this. Just comment the code for this like multiplication, or else you can reply on chat. You can write just syntax only for the product. I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide the answers at the end of the session, or our team will reply at your comment at the same time. And those who are watching the video like we watch normal video, or you are not attending the live session, so you can just pause this video and comment on how we can find the product in Excel using Python. I'm repeating again, I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answers at the end of the session, or our team will reply at your comment at the same time. Those who are watching this video like we used to watch normal videos, so what you can do is just pause this video and comment on how we can find the product in Excel using Python. So I guess time is up, guys. I hope most of you gave the correct answer by putting comments. We will verify your comments and we will back to you soon. So moving at the last of the session, let's do something with charts. So what I will do is first I will move it bit up. Yeah. So let me write code for that, for the chart. So I will write from open py excel import workbook from open py excel dot chart import reference comma line chart. Okay, we will create line chart. WB equals to workbook, WS equals to workbook dot active. So after this I will set the chart title, title equals to chart. Okay, let me create the rows. So rows equals to I will do is I will create something like weeks, okay, comma sale, comma veggie sale is comma not here, comma, and I have to give the values. Weeks are Monday. Okay, let me give the same. Put cell should be like 100 comma 200 Tuesday comma 200 comma 300 Wednesday 300 comma 400 for the Thursday comma 400 30 day 20 comma Saturday. Comma 30. Okay, it seems good. Let me do like for rows. Okay, row in rows. ठीक है. WS dot append row. Values equals to reference ws comma min call equals to 2 comma min row equals to 1 comma max column equals to 3 comma max underscore row equals to 7. Okay, it seems good. Okay, x dot values equals to reference underscore string equals to chart A2 A7. So chart equals to line chart we are making. So let's add the data to line chart object. Chart dot add underscore data values comma titles 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 underscore from underscore data equals to true. Okay. T should be capital. So let's set x-axis chart dot set categories x underscore values okay, let's set chart dot equals to sales chart dot axis equals to weeks and chart dot y axis dot title equals to fruit and veggies sales chart dot legend dot position equals to b. Okay, so ws dot add underscore chart comma h1 cell. So wb, okay, let me copy this code from here. Yeah. So here I am importing reference and charts library like this, reference and charts library, and just giving title as charts. You can say here chart. So rows are the data from which we will make chart, and for loop is to append the data on the workbook. Chart add data values titles from data equals to true. This is for adding data to the line chart object, just giving the title x-axis and y-axis and all. So let's save this and see whether chart is visible or not. Let's save this. Okay, what is it going? Cannot import name reference from open file reference. Okay, let me see. Error in line 2. Okay, sorry, my bad. Okay, now it will. Workbook, fourth number. Workbook. Okay, W should be capital. W should be capital. Now it will work, I guess. Again, that's reference. Okay. Dot values. Dot, my bad. HART CHART dot save. Okay, WB dot save. Okay, finally no error. So let's save this and see whether chart is visible or not. Let me go to the Simplilearn. Yeah, you can see chart is coming and it looks so good. I hope you guys must have understood the concept of automating Excel with Python. If you have any queries or doubt, you can ask them in comment section.
Hello everyone and welcome to this session on Python projects, and today we're going to discuss about how to send emails using Python. So we will see the piece of code in our Jupyter notebook that how can we leverage Python as a programming language to connect with SMTP server, email servers, and send emails to the desired recipient, simple emails, emails with attachment, etc. So we will see with certain examples. Now before we move ahead, just make sure that whatever email ID we are going to use for sending emails, so we are going to use our Gmail. So make sure in your Gmail you have allowed less secure app access, and that's after this, if you have enabled this, after that only you will be able to send email using Python. So please make sure that you have enabled this less secure app access. Okay, so we are going to use our Gmail account as an example, so that's why we are doing this. Now let's start. So first of all, you have to import the relevant Python library, which is the SMTP lib and SSL library. Okay, and then you need to mention the sender email and the password of your email ID. Then provide the details of the receivers whom all you want to send the email. Okay, then we will enter the details of the email body, the data which we want to send in an email to the receiver. Now coming to connectivity with the email server, now at this point we are utilizing this utility SSL to create a context, and after this we will make connection with the Gmail server, and by default the SSL Gmail server is running on port 465. Then we will log in and then send an email. Okay, so we need to connect to the Gmail's SMTP outgoing mail server. Then we need to provide the login information and then send email. So now when I will execute this point, now I will try to check my inbox, and if you can see, there is an email which I have received just now, that and which has, this is the content. This email is sent using Python and subject is mail from Simplilearn. So this is the very simple piece of code which allows you to send email from your Python code. Now let's take a look at another example where we will try to send email in an HTML body, right? Okay, so similarly we will start by importing SMTP lib and SSL, but Also, we will add two new libraries, which is MindText and Multipart. Now, because we are trying to send email in a HTML body part, so I'm going to provide the email addresses of the sender and the receiver. So I'm going to send email to myself. I'll take my password as an input. Now I have to provide the multipart, which I'm going to provide as alternative, subject as anything which you can put, multipart test, sender email and the receiver email. Now I'm creating a text and an HTML body part. So this is an HTML body which will go in my email. Now I'm creating two variables, one in which I'm defining my text part, which is text plain, and another part I am adding my HTML, which is I am tagging as HTML. Now you attach both part 1 and part 2 in the message. Okay, so now your message has both the text and the HTML. Now thereafter you have to create the same connectivity with your SMTP Gmail, login, and then you have provided the details of the sender and the receiver. Now you have to apply message.as_string. So now this is the difference from our previous example, where now you have encapsulated the HTML and the text part, encapsulated in a message, and then you are converting into a string and sending. Now I have received an email, multipart test. If you see, this is an HTML body where I have kept this as a header and this as a plain text. We are sending email using Python. So if you see, this has come in bold as a header and this has come as a plain text. Okay. Now another important aspect, any email generally you also need flexibility to add an attachment to it. Okay, so right now what we have done is we have just created the email body in a different style. Earlier we had a plain text. Now here we created the body in HTML. Now we want to attachment. So what we will do is we'll say import email SMTP lib SSL. Now you have to import packages of encoders, MIME-base, MIME multipart and MIME text. Now my other variables, an email with attachment from Python, this is my subject. This is an email with attachment sent from Python. This is the body, sender and receiver email and password. Now I'll put all these variables encapsulate in a message, which is MIME multipart. Okay, the from details, the to details, subject and the receiver email. Now I'm going to attach the body, and now I'm going to define the name of the file which I want to attach. Now make sure, like, I'm running this Python script from my folder C drive, users, PyGame, and in this folder I have a document called document.pdf, which I have kept it already. So you make sure that the document is lying in the same folder from where you're running the script, and then you have to open the file, attach the file to the payload in octet stream. Then you need to encode it in the base 64. Okay, and then add header, content description with the file attachment and the file name. This is essential. Then at this part, now your part is ready. You have encapsulated the entire attachment in the part and you have attached that part to the message. convert the message as string. Now you are at a point of creating connection with the SMTP server, sender email, receiver email, and the text part, and you need to send it. Now if you go to your email, this is the document PDF which has come as an attachment and you have received it. So we have seen three variations of how you can send email from Python. One, same plain simple vanilla email with simple text. Second, you are sending email with HTML body where you can use the HTML tags. Third, sending email with attachment. The common part between all the three parts is that you need to create a connectivity with the SMTP server, okay, and provide your credentials of the sender email and the data which you want to send in the attachment. In other two cases where you were sending HTML body, we used MIME text and MIME multipart, and in the attachment part we use MIME base as an extra library which we are supposed to use in order to send an attachment. Hello everyone, today we are here to discuss a project on Python and how Python can be used to invoke and send messages in WhatsApp. So what we are going to today do is we're going to demonstrate you how to use PyWhatKit. It's a Python utility which is available in order for you to interact directly with the Python and WhatsApp. So we will show you certain examples using which you can directly interface with your WhatsApp. Now, in order to perform this activity, first you need to go to your Python installation folder. Now, in my case, I have my Python installed in my app data local programs Python 310. So your first task is to go and open a command prompt from this folder, and then you need to install pip install PyWhatKit. So under Python 310 there is a folder scripts, and you paste this command and you should get this particular message if you have already installed PyWhatKit. If not, then Python will install the relevant library in your computer. After you have done this, then go back to your Python root folder, go to the Python terminal, and then run the command import PyWhatKit. Okay, so after you have installed the PyWhatKit library, then you need to import the PyWhatKit, and this message should be successfully imported. Now, I want to send a WhatsApp message to a phone number, and I want to send it at a particular time. So right now I'll just set the time as 20:38. And please make sure that you are already logged in to your web.whatsapp.com, and so that when Python tries to send a message, you are already pre-logged in. Okay. Okay, so now if you see with this message, with this API, I'm going to send the message at 8:39. So this will go and open the WhatsApp window in next 46 seconds, and after 20 seconds the message will be delivered. So 8:39, so when the timer in my system clock will reach to this particular time, Python will open a WhatsApp window, log into that, reach to this phone number which is there in my WhatsApp contacts, and then after 20 seconds this message will be delivered. So let's just wait for a few seconds and wait for Python to perform that activity. Yes, now Python has opened the web.whatsapp.com in which I'm already logged in. It has reached out to that number and typed the message, "Welcome to Simply Learn World," and I can send this message. Now, let's move on to another example. If I want to send a message to a WhatsApp group, then you need a WhatsApp group chat ID and the message you want to send. So now, in order to send a message to the WhatsApp group, you can pick any WhatsApp group in which you are administrator, go to the group info and click invite to group via a link, and in this link copy this part, copy link, go to notepad, just copy this part, this is the group ID, okay, and paste it over here. Okay, so now you can send message to a group, copy paste this in your command prompt, set the timing, in 16 seconds WhatsApp will open a window, and after 30 seconds the message will be delivered. Okay, so WhatsApp window is opened. It will reach out to that particular group. It will type the message and submit it, and even it will close the window automatically now. Okay, so this particular command has typed the message, submitted it, and closed the window. Now if you want to send the WhatsApp message instantly, you just use the API send WhatsApp message instantly, and it will send it instantly to the user. Now another utility is that if you want to find a keyword on YouTube, so we'll just play on YouTube, Simplilearn on YouTube. So it will automatically play the YouTube channel which you have put in that particular keyword on the YouTube. So Python can also directly open a YouTube URL, or if you want to do a Google search, here you go. So as soon as you put that command on the Python console, it will open google.com and search it.
There are many reasons to be able to go online and scrape different websites. They range everything from pulling out different links to pulling data off of websites. As a data scientist, you might need to get some information off a website that doesn't have a direct API to pull that information. And in Python, we have a wonderful tool. When you talk Python and you talk web scraping, we're talking Beautiful Soup, which is a package you add into your Python that you're running. And we can come over here to the website, www.crummy.com/software/Beautiful Soup. You can actually read a little bit about it. Currently, Beautiful Soup 4 is the current version. If you don't remember the full website for it, you can always do what I do, which is go over and do a search for Beautiful Soup official site. And it almost always comes up right at the top, and you click on there and it'll take you to the crummy.com software site for Beautiful Soup. Now, we're going to use our whatever Python interface you want, IDE. I'm going to use Jupyter Lab, which is built on Jupyter Notebook through Anaconda. Jupyter Lab is Jupyter Notebook with added tabs and some added features. It's basically in beta testing, so it's got a few little glitches when you're saving things and moving between projects, but for the most part it's a great upgrade to the Jupyter Notebook, and you can use them together, so you don't have to, it's built on Jupyter Notebook, so anything you do in Jupyter Notebook you can open up in Jupyter Lab. And the first thing we need to do is we need to go ahead, in this case I'm going under my environments since it partitions the environments out, and I'm going to open up a terminal window. We have to install some packages in here there to work with. Now there's a lot of choices on this. Because of the simplicity, will be using conda install. Now you can use pip install for the same thing, and we're going to install our beautiful soup 4. And you have to type out the whole thing, beautiful soup 4, and you can use a pip install if you're using a different environment. And I am using Python version 3.6, although according to Beautiful Soup they also work on 3.7 all the way from 2.7 through all of 3x. Now according to the Beautiful Soup website, the Beautiful Soup 4 works on anything you can install on anything from Python 2.7 all the way through any of the Python 3 versions. This just happens to be Python 3.6 because there's a lot of other packages that don't work on 3.7 yet. And we'll go ahead and run this install on here and let it go through its environmental setup. And of course with conda, it goes in there and finds all the dependencies. Pip doesn't do as much as far as finding dependencies, but you know exactly what's on there with pip. So if you're doing a huge distribution, you probably want to use your pip install so you can track what's going on there. With the conda, I like to just let it take over since this isn't a major distributed package going out. Another quick note between pip and conda is that if you start on a project in one of these environments and you're using pip in there, stick with pip. If you're using conda, stick with conda. They track the packages and you can run into some issues where they're not tracking the same packages and something gets overwritten. So it's important to stay very consistent with your install on your environments. And we'll also need to go ahead and install our Numpy environment and our Pandas on here. So go ahead and do that. If you haven't added those packages in, go ahead and install those into your environment that you're working in. And of course Pandas is just simply install Pandas. And let's just install a couple more packages. In this case, let's get install our matplot library because we're going to plot at the end since we're going to be collecting data. And for this project, that will be all the packages we'll need. So we can go ahead and close out of our installer or whatever setup you have. And we'll go back to home and we'll just launch our Jupyter Lab and that will open up in our browser window. Now, if you're coming from Jupyter Notebooks and first time in lab, we can go ahead and just create our first notebook, Python 3. You can also do it under File, Launcher, and you'll see New Notebook. It automatically opens up and we can just click right on there. It'll pop open on the left and I'll right click this and we'll rename this. We'll rename it just Beautiful. And it is a IPyNB file on there. So that should look familiar because that's the Jupyter Notebook file. This is a new one. Now I have multiple tabs, and in the past I usually hid this on the other computer, all my notes for the lesson today. But this is my notes going down, and we'll go ahead and just start going through this and see what it looks like to do a data pull from front to end and see how that works as a data scientist pulling that information in from the website. And the first thing I want to do is I want to go ahead and close this side window. That way it get the nice full screen. And we can also up the size a little bit. One of the wonderful things about working in a browser window. Just do that Control+ thing. The packages we talked about is Pandas. So we imported our Pandas if you haven't already. That's our data frame. If you haven't done our Pandas tutorial, definitely worthy of the time to go through there and understand Pandas because it's such a powerful tool. This basically turns your data into a spreadsheet data frame. Our Numpy is our number array, so it kind of works with Pandas very closely as far as manipulating data in arrays. Matplot, we want to go ahead and bring that in, our PLT, so that we can plot the data at the end. And this line right here that says Matplot library inline is for the Jupyter Notebook specifically. It tells it to print that on this page. A lot of the newer versions don't actually require to have that line. They'll still print it on the page, but you should still include that if you're in the Jupyter Lab setup. And then we have our URL library.request. We're going to import URL open for opening up the website. And then we have our BS4, that's your Beautiful Soup 4. We're going to import Beautiful Soup. And then our last one is our RE. That is for manipulating our regular expressions. So when we get to that part of importing our data, we have to do a lot of reformatting so it's something we can use. And the RE is one of those tools. We'll go ahead and run this and just bring all that in. So this is all imported. All these packages are now into our web scraping program we're going to run. Now if we're going to dive in and pull data, we should have a nice website to pull from. And let's go ahead and we'll use the HubberTiming.com results for the 2018 Martin Luther King race. And if we take this, you can actually just take this, where did we get this from? Well, you can go in here and find the website you're going to scrape from, and you'll see right here it says you just copy that link right in there, that HTTP. And this is the website that we're looking at, and you can see right here all the information that we're looking at. Let's say we wanted to run some statistics on this. It sure would be nice to be able to pull it off of here. And if they don't have a direct API, that means we need to pull it from their website. Some of these will have a download, although if you've ever done it where you have a download click and maybe you're paging through 100 websites. In one case, I was polling all the different United States bills that are passed to track who voted on them for a project. And you can imagine that there's hundreds and hundreds of those, thousands of these documents that they voted on, who voted on it. It goes through the Senate, it goes back to the Congress. So I opened up a website, pull all the links off of there that match a certain criteria, and we'll look at that in just a minute, how we go through the HTML. And then I had to reformat them, or I could hand download each one at a time, which would just be a nightmare. So it's nice to automate it. In this case, we're going to be pulling up this chart, and we want to figure out how to pull this chart off of this website. And so when we go back into our Jupyter Notebook, I've got my URL, just our name for it, and it's just a string. That's all this is. Nothing fancy there. You'll notice that on the slashes, we now have // You can do a single forward, and HTTP is a double forward. This is just how you have to switch it to match setup in there. And then it's going to go ahead and use the HTML equals URL open URL. And that's from our URL library request. So it's opening a link to that website, or at least pointing to it. And if we run this, this just sets it up. So this is all set up. And then once we've done our setup, let's go ahead and create an object called soup. This will be, and if you remember up here, here's our beautiful soup that we imported from the BS4. And this is the package that we're working with. And so we're going to do our beautiful soup on here. And on this, we need to go ahead and send it our HTML so it knows what it's opening. And then the second part is we have to tell it how the format is coming in. And the most common one for your HTML polls is an LXML setup. And so almost all of them you'll end up using the LXML. There's a few other options. And because this is so common in the newer versions, a lot of times they just leave it out just because it's already on the default. We'll go ahead and leave it in here just to remind us that it's there, and we'll go ahead and run that. And on the newer versions, they actually default it to the XML setup and the HTML. We'll just leave it out and call it HTML. So it's just going to pull from this URL. And when we run that on here, we've now created an object soup that has pulled the website into it. So soup contains the information along with information on that website and what's going on. So let's just go over what we did real quick before we start digging into the actual soup, before we start scooping out stuff. We imported our different modules that we're going to use with our package, specifically the beautiful soup. We did install the beautiful soup. If I remember correctly, you have to call it beautiful soup 4 specifically, so it knows what you're bringing in. And this line right here is very key. From BS4, because that's how it installs the module, we're importing our beautiful soup. And then we found our URL. In this case, we're going to go pull information from the Martin Luther King Dream Run. And then we set our HTML to our URL open URL. And you can see right here we imported that. So here's our URL.request, import URL open. So we're requesting a connection. And once we send that connection into the beautiful soup, it creates an object called soup. And then this one, of course, we chose soup just because it goes with beautiful soup. I guess we could have chosen beautiful. And now we can start extracting information from our website because we've pulled it down onto our computer under soup. And we can start by looking at the title of the website, soup.title. And if we print title.text, you'll see this a lot in beautiful soup because title contains all kinds of information, and if we want just the text from that title, you add the .text on the end. And you can see right here we have our 2018 MLK Dream Run 5K race results. If you look at the tab, that's the actual title up here, 2018 MLK Dream Run 5K race. That's what the title is on the website. And then you might be curious, what's in title? What's the whole title that it's storing up there? Well, let's go ahead and print it out. Here's print title and print print title.text. And when we run that, you can see it has the HTML tags title on it, and then the / title to end it. And so we're really just pulling off this piece of the HTML code, and then we look at the text inside that particular part of the HTML. And earlier I mentioned links. What if you want to get all the links off this page? Well, that would be fun. We could do soup dot, and we'll do find _all, put this in bracket, and then quotation marks, we'll go ahead and put A. A is the key find, and you'll start seeing a div and all the different options you have for finding these entities in a website. And then let's go ahead and just print our links, and you can see here that it now shows all the different links in here that are marked by A, because we did a find all A. And then we can also, because this is a little bit hard to pull off the href, so we can also add in our find all, fine tune that. In this case, the href equals true. We'll actually filter that out. And then finally, we might do a for link in links, and we can simply do something like this for each link. We want to actually find the href, because we know there's an href in it. And if I run this, you can see it just comes through and prints them out one at a time. Some of these are really useful. So you might be looking for something that has HTTPS in it, and you know that's a link running to something else. Or you might be looking for the mail to tag, so you know that's all the mail addresses. But either way, you can easily find all the links in your HTML document that you're paging through. And of course, any packages that have evolved over time, you can also do link.get href, which should do the same thing as our other format. And you can see it certainly does. We get the same printout up here. In this particular case, we really want to get the data off the page. So let's go ahead and do that. Let's see what that looks like. And in data, let's call it all rows. There we go. Equals. And then we have our soup.find _all. There's our brackets. And then if we're looking for each row in a database, you'll remember your HTML code, we're looking for the tag tr. So we want to find all tr. And we can take this, and let's go ahead and just take all our rows and do a print all rows. And about this time, you're going to guess that we're going to get a huge amount of information just dumped onto our page. And sure enough, we do. If you look at this, it just kind of goes on forever. But this is an array. Each row is considered an array. So because of that, we can do something simply as putting brackets and just print the first. Let's do the first 5 rows. So from beginning to 5. And you can see here's our first 5 rows on here. I sometimes like to just do, let's just do row 0. And we see that row 0 is finishers. Finishers 191. And just out of curiosity, if that's 0, what's row 1? Mail. Okay, so we're starting to see titles going across here. So if we come up here and we do rows, we did what, up to 10? Let's just take a look and see what 10 does again. And just take a look at that information that comes across. Place, bib, name, gender, age, city, state, chip paste, gender, and so on. So it comes all the way down here. We kind of have an ending right here, and then we have 1, and then we actually, it looks like we start to have information. So we have our 1, our 1191, Max Randolph, that must be the name, Mel 29, and so on. You can start seeing how the information starts getting displayed going down. So the next thing we want to do with this, and I'll go back up here and just edit the space we're in so it starts to make a little bit more sense. Keep it all together. And so we want to do for each row in all rows, we're looking at, what information are we looking at? Well, we have our TH up here, that's the header, our TD down here, which looks like the individual information. And we really are looking for the actual data. So we're looking for our TD tags in the rows. And we can do that because remember when it stores the row, it also stores the tags underneath that. So all rows have all the different tags in it. And you can see right here as you print each one of those out. And so when we look at each row, we can create another variable and we'll call it row list. And we'll set this equal to, in this case, row, because we've already pulled all the rows out of soup. So now we want to find for each row, and in there we want to find our TD. And if we go ahead and just print, I'm going to do it, if you notice I changed the indent, so I'm just going to print row list. What this does is the last value to go into row list, our last row is going to print now. And of course make sure you have an underscore instead of a period when you're typing. So row.find _all TD, and if we print the last row, you can see I have all the data coming across here. We have our 191, our 1216, Zuma, Okchoa, I hope I said that right, female, I believe that's age 4. 40, and so on. And then we can take our row list, and there's a lot of things we can do with the row list. But we'll do let's do object, or let's just do cell in row list. And so we're going to look at each cell, because this is, if you look at this, they have commas separated between the different objects. And then we're going to go ahead and print cell.text. Let's just take a look and see what that looks like. And we can see here for each row we get 191. There's our 191. There's our 1216, 1216, our individual who's in the race, and so forth all the way down for those different settings. And let's go ahead and create a new variable up here. We'll call this all, let's just call it data. We'll keep it simple. So here's our data. And then we have our row. We take our row and we break it up into individual cells. So we'll call this data row, and we'll set this empty to an empty row. And we're going to take our cells, tab this, and we know that each cell generates a text. And so what we want to do is I want to take my data row, let's just replace that. Let's take our data row and let's append our cell.text. So I'm going to add each row is going to be a row of the different text on here. And then once I create each row, I want my data, which is going to be everything, to append each row. And here's our data row. And then if we go ahead and come down here, and let's just print data. Now, if we were working with large data, we'd be very careful about just throwing all our data on the page. But you can see here, we throw the data on the page and we get finishers, 199, male, 78, female, 113, 1, and so on. And if you look at this, this is the headers on the file. We have finishers, male, female. It's just like some general statistics on the first one. And then we have actually an empty data set, and then we have our data that continues, which the actual information we're looking for. So we have 1, 1191, Max Randolph, male, 29, Washington, D.C., runtime, 1 of 78, and so on here. So we could really quickly get rid of that. A number of different ways to do that. One of them is just to do, we're going to set, if we do data 2 on, we should get rid of everything, but we want to keep Randolph, so make sure Randolph is in there. Oh, we lost Randolph. Let's try 1 on. There we go. There's Max Randolph on there. So we can just simply redo our data on here, and we can do data. Probably want to do it in all rows from 1 on, but I'm just going to do my data equals data 1 on down here. There's reasons to split it this way. In data science, sometimes you don't want to touch the original data in case you need it, in case we do need the first row. So we'll put it down here, and maybe we'll just call this titles. Titles equals data of 0. And so we could do something here where we print, and we'll print up our titles, and we'll print our data. In this case, instead of 1 on, let's go -2. Let's look at the last 2 rows of data. So here we have our titles, and for some reason just put in finishers of 191. I was expecting a little bit more up there. And we have our last couple people, and they look like the data on these looks just fine on here. Turns out this is just some generic statistics up here. So we'll get rid of titles completely. It doesn't really do us any good. But we know that data comes in here, and we can look at our data and look at the very end of the data too, the -2 to the end. And we can see it pulls the data in pretty good. We don't have anything too funky in here we're looking at. It looks pretty clean. Now you got to be a little careful, because at some point we might have to come back here and clean up the data if we get an error for running data analysis. We might find out there's some unusual characters or something is misset in the data itself. And you also notice that everything is a string. So when we're bringing it in, we might have to do some conversions to test it out and convert them to whatever kind of data format we're working with. So at this time, we want to go ahead and bring in our pandas. And let's go ahead and call this df for data frame. We'll set it equal to, and if you remember correctly, we imported pandas as PD, and that's standard. You'll see that in most code examples where they import pandas as PD, and it is capital D, capital F for data frame. And we're just going to bring in our data. That's what we called it on here. And let's take this and we'll print. Now, when you're working with data frames, you're usually talking large amounts of data. And so you almost never want to print the whole data frame out. We're going to go ahead and do that anyway, just so we can see what that looks like. And you can see in here, it brings in our data frame coming in here. We just have a mess of information. This is our data. Let's go ahead and print df and see what that looks like in the data frame. And this is nice because it organizes it into a very easy to read table. And we have, they set the label 0, 1, 2, 3, 4, 5, 6, and so on. And then we have each row. We have male, 78, none, 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 going across. When we get all the way down here, we'll see Max Randall about number 3. And the first thing this does is this flags me that I brought in a bunch of information up here that we really didn't want. It's from 3 on that we want. And we can clean this up in one of two ways. We can try to clean it up under the data, or we can clean it up under the data frame, depending on what it is we're trying to do. And so to fix this, I want to go ahead and just change it up here in the actual data pull in. We don't need that information. So I'll rerun it, reload our data from 4 on. And then when I run this, we see we have Max Randolph is right at the top of the list like he should be, and we have all the data going down. Now with the data frame, remember I said we don't usually print the whole data frame. We'll go ahead and do df.head, and this prints the first 5 rows, and you can see that we have 13 columns. Here's Max Randall all the way to Theo Kinman, and I usually also print df tell. And the reason I like to do these particular 2 setups, and I'm going to change it just to 2 rows, because you can do that, you can print as many rows as you want, is it's good to look at the first part and the end, because those are usually where you have extra data brought in, something's messed up. And you can also see that we have 190 rows in here. And it comes in with our Zulma, Lisha, and they're both on here on the list. So now we have a nice data frame, columns and rows. We can easily look at it, we can see the setup on here, and we can look at the names and everything. Now at some point you might be looking at these individual columns and find different information that needs to be re-edited. If you can, you try to do it with the whole column under Pandas. You can, up in the upper part of the code where you went from cell to cell or row to row, you can look at individual cells. Maybe you find a marker in that cell that's something specific, like remove all colons or semicolons or something in there, or brackets. So there's a lot of options in there. But you'll find that this one actually comes in pretty clean on here all the way down. And the next thing we really want to do is we want to look at the headers. I don't know about you, but it doesn't make any sense to me when I have column 1, I don't know what 1191 is or 1080, need name Kaiser runner. I'm guessing that's column 2 is names. Third one, it looks like male or female, probably age, but I don't want to guess. I want this to bring in my column so I know exactly what I'm looking at. So how can we make Beautiful Soup do that for us? Well, let's take our column headers, and we're going to set that equal to our soup find underscore all, and then we're going to look for our headers, our th files. And since we're in Jupyter Lab, in this case Jupyter Notebook, I can just type out column headers. If it's the last variable I have listed, it'll automatically print it. So it's kind of a shorthand. And we can see right here we have place, I'm guessing that's bib, name, gender, age, city, state, chip time, chip pace, and so on. So we have all our headers right there. I shouldn't have to type them all in. And we'll go ahead and do it before. We'll go ahead and do a header list equals our empty array, and then we can do for column in column headers, and we can take our header list and just append. And what do we want? We want the text from the column, so we'll just do column.text. And then if we come down here and we print our header list, let's see what that looks like. If we did it right, we should get a nice list of all the different column headings we want. So we have place, bib, name, and so on. And then Pandas, just because Pandas is so cool, we can simply do df columns equals our header from our header list. We can simply set df columns set to df headers, and then if I print df.head, we'll take a look at that, and we'll see right here it has nicely placed our values on here. Place, bib, name, gender, age, and so on. So very quickly we've created this nice data frame. We have the data displayed in nice rows and columns and easy to read. And then as a data scientist, the first thing we want to know is the info. What is in these columns and rows and headers? And you see right here they all come up with non-null object. There's a big flag. So if I want to do anything with this, these are all coming through as strings or an object. I usually mean strings in this case, that they're a string variable. And we have, you can quickly read through this, 191 entries, date columns, total 14 columns. There's a total of 14 columns in the data, and it shows you all the different names and what type of column they are. And it's probably good also to look at the shape of the data. df.shape, we'll go ahead and just run that. You can see it's 191 by 14, 14 columns, 191 entries. This is more like the way you look at a Numpy array, 191 by 14 for the shape. And remember, this is a variable, so if I put it on, if it's a last variable or last value in the set of cells, Jupyter automatically prints it out. So if you're in a different IDE, you'd want to go ahead and use the print statement on here. And then one of the things you'd want to also go through, we'll create a second one, df2 equals df.dropNA. Now the axes is automatically equal to 0. So a lot of times you'll see something like axes equals 0, comma, how equals any. Axes equals 0 is default. That means we're looking at going down the rows. You could look at the column going across. Let's remove the how any because that's just going to confuse you. The axis is whether you're going down the columns or if you're looking at it row by row by row by row. Or you could be looking at it by column by column by column. This would drop any column and it would drop off the NA in any column. And how equals, and we want any. I always confuse all and any because they both start with A. All means that all of them have to be non-value, where any means that any of them can be there to drop it. So this would drop any column with a null value in it. But we want 0, and it'll drop any value with a null value. And then because 0 is always the default, we'll just leave it out. And then it's curious as to what the shape is now. Did we lose anything? Was there any null values in our df2 that we dropped from the df? And we'll go ahead and run that. And we see 191 and 14. So we didn't really drop anything. But it's always good to check. There's other ways you can also do, are there, let's see, any NAs? You can detect NAs in here. Null values, infinite values, that's another one you got to watch out for. We're working with data that we're going to do something with here in a minute. So you got to be a little careful also in the conversions. Are you going to convert something where people typed in weird characters to describe the data a certain way? So now we've got to this point where we have all our different columns, we have our different data, and at this point maybe you're asking, or maybe the shareholder of the company is asking, hey, can we look at the, based on the chip time, here's our chip time, can we plot that versus gender? How does gender versus chip time compare? And so we can do that. We can take that. And the first thing we look at is we say, hey, well, chip time came in as a string, and that's going to be an issue. Now, there's a number of ways you can change this. One of them is we could go all the way back up here where we created the data and find a way to tag it and say, hey, whenever this cell text, maybe instead of appending this, I noticed that anytime there's 2 colons in it, that's probably a time signature. And let's convert all the time signatures to date time field or whatever. A lot of times you don't get that. You don't get that option. And that's always a question in bringing in data. Whether you convert the data coming in at the beginning, or do you wait till you have it, open it up, and then convert it when you go to use it. We're going to go ahead and convert it after we got it into our data frame. So we have our df2 here. We've dropped all of our NAs. We have a shape. In fact, let's do this since there's no difference between df and df2. Well, we'll just go ahead and use df2. So let's go ahead and take our df2, and we want to take that specific field and convert it into some kind of numerical value we can use. And let's add another column. A lot of times this is something you want to do is where you want to go ahead and keep all the original columns and just add a new column in there. And this new column is going to be based on the, if we remember correctly, we had chip time. That's what we're going to look at. Okay, we want chip time versus gender. If we go into our pandas, we find out we have pandas to delta, and this is actually time delta. And then we just want to take our df2, and we're going to use the chip time column. So this is going to say, hey, let's look at, let's convert everything in df2 chip time into a time delta format. That's the data type we're going to put it as. And we can go ahead and just run this. And if we go in here and we do info, df2, and we'll keep our, we're going to look at this particular column, but we want to keep it as a data frame. So this is a list of all the columns we want to look at. We'll just do .info on here and run that. And we do an info on that, you can see it's now a time delta 64 nanoseconds. Well, we really don't want nanoseconds. We actually probably want to do it in minutes. So let's take a look at that. And let's take this whole thing, df2. Let's just set the df2. We have our df2. This is a column we're working with here. And we can use the as type property in Pandas. And so we can set this equal to df2. We'll take our same column in here, and we'll set it as type time delta second. So it's still a delta time here. So if I run this, you'll see that it still comes up as, where is it? Oh, it turns it into a float. So we're now at a float 64. So it's a number of seconds in that delta time. And then finally, we want to go ahead and turn that from seconds to, say, minutes. And, you know, there's 60 seconds in minutes. And so now we divide by 60. We still have a float. We have our info that shows us it's a float. And then we can go ahead and just do a print df2. And let's just keep it small. We don't want to look at all our data. We just want to do the head of it. And we run this, and you can see right here where we go to, it'll be the last one. Here's our chip time in minutes. And a lot of times, just to make life easy, for viewing, since we're only looking at this particular element, we can do chip time in minutes. And now we just see that, oops, we take off. We'll go ahead and take off our info. Done with that. And we'll run this. And you can see we have our minutes. 16.8 minutes, 17.51 minutes, and so on. It's a float number. Now keep in mind, this is 0.8. That's not 16 minutes and 80 seconds. They can always throw you if you're going through so many numbers you forget. So important to remember that. And we're also going to look at, the other one we're looking at is what? Gender. You want to look at gender to chip time in minutes. And so we can see here under the head, we get male, 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 and a number of different setups. And let's switch this to tail real quick and just look at the end of it. And here we have female, female, male, female, female. So we have two different genders, and we have our chip time in minutes. And if you remember, we brought in our PLT. If you haven't used the plot library, the matplot library, you have a drawing place you're putting stuff on. So we have our PLT, we're going to do a bar graph, and we just want to simply use our DF2 gender and DF2 chip time in minutes. So that's going to plot the two bars. And to make it pretty, we'll go ahead and give it the X label gender, the Y label chip time minutes. And that simply is, remember, it always plots X and it plots Y. We have our gender, our chip time. Give it a nice title, comparison of average minutes run by male and female. And if we go ahead and run this with the correct titles in here and everything matches, you'll get a nice graph. We can see here the comparison of average minutes run by male and female. Here's our chip time in minutes. The men seem to be slackers in this particular case. And it's actually, there's a number of studies that show that women tend to have, as far as doing cross-country, there's a lot of women who have a longer endurance than men. So it's not too surprising. But we can see here the average chip time around 70, and for women over 100 minutes. And then another really cool thing we can do is we can describe the data. So df2.describe, this again is a Pandas function, just like info is. And we're going to include NP number, the Numpy number. And if we run that, you'll see here it comes up and it says chip time in minutes, count, it gives you the average or the mean, standard deviation, the minimum, the maximum, all the different descriptive information you're going to want from your data set on there. And just because there's all kinds of fun ways, let's do a box plot to display your information. We can do a box plot where the column equals chip time in minutes. And let's go ahead and run that. Keep mistyping my chip time in minutes. And you can see it puts out a nice box plot showing you the information. We have our different values and floaters. And this is always interesting because this is a nice way of seeing where we have these floaters, one up here and there's two up above, and of course your nice spread on the box plot. And we can also modify this a little bit, and we can add in by equals gender, and then we'll just give it a blank title. I don't know why we're giving it a blank title. We'll just add a Y plot, Y label on there for runtime. And if we run this, you can see here box plot grouped by gender, chip time in minutes, and now we have our female and male, two different areas, and you can see how they vary. You have your two different your outlier up here, and you can also see how there's such an overlap between the two different values. So if I was looking at this, I'd be like, wow, I really could not draw a conclusive thing on this saying that women's runtime was more in general because they overlap too much. That would be one of the conclusions I'd have to come up with on here. And then we get to maybe the partners come in from the company and say, hey, we'd like to know the age versus chip time in minutes. That'd be something worth knowing on the statistics on this. And the first thought is we can simply plot it. And we can do this. We can actually plot the scatter plot, chip time versus DF2 of age. There's our XY coordinates. But if you remember from DF2 when we did the info, let's go way back up here. We're looking at a data object as far as our chip time on this and our age. Now we converted the chip time, but we also need to convert the age. And if we do it right here, we just plot it, and it'll actually let us plot it. It shouldn't. It should give us an error, but it does let us plot it. You'll see the ages come up a mess over here because they're converting it to weird float numbers and all kinds of things. So what we want to do is we want to take our age, and we'll just call this age underscore I. So we're going to take our age and we're going to create another column for DF2, age underscore I. And the I is just going to stand for integer. It's our own choice of values. There is a number of ways to do this, but we're going to do Pandas to numeric is the best way in Pandas. And the reason we're doing this is that numeric creates a float value. So right off the bat, we want all our stuff converted. It converts it to the least common denominator. So if they're all integers already, you'll get integers. As you can see from here, it's doing some kind of conversion that converts it to a float value. The other thing that numeric does is if there's a null value or they put in like a blank blank line or a dash to represent no information, it'll convert it to a null. So it goes from like a string to a null versus just having some kind of made up number that Python somehow created for the graph we have below. And then we want to add our df2 age, because that's what we're converting to numeric, and then we want to coerce it. And there's a couple different options on this, like you can have it where it just doesn't process it in Pandas, but coerce means that if it gets a weird value, that is a null value now. And since we're dealing with errors, this is what happens when you get an error converting it. We want to coerce it. There we go, and put the end bracket on there. And then finally we want to go ahead and round this off. So we'll put brackets around all the way around it, and this rounds off everything in this series. So what we've done here is I've taken df2 age, which is a d-type object, which in this case is mostly strings with a couple of blank ones in there, and we're going to convert it to a numeric, which will automatically go to float. And then we're going to take wherever there's an error, wherever it says, hey, this doesn't convert, and usually that's a blank string. Like I said, I've worked with so many databases where someone puts down none, someone types in space, some types in a dash to mean none, and you get this really weird conversion coming up. This covers all of that in Pandas, so it's really a nice way of just coercing it and saying, hey, if we don't have a number in there, let's make it a null value, and then we're going to round it off. And then finally, let's go ahead and take our df2. Here's our df2, and let's drop those null values. Drop NA, and we want how equals any. So that means if there's any null values in the data set, now this might get you in trouble because you might have null values in a different column, and so you might lose data that way. At this point, we could also do like certain parts of like drop just certain columns with null values. There's all kinds of other options in here, but we're just going to do how. We're going to just drop any, and we want to do it in line equals true. So that means it's going to reassign it to df2. So df2 now has rounded out, so it's rounded to the integer. We didn't do any places. The age, and it's going to be age I, and then we've dropped all our null values. That way we're not going to get any errors when we try to plot a null value. And it also makes sure that data, by deleting out the rows, because that's what this does, it automatically does axis 0, which is your rows, axis 1 is your columns. By doing this, it automatically removes all the rows with null values. So it just cleans out the rows. And then when we go ahead and plot this, we see we have a nice clean data, and we have age all the way up to 70. So we have our chip time set, and then our age going across, and it makes a nice plot that you can easily show for display, and for and you can easily show that to your shareholders or whatever group you're working on. It makes a really nice and quick, easy display.
Now guys, before moving ahead, let us try to understand about REST API. So REST stands for Representation State Transfer Protocol. It is a kind of a web service that basically allows clients like web apps and mobile apps to interact with the server using HTTP methods. Now, you would be dealing with methods like get, post, put, delete. Now, if I talk about get method, guys, so get is all about retrieving a data, okay? And if you want to use post HTTP method, it means like we'll be creating any new data. Similarly, if you talk about put, then this given method updates the existing data. Suppose, for example, you have this data along with you, which you just recently entered using the form, and in which you entered your name, ID, and your given designation. Now, suppose I want to send a HTTP request where I want to change this data, the current designation, to something else. So, for the same purpose, you'll be using put as a given request. So, in this way, you could also do it, and definitely you will have one more option to delete it. So, delete is also one of the HTTP verbs, okay, basically HTTP method, which is going to delete the data from the given database. So guys, basically REST APIs are commonly used in web development, backend systems, and microservices. Now, we will outline our project. We'll be using a layered structure to create our given projects for this API tutorial. And we'll be using Python's backend framework, Flask, to do the same. So as you can see all over here, I have created this folder Python REST, under which you could see that I have these subfolders: controllers, models, repository, services, init.py, and app.py. Now, let's try to understand the role of each of the given folders. So, as you can see all over here, that in this given folder, we have app.py, which is basically the main entry point. So, this will be the entry point of our application. So, this given file is going to initialize our Flask app. It is going to register the controllers, okay, whenever our server starts. Then we have the controller file, okay. So basically in this file, we are going to define our API endpoints with the help of those methods that we discussed, like get, post, put, and delete. And this given layer will be responsible for handling all the user requests, and it is going to send the appropriate response based on that. Then this given controller layer is going to call our business logic layer, okay, which is basically the service layer to process that given data. Think of this as a front desk of your API. It receives requests and directs them to the right department. If I talk about service file, then in this we are going to implement the core logic of our application, which is going to call the repository layer, okay, to interact with the databases. And it is also going to validate and process data before sending it to the controller. This is where the actual decision making happens. It ensures that data flows correctly between controller and repository. Now, I hope you have got a brief idea about these files. So we have one left file, init.py. Now, this is a given file which is going to make each directory like controller, services, repositories, model act as like a Python package. So it is basically required for importing modules properly. Now, you could see this is a given folder structure, and I would recommend you to use this folder structure for basically, creating organized code, easier maintenance, scalability. And each component has a specific role. You can maintain it will be very kind of easier maintenance. You can modify one part without breaking, everything. And the scalability is also there. Easily you could add new features without cluttering the code. Now let us try to understand what is there in our models folder. So here we have file name item.py. This file is going to define how our items are structured in our application. So you can see all over here we have created a class item. This defines a class item that represents an item. And then you could see we have written def init self, item ID, name, description, and we have binded all these variables all over here. Just like that we do create a constructor in Java, and similarly we use this dot given field name to bind it, so that the particular thing could be what kind of behavior could be occupied in that object. So similarly, we could see that init is a constructor in Python, which basically initializes the item within it. So here we have item ID, which is a unique identifier. Then you have a name. For example, you could put name as laptop. Then you have description, where there is the description of the item. And finally, you have def to dict self. And then you are returning the ID, name, self.name, description, and self-description. So basically, this converts the object into dictionary or a JSON format. So it can be returned as an API response. So you would have got a brief idea of what we are exactly doing in our model class. Okay, so we are defining all the parameters that our given API will be returning, or what given data that will be adding to the post request. Now, after you have created your model, it's always a good activity to go to your services class. Okay. Now, before moving to the services, let us go all over here and try to understand. So you could see that we are using an instance of repository all over here. Now, what happens, guys? So basically, after creating your model, it's always a good practice that you should go to your repository, write a code in the repository. So let us try to understand our repository first, okay? And then after that, you create your business logic. So basically, all over here, you could see we are importing our models.item, importing the item all over here. Then we are creating a class called item repository. Okay, then you could see we are doing self.items, which is basically storing items in a memory like a dictionary. So dictionary is acting as a database. Then we have put self.counter equals to 1, which is basically going to generate unique items IDs. Okay, and then you could see we have created def create self name description, and then we are using item string self.counter name description. So basically, this given piece of code creates a new item object with auto incremented ID, and it adds to the dictionary with self.items. Okay. Now, there's another method called def get all self, which basically returns all the items as a list of dictionaries. Okay. So that's one thing you should remember. Then what we have all over here in this piece of code, def get by ID, self item ID, item equals to self.items.get, the given ID, and then you are returning in the form of dictionary. If item is there, then return, otherwise do nothing. So basically it retrieves an item by its ID and it returns none if the item doesn't exist. So you have got a brief idea regarding the get by ID. Okay. Now similarly, for updating the given data, there is a def update function. Okay. So you could see it's written that def update self item ID name description. If item ID is present in the items, then what you have to do, you have to assign the given item with the proper ID. Okay. You have to access this item, then you have to access it name and description and return in a form of dictionary. If present, then do it, otherwise return none. Similarly, there's a delete function that we have created and it returns self item.pop item ID none if it's not none. So basically it is popping up, or it is deleting the item ID present. Okay, if that item ID matches the given item ID present in the item, then it will be popped out. Now, we have successfully created our item repository, and this given layer will be responsible for interacting with the database and do a bit of manipulation. Now, let's move to our service layer, which will basically be using the instance of repository for all the business logic that needs to be implemented in our REST API will be done by services. So you could see we have this file name itemservices.py. Just right click on this. So guys, as you can see all over here, that when the request is coming from controller, it is directed to the services layer. Okay. Then the services layer is using the item repository instance to interact with the database and do all the manipulation. So all your business logic, imagine like services file is acting as a middle layer between the controller and the repository. It is somewhere here in the hierarchy of communication. Now, if you could see our code, we are importing the repository from item repository. Then what we are doing is we are creating an instance of item repository so we can call all the database functions. Now, you could see in this line that we are doing the same thing. Now, in the next, we are creating a method def get all items, and we are using the instance of the repository and calling the method get all, okay, which we have created in the repository. Similarly, by get by ID method, the same thing that we have done. For updating the item ID, we have done the same thing, and for deleting the item ID, we have also done the same thing. Now, the logic for these methods are built in the repository section. So whenever the controller, for example, let's go to our request ID. Suppose if the request goes to get the given item by ID, okay, as you can see in the controller layer, so /item ID, okay. So now it is going to go all over here, and the service method that's all over here. So it is present that get item by given ID. So it will be calling the service instance. Now, if you go in the service class, guys, so in the service class, you have this method def get item by ID. Now, this method is going to call this given method, which is present in our repository section. So def get by ID, and here is your logic written, which is basically interacting with the DB. If you connect it to MySQL or MongoDB or anyone else, so all manipulation you could do is. So there are a lot of things you could do with the REST API. Now let us try to understand our controller layer once. Okay, so you could see all over here that in this given file we will be creating all the important HTTP request methods that are get, post, put, and delete. So basically this given layer will be handling all the given request which is coming to the endpoint. So our base endpoint is /item. Okay, so this is a given URL that is mentioned. So when your application is running on a given port, so you can use HTTP localhost /items/item/item ID. If you want to get that particular ID, you could post it or update it using the put request, and also you could delete the given item. Now let us try to understand the code present all over there in this file. So you could see initially what we are doing is we are importing our Flask module. Okay, so as you can see, so in Flask we are importing blueprint, request, and JSON file. Now blueprint allows for modular routing. You could use it for that purposes. Request basically reads the incoming data from the request. Now you have JSON file, which basically converts Python objects into JSON responses. So you can see all over here we are importing item service to access the business logic. Now you can see item controller, blueprint, item controller, name, service equals to item service. Now what it is doing, guys, it basically creates a Flask blueprint, which is basically item controller, to handle all the requests which is coming to /item route. Okay, this creates an instance of item service to interact with the stored data. Now you could see all over here we have the post request first, like creating the item. Okay, So you could see we have used this annotation item controller dot route. So route here we have to give the given route which is going, and you could mention the method, what kind of HTTP method you are using. So suppose here we are using the post method. Now basically you are creating the item, so you are requesting a data from the request.json. So we are using this given package from the Flask library. Then what you are doing is that this data, it is going to read the JSON file. Okay, then you could see it calls service.create item to create an item. Okay, and then it returns a new item with the status code 201. Okay, now similarly if you go and see all over here in get/items, okay, so in the get all items request, what we are basically doing is we are trying to use the method get request. Okay, so which is going to return the resource. Suppose you added any data, like suppose let's say for example you added a product with name, ID. Okay, so when you are going to go at this URL get/items, so that given data will be returned. So basically it is going to call service.getAllItems to fetch all the items that you have added in your database. It is going to return the list of all the given items. Now every item added will have the particular item ID. Now if you want to access the individual items, then this given method will be called. So basically you are using the instance of service to call this method getItemById. Then you are returning the JSON file item, okay, in that format, the JSON format. Now you can see all over here, we have the update method all over here. So you can see we have the method mentioned name as put, and the given way to actually update the data is, you have to access the given data by that ID. So in this case, we are basically accessing the user's data by the given user ID. So that's why we have used item/item ID. Similarly for the controller, we have the same thing mentioned for deleted the given item with its item ID. Now similarly you could see we have put the method as delete, okay, and then it deletes the item if it exists. So you could see it is stored in the variable success, and this is calling the method from the service class, okay, which is present delete item by given ID. And finally it is going to return a JSON data with message name as item deleted. If the given item is present, means if the operation is success, you return it, otherwise else return a error response. So basically with the message as item not found, basically 404 status code. So this is how our controller is designed in this project. You would have got a brief idea what packages we are using from the Flask library, okay, and how our given layers are actually working and interacting with each other. So there is a lot of dependency management going on in this REST API. Okay, so that's it, guys. So we have created all those things. So guys, you can leave init.py is empty right now because we are not doing the package level imports in this. So this code looks pretty much fine. This project structure looks good. Now if you go to the app.py, our server will run on this given port, and this is our local host. Okay, so go to your terminal after this, guys. So click on terminal. So you could see we are in our required directory. Now type the name of your given file, okay, and try to run it up. So type Python, okay, and then type app.py, and let's see what is happening. So you could see our server is running on this port. Now I'll be using terminal, guys, to check how our whether our get request or post request is working or not. So what you could do, guys, you can open PowerShell. Okay, now guys, as you can see all over here, we have put a post request in our terminal, and we are using PowerShell for the same. So you could see I have put the header as content type, and the file is application.json, and this is a body which I am sending right now, name, laptop, description, MacBook Pro. Okay, now you could also see I also telling it to convert it into JSON with depth of 10, and then I'm invoking this URI to the REST API. So guys, now let us do the post request. Now guys, as you can see all over here, let's say we are giving the body something like this, hash headers @ the content type is application.json, and here you could see the body is mentioned with the name, description. Okay, So this is a Dell Pro laptop, and finally I'm invoking it to the given URI, which is the method is post, and I'm attaching the headers and the body section that I've sent all over here to this given URL. Now just click onto it, and you could see our item with the ID 3 Dell Pro 16 laptop is created. So it means that our server is running great and everything is all good. Now guys, let us try to use a GET request and see whether our given items are added or not. So as you can see all over here, we have updated it to MacBook Pro 14 with M3 chip. And this is how you could do it. Now let me also show you how could you do the delete request. Suppose we want to delete this given ID. Now the same command that you have to invoke REST method with the given URI, you have to add the URI with the given item ID set with the ID 1, and I'm using the method delete. Now click on it and you could see message item deleted. Now let us try to use a get method, okay? And we could see we don't have any items with the ID 1. So guys, this was a short tutorial on REST API using Flask and Python, where we were using the layered architecture of controller, model, repository, and a service.
Today, we are going to perform 2 hands-on projects on COVID data analysis using Python and Tableau. This is going to be a really interesting and fun session where I'll be asking you a few generic quiz questions related to coronavirus. Please make sure to answer them in the comment section of the video. We'll be happy to hear from you. COVID or coronavirus is an ongoing global pandemic of coronavirus disease that emerged in 2019 and was first identified in Wuhan, China. It is defined as an illness caused by a novel coronavirus called Severe Acute Respiratory Syndrome Coronavirus 2, commonly known as SARS-CoV-2. On March 11, 2020, the WHO declared COVID-19 a global health emergency. The virus has so far infected over 22 crore people and killed more than 4.5 million innocents. In India, there have been over 3.3 crore confirmed cases and nearly 4,41,000 deaths have been reported so far. This data is according to official figures released by the Union Ministry of Health and Family Welfare. As the world tries to cope up with this deadly virus, we request all our viewers and their family members to follow all the necessary precautions to avoid getting infected. Quiz time. Now let's see our first quiz in this project. What does corona in coronavirus mean? Here are the options. Is it A. beer, B. respiratory, is it C. crown, or is it D. sun? This is a very generic question. I'm sure a lot of you may already know, some of you may not. Please let us know your answers in the comment section of the video. We'll be glad to hear from you. Now in this video, we will use 3 different COVID-19 datasets and perform data analysis using Python and Tableau. The project will give you hands-on experience working on real-world datasets and how you can use the different Python libraries to analyze and visualize data and draw conclusions. You will learn how to create different plots in Tableau and then make a dashboard from the visuals. The project will give you an idea about the impact of coronavirus globally in terms of confirmed cases, deaths reported, the number of recoveries, as well as active cases. We will also see how India has been affected since the pandemic started and dive into the different states and union territories to learn more about the COVID-19 influence and the vaccination status. First, let me show you the 2 datasets that we'll be using. So for our first project using Python, we'll be using the first 2 datasets, COVID-19 India and COVID vaccine statewise. Let me open the 2 datasets. Okay, so this is the first dataset. You can see here we have the date, we have the time, then we have the different state names. If I scroll down, you can see we have Kerala, Tamil Nadu, Delhi, Haryana, Rajasthan, this Ladakh, Punjab, Telangana and other states. Then we have something called as confirmed Indian national. So actually this 2 datasets, confirmed Indian national and confirmed foreign national, we won't be using. So in the demo itself, we'll be dropping these 2 columns. What we are concerned about are the last 3 columns, the cured cases or the recoveries, the number of deaths reported, and then we have the total number of confirmed cases. Let me just sort the B column, that is the date column, so that you have an idea about the recent data we have. I'll continue with the current selection and sort it. You can see here This is till 11th of August 2021. So this data was collected from Kaggle. It has some discrepancies that we will see in the demo. The data is available for free. We will provide the link to the datasets in the description of the video, so please go ahead and download them. The visualizations and results that you will see in the demo are based on the datasets that we'll be using. We haven't pre-processed the data to remove outliers or any missing values. Now before I jump into the demo, let me show you the second dataset that we are going to use. Okay, so COVID vaccine state-wise is my second dataset. Let me open it. There you go. So this is the second dataset that we'll be using in the Python project. You can see we have a column called updated on, then we have the state. Again, you can see here there are a few discrepancies here. It has taken the country name and not the state name. Below you can see there are the different state names, and you can also see we have information about the total doses administered. We have the sessions, sites, first dose administered, then we have the second dose, then we have information about male and female doses. You can see here the different vaccines administered, Covaxin and Covishield. You have Sputnik V, and here are the different age groups as well. And finally, if you see, we have male individuals vaccinated, the total number of female individuals vaccinated for a particular day. We have information about transgender individuals vaccinated, and finally we have the total individuals vaccinated each day. Alright, before we jump into the hands-on part, let's have a look at the second quiz in this project. So here is the second quiz question. Which is the first country to start COVID vaccination for toddlers? Is it A, Japan, B, Israel, C, Portugal, or is it D, Cuba? This is a very recent development that took place. If you watch daily news updates on coronavirus, you will be definitely able to answer the question. Please give it a try and put your answers in the comment section of the video. It is really important for our viewers to know the right answer. Alright, so now let's begin with our demo. So I am on my Jupyter notebook. So the first project we are going to use Python Jupyter notebook. I'll just rename this notebook as COVID Data Analysis Project. I click on rename. Alright, so first and foremost we need to import all the necessary libraries that we are going to use. So first I'm importing Pandas as PD. This is for data manipulation. Then we have Numpy as NP. Numpy is used for numerical computation. Then we are importing Matplotlib, Seaborn, and Plotly. These three libraries will be used for plotting our data and creating interesting visualizations. Finally, I'm also importing my datetime function. Alright, so I'll hit Shift Enter to run the first cell. Now it's time to load our first dataset, which is related to the COVID-19 cases in India for the different states and union territories. So I'll create a variable called COVID_df. df is for data frame. I'll use my pandas library and then give the read_csv function, since our datasets are CSV files, and inside double quotes I'll pass in the location where my datasets are present. So I'll just copy this location, I'll paste it here. We'll change the backslash to /, and after that I'm going to give my file name followed by the extension of the file. I'll say COVID-19 India.csv. Let's go ahead and run it. Alright, now to see the first few rows of the data frame, I'm going to use the head function. I'll say head, and within brackets, let's say I'll pass in 10, which means I want to see the first 10 rows of data. If I run it, there you go. Here you can see from 0 till 9. So we have 10 rows of information, and these are the different column names. You have S number, date, time, state or union territory. Then you have confirmed Indian national, confirmed foreign national, cured cases, deaths reported, and the confirmed cases. Alright. Now moving ahead, let's use the info function to get some idea about a data set. If I run it, you can see here it gives us the total number of columns. We have 9 columns. The total number of entries or the rows, we have 18,110 rows of information starting from 0 till 18,109. You see here the different types of variables or column names that we have. Then it has information about the memory usage as well. And this side you can see the data types. Cool. Now we'll use another very important function, which is to get some idea about statistical analysis, the basic statistics about your data set. For that I'll be using the describe function. Okay, so if you can see here, the describe function is for numerical columns only, and you have the measures such as count, the mean, standard deviation, maximum, minimum, the 25th percentile, 50th percentile, and the 75th percentile value. Okay, now let's move ahead and import the second data set, which is related to vaccination. So I'll create a variable called vaccine_df. I'll write pd dot read_csv function, which is present in Pandas library. I'll move to the top and I'll copy the file location and we'll change the name of the file. Copy this and let me paste it here. And instead of COVID_19_India, I'm going to say COVID_vaccine_statewise. Okay, so this is the dataset that we saw, COVID_vaccine_statewise. Alright, let me run it. Cool. And let's display the first 7 rows of information from this data frame. I'll be using the head function, and inside the function I'll pass in 7. There you go. So here you can see we have from 0 till 6. There are total 24 columns. A lot of them have null values, you can see here. Alright. Now, from the first data set, which is the COVID_df data frame, we'll be dropping a few unnecessary columns such as the time column, confirmed Indian national and confirmed foreign national, as well as the S number. We don't need these columns, so it's better to learn how to drop the columns for our analysis. So I'll say COVID_df dot, I'll use the drop function, and within square brackets I'll pass in the column names. The first is S number. I'll give a comma. Within double quotes I'll say the next column is time. My third column that I want to drop is confirmed Indian national. Give another comma. Within double quotes I'll say confirmed foreign national. Outside the square brackets I'll give another comma and pass in my next argument, that is in place equal to, I'll say true. I'll give another comma and say axis equal to 1. Let's run it. Okay, it has thrown an error. Let's debug the error. Says confirmed Indian. Okay, it should be Indian national and not Indian nation. I'll just mention it as national. We'll run it again. Okay, now we have removed these 4 columns. Let me show you the dataset now. There you go. So we have only the date column, state or union territory, cured, deaths and confirmed. Now let's see how you can change the format of the date column. For that you have the function called toDateTime. I'll say COVID underscore df. I'll pass in my column name, that is date. I'll say equal to pd dot. I'll use the pandas function, that is to underscore date time. I'll say COVID underscore df, which is my data frame name. Pass in my variable, which is date. Give a comma, and I'll use my argument, that is format, equal to. I'll say percentage %y, give a dash, say percentage %m, give another dash and say percentage %d. Let's run it, and I'll print the head of the data frame. Cool. Now moving ahead, now we will see how to find the total number of active cases. So active cases nothing but the total number of confirmed cases minus the sum of cured cases plus deaths reported. So let's find the active cases. I'll give a comment. Okay, I'll first write my data frame name, that is COVID underscore df. Within square brackets I'll give my new column, which is active underscore cases. I'll say equal to COVID underscore df, and my first column would be the confirmed cases column minus, I'll say COVID underscore df, then I'll pass in my cured column plus, I'll again say COVID underscore df and add my deaths column. This time let's print the last 5 rows from the new data frame that we have created. Okay, let's run it. Okay, it has thrown an error. Let's debug it. Says data frame object has no attribute tails. This should be tail. There you go. You can see here we have added a new column called active cases, which is the confirmed cases minus the sum of cured and deaths reported column. Now we will learn how to create a pivot table using the pandas library. So in this table we'll be summing all the confirmed deaths and cured cases for each of the states and union territories. So we'll be using the pivot underscore table function for this. I'll create a variable called statewise and say pd dot. I'll use the pivot underscore table function. I'll pass in my data frame, that is COVID underscore df, and then I'll give my values parameter. Inside the square brackets I'll pass in my columns confirmed deaths, and then we'll have the cured column. I'll give a comma, and next argument would be index, which is going to be my state slash the union territory column. Let me bring this to the next line so it is more readable. I'll say union territory I will give a comma now and pass in my last argument, which is agg function, that means aggregate function, and this function would be max. Alright, let's run it. Okay, now I'm going to find out the recovery rate. So recovery rate is basically the total number of cured cases divided by the total number of confirmed cases into 100. So I'll say state-wise, and within square brackets I'll pass in my variable that I want to create, which is recovery rate. This will be equal to the cured cases multiplied by 100 by the total number of confirmed cases. Within square brackets I'll give my column as confirmed. Let's run this. Okay, I'll just copy this column, paste it here. So this time we are going to find out the mortality rate. So mortality rate is nothing but the total number of deaths divided by the total number of confirmed cases into 100. So I'm just going to replace the names. Here I'll say mortality. Alright, and then instead of cured I'll say my deaths column into 100 divided by the confirmed cases. Let's run it. Okay, now we are going to sort the values based on the confirmed cases column, and we'll sort it in descending order. So let me show you how to do it. I'll say state-wise equal to, I'll use the function sort underscore values. So I'll pass in my variable state-wise dot and use the sort underscore values function. I'll say by, I want to sort it by my confirmed cases column. Give a comma and I'll say ascending equal to false. Let's run it. Now we are going to plot our pivot table using a nice visual. So for that I'm going to use my background underscore gradient function, and inside that function we'll pass in our CMap parameter. I'll show you how to do it. I'll say style dot background underscore gradient, and inside this we'll pass in a parameter called CMap. So CMap stands for color maps. This is present inside the matplotlib library. So here you can see there's a nice documentation on choosing color maps in matplotlib. This is provided by matplotlib.org. If I scroll down, you can see there are a number of CMaps that you can use. Purples, blues, you have something called reds. There are other things like magma, you have summer, autumn, spring, winter, cool, all these. You can use whichever color map that you want, and here you can see the different shades or the gradients. Okay, so I am going to use my color map as cube helix. Let me run it and show you the pivot table. There you go. Here you can see we have our pivot table ready. Now, as I said in the beginning, there are a few discrepancies in the data set. So here you can see there's one called Maharashtra, and there's also Maharashtra triple star. This you can ignore. Even if I scroll down, you have Madhya Pradesh followed by 3 asterisks. You can ignore this value as well. Even for Bihar we have. So these have been duplicated. and here you can see the different state names and union territories. Then on the top you have the confirmed cases, cured cases, the deaths reported, and the new columns that we created. These are calculated columns, recovery rate and mortality rate, and we have ordered it in descending order of confirmed cases. So far our data says that Maharashtra has the highest number of cases, followed by Kerala, Karnataka, Tamil Nadu, Andhra Pradesh and Uttar Pradesh. So these are the top 5 states which have the highest number of confirmed cases. Even if you see, the mortality rate is also high for Maharashtra, and if I scroll down, the mortality rate is also high for Uttarakhand. If you see here, if I scroll further, you have Punjab, the mortality rate is also high. Alright, so this was our first visual that we created in the COVID data analysis project. Now moving ahead, we'll see the top 10 states based on the number of active cases. So we'll start. I'll give a comment, top 10 active cases states. Okay, so we are going to explore another very important Pandas function in this, which is known as group by. So I'll first pass in my data frame, which is COVID_df dot followed by the group by function. I'm going to group my data based on state/union territory column. Then I'll say dot max, which is to find the maximum value from the states that have the highest active cases. So I have passed in my active cases column, and we're also going to group it based on the date column. After that, we are going to sort the values. So I'll use my function that is sort underscore values. I'll say sort by my column that is active cases. Let me bring this to the next line. Underscore cases. I'll give a comma and say ascending equal to false, say dot, and then reset my index. For that I'll use reset underscore index function. Okay, let's check if everything is fine. I have missed a square bracket here. Let me give another square bracket here. Okay, and all this we are going to store in our variable called top underscore 10 underscore active underscore cases. Okay, now let me go ahead and run this cell. Okay, there is a syntax error here. Now let's run it. Okay, now I'll create another variable called fig. Here we'll pass in the plt, which is for matplotlib library, and we'll give the figure size using the fig size argument. It's equal to, and within a tuple and passing the size, let's say 16,9. We'll run it. Okay, and let's give a title to our plot. So here we are going to create a bar plot. So using plt.title, we'll pass in the title, let's say top 10 states with most active cases in India. I'll give a comma and pass in the size of my title, let's say 25. Okay, you can see we are slowly being able to create our graph. The most important thing is to pass in the x-axis and the y-axis. I'll say ax, which is for axis. To pass in the axis, I'm going to use the bar plot function that is present inside the Seaborn library. I'll say sns.barplot. I'll say data equal to my variable, which is top underscore 10 underscore states. This is actually active states. Alright, and now I'm going to use the iloc function and take the first 10 states. So I'm using a colon and then giving 10 as my value. ILOC is for index location. I'll give a comma and say my y-axis to be active cases. Give another comma and say my x-axis to be state slash union territory. Give another comma. We are going to pass in the line width to 2. I'll say line width equal to 2 and we'll give an edge color. Let's say the edge color is red. Okay, so I have my axis defined now. Let's run it. There's an error here. It says top 10 active states not found. Let's go to the stop and see the exact. Okay, so this is top 10 active cases. Let me change it to cases here. Now run it. Okay, the x-axis also has a mistake. This should be state slash union territory. Now let me run it. There you go. We have our plot created, but as you can see here, the labels of the different states and union territories are overlapping. So for that, let me first pass in the x labels. I'll say plt.x label and my x label would be states. Then I'll say plt.y label. My y label will have the total active cases. And finally, I'll write plt.show. Before I run it, let's collate all the lines of code that we have written for our top 10 states for most active cases in India into one cell. So what I'll do is I'll just copy this and we'll keep adding in this cell itself. Okay, I'll go to the top. Next, we'll copy my figure size and we'll paste it here. Next, let's take the title and put it here. Give a space and we are going to copy this cell and I'll paste it here. Alright, now it's time to run it. There you go. You see it here. We have a nice bar plot ready. On the top you can see the title, top 10 states with most active cases, and you see the edges are in red color for all the bars. On the x-axis you have the different state names: Maharashtra, Karnataka, Kerala. You also have Andhra Pradesh, Gujarat, West Bengal and Chhattisgarh. So as you can see, Maharashtra has the highest number of active cases based on our data, followed by Karnataka, Kerala and Tamil Nadu at 2nd, 3rd and 4th place respectively, and in the 9th place we have West Bengal, in the 10th place we have Chhattisgarh. On the y-axis you can see the total active cases, which are in lakhs. Okay, now moving ahead, now we'll see the top 10 states based on the total number of deaths reported. So I'll give a comment: top states with highest deaths. Okay, so I'll first create my variable saying top 10 underscore deaths. This will be very similar to what we did here, just that we need to change a few column names. So instead of active cases we'll be using deaths. Okay, so I'll start with my data frame, that is COVID underscore df, followed by using the group by function, and I want to group my data based on the state slash union territory column. Then I'll choose the max function, and within double square brackets I'll pass in my column names deaths and date. Let's make it consistent. I'll be using single quotes. Okay, I'll say dot, I'm going to sort my result, therefore I'm using the sort underscore values function. I want to sort it by deaths column. I'll give another comma and say ascending equal to false, which means I want to order my result in descending order. Then I'll say dot reset underscore index. Okay, after that I'll give my figure size. I'll say plt dot figure, and within brackets I'll pass in my argument, which is fig size equal to, using a tuple I'll say 18 comma let's say 5. Now let's give a title. For that I'll use the title function which is present in the matplotlib library. I'll say top 10 states with most deaths, and let's give a size to the title 25. Now it's time for us to give the access labels. I'll just scroll down. Okay, so I'll say ax equal to, again this will be a bar plot, so I'm using my Seaborn library followed by the bar plot function. My data will be top underscore 10 underscore deaths, which is this variable. I'll give my index location ILOC. I'm going to choose 12 states. The reason being, there are some discrepancies in the data. I'll show you once I plot this result. So in the y-axis we'll have deaths column. In the x-axis we'll take state slash union territory. Okay, I'll give another comma and say line width equal to 2, and we'll give an edge color to our bars like we did here. So I'll say edge color equal to, let's say, black. Okay, now finally we'll give the x label, the y label. So I'll say plt dot x label. X label would be states. My y label will be total death cases, then I'll write plt.show. Now let's run it. There you go. You can see here we have a nice bar plot. On the top we have the title, top 10 states with most deaths. Now what I specifically wanted you to see was these discrepancies in the data. You can see here Maharashtra is repeated twice, even in our data that we collected from Kaggle. Karnataka spelling has an error. You can see here we have a few rows of information where Karnataka is spelled as K-A-R-A-N instead of K-A-R-N-A. Alright, so to remove these two results or to ignore these two results, I had given my index location till 12. So we have Maharashtra, Karnataka, Tamil Nadu, Delhi, then Uttar Pradesh, West Bengal, Kerala, Punjab, Andhra Pradesh and Chhattisgarh with the states that have the most number of deaths reported. Okay, now we'll create a line plot to see the growth or the trend of active cases for top 5 states with most number of confirmed cases. So the states are Maharashtra, Karnataka, Kerala, Tamil Nadu and Uttar Pradesh. I can show you. So these are the states with highest number of active cases. Okay, I'll just give a comment saying growth trend. Alright, so for that we'll start with our figure size as plt.figure. I'll use my parameter fig size equal to 12,6. I'll say my axis as SNS dot. This time we are going to create a line plot. My data would be my original data frame, that is COVID_DF, and within square brackets I'll say COVID_DF, and we are going to pass in the state or the union territory column. I'll give a dot and use the isIn function, so the states should include Maharashtra, I'll give a comma, the next state should be Karnataka, next we have Kerala, give another comma, my fourth state is Tamil Nadu, give a comma, and my fifth state would be Uttar Pradesh. Alright, so I'll give a comma here and then say x equal to the date column, y will be active cases column, and I'm going to use another parameter called hue, which is to give different colors to the different states, the 5 states that we are looking for. So hue will be my state/union territory column. Okay, after this I'll say ax dot set title. My title will be top 5 affected states in India. We'll give a size, let's say 16. Alright, okay, this should be size equal to 16, and to make sure everything is fine, let me just move it to the above line. Okay, now we'll run it. Okay, there is some error again. It says invalid syntax. Let's see where we went wrong. Let me bring this to the above line. Okay, this should be COVID_df. Okay, make sure you keep these small errors in check. Let's try and run it again. Alright, if I scroll down, there you go. Here you can see we have the top 5 affected states in India. You see the different states here and the colors. So this violet or the purple color is for Maharashtra. You can see how the active cases surged around April and May, and then you can see even for Karnataka the active cases surged very rapidly around May and June. Then it has decreased, luckily. Similarly, you can see the plots for even Uttar Pradesh as well as for Tamil Nadu. So all the 5 states, you can see one common trend that after March, so around April, the cases started to emerge very rapidly, and later after July they started dipping. Okay, now we are going to use our second data set, which is related to vaccination. Alright, so first and foremost, let me go ahead and print the data frame for you so that you know the data that we are going to use. So this is the data we are going to use for our next set of analysis. Even this data has a few errors, and you can see there are a lot of missing values. It makes sense because not all the days you would have vaccination for people, and very crucial error that we are going to deal with is this state column. Here you can see in the state column we have India in a few rows, so we are going to ignore these rows. Alright, first let's rename our updated on column to just vaccine date. So you can use the rename function present in the Pandas library to do it. So I'll say vaccine_df dot rename. I'll say columns equal to, within curly braces I'll write updated on, which is my original column name, give a colon. I want to change this to vaccine_date. I'll give a comma and say in place equal to true. So it will change my column name from updated on to vaccine_date in the original data frame. Let's run it. Now let me go ahead and print the first 10 rows in the dataset. You can see here we have successfully changed the column name to vaccine_date. The rest of the columns remain the same. Alright, now you can check the total number of columns, rows, the data types, and the memory usage using the info function. Here you can see it. We have total 24 columns, 7,845 entries, and these are the columns that are present. And if I scroll further, you see here says the memory usage, and here on the right you can see the data type. Cool. Now as you saw, the data has a lot of missing values. Let's find the sum of all the missing values for each column. So I'll say vaccine_df dot is null, and then I'm going to use the sum function over it. If I run it, there you go. So almost all the columns have missing values, but columns such as male individuals vaccinated, female individuals vaccinated, even for columns like the age groups, there are a lot of missing values. Now in the next step we are going to drop a few missing value columns. So I'll say a new variable called vaccination. I'll give the data frame name vaccine_df and use the drop function, and inside the drop function we are going to write columns equal to, I'll pass in the column names that I want to drop. I'll say doses administered. So this is the column that I want to delete, Sputnik V doses administered. I'll give a comma. The second column is AEFI. The next column is 18 to 44 years. Within bracket it has doses administered. Give a comma. I'll say 45 to 60 years, doses administered. Give another comma. The final column that we are going to drop is 60 plus, which is this one, 60 plus years. Doses administered. Okay. So these are the columns that we want to drop, and finally I'll give my parameter access equal to 1. Okay, let me just recheck these column names. First one is Sputnik V doses administered, then we have AEFI followed by 18 to 44 years doses administered, then we have 45 to 60 years doses administered. Finally we have 60 plus years. I have added a S here which was missing, and there should be a space as well because there's a space here in the column. Now let's run it. Alright, so we have successfully dropped the columns that we wanted to drop. Now I'll say vaccination.head. You can see here we have dropped those columns and we are left with these columns now. Okay, now we are going to create a plot, that is a pie plot, to see the vaccination for male and female individuals. So I'll give a comment as male versus female vaccination. To create this pie plot, I'm going to use the plotly library that we had imported, which is this one, plotly. Okay, so first of all we need to filter out the male individuals from our data frame. I'll say male equal to vaccination male. I'll passing in the column individuals vaccinated. We need to recheck the variable name whether it is correct or not. You see here male individuals vaccinated. Then I'll say dot sum. Similarly we'll filter out the female individuals. I'll say female equal to vaccination, which is my new data frame, Within square brackets, I'll pass in the column name female individual, vaccinated, I'll say dot sum. Okay, these should be individuals as per the column name present in the data frame. Cool. Now I'm going to say px dot py function, which is present in the plotly library. I am going to give the names of the pies. So first one is male and the second one is female. Give a comma and say values equal to male comma female. Then I'll give a comma and pass in my title, which is male and female vaccination. Okay, this should be names. Alright, now let's go ahead and run this cell. So it will take some time to create the pie chart. Here we go. See, here I have my title, male and female vaccination. So these are the two pies or the areas. You have the label female and the value. Here you have the label male and the value. So from our data you can see 53% male individuals have been vaccinated compared to 47% for females. Okay, now we are going to drop all those rows where our state was mentioned as India in the original dataset. I had shown this to you in the beginning, so we are going to remove rows where state is India. Okay, so to do that I'll say vaccine. I'm creating another variable called vaccine and we'll use our original data frame that we had imported, which is vaccine underscore df. I'll say vaccine underscore df dot state not equal to India. Now let's print vaccine. Okay, you can see here we have our data frame printed, and from this data frame we are taking only those values or the rows where state is not equal to India. Cool. Now what we are going to do is we'll rename the last column, which is total individuals vaccinated, to just total. So I'll say vaccine dot rename. We'll use the parameter columns equal to, within curly braces I'll say total individuals vaccinated, give a colon, and we'll change this to just total, give a comma and say in place equal to true. And finally I'll print my head of the new data frame. This should be columns equal to. Okay, now you can see here if I scroll to the right and if I check, we have successfully renamed our column. Alright, now moving on to the last two visualizations that we'll see in this first project using Python, that is to find the states with most number of vaccinated individuals and the state with the least number of vaccinated individuals. Okay, just give a comment, most vaccinated state, Okay. For this, I'll first create a variable called vax_VAC, which is for maximum vaccination. I'm going to use my data frame vaccine followed by the group by function. I want to group it by state column, and we'll find the total sum of vaccinated individuals for each state. I'll convert this to frame. There should be a dot, 2_frame, and I'll pass in my column name, which is total. After that, I'll say max_VAC equal to max_VAC dot sort underscore values. I'm going to sort it by my total column and say ascending equal to false, which means I want to sort it in descending order so that we have the states with the highest number of individuals vaccinated. I want the top 5 states. Now let's go ahead and print it. So this will create a nice table for us. There you go. Here you can see we have Maharashtra, Uttar Pradesh, Rajasthan, Gujarat and West Bengal as the top 5 states with most number of vaccinated individuals. Now we are going to use this table and convert it into a chart. Now I had already written my code for the bar plot. I'm just going to paste it. So here I have defined my figure size as 10,5. Then I'm giving a title as top 5 vaccinated states in India and the size is 20. After that, I've created a variable called x, which is going to store my bar plot. This bar plot we have created using the Seaborn library, and you see here I have my y-axis defined, then I have the line width and the edge color as well. I've given my x label as states, y label as vaccination, and I'm finally going to display my plot. So let's go ahead and run it. Okay, you can see it here. We have converted this table into a bar plot now. So first we have Maharashtra with the highest number of vaccination. Then we have Uttar Pradesh, Rajasthan, Gujarat and West Bengal. Now I want the viewers watching this video to find the states with least number of vaccinated individuals and convert that table into a bar plot that will show the bottom 5 vaccinated states in India, which means the states which have least number of individuals vaccinated. So please go ahead and put your codes in the comment section of the video. It will be very similar to these two cells, just that now we want to know the least 5 vaccinated states in India. So please put the code snippets in the comment section of this video. We'll be more than happy to know from you. In case you are not able to do it, we'll definitely give the answers in the comments itself. Alright, so this brings us to the end of the first project on COVID data analysis using Python. So in this project we used 2 datasets. One was on the COVID-19 India dataset for different states and union territories, and the second dataset that we used was for analyzing the status of vaccination in the different states in India. Now we'll move on to our second project. Okay, so before moving on to our Tableau project, let's see the final quiz. Which of the following is not a common coronavirus symptom? So this question is to make you aware of the correct COVID symptoms. Here are the options. Is it A, fever, B, vision loss, C, loss of taste and smell, or is it D, cough? Please put your answers in the comment section of the video and let us know what you think. Now we'll move on to our second COVID data analysis project. For this project we'll be using the Tableau software and a global coronavirus dataset. First we'll look at the dataset and the fields we have. Okay, so I am in my dataset folder. We have already seen the first two datasets in our Python project. This time we are going to use the global COVID data. Let me open it. Alright, so here you can see we have the different country names. There are 192 countries in our dataset. Let me go to the top. So we have country or region. We also have the code for each of the countries. Then we have a column called last updated. So here you can see our data is still 12th of March 2021, and there are two columns which don't have any information, that is people hospitalized and people tested. Then we have a column called active cases. Then we have a column for confirmed cases in the different countries. We have the number of deaths, and then we have the incident rate, the latitude and the longitude for the countries. Then we have the mortality rate, this is in fractions. Then we have the number of recovered cases, and finally we have a column called UID. So we'll be mostly using the country column, active, confirmed, deaths, and the recovered cases column. And we'll be using the Tableau software to create interesting visualizations, and we'll convert those visuals and put it in the form of a dashboard towards the end of the project. Okay, so let me close this file, or let it be open. I'll search for Tableau public. You can see here I have Tableau public installed. You can use the desktop version of Tableau or the public version of Tableau. So for this project we are going to use the Tableau public edition. So here you can see I have created a few visuals already. If you want, you can clear them out. Okay, now the first thing we need to do is to connect our CSV dataset to Tableau. For that, under connect we have to a file. I'm going to use text file, and under Chrome downloads I'll search for my folder COVID-India, and here I have my global COVID data file. Let me open it. This will take some time to load. There you can see. So on the Tableau you can see the view here. It shows the country or the region. You have the last update. You have columns like active, confirmed, deaths, mortality rate, and recovered. And here you can see the symbols for the different columns. So this is a globe, which means this field is a region or a geographic field. ABC means it's a text field. Then we have the calendar, which is for a date field. ABC are text field, and this hash represents numeric fields. Alright, so now that we have loaded our data, let me just click on sheet 1. So this is the canvas where we are going to create our different reports. Alright, so on the left you can see there are two panes, the data pane and the analytics pane. In the data pane you can see the name of the dataset, global COVID data, and here you can see the different columns that we have in the dataset. So on the top, the ones marked in blue are called as dimensions, and at the bottom whatever you see are marked in green and are called as measures. So dimensions are always represented with blue icons and measures are in green icons. So Tableau has automatically detected the different data types for each of the columns. Alright, so first of all we are going to create a simple table to see the total number of confirmed cases for each of the countries. So for that I'm going to drag my country or the region column onto rows. Here you have rows. I'll just drag it and drop it here. There you go. It has populated all my country names starting from Afghanistan till Zimbabwe. So it has ordered in ascending order of alphabets. Now to see the total confirmed cases for each country, I am going to drag my confirmed column onto text. So here under marks card you have the text option. I'll just drag it and drop it here. There you go. So Tableau how easily has shown me a table where you can see the different country names, and on the right you have the total number of cases that have emerged from these countries. Now this is not the most recent data, as I told you this data was till March 2021. Cool. Now you can go ahead and sort the table based on the total confirmed cases. Here on the top you can see here there are two options to sort in ascending order or in descending order. Let's first sort in ascending order by sum of confirmed cases within country and region. There you go. So here you can see these are the countries which have very few cases, and if I scroll down you have France, UK, Russia, Brazil, India and US with the highest number of COVID-19 cases. If you want, you can also sort it in descending order so that the countries with the highest number of confirmed cases appear at the top. You can see it here, and these are the countries that have very few COVID cases. Now you can convert this simple table into different charts and graphs. To do that, here on the right top corner you have an option called show me. Now I can just click on this horizontal bar graph, so that will automatically convert my table into a bar graph. Again you can go ahead and sort the data. There you go. So here you have US, India, Brazil, Russia, UK, France, Spain and Italy. This is a horizontal bar graph sorted in descending order of confirmed cases. Now suppose you want to display only the top few countries with the highest number of confirmed cases. For that you can select these bars. So I'll select till, let's say, Germany, or let's say till Argentina. Okay, and I'll click on keep only. You can see it here, it says 12 items selected, that is the sum of confirmed cases. I'll just click on keep only. There you go. So this horizontal bar graph has information only for these few countries that have the highest number of confirmed cases. Now you can go ahead and play with the color formatting. So here under colors, let me choose a green color. Okay, now you can mark here, since we selected only the top 12 countries with the highest number of confirmed cases, so what we did was we just filtered it to the top 12 countries. So Tableau has automatically added country region in the filters card. Now if you want, you can go ahead and edit this filter as well. Suppose you want to remove Argentina, you can just uncheck this, click on apply and OK. You see here Argentina has been removed. I click on undo, so Ctrl Z to get it back. Cool. Now you can convert this horizontal bar plot into a vertical bar plot. Let me show you how to do it. I'll just remove these fields from my chart. Now what I'm going to do is I'll drag country or region onto columns, and I'll have a confirmed column under rows. There you go. Here you can see we have a vertical bar plot now, and again you can use the axis now to sort your data. This is in descending order. Similarly you can sort it in ascending order. Here you have the option to sort your data. Okay, cool. And below you can see the different country names. Alright, now you can go ahead and give a name to this sheet. Let's say top 10 confirmed countries. Just apply and click on OK. You have the title to this plot. Similarly, you can change it here as well. Top 10 confirmed countries. Okay. Now let's move on to our second visualization, where we will create a global map. So this global map will show the different countries present in the map and the cases that they have. So to create the map, first I'll drag my longitude generated field onto columns, and then I'll drag latitude onto rows. You see here we have the map ready, and now I'll drag country region onto detail. So this will give you the different country names. You can see here we have Canada, the United States, Mexico, here you have India, Sri Lanka, there's Australia, this is Brazil, and similarly we have Spain, France, Belgium, there's Italy here, we have also Greece. Similarly we have the African countries like Central African, Angola, and on the top you have Russia, and this is Iceland, so on and so forth. Now I'm going to drag the active cases column onto detail again. Now if I hover the cursor, you can see the active numbers for Brazil, you can see for India, you have countries like China, then here you have Thailand, Algeria. Now I'm going to drag the confirmed cases column onto label, so that you have the labels here. You can see here the confirmed labels. Cool. Now if you only want to focus on a few countries present in a particular region, you can highlight that region. For example, suppose for Europe you want to focus on this region. If you select it, it will highlight only those countries, and if you hover your mouse over these points, it will show you the active cases and the total number of confirmed cases. Alright, now if you want, you can go ahead and change the color of the circles. Let's say I'll keep it as red. Okay, so this is how you can create a map to represent the different active and confirmed cases. I'll rename the title to global cases. I'll just click on apply and OK. Similarly, I'll change the sheet name as well to global cases. Okay, now from this map you can see the countries such as USA, Brazil, you have Russia and India with the highest number of COVID-19 cases. Even in countries such as Spain, the numbers are really high, and a lot of the African countries were also impacted. And these small countries like Solomon Islands, you have Fiji Islands with few number of cases, even for New Zealand as well. Alright, now moving to our next visual. Now we are going to see the top 10 countries where highest deaths have been reported so far due to the pandemic. For this we will create a tree map now. So first of all, I'll choose my country column and put it under columns, and then I'll select the deaths column and put it under rows. I have the bar plot ready. Next I'll go to show me, and here I have the option to select a tree map. You see here, for a tree map you need one or more dimensions and one or two measures. So I'll just click on this tree map. Okay, here you can see I have my tree map ready. So Tableau has automatically adjusted my fields. So it has removed my fields from rows and columns and put it under size, color and label. Next, I will drag my country column and put it under filters, and from here I'm going to choose top. I'll filter by field. I'm going to select the top 10 countries based on the total number of deaths. Just click on apply and click on OK. So these are the countries: US, Brazil, Mexico, India, United Kingdom, Italy, Russia, Spain, France, Germany, which have the highest number of deaths reported. Now you can also give the label. I'll put the deaths column under label so that you have the labels here. Alright, so this was a tree map that we created to show the top 10 countries with the highest number of deaths. I'll just change the title top 10 deaths cases. Now you can also edit the title in terms of the font, color and everything. So I'll keep it Tableau bold and I'll choose this as 14. Click on apply and OK. There you go. Similarly, let's rename the sheet to death cases. Cool. Now moving to the next visualization where we'll see about the recoveries. So before we move on to create a visualization for the top 10, or let's say the bottom 10 countries in terms of recoveries, let me show you how to change the color of this tree map. So here by default Tableau selects the automatic palette. If you want, you can change it to different palettes. Let's say I'll go with gold, purple, diverging. Click on apply and I'll click on OK. If this is not looking that great, you can select another one. Let's say red, green, white, diverging. Cool. Now let's go to our fourth visualization, which is about top 10 recoveries. I'll click on apply and OK. First, I'll drag my country or the region column under columns, and then I'll take the recovered column under rows. This time, instead of sum, we are going to choose average. Okay. And here I'll select my packed bubble chart. After that, I am going to drag my country or region onto colors, and then I'll also put country under filters. So I'll go to the top menu and I'll filter it by field. I want to show the top 10 countries based on the average number of recoveries. So click on apply and OK. You can see here these are the countries that have the highest number of average recoveries. You have India, Brazil, Turkey, Italy, Argentina, Germany, Colombia, Russia, Poland and Mexico. I'll just rename this sheet to recovery cases. Cool. Now let's move on to our next visual. Okay, so here we are going to create a scatter plot to analyze the total confirmed cases versus the total number of deaths. So whenever you have two numeric fields, it is better to create a scatter plot to visualize the cases. So for that, I'm going to drag my confirmed cases to columns, and then I'll drag my deaths column onto rows. Okay. So by default, the shape is a circle, and to see all the countries, I'm going to drag country under color. I'll say add all members. There you go. Here you can see the legend for the different countries, and the top you have US with the highest number of confirmed cases and the highest number of deaths as per our data set. Then you also have Brazil here, which has the second highest number of deaths. Then you have Mexico followed by India. So this data is not a very recent data. This data was last updated on March. Now from this we are going to filter out the top 10 countries with the highest number of confirmed cases and the deaths. So for that I'll drag my country column onto filters, and I'll go to top, I'll filter by field, I'll say top 10, and I'll click on apply and OK. So here you can see we have Siberia, Sweden, Belgium, Netherlands, Spain, Italy, France, Russia, UK, and you have Brazil. So these are the countries which have the highest number of active cases. So instead of active, let's select deaths, click on apply and OK. Okay, now if you see we have US here, Brazil, India, then Mexico, UK, Russia, France, Italy, Germany and Spain, which have the highest number of deaths reported so far. Now if you want, you can change the size of the circles based on the highest number of active cases. So I can just drag my active column under size. So you can see here Spain, France, UK have the highest number of active cases. Now let's say instead of active, I'll just have my confirmed cases under size. Okay, and then you can also change the shape from circle to any other shape, let's say square or this asterisk. Okay, let's go with the triangle. Cool. I'll rename this sheet to confirmed versus deaths. Click on apply and OK. I'll rename this to confirmed versus deaths. Alright. Now moving on to our next visualization, where we will see the mortality for each of the countries and figure out which countries have the highest mortality rate. Okay, so first I'll drag mortality rate onto column, and then I'll have my country column under rows. So there you go. Now let me go ahead and sort it in descending order. So you can see here you have Yemen, there is Mexico, Syria, Sudan, Egypt, Ecuador, China and other countries which have the highest mortality rate. And you can also select the country region under colors. Let's go ahead and edit the color. Instead of automatic, let's select summer, or you can go for some other palette. Let's say Tableau Classic Medium. I'll assign this palette. Yes, I'll apply and OK. Alright. Now finally, we'll move ahead to our last visualization, where we'll create a dual axis chart. So the dual axis chart in Tableau will have one column and two different visualizations on the rows. So here you have one column, and on the right also you'll have one column with their own axis values. So this dual axis chart will be for recovered cases and the depth cases. Let me show you how to do it. So I'll drag my country field onto columns, and then I'll choose recovered column onto rows. So here I have got my line chart, and the second column I'm going to choose is the deaths column. I'll hold my cursor and I'll place it when I get this green color rectangle. I'll place it here. There you go. So now we have created two measure names, deaths and recovered, and here you have the access values. You can synchronize the access values if you want. The recovered cases are in millions and the deaths are in thousands. Now let's go ahead and change the recovered line to bars, and we're going to short it. Okay, now let's change the color. We'll select, let's say, blue. I'll assign the palette, click on apply and OK. And if you want, you can also change the color for deaths from blue to, let's say, winter. I'll assign the palette, click on apply and OK. You can have whichever color you want, and to make the axis same, you can just right click on this axis and click on synchronize axis. So here you can see the values. Let's keep it in thousands only. Cool. I'll rename this sheet to dual axis. Okay. Now before we move ahead and create our final dashboard, I want to show you one more feature in Tableau, that is to format the labels. So you can see here, instead of writing 5,30,821, we can change this in terms of millions or thousands and write it as, let's say, 530k. To do that, what I'll do is I'll go to format, and here we have the option to select font, and in font I'll go to fields and click on sum of deaths, and here in this pane I'll choose number custom. Decimal places will be 0, and display units I'll select thousands. You can see here the values have been changed to 531k, 193k, 158k, so on and so forth. Cool. Now let's go ahead and create our final dashboard. Here is the option to create a new dashboard. So I'll just click on new dashboard, and we are going to increase the size here so that it fits our view. So we have selected the default view, and the size I'm going to choose here is automatic. So now we can drop our sheets one by one. First, let's drag the global cases sheet here. Okay, you can see we have our map. Now I'm going to choose the top 10 confirmed cases. Alright, and after that we'll choose the death cases sheet. So Tableau will prompt you to place the sheet at the right location. Okay, and now I'll choose my fifth visual, which is confirmed versus deaths, and if you want you can choose any one of these. Let's say I'll take the dual axis chart. Now you can just minimize the sheets and adjust the sizes to make it look better. Okay, so you can see here we have our dashboard ready. Now you can still go ahead and customize the dashboards in terms of adding different filters to it. We are not going to show that Now you are getting some messages here, 2 unknown, 4 nulls. You can remove them as well. And here on the top you have the option to click on the presentation mode. There you go. So this is our final dashboard that we have created. Alright, so this brings us to the end of the second coronavirus data analysis project using Tableau. Now you can just click on escape to go back. Alright, now you can save this and this will be published in the Tableau public platform under your profile. So that brings us to the end of this video tutorial on COVID data analysis project using Python and Tableau. Welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC, so they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly, there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as Numpy, Pandas, Matplotlib and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first dataset. You can see on the top athlete_events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge dataset that we are going to use. The other dataset we are going to use in this demo is called NOC_regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. We have the region names, so AFG is for Afghanistan, you have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright, let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete_events.csv contains nearly 2,71,116 rows of information, and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. Alright. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two data sets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I've opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use Numpy, Pandas, Matplotlib, and Seaborn. Let me hit Shift Enter to import all the libraries. Alright. Now the next thing is to load the datasets using Pandas read_CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read_CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another /, and after that I'll give the file name, that is athlete_events.csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set. I'll create another variable called regions. So it will have my data frame. I'll use the same function pd.read_csv. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc_regions.csv. You can verify here. The first one is athlete_events. The second one is noc_regions. Okay, I'll close the quotation and we'll run it again. Okay, there seems to be some error. I think this is the regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes.head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions.head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second dataset. You have NOC, region and some notes. Alright. Now the next step is to combine both the datasets. So we'll join the data frames using the Pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes_df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the datasets is actually NOC. So I'm going to use the NOC column as my common column to merge both the datasets. Now let's go ahead and print the merged data frame. I'll say athletes_df.head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added 2 more columns that were present in the second dataset, which was regions. So we have regions and notes added to my first dataset, that is athletes_events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last 2 columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt. I'll select athletes_df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows. So 2,71,116 rows, and earlier we had 15 columns in the first dataset, and now that we have added 2 more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes_df. dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region. I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually. My second column, that is notes, I want to change the first letter to uppercase, so I'll say capital N. The rest all remains same. I'll give a comma here and say in place equal to true. So it will change the column names and will reflect in this athletes underscore df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last two columns, region and notes. All right. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values, and memory usage. So for that, you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. Alright. Next, the describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile, and the 75th percentile value of the columns ID, age, height, weight, and year. Alright. Now one thing to notice here is, if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright. Now moving ahead. Now let's check if there are any null values present in the columns of the dataset. So first I am going to create a variable called nan values, give equal to, I'll say athletes underscore df, and the function to check is, I'll say is na. I'll create another variable called nan underscore columns, and here I'll use the any function. I'll say nan underscore this variable, which is underscore values dot, I'll say any, and I'll print my nan columns variable. So this will display the result in terms of Boolean values. So if there are any null or nan or missing values in any of the columns, it will say true, otherwise it will say false. Let's display the result. There you go. So if you mark here clearly, so there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any NaN or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. Let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, we'll use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year and everything. Alright, similarly you can also check for Japan. Let me just copy the above code, I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright, now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that I'll create a variable called top underscore 10 underscore countries. I'll say equal to, I'll use my data frame, that is athletes underscore df. I'll say dot team Then I'll use the function value underscore counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top underscore 10 underscore countries. Alright, let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short underscore values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896. You have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot the top 10 countries who have participated in Olympics. So here I'm using the figure function to give the figure size. So these are the dimensions 12,6. Now I'll tell you what this PLT_X means. Just wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the X and the Y axis. So my X axis has top. I should make this top 10 countries because above we used top underscore 10 underscore countries. Similarly for Y axis, I'll make it top underscore 10 underscore countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this, we are going to create a histogram. I'll be using the matplotlib library specifically for this visualization. So I'll say plt.figure. We'll give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the X labels. I'll say plt dot X label. This will have age. Then we'll say plt dot Y label, and this will have the label as number of participants. Next, I'm going to use the hist function. So I'll say plt.hist, and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function. So np is for numpy, and inside this I'll say 10 comma 80 comma 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge color, this is the parameter or the argument name, and the color I want is white. Let's give a semicolon here, and this should be edge color. There's a spelling mistake here. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the Summer and Winter Olympic Games. Let's look at the different sporting events that are part of the Summer and Winter Olympic Games. Just to give you a heads up, the Winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter underscore sports, so I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the Winter Olympics. Now similarly, let's see for Summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer underscore sports, athletes underscore df remains the same. Here season we'll change it to summer. Dot sport dot unique remains the same, and here I'll say summer underscore sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the Summer Olympics compared to Winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender underscore counts, which is my variable name. I'll use my data frame, that is athletes underscore df dot my variable name, that is sex, dot value underscore counts, and then we are going to print gender underscore counts. Let's run this. There you go. So since the inception of Olympics, we have more number of male participants than female participants. Now here in this current cell, you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender_counts.index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. Now you can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we are going to find the total number of medals that the athletes have won. So I'll use my data frame athletes_df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female_participants. I'll say equal to, and then use my data frame name, that is athletes_df. Using square brackets, I'll say athletes_df dot, the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column. So here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function. Say group by, which is part of the Pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index is a function, and finally we are going to print female underscore participants, and let's say the head. Alright, so what we are trying to do is, I'm trying to filter my data only for the female athletes for Summer Olympics, and here I am printing the participation based on each year, so I'm finding out the count. So here we need to add one more square bracket. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here. For the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics, we had 5,815 Olympics. Similarly, for the 2016 Rio Olympics, we had more participation than the London Olympics. So 6,223 women athletes had participated. Alright. Now here, this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid. Then my figure size I have given as 20,10. My count plot will have the x-axis as year. The data is Women Olympics, and palette I'm using as spectral, and then I've given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot, which says Women Participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis, now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next I'm going to say gold medals dot head. Let's run it. There you go. So here we have the top 5 rows of the athletes who have won a gold medal. You can see all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have said gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I'll close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event. This is going to be my variable name, equal to, I'll use the same variable name, gold medals. I'll going to choose my sport column, and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it, and if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years, and since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright, now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals. Then we have Russia, Germany, UK, Italy and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6. So it will give me the top 6 countries. Alright. Now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets, I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team. Then I'll say team underscore names dot value underscore counts dot head, and will display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20, and Japan 17. Alright. Now using the above result, we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it, and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal, or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values, so we are not going to consider those null values here. We are only going to consider for the athletes who have won a medal. So for that, I'll create a variable called not underscore null underscore medals equal to, I'll say athletes underscore df, then I'll give my, let's make it df, I'll give my condition Let me just copy this. I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis. I'll say athletes underscore df. This time we'll consider the weight column. Again, I'll use the function as not null, and I'll close the parenthesis. Okay, I had missed one s here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure. I'll give my figure size equal to, I'll say 12,10. I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma. In my y-axis I'll have weight, comma. My data should be not underscore null underscore medals. So this is what we created here, not underscore null underscore medals, comma. I'll use hue equal to my sex column. Cool. Finally, I'll say plt dot, I'll give a title to my plot saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Alright. So that brings us to the end of this video tutorial on Olympics dataset analysis. Indian Premier League, that is IPL, is one of the most popular and exciting events in world cricket. IPL 2022 will begin on 26th of March, so it's the best time for us and our viewers to learn about how to perform exploratory data analysis using the recently held IPL auction dataset. So in this video, all the results and insights that you will see are totally based on the data we have collected from Kaggle. We will leave a link to the dataset in the description of the video. You can go ahead and download it. For this demo, we'll be using Python and Jupyter Notebook to answer specific questions. So let's get started. We'll move over to our Jupyter Notebook. Okay, so I'm on my Jupyter Notebook, and this is the file that we are going to use. So here you can see I have some of the cells already filled in. So this will save us some time and we can explore this data set in depth. So this is the file that I'll be using, or the IPython notebook. Cool. So first, let's go ahead and import all the crucial libraries that will be needed for our analysis. So here you can see I'm importing the Pandas library, the Numpy library. These are for data manipulation and numerical computation. Then we have Seaborn and Matplotlib for data visualization. Then I have imported this warnings module so that we do not get any warnings while running the code. Cool. So let me just hit Shift Enter to run the first cell. So here we will import all the libraries. Okay, it's done. Now the next step is I'm going to create a data frame in the name of IPL, and here I'm importing the dataset using the read_csv function, which is part of the Pandas library. So PD here has been imported as Pandas. I'm giving the dataset location followed by the name of the dataset. So here the name is IPL_2022_dataset .csv is the extension of the file. So let me go ahead and run this as well. Alright, so now we have successfully imported or loaded our dataset. Now the next step, let's go ahead and explore our dataset. So I'll use the head function for this, IPL.head. Okay, so here you can see the different columns. We have an unnamed column which is actually unnecessary for our analysis, so we'll see how to drop this column. Apart from that, we have the name of the players, the base price at which the player was sold, or whether the player was a draft pick. So here Rashid Khan from Afghanistan, Hardik Pandya, then we have Subman Gill. These are all draft pick, and then we have the price at which the players were listed in the IPL auction. Then we have the type of player, whether the player is a bowler, an all-rounder, a batsman, or a wicketkeeper. Then we have the cost in rupees. This is in crores. So basically this column tells us the price at which the player was sold in the auction. Then we have the price or the cost in dollars. After that we have 2021 squad. Basically this means in last year's IPL, where was the player? So here you can see Rashid Khan was playing for SRH, the Sunrisers Hyderabad, in 2021. But this year in 2022, he'll be playing for Gujarat Titans. Similarly, Hardik Pandya was playing for Mumbai Indians for past few seasons, including 2021. But this season is going to play for Gujarat Titans. So on and so forth. Now, let's see the total number of players that are present in the dataset and the total columns that are there. For this, I'm going to use the shape attribute. So I'll write IPL.shape. You can see here there are total 633 players that were part of the auction, and this includes the players who were draft pick also. And there are total 8 columns in my data frame IPL. Next, let's use the info function to check the columns, the data types, and the total non-null objects. So I'll say IPL.info, which is a function, so I have to use brackets. There you go. So here you can see it says total 633 entries from 0 to 632. Data columns, we have total 8 columns, and then these are the different column names, and here you can see the total non-null objects present in the column, and here you can see the data types, and at the bottom you can see the memory usage as well. Cool. Now the dot columns attribute will return the name of the columns in the data set. So if I say IPL.columns and run it, it will give me all the different column names that are present in the data frame. Now, as I said, the first column, which is unnamed :0, is actually unnecessary. So we are going to drop it. For that, we are going to use the dot drop function, and then I have passed in my column name followed by the axis, on which axis is it there, and then I say in place equal to true, which means it will replace and permanently remove the unnamed column from the data frame. So let's run it, And now we'll again check the head of the data frame. You can see before we had the unnamed column, which was the first column in the data frame, and now we have successfully removed it. So player becomes the first column in the data frame. Alright, now moving ahead, let's see the total number of null values that are present in each column of the dataset. So I'll say IPL dot, I'm going to use the isNull function followed by the sum function. If I run this, you can see here the player column doesn't have any null values. Similarly, base price and type column also don't have any null values, but you can see cost in rupees and cost in dollars have nearly 396 missing or null values. The reason being those players were not picked in the IPL auction and hence there was no price associated. And then you can see there were a few players who were not part of the IPL squad in 2021. So those are being reflected as null as well. Now we'll check the rows that have cost in dollar as null or NaN. So here I have used IPL, and after that I'm passing in the column name, which is cost in dollars, and then I've used the isNull function. If I run this, you can notice the cost in dollars column, all these values are NaN or null, and even the same rows have NaN for cost in rupees as well. Cool. Now the next task is to fill these null values or NaN values with zeros. So for that I'm going to use the fill NA function, and here I have passed in 0. So all the null values in the dataset will be replaced with 0 for cost in rupees column and cost in dollars column. Let me just run it. Alright. Okay. Now we will see the players who were unsold in the 2021 auction, which means we will check the rows that have null values for the 2021 squad column. So what I'll do is I'll say IPL, within square brackets I'll say IPL, and then I'll pass in my column name, which is 2021 squad, and then after this I'll say dot is null. So this cell will give us the unsold players in the 2021 auction. If I run this, you see here, you mark the 2021 squad column, all these players were unsold or did not participate, so hence it has NaN values. Alright. Now what we are going to do is we will replace all the null values that are present in the 2021 squad column with not participated. Like how we did in the previous example, we replaced all the null values with 0. Here we'll replace with a text value called not participated. So I'll say IPL, I'll pass in my column name, which is 2021 squad, equal to, I'll say IPL 2021 squad dot fill NA, which is the function, and here I'll pass in a text or a string saying not participated. Alright, let's run it. Before that, let me just scroll it down. Now I'll run it. Cool. Now that we have treated the null values successfully, let's verify it again. So I'll just say IPL dot is null, and then I'm going to use the sum function. If I run this, okay, this is also a function. Cool. Now if you see, we have successfully removed all the null values and replaced with either zeros or not participated, and hence now you can see none of the columns in the IPL data frame have null values, so it shows 0. Great. Now moving ahead, Now we are going to add another column called status, which will hold two values, sold and unsold. But before that, we are going to slice our data frame. So here I am looking for all the rows where cost in rupees is greater than 0, and those should be unique, and I'm storing the value in a variable called teams. So here you can see we have the different teams where the cost in rupees is greater than 0. Now I'm going to create another column called status. So I have written IPL within square brackets. I'm passing in the column name, which is status, and that will be equal to the team replaced by sold value. Let me just run it and show you the result. There you go. So here you can see we have added a new column called status, and it has values sold and unsold. If I just say IPL, at the bottom you can see the unsold values as well. Cool. Now in the next cell, we are going to check for duplicated players. So there are duplicate rows in the data frame, but here the names of the players are same, but in reality the players are different. So it is quite understood that different players can have the same name. So to get those names, I am using the duplicated function, and I'll say keep equal to false, which means I don't want to keep those players. Now let's run it. There you go. So here you can see Lalit Yadav, we have two entries. So Lalit Yadav here is an all-rounder whose base price was 20 lakh for 2022 IPL, and last year he was playing for the Delhi Capitals, and this year also he is sold to Delhi Capitals. Next we have Lalit Yadav, who happens to be a bowler. So this is again different Lalit Yadav. So last year he was unsold, and even this year he remains unsold. Similarly, we have Amit Mishra, who earlier used to play with the Delhi Capitals, but this time he remains unsold, so on and so forth. So you can see two entries for Subham Singh as well and Shivam Mishra. Alright. Now let's answer a very basic question. We're going to find out how many players have participated in the 2022 IPL auction. For that, we have already seen the total number of rows that were present, but again I'm going to use the shape function, and within square brackets I'm going to say 0, which means it will give me the total number of rows, and you can see 633 players were part of the auction. This is as per our data that we have collected from Kaggle. Up next, we are going to find how many types of players have participated. So I'm going to say types equal to, say, IPL. I'll use the column name, which is type, and I'm going to find the count of each type of players that are present in the data frame. I'm going to use the values underscore counts function, and then I'll say types dot reset underscore index. If I run it, okay, there is an error here. Let me debug the error. Okay, so this should be value underscore counts, and the variable name is types and not type. So let's run it. You can see here we have the different types of players. So all-rounders, there are total 242 all-rounders who are part of the auction. Then we have 215 bowlers, 112 batsmen, and 64 wicket keepers. Now using the above table that we just created, I'm going to plot my first pie chart. So for that I'm going to use the matplotlib pie function. So plt.pie, I'm using types.values since I want only the values from this table, and then I'm saying labels equal to types dot index. I've used a label distance of 1.2 to maintain some space, and then this is my format in which I want to print or show or display the percentage of distribution. I am going to use shadow, so it says shadow equal to true, which is another parameter or an argument, and then I'm going to start my angle at 60 degrees, and here I have used a title called roll of players participated that will have a font size of 15, and finally I'm saying plt.plot. So let me just run it. There you go. So here we have a nice pie chart or a pie plot. So you can see the different pies here. We have all-rounder, wicketkeeper, batter and bowler. So majorly there are all-rounders in the auction followed by bowlers. Then we have 17.69% batters and 10.11% wicket keepers, which is the lowest. Cool. Now we are going to create another bar plot or a bar graph that will tell us how many players were sold and unsold. So for this I'm going to use a count plot. So we'll create two bars, one for sold and the other one for unsold, and each of the bars will have different colors. One will have orange, the other one will have pink, and I'm using labels. So to label the x-axis and y-axis I have sold or unsold. Y label will have number of players. The title of my bar graph would be sold versus unsold. I've given a font size of 15 and I'm saying plt.plot. Now the function that you see here at the bottom will display the data labels for each of the bars. Let me just run it and show you the result. There you go. So I have used a figure size of 10,5. Alright, now you can see we have a really good bar plot which says there were total 237 players sold and 396 players were unsold as per the data we have. Cool. Now you can also print the total sold and unsold values. Let me show you how to do it. I'll say IPL dot, we can use the group by function, and I want to group it by status column, and the value that I want to measure is the players count. So I'll say players, rather player, and then I'm going to use the count function. If I run this, you can see here I've successfully grouped the unsold and sold players. The values are matching with the bar plot that we just created. So sold were 237 players and unsold are 396. Cool. Now we are going to see the total number of players bought by each team. Again, this is going to be a count plot, so basically a bar plot. So here the condition I'm passing is in the teams column the value shouldn't be unsold. So players bought means the value should be sold. So here I'm using this condition, and the rest of the things remains the same. One improvement I have done here is I'm using x-ticks rotation equal to 70 degrees. This basically means the x labels would be tilted by 70 degrees. Now let's see the bar plot. There you go. So here you can see I have the title players bought by each team. On the y-axis we have the number of players, and on the x-axis you can see the values have been tilted by 70 degrees. Let me just zoom in so that you can see it better. And this is the bar plot. So the maximum a team can purchase is 25 players. Some of the teams have also purchased 24, 22 and 23 players. Let me just show you. So Gujarat Titans have totally purchased 22 players. Then Delhi Capitals have total 24 players in their squad. Again, Lucknow Super Giants have 22 players. If I scroll and see again, Bangalore Royal Challengers or RCB, the Royal Challengers Bangalore have 22 players in the team. and Rajasthan Royals and Sunrisers Hyderabad have 24 and 23 players respectively in their teams. Alright, now we will create 3 more columns called retention, base price and base price unit. For that, first of all, I am creating a new column called retention, which is equal to IPL base price. Let me just run it, and then I'm going to replace these values that are present in the list: 2 crore, 40 lakh, 20 lakh, 1 crore, 30 lakh, 1.5 crore with from auction, and I'm saying in place equal to true. Let me just run it. Then we are going to treat the base price. So here in the base price column, I'm going to replace draft pick value as 0. So let's run that as well. And now I'm going to split the base price value into two separate values called base price unit and base price. So basically I'm splitting on the space that I have. Let me show you how it is going to split. So this is, let's say, our base price column. What I did was I replaced the draft pick values to 0, and then the rest of the values will be split into two columns called base price unit. So basically it will have the unit of the base price, let's say crores or lakhs, and the base underscore price column will have the value, which is 2, here 40, 20, 20, so on and so forth. Let me just scroll down and run that particular cell. Now to create these two columns, the base price unit column and the base underscore price column, I have used the lambda function and I'm splitting based on the space. Let's just run it. Now I have replaced retained with 0, and let me show you the final data frame that I have. So here you can see we have replaced the draft pick values in the base price column to 0, and on the right side you can see the three different columns that I wanted to create. So one is called retention. So zeros refer to draft pick. Any other value will say the player was picked from the auction. Then you have the base price unit. So here you can see crores, lakhs, and the value base prices 2, 40, so on and so forth. Cool.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's check how many players were retained and bought from the auction by each of the teams. So I'll say IPL, let me just scroll down, dot, I'm going to use the group by function. Then I'll say team, comma, retention. Then I'm going to use the value as retention because I want to find the count of retained players. Then I'll say colon -1. Let me run it. You can see here the different team names because I have grouped by team and then retention. So I have Chennai Super Kings. From the auction they had picked 21 players and they had retained 4 players. Coming to Delhi Capitals. Delhi Capitals in the 2022 IPL auction they picked total 20 players and they have retained 4. Similarly, if I scroll down, let me talk about, let's say, Punjab Kings. They have picked 23 players from the auction and retained 2 players from the team last year. Talking about RCB or Royal Challengers Bangalore, they have picked 19 players from the auction and they have retained 3 players. Alright. Now in the next cell of code, we are going to display the players in each team based on the different types of players. So let me just run it and show you the result. So here I am using the same condition. The value shouldn't be equal to unsold, and I'm going to use another parameter called hue for the different colors. So here I have used hue as type because I want to show the players in each team based on the different types. Again, I have given my title to the bar plot, and then I have the X label, the Y label, and my rotation is 50 degrees now. If I scroll down, you can see the different types of players. Here is the legend. So blue is for bowler, orange or yellow is for all-rounder, green is for batter, and red, which also looks like maroon, is for wicket keepers. And on the x-axis you can see the different team names. Alright, now let's answer another couple of questions. So here I have, what is the highest amount spent on a single player by each team? So to solve this question, I'll say my data frame name, that is IPL. Then I'm going to say retention equal to, this should be from auction because we want to see the highest amount spent and not from the retained players. Then I'm going to group by, I'll say team, and then I'll say cost in, let me just copy it from here, cost in rupees, that is in crores, and I'll say max colon -1 dot sort underscore values, I'll say ascending equal to false, which means I want the sorted result in descending order. Okay, let me just bring this to the left side and we'll run it. There seems to be some error. Let me check the error. It says there's a spelling mistake. This should be team. Let me run it again. There you go. So you can see Mumbai Indians have spent 15.25 crores for one of the players, and this player happens to be Ishan Kishan. Then Chennai Super Kings have spent the highest amount for a player who happens to be a bowler. The name is Deepak Chahar. They have bought him for 14 crores. Kolkata Knight Riders bought Shreyas Iyer for 12.25 crores, and so on and so forth. So these are the highest amounts spent on a single player by each of the teams. Let me scroll down. Now we are going to see the player retained at maximum value or maximum price. Now if you follow IPL, the maximum price at which a player was retained happens to be Ravindra Jadeja. So let's see at what price was he retained. I'll say retention equal to, I'll say retained, then I'll say sort underscore values by equal to, I'll use the same column, cost in rupees, that's in crores, I'll say ascending equal to false dot head, and I want to find the top player. Again there's some error. Let's see where is the error. C is ascending equal to false dot head. Okay, this should be sort underscore values. Within bracket I should say by. I think this should be fine now. Let's run it. There you go. So you can see here our result is player name Ravindra Jadeja, who was retained for 16 crores by Chennai Super Kings. Cool. Now the next cell of code will display or print the top 5 bowlers who have been picked in this year's IPL based on their cost in INR. Let me just run it and show you the result. You can see here Deepak Chahar went for 14 crores. Then we have Shardul Thakur, who was bought by Delhi Capitals. Earlier he was part of CSK for 10.75 crores. Then we have Prasiddha Krishna, who has been bought by Rajasthan Royals this time. Last year he was with KKR and he has been bought for 10 crores. Similarly, Lockie Ferguson has been bought by Gujarat Titans and he played for KKR last season. He has been bought for 10 crores while his base price was 2 crores. Then we have Avesh Khan. You can see Avesh Khan's base price was just 20 lakhs and he has been bought for 10 crores by Lucknow Super Giants again, and last year he was part of the Delhi Capitals. Now you can replace this value. Suppose let's say you want to find the top 5 batsmen picked or batters picked with the highest amount. You can just say batter instead of bowler, and if I run this, you can see here Shreyas Iyer was bought by Kolkata Knight Riders for 12.25 crores. Last year he was part of Delhi Capitals. Then you have Shimran Hetmeyer, who's from West Indies. He has been picked by the Rajasthan Royals for 8.5 crores. Then we have Rahul Tripathi, Sikha Dhawan and Devdutt Padikkal. Now if you wanted to check for, let's say, all-rounders, you can replace batter with all-rounder. If I run this, you can see Liam Livingstone has been bought by Punjab Kings this season for 11.5 crores. His base price was just 1 crore and last year he was part of the Rajasthan Royals. Then we have a player from Sri Lanka, Hasaranga. Then we have Harshal Patel, Shah Rukh Khan and Rahul Tewatia, who have been the top 5 all-rounders picked at highest amount. Cool. Now finally, we want to see the players who were part of the IPL last season but were not picked for this year's IPL. So for that, what I'm doing is first I'm renaming my 2021 squad column. This column I want to rename it as previous team. Let's run it. Then I'm going to find out the unsold players. So here I'm saying previous team not equal to not participated, and then I'm using another condition. The team should be equal to unsold, and I'm going to find out only the player and the previous team. So let's run it and see the result. So here you can see these players were part of the IPL last season, but they haven't been picked this season. And last season they had played for, let's say, Suresh Raina played for CSK, Steve Smith was part of the Delhi Capitals, Sakib Al Hasan was part of KKR. If I scroll down, you have David Malan, who played for Punjab Kings in 2021. Owen Morgan, who played for KKR. He also captained KKR, but unfortunately he was not picked this season. Chris Lynn from Australia also remained unsold this season. Andrew Tai, we have Ben Cutting, Aditya Tare. There are other players as well. We have Kane Richardson, Dhaval Kulkarni. Cool. So these were the players who were part of the IPL season 2021, but unfortunately were not picked and remained unsold for 2022 season. Cool. And that brings us to our end of this demo session on IPL data analysis 2022. So we learned how to use the different functions and attributes that are part of the Python libraries, and we manipulated the data, we visualized the data, and answered some specific questions. In this video, we'll be using 4 publicly available datasets about Formula 1 that has information from 1950 to the 2019 F1 season. We'll see how using the Python libraries you can perform exploratory data analysis and draw valuable insights. So let's begin by understanding what Formula 1 is. Formula 1, also known as F1, is a motorsport defined by open-wheeled single-seat race cars. It features the best drivers in the most powerful and technically advanced cars. The sport is governed by the FIA, that is International Automobile Federation. Here 10 teams comprising of 2 drivers each compete in a series of races over a period of 1 year to find out the ultimate driver and a constructor champion. In our demonstration, we'll be using 4 datasets. Let me show them one by one. These are all CSV files. Now this is the first dataset that we'll be using in our demo. So if you notice, the dataset does not have column names. In fact, none of the datasets have column names. So while importing the dataset, we'll assign the column names using the names parameter. I'll show that in a while. Now this is the results dataset. The results dataset has information about the result ID. Then we have the race ID, driver ID. We have the constructor ID, grid, position. Then we also have information about the fastest lap. Then we also have information about rank, the fastest lap speed, and the status ID. Now moving on to the second dataset, which is about races. Now this is the second dataset, which is about races. So it has information about the race ID, the year in which the race was held. Then we have the round number, circuit ID, then the name of the Grand Prix. So you can see here Australian, Malaysian, Chinese, Spanish, Monaco, Turkish, British, German, and others. Then we have the date on which the GP was held or the Grand Prix was held. We have the time and a URL which basically leads to the Wikipedia page of that particular Grand Prix for that year. Now moving on to our third dataset. So this is our third dataset, which is about drivers. Now it has the driver ID, the name of the driver. You can see here Hamilton, Rosberg, Alonso, Raikkonen. Then we have Sato, Massa, Button, Weber, and all. After that, we have the number code. Then we have the forename of the driver, the surname of the driver, and then we have the date of birth of that particular driver. We have the nationality as well. And we have the Wikipedia page for the driver. Now moving on to the last dataset, which is about constructors. So this is the fourth and the final dataset that we'll be using in our data analysis project. So here we have the constructor ID, then the constructor reference in Formula 1, and this is the actual name of the constructor. So we have McLaren, we have BMW Sauber, Williams, then we have Ferrari, Toyota, Red Bull, Force India. We also have Jordan, Jaguar, and all. Next, we have the nationality and the URL, that is the Wikipedia page of that particular constructor. Now let's head over to our Jupyter notebook and we'll start with our analysis. Here is my Jupyter notebook that I'll be using for this demo. You can see some of the cells are already filled. This is just to make sure we save some time. So using these datasets that we just saw and our libraries such as Numpy, Pandas, Matplotlib, and Seaborn, we'll answer specific questions such as the drivers and constructors who have been the most successful throughout the history of F1 sport. Then we'll explore the impact of starting and finishing positions and if the speed of the cars has changed over the years. So let's begin with our analysis. First and foremost, we are going to import all the necessary libraries. So here I'm importing Numpy, Pandas, Matplotlib and Seaborn. And after that I'm writing percentage matplotlib inline. That is to ensure that all the plots are embedded inline. I'll hit Shift Enter to run it. It'll take some time. There you go. So we have successfully imported all the libraries. Now the next step is to load the data and assign column names. So I'll load my first data, which is results. I'll say pd dot read underscore csv. I'll give my file name, which is results dot csv, and then using the names parameter I'll pass in the column names. So actually I have written the column names in a notepad. Let me open that. So I have this F1 notepad created which has the column names. I'll just start copying the column names. Within the names parameter I'll paste it. If I scroll to the right, you can see the different column names that have been assigned, and for that I'm going to say comma, and I'll write header equal to none. I'll close the bracket. Cool. Similarly, let's import the second data set, which is about races. I'll say pd dot read underscore csv. I'll give my file name, which is races dot csv, and then I'll give the names parameter. This is actually names and not name. Okay, I'm going to copy the second line and I'll paste it here, and again I'll say header equal to none. Next, we'll import our third data set, which is about drivers. So I'll say pd dot read underscore csv. I'll say drivers dot csv, and then again use the names parameter, and I'll copy the third line now, which has the column names for the drivers dataset. Here I need to give another parameter, which is header equal to none. Finally, we are going to import our constructors dataset. We'll say constructors equal to pd dot read underscore csv, which is the function present in the Pandas library. I'll say constructors.csv, which is my file name, and then again I'll use the names parameter. I'll go to my notepad, and this time I'll copy the fourth line, which has the column names for the constructors dataset. I'll paste it, and here I'll give my final parameter, that is header equal to none. Alright, now let me hit Shift Enter to run it. Okay, we see some error here. Let's debug the error. It says no such file or directory, drivers.csv. Let's see where was the issue. Okay, this should be driver.csv. Cool. Now we have successfully loaded the data and assigned the columns to the various data sets. Now the next analysis is to merge all the data set. So here I'll create a data frame called df, and I'll use pd dot merge function. First I'll use the results data frame that we just imported above, this one, and I'm going to merge it with races data frame, and from the races data frame I'm going to take specific columns like the race ID, then I need the year, after that I need name. Next I'm going to take the round column as well, and I'm going to use on parameter. So on parameter is actually the column that is common to both the data frames, that is results and races. So here my common column is going to be the race ID because it is present in both the data sets, and I would like to merge. So for that I'm going to use how. So I'm going to use a left join. So if you know SQL, you will be aware of left join. It takes all the rows from the left table and only the matching rows from the right table. Again going to use the merge function, so I'll write df equal to pd dot merge. I'll say df comma, and now I'm going to merge the diverse data set, and I'm going to select specific columns. So I'll say driver ID. Make sure there are no spelling mistakes in the column names. Then I'll say driver ref, which is the name of the driver or reference, comma, and then I want the nationality of the driver. All right, I'll give a comma. I'll say on which column I want to merge. So here the common column is going to be the driver ID. Again, how is going to be a left join. Going to the final merge part, I'll say again df equal to pd dot merge. I'll pass in my data frame, and my final data set which I have is about constructors. From constructors we are going to choose specific columns. So I'll take the constructor ID, then I'll take the name column, and again the nationality column of the manufacturer. Here I'll say on equal to the common column I'll use is constructor ID. Give a comma and say how equal to left again. Cool. Make sure you're merging it with the right column names. So let's run this cell to merge all the 4 data sets. I'll hit enter. Oops, there is some error. Let's see. It says constructor ID index. Okay, there's a spelling mistake. This should be constructor ID. Cool. Let's run it. There you go. Now the next thing we want to do is to drop the unnecessary columns. So I'll say df dot drop. Within the drop function we are going to pass in the column names. I'll say number. Then we also don't want the position column. Next we have position underscore text. After that we have laps. Next we are going to drop fastest lab. Then we'll also drop the status ID, comma. We'll drop the result underscore ID column. Then going to drop the race underscore ID column. We'll also drop driver underscore ID column. And finally, we are going to drop the constructor underscore ID column, and I'll say access equal to 1, and in place I'll say equal to true because I want to remove it from my original data frame, that is df. There you go. Now the next thing I want to do is I want to rename some of the columns. So I'll say df dot rename. I'll say columns equal to, now we are going to pass in a dictionary. I'm going to change the rank to test underscore lab underscore rank. Let me give a comma. Now I'll say name underscore x equal to, I'll say the Grand Prix name. So I'll say GP underscore name. Next column I'm going to focus is the nationality column. So I'll say nationality underscore x. I'll give a colon. The value I'm going to pass in is driver nationality. All right. Up next, we have one column called underscore y, and that I'm going to change it to constructor name. Another comma, I'm going to say nationality underscore y colon, change it to constructor nationality underscore nationality. Finally, we have driver underscore ref column, and that I'm going to replace with just driver. Finally, I'll say in place equal to true. Cool. Just verify if all the column names are correct. Let's run it. All right, so now we have successfully renamed the columns. After that, in the next cell, I'm going to rearrange the columns. So here I'm using the same data frame and we have just renamed the columns. So starting with year, Grand Prix name, round, driver, nationality, and others. Let's run this. Up next, we're going to drop the 2019 season data because it is incomplete. So I'll say df equal to df, then I'll say year not equal to 2019. Let's see how to sort the values. So I'll say df equal to df dot sort underscore values, which is the function name. I'm going to sort it by year followed by round followed by the position underscore order, comma, I'll say ascending equal to first, let's say is false, next I have true, and then I'll have true. Alright, moving ahead, now we are going to see how to replace the /n values in the time column with something called NaN, because the time column was not registered when a driver did not finish a race or was lapped by another driver. So to do this, I'm going to say df dot time dot, I'm going to use the replace function, and here I'll say / or /n, and I'm going to replace with numpy's NaN. I'll say in place equal to true. Let me just copy this because we are going to use the same meters. Next, I'm going to replace the milliseconds value, the milliseconds dot replace, I'll paste it here, then I'll say df dot fastest underscore lap underscore rank dot replace, paste it. Next I have df dot fastest dot lap dot time, they replace. To that I have the next column, which is speed, so I'll say fastest underscore lap underscore speed dot replace, I'll paste it. So here I'm going to replace this particular value, the backward /n, with NaN. Let me run it. Cool. Step, I'm going to change the data types for fastest underscore lap underscore speed to float, then fastest underscore lap underscore rank to float again. Now problem here is we cannot convert it into an integer because there are missing values, so we are going to change it to float. Again, for milliseconds also we are changing it to float values. Let me run it. Now I'll reset the index. Let me show you how to reset the index. I'll say df dot reset underscore index. I'll say drop equal to true. I'll give a comma and say in place equal to true. All right, that we have done our initial processing step of the data set. Now we'll check the shape of the data set. Then we see all the data sets, the total number of non-null values, the memory usage, and we'll check the head of the data set. Now to see the total number of rows and columns, I'll say print df dot shape. You can see here there are total 24,197 rows in my dataset, and there are total of 15 columns. Now let's use df dot info function. So it gives me the year, the Grand Prix name, the round number, driver, constructor name, grid, position order, total number of points, time, then time in milliseconds, the fastest lap rank, the fastest lap speed, the nationality of the driver, the nationality of the constructor. Then here we have the total number of non-null objects, and then you also have the memory usage at the bottom. Finally, let's see the head of the data frame. So I'll say df dot head. Let's say I want to check the first 10 rows. There you go. If I scroll down, you can see here we have the top 10 rows printed, and you have the year, the Grand Prix name, round, driver, constructor name, and other columns. Now let me just brief you about what these column names stand for. So the year column that you see here is the season that the Grand Prix took place, and then we have the name of the Grand Prix. Now the round column is the number of the race in each season. For example, 1 means it was the first race of the season, and then 2 means it was the second race of the season, so on and so forth. Then we have the name of the driver. For that we have the name of the car constructor, so you can see Ferrari, Mercedes, Red Bull, Renault. Then we have the grid, that is the starting position before the race. Actually, this depends on the qualifications which occur 1 day before the race. Then we have the position underscore order column. This means the final position at the end of the race. Then we have the points column, that is the total number of points scored in the race. Next we have the time, that is the amount of time that took to finish the race. Only the winner's time is displayed, and drivers behind the winner are shown how far behind the winner they are. Then we have the milliseconds column, that is the amount of time that took to finish the race in milliseconds. If I just scroll down, I'll just move to the right, go to the top. Then we have the fastest underscore lap underscore rank, that is the order of the fastest lap during a race. Next we have fastest lap time, that is the shortest amount of time that took to complete a lap in the race. Then we have the lap speed, that is the average speed of the fastest lap. Then we have the country to which the driver belongs to, and then we have the constructor nationality, that is the country where the car constructor is based out of. Okay. Now here I'm going to set my figure size to 10,6. This is going to be for all the plots that we are going to create afterwards. Cool. We'll create a data frame that will have all the Grand Prix winners. So here I'm going to say driver underscore winner equal to, use my data frame df dot, I'll say loc, then I'll say df, I want the position underscore order, and that should be equal to 1, so which means the driver won the race. And then I'm going to use the group by function. I'm going to group it by driver, and for values I'll say position underscore order, use the count function followed by sort underscore values. I'll say ascending equal to false. Change it to 2 underscore frame dot reset underscore index. So what essentially I am doing here is I am finding out all the drivers that have participated and won a Grand Prix. Next, I'm going to create a bar plot. So this is going to be the first visualization of our analysis. So I'll say SB, which we have taken in our analysis. Ideally it should be SNS, but SB also will work. So I'll say SB dot bar plot. I'm going to say data equal to driver underscore winner. In the y-axis, I'll have driver. In the x-axis, I'll have position underscore order. Then I have color equal to green. That I'll set my alpha value to 0.5, or let's say 0.8. Then we are going to give a title to our plot. So I'll say plt dot title, let's say most Grand Prix winners in F1. Then we are going to label our axis. So for Y label, I'll have driver name. We have the X label that will have number of Grand Prix wins, and I'll say plt dot y ticks. Cool. Let's run it, and you can see we have our first bar plot here. Now the bar plot shows that there are a large distribution of Grand Prix wins. Only a few drivers in history of F1 have won over 20 Grand Prix in their careers, and there are some drivers who completely dominated the F1 racing and have won over 50 Grand Prix in their careers. So we are going to focus on those top 5 or top 10 drivers in the next section. So what I'm doing here is, from the above result that we just got, I'm going to filter out only the top 10. So I'm going to use the head function, and inside that I passed in 10. If I print it, you can see here, as per the data that we have Michael Schumacher, who is the position order leader with 91 GP wins. Then we have Hamilton, Vettel, Prost, Senna, Alonso. Then we have Stewart, Clark, and Lauda. The data that we have is not the most recent one. So if you check the actual stats, Hamilton has actually overtaken Michael Schumacher and has won over 103, close to 103 races as of now. And next we have Michael Schumacher. So this is not the most recent data. Cool. Now using this data, we'll create another bar plot for the top 10 drivers. So I'll say sb dot bar plot. I'll say data equal to the name that we have used, that is top 10 drivers. So I'll say top 10 drivers. In the y-axis, we'll have the driver name. In the x-axis, we'll have position underscore order. For the bars, I'm going to use a color equal to, let's say, blue this time. I'll set my alpha value to be 0.8, and I'll say, let's say, line width equal to 0.8, and I'll also give an edge color of, let's say, black. Cool. Follow the same drill. I'm going to give a title to my plot. So I'll say plt dot title most GP winners in F1. I'll give a Y label that says driver name, and then I'll have X label, which will have number of non-prey wins. Cool. Let me see if everything is fine, and then we'll run this. There you go. You can see we have a very nice horizontal bar plot that shows the top drivers in F1. So as per our data that we have Michael Schumacher, who has won over 91 or close to 91 races. Then we have Hamilton, Vettel, Alonso, Clark, and others. All right. In the same way, we are going to create bar plot for the top constructors that have participated in F1. So here I'm finding out all the constructor winners. So here I'm using my position underscore order equal to 1, and then I'm using the group by based on the constructor name, and then I'm finding the count of position order and sorting the values in descending order, and I'm changing it to frame or to a data frame. And to create my bar plot, I'm using the bar plot function, the data which is constructor underscore winner. In the y-axis I'll have the constructor name, on the x-axis I'll have the position order. So you can see here I've used color as pink, and I've given a title, x label, y label, and y-ticks. Let's run it. There you go. So here you can see again the data is widely spread. So we have a lot of constructor names. Now our next task is to check the top 10 GPA constructor winners. So here I'm using the head function and finding out the top 10. If I run it, you can see here the manufacturing companies or the constructors who have won the most number of races are Ferrari, McLaren, Williams, then we have Mercedes, Red Bull, Team Lotus, Renault, and others. Okay, now we'll convert this data into a horizontal bar graph or a bar chart. So that will show the bar plot for the top 10 constructors. Now let me show you how to do it. So I'll say SB, which is for Seaborn dot bar plot, going to say data equal to top 10. Let me just confirm the name. We have top 10 constructors. Scroll down, I'll say constructors. The y-axis I'll have constructor on the x-axis I'll have position underscore order. Then I'll say color equal to, let's say we'll use the red color for the bars. Then I'll set my alpha to 0.8. I'll say line width equal to 0.8, and my edge color I'll say black. That I'll say plt dot title, say top 10 most GP wins. Plt dot y label would be constructor name, and I'll have plt dot x label as number of GP wins. Cool. Let's run it. There you go. So here you can see we have Ferrari at the top, then we have McLaren, Williams, Mercedes. I'm pretty certain by the end of 2021 season, Mercedes would have gained a lot of wins since Hamilton has been on the top for Mercedes for quite some time now. All right. Now, finally, we are going to create a regression plot that will show how two variables, that is the starting position and finishing position, vary. So to do that, I'm going to exclude the data points with grid 0 because it skews the data. So 0 means that the driver started from the pit lane. So I'm using this function called reg plot to plot my regression line. Let me run it and show you the result. There you go. So if you see here, we can easily see there's a linear relationship between the starting and finishing position. So on the x-axis we have the starting position, on the y-axis we have the finishing or the finished place. So which is what is actually expected, right? Now we can also see that most races had up to 25 drivers. You can see the density of the points here, but some of the races also had over 30 drivers. You can see the light color blue dots. Next, we are going to check whether the speed of the cars changed over the years. Now, since this data is only available from 2004 onwards, so we have taken years that start from 2004 onwards. Now let me show you the result of this data. So essentially we are plotting the average speed amongst all teams during the fastest lap at individual Grand Prix, and here on the y-axis you have the average fastest speed in kilometer per hour, and then you have the different GPs, and you can see here the year values. Now in general what we see is there's a decrease in the average fastest lap from 2004 till around 2015 for almost all the circuits, and again from 2015 onward the speed started to increase. You can see here there's an increase after 2015, there's an increase here as well. You can also notice that the speed is very different on each track. For instance, if you check the Italian Grand Prix, which is here, Italian GP has the fastest race in the calendar with average speed exceeding over 240 kilometers per hour. On the other hand, if you talk about the Monaco Grand Prix, let me show you. If you see here, the Monaco GP is the slowest race with average speed below 160 km per hour. Now this is actually expected because the Monaco Grand Prix has very narrow streets and hence the drivers cannot drive fast in this circuit.
Data analysis using Python and taking the top 1000 Instagram influencer dataset. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. I'm repeating again, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. In today's session, we will go through the data analysis using Python. We already have a dataset with us where we have data of top 1000 Instagram influencer. We will analyze this dataset using Python. Before we move on to the programming part, let's discuss data analysis and the steps and the importance of the same. Data analysis is a process for acquiring, arranging and changing data so that prediction about the future and the data-driven decision can be made. Finding potential answer to business problem is also helpful. Let's move forward and see steps to perform data analysis. So first one is define the question. What commercial issue are you attempting to resolve? By raising it as a query, you can concentrate on coming up with a precise response. And the second one is collecting data. To answer specified research question, test a hypothesis, and evaluate outcomes, data collection is the act of acquiring and measuring information on variables of interest in a systematic and defined manner. And the third one is cleaning data. Your data should be explored, cleaned up, and deducted and organized as a necessary. Do whatever needs to be done, but wait a moment, give it some time. And the fourth one is analyzing data. Perform a variety of analysis to gain insights. Concentrate on a descriptive, diagnostic, predictive, and prescriptive types of data analysis. And the fifth one is visualization and sharing your findings. How can you most effectively impart your knowledge and suggestions? The trick is using communication and visualization technologies together. After seeing the steps to perform data analysis, let's move forward and see some importance of data analysis. So, Python is a high-level open source interpreted language that offers a fantastic approach to object-oriented programming. It is the one of the greatest language for a variety of projects and applications. According to data scientists, working with mathematical, statistical, and scientific function is a breeze with Python. It provides top-notch libraries for working with data science application. Python is the one of the most widely used programming language in the field of science and research due to its simplicity and use. This means that even those without engineering skills might quickly learn how to utilize it. Furthermore, it works better for rapid prototyping. There are some most common libraries used for data analysis. The first one is Numpy, Pandas, Matplotlib, SciPy, Seaborn, and many more. So, what do you guys think about data analysis? Do share your thoughts with us in the chat section. Now, let's move to our programming part to perform data analysis using Python. So first we will open command prompt to write command to open Jupyter Notebook. So we will write Jupyter Notebook. Press enter. So this is the landing page of Jupyter Notebook, and select open new Python file. So this is how the UI looks like. So at first we will import some major libraries of Python, which will help us in mathematical functioning. So the first one is Numpy. Numpy is a Python library used for working with arrays. It also has a functions for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. Numpy stands for numerical Python. So we will write import Numpy as np. So here np is denoting Numpy. So we will import the next library is Pandas. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. So we will write import Pandas as PD. Here PD is for denoting pandas. So we will shift close back. So after importing the libraries, we will move ahead and import dataset. So for importing dataset, we have to write data equals to pd dot read underscore csv, and here we have to write our dataset name, dataset insta dot csv. Press shift plus enter. Yeah, here PD is for pandas library, read is used for reading the dataset. from the machine, and CSV is used for the type of file which you want to read. So then we can write data to see our data. So see, this is how our data set look like. So let's first rename this column name followers. This one, followers in million, by writing followers only because it is so lengthy, and this followers column we are going to use most of time. So it will save our time. So we will write here data dot rename column equals to that curly braces. Here we will write the name of column which you want to rename followers in millions. Colon to followers. So here we will write in place equals to true. Okay, then here we will write data okay, it is not changed yet. Okay, because it is followers. To give one space here. Yeah, done. So rename function is a function which is used to rename the column name. So there are many keywords arguments like index, column, axis, copy, in place, level, errors, which you can use as a parameter. So column name is changed to followers. Let's move on. So here you can see the three dots, this one. And we are unable to see our full data, like only we can see the 10 rows. So like we have 1000 rows, right? So for that we can write here we can write pd dot set underscore options display dot max underscore columns, and here we can write none. After that, this is for columns, and we can write for the same for the rows sort underscore options. It is option, not options. Okay, we can write here display dot max underscore for rows. Perfectly done. Okay, we can write here none. Yep. So pandas features and options, this one, system that allows you to modify various aspects of their behavior. Users are most likely to change display related options. So the maximum number of rows by default is 10. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the maximum number of rows by default is 10. All rows of data frame are considered if the value is set to none. Set the display value by setting as max rows to none and passing it to the set option. All rows from the data frame will be shown. So let's move on and see our full data by writing data frame name here. So okay, let me debug the error. Okay, here column name LUMNS. Okay, sorry. So here we can write data So see, this is how our data look like. The 1000 rows. With full 1000 rows, like from 999 to 0. Yeah. So moving ahead, here you can see the NaN values like this. NaN and below NaN, NaN. So NaN means not a number, and it is one of the typical methods for representing the dataset missing values. It is a unique floating point value and can only be changed to the float type. So let's change it to 0 for the better result and the better prediction. So we will write here data dot fill NA 0. So by writing this, we will shift plus enter. So all NA values are now changed to 0 with the help of this fill NA function. This fill NA method replaces the null values with a specified value. So after this, let's move on to the another function which is shape. So we will write data dot shape, then shift plus enter. Yeah. So this shape function will return you a number of rows and columns your dataset have. So here we have 1000 rows, you can see, and 7 columns. Yeah. So let's move on to the another amazing function which is info. So here we will write data dot info. Perfect. So data frames information is printed by the info method. The data includes the total number of columns, their labels, data kinds, memory use, range index, and another number of cells in column. Note that the information method does indeed print the information. So here you can see all information has been printed, like all the columns name, all the non-null values count, and data types for the particular column. So let's move forward and see our next function, which is data.columns. So which is data.columns. Okay, again I wrote wrong. LUMNS. Okay, perfect. So as per the name, you can easily tell me in the chat section what is going to print for us. So this function is going to print all the columns name. So here we have names like name, rank, category, followers, audience country, authentic engagement, engagement average, data type is object. Why data type is object? Data type is object because this is taking as the one category, that is why it is taking as an object. So let's move forward for the next function, which is describe. So data frame comprises of numerical data, and each column's description includes the following details like count is the total amount of non-empty values, mean, the standard deviation, and many others. So here we will write data dot describe open brackets. So C. So here you can see all the columns which have numerical data is displayed by the full description. So this is our mean, count, STD, minimum, 25% of the particular date column, 50% and 70%, and the maximum value present in the column. So moving forward, let's solve some questions like how to show audience country, like from which country we have the most number of followers. So let me write this question as a comment. So for comment, we have to use hashtag. So here you can write how to show audience from which country we have most number of followers. Okay, perfect. Yeah. So let's solve this with a small line of code. We can write here data, here column name as audience country dot value underscore counts normalize was to true, Then we will round it to 2. Okay, here we have to write the capital T. Perfect. Yeah. So returns an object with counts of distinct value. The resulting object will be arranged in descending order, with the first element being the one of the that appears most frequently. By default, exclude any values. Index value count, normalize equals to false, sort equals to true, ascending equals to false, or bins equals to none. Is a syntax of counting values. The normalize function in Python processing package is used to normalize the data. It accepts an array as input and converts its content to a range between 0 and 1. After that, it will give back an output array with the same size of input array. If we remove round function, it will show the output like it is still showing the values, but we round this value for how many decimal places we have to see the value. That is why I has written 2 here for 2 decimal places. So we will write here. Yeah, the data look like good. So from this question we can say maximum audience is from United States with like 28%, followed by India like 16% and Brazil 15% and so on. So let's move to the our next question, which is how to show audience country, like who is having more followers from India or a particular country. So let me write it as a comment. So how to audience. Okay, this is 3 hashtag show audience country, like who is having more followers. The question is that like which influencer is having more followers from India. So don't worry, we will like do for the more and more countries. So here I have to write data underscore ind for India. So equals to data and again data. This is our data frame name. So audience tree. Here we can write double equals to yeah. Here we can write data. So here we are giving data ind name of you can say a variable name, and data is our data frame name, and audience country is column name, and India is a country name from which we want to collect influencer. So let me do this. Let me debug the error. Audience country. Okay, C is capital here. Yeah, perfect. So these all influencers are who has audience from India. So like Cristiano or Virat Kohli, that Khabi, Justin Bieber, Instagram, Zayn, The Rock, and so on. So let's take another country this time. We will take United States. So we will write here data underscore USA. Okay, data again and audience. C is capital now. Country perfect equals to it is USA or United States. In the United States. Perfect. So United States. So data dot USA This time I'm using score and dot head. Right. So we have to write same code like we did for India. Here I have used the head function. You can see the head function to show only 5 first rows. You can also write only data USA, so to see the full data. So I will write like this. I can do like this. So here I can see the full data. The influencer who belongs to United States, that audience country who belongs to United States. So I will control Z for head function. Yeah. So okay, let's do for one more country, Brazil. So let's write data underscore Brazil pursue data again data right, audience is capital country equals to Brazil, how it is written. Brazil. Okay, Brazil P capital. So here we will write Brazil P is capital. Forgot Brazil. So here we will write data underscore Brazil. So we have to write same code like we did for India and USA. So here let me use a function called tail. So here I have used the tail function to show only last 5 rows. Head will show you the first 5 rows and the tail will show you the last 5 rows. So you can also write only Brazil to see full data. So let's move forward and see our next question, which is like how to show audience for a particular category. So let me write this question as a comment for your better understanding and readability. So here we will write how to show audience for a particular category. Okay. So this time I will use fashion category. So let's write code for this one. So fashion equals to data underscore USA data underscore USA. Right here category okay dot str dot contains right here fashion comma na equals to false. Okay, fashion bats. Yeah, here I'm using the data USA set for retrieving the fashion category. We can do this for all the data using our data frame name. We can also write data only here. So I have given the column names as a category and str contains means string which contains fashion. This is what we have to print and na should not be false. Okay, so let's see why it is showing this data underscore USA. Okay, here F is capital. Is capital. So yeah, perfect. See these all influencers which have audience from United States like Kendall Jenner, Zendaya and Beyonce. So these all influencers which have audience from United States and belong to some kind of fashion industry. So moving ahead, let's take one more category. This time we will take sports category because sports is something like which most of people like. So we will write here sports equals to data. This time we will take India dataset. IND. I guess we have wrote the same. Yeah. So here we will write data underscore ID and category same str dot contains. Perfect. We will write here. We check one thing. So sports S is capital. Sport comma NA equals to false. Then sports again. Okay, this time we will use sports dot hat. So use India data and all the things are same, just replace fashion with the sports. So see, these are all the influencer Cristiano, Virat Kohli, Khabi, Rohit Sharma, Hardik Pandya, which have audience from India and belong to some kind of a sports industry. So as I'm talking before, like we can use data frame name for all data instead of using like India data or like this one. So we can also write like this data only. Okay, let me create one more for the for only data. So we can write like here sports so data. Here we can here we are like taking our data like full data frame name. So we can write category name. So dot str dot contains sports comma na equals to false. Okay, here we will write sport. Okay. So as I'm talking before, like we can use data frame name. So instead of like writing only data India or data USA Brazil. So these influencer like from sports category belong to any one country. So this is our full influencer category. So let's move forward and do this again for the music category, like because music is also one of the favorite category of you folks. So we have to write music. Okay, music equals to we will do is for the whole data. So data category dot contains I guess M is capital in music. Yup, it's capital. So music N equals to so this data will contain all the category influencer name which belongs to music category, whether they are from India, USA, Brazil, or any other country. Doesn't matter. See, you can see Indonesia, South Korean. So moving forward, let's change our some column data types to integer type. So we can write here data equals to data dot as type round bracket, then curly braces. So here we can write followers, if followers. And then it should be changed to integer. And take it from here, authentic engagement. Overcome the spelling mistakes, so I can take from here integer. Let's do for one more engagement average. So integer. So here we can write data dot head. Yeah, perfect. All the columns change to integer type now. So this is how we can change like data type in column. Here, like data is our data frame name, this one, and the AS type, this one, AS type is the method like which gives a back a new data frame with the requested data type for the data. To select a data type for each column, you can either cast the entire data frame so that the type, or I use Python dictionary like in the following example, like calories, pearls, or whatever, respectively. I repeat, calories, pearls, duration are all like integers value respectively. So let's move to our next question, which is like top 20 category by follower. Before making graph for this one, let me create like top variable followers. So here I can write like 20, top 20 followers to data dot n largest and largest, like we need 20, so we can write here I am writing followers spelling like this because we have to like this, followers, follwers. So perfect. Yeah. So top 20 followers we have taken as a variable name to store followers and to obtain the first n rows arranged by the columns in descending order. Use of the n largest function, which is this one, n largest function. Specified columns are also returned. I repeat, but they are not used to determine ranking. So data frame dot n largest, you can write the syntax like this: self comma like n comma column names, or keep, you can also write keep equals to first. So top 20 followers are generated. Let me create graph. So first we will import library, like one of the main library for visualization, which is matplotlib. So for importing this we have to write import. Okay, so we can also write like, instead of writing import, we can also write from matplotlib import import pyplot as plt. So for the Python programming language and its NumPy numerical mathematics, matplotlib is a graphing library with the help of general purposes like GUI toolkits like Tinker, Python, Qt, and GTK. It offers an object-oriented API for embedding plots into applications. So after this, let's create the figure. So we have to write plt dot figure, like again figure size equals to We can take 12 and 8. Perfect. So we will get figure 2 here equals to plt dot bar top 20. We have take followers dot category comma category top 20 followers. Okay, followers dot followers comma, like label should be followers it should be like I'm taking 0.8 here, and my favorite color is maroon, so I will take maroon color. So plt dot xsticks font size should be like 12 and rotation should be 90. Perfect. So let's create y and x labels. So plt dot y label followers comma font size should be, let me take 16 here, and plt dot x label category, and font size should be 16. So let's set the title for this now. For plt.ti title is top 20 categories towards comma font size should be, let's take it as 20, and plt dot underscore layout this one, and we can write plt dot tick label underscore format is equals to y style should be plain. Okay. So this is how the visualization look like. Here I have used the bar graph for this visualization, and top 20 followers dot category, and this one top 20 followers dot followers are the x and y values, and color is something like which color you want to show with, and you can choose as your preference, and x and y labels are used to print in x and y coordinate like this, followers in millions and category. So this tight layout, this tight layout in I repeat, this tight layout function, this one, this tight layout function, this tight layout function in pyplot module of matplotlib library is used to automatically adjust subplot parameters to give a specified padding. So plt.tick label format is used for in which axis or in which style you want to print. Plt.tick label is not necessary to write or to showing paragraph. So like when we can remove this, so our visualization should look like this. So it is not necessary. Okay. Tool Z. So let's move to our next question. Like using bar graphs, let's see how our category look like. So first we will create, I'm writing here, showing categories using pie chart. Okay. So using pie chart, let's see how our category look like. First we will create categories. So we have to write here like types equals to data dot category dot value underscore counts, and this one, yeah, types, okay, types dot reset underscore index. Yeah, here we have used types as a variable and value counts, like we already discussed before. So these all are the categories from our data. So let's create the pie chart now. So for plotting a pie chart, we have to write plt dot pie like types dot values comma label should be types dot index. This one, label should be type dot index. This music, cinema, lifestyle, modeling, and so on. So index comma label distance equals to 1.2, and then auto PCT should be like percentage 1.2 F percentage. So like shadow should be true. Perfect. And let me add one more thing. Start angle should be 60. Okay, so plt dot title is like, you can say different categories comma font size should be 20, and let's plt dot plot. So let me check everything is correct. Values, labels. Okay, here we can write labels. Type dot values labels equals to type dot index, and label distance equals to 1.2. So here auto PCT is equals to like, okay, shadow equals to true, perfect, and starting is equals to 20, 60. So plt dot title different categories. Okay, fine, everything is great. So it's not coming. Okay, perfect. So this is how our pie chart look like. This is looking like a mess because we have more than 100 categories. That is why like 100% is splitting into 152 categories. Like you can see here, we have 152 categories. Okay, so this is how, sorry, this is how our like pie charts look like for our different categories. Let me write D capital. Yeah, perfect.
Creating a Telegram bot using Python. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. In this session, we will create a Simplilearn bot that will help its users to choose from various courses offered by Simplilearn. Now, let's understand the uses of bots. The first use of bot is to get customized notifications and news. A bot can act as a smart newspaper, sending relevant content to its subscribers as soon as it's published. The next use is accept payments. A bot can offer paid services or work as a virtual storefront. Another use is create custom tools. A bot may provide you with alerts, weather forecasts, translations, formatting, or other services. And another use is build social services. A bot could connect people looking for conversation partners based on common interests or proximity. With the understanding of uses of bots, now let's create our own bot. You will have to follow the steps to create a Telegram bot. And the first requirement to create a bot is you should have a Telegram account. Now let's move to Telegram. And using the Telegram, we will interact with the Telegram bot further, which is going to provide us with the bot and the token, which will act as a password for that bot. And then we will create a Python program to do all these interactions. So you need to get the Telegram app whether on the desktop or in your mobile phone. I'm going to use desktop versions. You can download the desktop app from desktop.telegram.org. I will show you how to download it. desktop.telegram.org. Here you can see that Windows bit64 version is available, and you can see all the platforms and you can choose according to your needs. I have installed the Windows 64-bit version and the Telegram app. Now we'll search for the bot further. And be careful and click on the verified one with the blue tick. This is the one. Just click on it and you can click on the start to start the conversation with the bot further. You can see the various commands here. And BotFather is again a bot which Telegram has created in order to do automation of all the bot creations. And now to create a new bot, we'll start with the command /newbot. Here you can see this is the command. You can click on that or just write here /newbot. Now the father bot has replied, all right, a new bot. How are we going to call it? Please choose a name for your bot. So here you have to choose a name for your bot. I will go with the name Upskill by Simplilearn for my bot. Now the father bot has replied good. Now let's choose a username for your bot. It must end in bot like this, for example Tetris bot or Tetris_bot. You need to make sure that the username is unique and it ends with _bot, or it should have bot at the end of the username. BotFather will inform you if your username is already taken. So I would be going with the username upskill_1122 Simplilearn_bot. And the BotFather replied, done. Congratulations on your new bot. You will find it at, this is the link. Hey, if you click it, you will just get to your bot. And we have received the token for our bot. Here you can see, use this token to access the HTTP API. This is your token. And the BotFather said, keep your token secure and store it safely. It can be used by anyone to control your board. As soon as you receive the token, you have to write another command, that is /set privacy, and press enter. It will change the privacy settings for your board, so no one can misuse your board token. And now you have to choose the port you want to change the privacy settings. So we are currently working on the upskill _1122 _Simplilearn board. So we'll choose this, and here you can see that the security is enabled. You have to write disable or choose disable from here. Now success, the new status is disabled. So your board is now secure and your token can't be misused by anyone else. This is how we created a board, and now we'll use this in Python program. First, we will see the external packages we need to install for this project. For that, we will move to command prompt and install the packages. The first package is pip install python -telegram -board. As you can see, the package is already installed on my system, so you have to install the package and then open your IDE. For that, I will create a folder and I will name it as Telegram board. And inside I will open my IDE. For that, I will write the command cmd and open my Visual Studio Code. Now I will create a new file and name it as telegram.py. And now first thing I will do is import telegram.ext. Now we are going to load the token provided by the board further. So we'll move to Telegram and copy the token provided by the board further. So this is our token. We'll copy it and move back to our IDE and create a new variable that would be token. A token in it. Now we'll create the updater object. This object will be used to perform actions with our board. So we're going to write the command updater equal to telegram.ext dot updater, and we'll pass the token and use context equal to true in it. First we will copy our token and pass another variable, that is use underscore context, and that would be equal to true. And now we're gonna get the dispatcher. We'll create a variable with the name dispatcher, and that would hold updater load dispatcher. Now we'll add the functions to give our board some functionalities. We will start with the start command. It's the first command usually given to the board. For that, we will write define, that would be defining the function with the name start, and inside we will pass update and context. As we have used the use underscore context as true, we will use the context for some information. And when someone starts the conversation with a board, what should be our first message? We will set the first message as welcome to Simplilearn. For that, we'll write update dot message dot reply underscore text, and inside we'll store a message that would be hello. Welcome to Simplilearn. Next, we'll define another function that is help, and for that we'll write the command df help, and we'll pass the same update and context. And inside this function, we will send the message with the commands that would be start, help, content, and the Python playlist or SQL playlist or Java playlist that the user wants to persuade or which course he want to persuade. So we will start with date dot message dot reply underscore text, and inside we will define all the commands. So we will go with the triple columns. So our first one would be start, and it would symbolize welcome to the channel, and our next command would be help only, and it would indicate this particular message. The next command we will define as content, and this would be about various playlists of Simplilearn. The next we'll start with the Python playlist, and if the user write this command to a bot, he will just direct it to the first video from the Python playlist. And next command we would write about SQL, and it would also direct it to the first video from SQL playlist. And the next up command would be about Java, and it would also direct to the first video from the Java playlist. And we would also set another command that would be contact, and that would hold the contact information if someone wants to contact to Simplilearn for further information. And now we'll define all these commands. For that, we'll write the function and content, and we'll pass update and context, and inside we'll just output to the users with the command update dot message dot reply underscore text, and the output that would users will see is we have various playlists and articles available. And now similarly we will update the next function. We will copy this so the token would paste it here. We will copy the function, and our next function would be Python. So if the user type Python in the chat board, so he will just direct it to the first video from Python playlist. For that, we will copy the link of the first video from the playlist Python and paste in the message.reply underscore text. And for that, we'll write tutorial link and paste the link of the video. And now we'll do the same for SQL and Java. We will copy the function and change the name to the SQL. And copy the link of the first video of SQL from the playlist. And now we will do the same for the Java. For that, we'll copy the function and paste here and name it as Java. Now we'll move to the Java playlist and copy the link of the first video from the playlist and paste it here. Now we are done with the functions Python, SQL, Java, and we're left with contact. So we will declare another function. For that also we will copy the same function and name it as contact. And inside you can contact on the registered mail ID provided on the website. So these are some functions which we can add to the dispatcher. We will create a command handler to handle the certain command and map the function to it, and then add the command handler to the dispatcher. So first we will write the command. That is dispatcher dot add underscore handler, and inside we will write telegram dot ext dot command handler, and inside we will pass the name of the command that will be inputted by the user and the function name. For that we'll write the command, that is start, and the function defined by us for the command start is also with the name start. Now we'll copy this command and do the needful for all the functions. So here we will change the command that would be Python. And the function name. And the same for SQL. And same for Java. And we're left with the last command, that is contact. And in the end, we'll write command updater dot start underscore polling. So it will check if our code is working or not. And updater dot idle, it is used when the user just enters the first command. So it will not exit the program, it will wait for user to enter other commands. And we forgot to write a command for help. For that, we'll copy the command. And write help. We'll save the program and click on the run button. Here we can see that the program is running fine. Now we'll move to the Telegram and click on our bot username. You can also search our bot username here. It's globally searchable. Now we'll click on the start. So on the start command, we have got the output, hello, welcome to Simplilearn. Now we'll input /help, and here we have got all the commands, that is /start, /help, and this particular message will appear when we click on the /help, or just write it here. When we click on /Python, we will get the first video from the Python playlist, and when we click on the /SQL, we'll get the first video from the SQL playlist. And similar with the Java, we'll get the first video from the Java playlist, and when we click on the command /contact, we get the output, you can contact on the registered mail ID provided on the website. So we have done with our Telegram bot. We have created the Telegram bot successfully.
Hello everyone, I am Mayank and welcome to Simplilearn. Today we will take you through the hands-off lab demo of how you can create face detection using OpenCV Python. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. I'm repeating again. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. If I forgot to reply someone's comment, sorry for that. Let's wait for some more minutes to let other people join. Until then, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek on a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great, I think we can get started. So in today's session, we will see what OpenCV is. Moving forward, we will see what is face detection, and at the end, we will go through the hands-off lab demo of how we can create face detection using OpenCV Python. We will perform different functions and use different Python libraries to create face detection. Before we move on to the programming part, Let's discuss what OpenCV is and proceed further for the same. What is OpenCV? A collection of Python bindings called OpenCV. Python was created to address issue with the computer vision. Python is general purpose programming language created by Guido von Rossum that quickly gained popularity largely due to its ease of use and readable code. The programmer can express concept in less code without sacrificing readability. Numpy, a highly efficient library for numerical operation with a MATLAB-like syntax, is used by OpenCV Python. Numpy arrays are translated into and out of all OpenCV array forms. Additionally, this makes it simpler to interact with other NumPy using libraries like SciPy and Matplotlib. After understanding what is OpenCV, let's move forward and see what face detection is. So what is face detection? Face detection, also known as facial detection, is a computer technology that uses artificial intelligence to find and recognize human faces in digital photographs. Face detection technology can be enable real-time surveillance and tracking of people in various industries, such as security, biometrics, law enforcement, entertainment, and personal safety. From basic computer vision method to developments in machine learning to increasingly complex artificial neural network and related technologies. Face detection has advanced leading to ongoing performance increases. It now serves as the foundation from some crucial applications such as face tracking, face analysis, face recognition. The application ability to perform sequential tasks substantially impacts the face detection. So, dear learner, if you want to upskill your AI and machine learning skills, so give a chance to Simplilearn Professional Certificate Program in AI and Machine Learning, which comes with completion certificate and in-depth knowledge of AI and machine learning. Check this course detail from the description box below. So here is one question for you guys. I will give you exactly 1 minute for this. You can comment or give your answer in the chat section so I can see if the answers given by you are right or wrong. So the question is, which of the following function is a built-in function in Python? Factorial, print, seed, sqrt. So I am starting the timer of 1 minute. Just type your answer in the comment section or in the chat section. Please do let me know your answers. So I'm starting the timer of 1 minute. Which of the following function is a built-in function in Python? Factorial, print, seed, sqrt. Let us know your answer in the comment section below. I kindly ask that everyone take part in this session. Which of the following function is a built-in function in Python? 30 seconds more. Factorial, print, seed, sqrt. Please let me know your answer in the comment section below. 20 seconds remaining. Which of the following function is a built-in function in Python? 10 seconds more. Please let us know your answer in the comment section below. So after the allotted time has passed, those who provided the correct response will receive a response, and those who provided the incorrect response will receive one. So now let's move to our programming part to create face detection using OpenCV Python. So first we will open command prompt to write a command to open Jupyter Notebook. So here we will write Jupyter Notebook. Press enter. So this is the landing page of Jupyter Notebook, and here you have to select new Python file. So this is how the Jupyter Notebook UI looks like. So at first we will import some major libraries of Python, which will help us in creating a face detection system. So first let me rename this face detection. First we will import CV2. Press enter, then import another library, import numpy as np. And the third one is major one, import face recognition as fr. Then press enter. So CV means capturing video. The CV2 function is a open CV can read video capture by using pass 0 function parameter. We can access our webcam. We may pass as RTSP URL in the function parameter to capture the CCTV footage, which is quite helpful for video analysis. And another one is Numpy. Numpy is a Python library used for working with arrays. It also has function for working in the domain of linear algebra and matrices. It is an open source project. You can use it freely. NumPy stands for numerical Python. And the third one is face recognition. Face recognition and manipulation using Python or the command line. The easiest facial recognition library in the world. Built using cutting edge face recognition technology from DLIB, developed using deep learning. So moving forwards, let's import our video capture device. So for that, we have to write here video underscore capture. This is our variable name equals to cv2 dot video capture, and we have to pass here 0. Then press enter. Okay, here v should be capital. So the video capture function from OpenCV is used to interact with the cameras. What we can do is video can be read, shown and saved, display the image that the camera captured. So moving forward, let me import my image for the further detection process. Okay, so image equals to fr dot load underscore image underscore file, then image name or image path boy dot jpg. Press enter. Using load image file, we can import image file to our detection system. So moving forward, let's set encoding for the image. Okay, so I will write here image underscore face underscore encoding equals to fr dot face encodings and image, then 0. Press enter. Yeah. So face encoding basically uses 128 computer generated images to represent the face. Similar encoding would be present in two images of the same person while being completely different in two images of two distinct people. So moving forward, let me write first. I will write here known encodings equals to image face coding. Okay, then press enter. Then known face names equals to, then here I have to put my name, so I will write bank. Okay, then press enter. So what I did is I assigned known face encodings to my image face encoding. So what will happen if image matches to my face, then it will print my name, and for the rest we will add name unknown. Okay, so let me add the function now for face detection system. So let me write the full code for it first, then I will explain you line wise. Okay, so just stay tuned with me. I will write here. So I will write while, okay, true. Okay, so ret comma frame. I will explain you line by line. Don't worry. Equals to, then video capture dot read then RGB underscore frame equals to frame, then colon, comma, then again colon, comma, then 2 colon, then -1. Okay, yeah. So here I will write FC underscore locations equals to fr dot face underscore locations RGB underscore frame, right here FC is for basically face, encodings equals to fr dot face underscore encodings and RGB underscore frame, comma FC underscore locations. Okay, so for top, comma right, comma bottom, comma left. Okay, then I have to write here face underscore encoding, comma face underscore encoding. That was encodings, this is encoding. Okay, so before that I will write here okay, so I have to write here encoding in zip. Okay, then here I have to write FC underscore locations, okay, then comma, then face encodings, colon, then press enter. So here I have to write matches is, yeah, matches equals to fr dot compare and faces, then known underscore face underscore encodings, comma face underscore encoding. Okay, so it so what if the image will not match? So I have to give the name equals to unknown. Then we will write face distances equals to fr dot face underscore distances underscore face underscore encodings, comma face score encoding. Then I will write match underscore index equals to np dot ar g min. Okay, then I will write here fc underscore distances. Okay, then moving forward I will write if matches, then match underscore index. Okay, then colon, then name equals to known underscore face underscore names, then match underscore index. And I have to write here cv2 dot rectangle and frame comma top comma right. Have to give another bracket here, comma bottom, then comma 0 comma 0 comma 255, again comma, then 2 for the border. So then cv2 dot rectangle comma, then again left comma bottom, then minus 35. Okay, so then I will write right comma bottom comma, then again 0 comma 0 comma 255, then cv2 dot filled field. Okay, f should be capital. Yeah, so then we will set font equals to cv2 dot font. Okay, font underscore Hershey underscore simplex. Okay, so then I have to write here cv2 dot put text name comma name comma left plus 6 comma bottom minus 6. Okay, then comma font comma 1.0, then again 1 comma, then we have to set location like 255 comma 255 comma 255, then comma 1. Okay, and here I have to write cv2 dot image show im show, then like Simplilearn is detection. Comma frame, and if cv2 dot weight key is 1, and like 0x ff should be capital ff equals to ord, then quit. And here I will write break. I will write video underscore capture dot release cv2 dot destroy all windows. Okay, yeah. So let me explain you. So in general, RET is a Boolean value that indicates whether or not there was a even a return. Each frame that is returned is at the same frame. If there is no frame, you will receive none rather than an error. In OpenCV, reading and writing videos and reading and writing images are quite similar. A video is nothing more than a collection of pictures, often known as frames. So to draw a rectangle around the face that was discovered, we utilize the OpenCV rectangle. The rectangle function, we can draw the rectangle by using the points or corners position that the face location. And face encoding, this. A face encoding, this one. So a face encoding basically uses 128 computer generated measures to represent the face. Similar encoding would be present in two images of the same person, while being completely different in two images of two distinct people. So I use compare face. So compare face is used to compare my face to uploaded image one. Okay. If it matches, it will print my name. Otherwise, we have given unknown here. So the Numpy arg this one, where it went, this Numpy arg min. So the Numpy arg min method delivers the indexes of the array's minimum element along each axis. Return an array of array indices with the same shape of the array. So this font, where is, yeah, font Hershey Simplex is normal size of sans serif font. Okay. So put text is used to put the text on the frame like my name or unknown. So in order to display an image in a window, we use the IAMShow, this one, this IAMShow function. Okay. So the window adjusts itself to the size of image, parameters window name, a string that identifies the window in which the displayed image will appear. Okay. So until a key is pressed, wait key 0, this one. Okay. So until a key is pressed, wait key 0 will keep the window open. It is suitable for image display. And wait key 1, I write here, wait key 1. So wait key 1 will show a frame for 1 ms before closing the display on its own. So after the script has ended, users can close or remove all the windows use the Python, like using destroy all function. Okay, you would use the function if you wanted to close a window while it was open in numerous windows at once. So let's see our face detection system is working or not. So let me close this person on screen first. Okay, so let me close this first. Let me run this now. So here you can see this pop up and I will open. So here you can see my name is currently printing. Okay. So like I have uploaded my image, it's directing correctly. Okay. So like what if I show one more image? So here you can see this is my iCard. So it is detecting properly. Yeah. So what if I will show like another guy image from my mobile? So here you can see it is spraying unknown in Messi's photo. Yeah. So what if I will write here like one of the other image, this random.jpg, then it should print unknown for me also. Okay, then I will run it again. Okay, it's working. Okay, it's working. Yeah, pop-up has come. So here you can see it is now printing unknown because like I have uploaded that another random image here. So it is importing. Okay, so it is printing unknown here. So here you can see like it's printing unknown for me also.
Hi everyone, I am Abhisar Ahuja and welcome to the Simplilearn YouTube channel. In this session, we will create an OTP verification GUI using Python. But before we begin, if you love watching tech videos, subscribe to our channel, like the tutorial and hit the bell icon to never miss an update. And before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. And if there is any issue, do let us know in the chat section. And let us have a simple question to brush up on our knowledge. And please answer in the comment section below and we will update the correct answer in the pinned comment. And your question is, how is a code block indicated in Python? And your options are brackets, indentation, key, or none of these. You can pause the video, give it a thought, and answer in the comment section. Moving on, first we will see what's a project and how it looks like. So we will save it and run the program. You can see that the Tinker window has appeared, and this is our project, and this is what we're gonna make in this video. So using Twilio, I have received the OTP on my mobile phone, and that is 4601. And if I submit it, I can see the show info window that says that the verification is successful. And we have one more window for you guys. If you want, you can also make it. We will also discuss this in this video. So you can see this is the first window we will create, and after we click on the generate OTP button, it will redirect to the second window, that is verify OTP, and there you could just type in the OTP you get on your mobile phone, and the OTP I got is 6709, and I will just click on the submit button. It will show that the verification is successful. There's a recent OTP button and there's a timer, as the Twilio tokens, they are default available for 10 minutes only. So I have set up a timer for 10 minutes. If you want, you can also make the timer, else you could just go with the verify OTP GUI. And the recent button, it will just make the Twilio send the OTP again to our mobile phones if there is any difficulty in reaching the OTP to us. So moving on, now we will start with our project. That is, first we will create a folder and name it as OTP verification. And inside, we will open the command prompt and now we'll open the editor. I will be using the Visual Studio Code. You could choose any editor as you like, or you have the hands on any editor. So for that, I will write the command code space period and press enter. So here we will create the name of the file as program2.py, and now we should install and import the modules. For tkinter, we don't have to install it. Like, tkinter is a Python module that is used to develop GUI, that is graphical user interface. There's no need to install any module, as tkinter module is a part of the standard Python library. And here we need to install Twilio. So for that, we will open the command prompt and write the command pip install Twilio and press enter. As it states that the requirement is already satisfied, I have already installed the Twilio module and used it in the project. So you just have to write the command and press enter in the command prompt or in the terminal of your editor, and the rest would be done for you. So moving on, we will import the modules. So from tkinter, we will import all the classes and files, and from Twilio we will import the client class. And to generate the OTP, we will use the random module and generate the OTP with the random function. So we'll import random. And we would also be using the message box, but yeah, we will see it later on. So now we'll create a class in the tkinter. So in order to initialize the class, we use the __ init function. This creates a method that runs itself when we form an object from the class. So we will make a class and name it as OTP verifier, OTP _ verifier, and inside we'll pass tk colon, and as I said, we will make the init and pass self init. So we will create a root window and display it on the screen. For that, we will just run window.main loop to pop out the tkinter window. And for that, and before, we will just write the super yeah. Tkinter provides many methods, and one of them is the geometry method. This method is used to set the dimensions of the tkinter window and is used to set the positions of the main window on the user's desktop. So for that, we will use the geometry function and write the command self.geometry, and inside the circle braces, we'll set the y-axis as 1000, course x-axis with 580, and we would make it shift with 200 dimensions, and y-axis and 80 dimensions in the x-axis. Now we will configure the window. So we will use the config function. So config and configure function, they both are same, and they can be used on any widget to change settings that you may have applied earlier or haven't applied yet. So for that, we will write the command self.configure, and inside we will set the background color as white only for the tkinter window, and use the hexa code for the colors. You could use hexa code or just write white. So for white, we have 6 Fs. You can search for the code, the hexa code, or you could just write the white color. Now we will use the resizable function. So this method is used to allow tkinter root window to change its size according to the user's need, as well as we can prohibit the resizing of the tkinter window. So basically, if you want to create a fixed size window, this method can be used. In resizable method, user can pass either positive integer or true to make the window resizable. But if you want to prohibit the resizing of the window, you could just pass false or 0. So we would just prohibit it. We will write the command self.resizable So we have prohibited a window, and now Before executing code, Python interpreter reads source file and defines few special variables or global variables. If the Python interpreter is running the source file as the main program, it sets the special variable that would be the underscore underscore name variable as value equal to main. That value would be equal to underscore underscore main. If this file is being imported from another module, so the name variable will be set to the module's name. Module's name is available as value to name variable, that is the global variable. So to execute it, we'll write the command if name equal to main, and that would be in the inverted commas. Here first we will the class window equal to OTP underscore verifier, and now we'll write a command to run the main loop. That is the main thing to get a window popped up. So we'll save the file and run it. So we got an error here. So it is due to the spaces. We don't have to make spaces in the geometry method. And now we'll save it and run it. You can see that the tkinter window has popped up. Now we will make its GUI, and before that we will see the Twilio. So this is the Twilio console. You have to log in into that, and that would be your account SID, your token, and the phone number from which you will get the OTP. So I will show you the demo for that. You can just visit the Twilio website. So Twilio is an American company that is based in the San Francisco, which provides programmable communication tools for making and receiving phone calls, sending and receiving text messages, and performing other communication functions using its web service APIs. So this is the website. Here you can just go sign up. As I have the account already, I will just log in it. You will just write the first name, last name, email, and password. That should be 16 plus characters. And after that, you will accept it and start your free trial. It doesn't need any credit card or something. You can just use it without any payment mode. And after that, it will ask you to get your phone number assigned, or it will ask you like what purpose are you serving the Twilio. So you could just make it that you want to run it for your project or any code purpose, and after that you have to generate the phone number from which you will get the SMS. So I have my console already. I have logged in. So going to the code part, now we'll use Twilio to get our OTP on our mobile phones. So for that, we'll write the command in the class only, that is OTP verifier. We will use the client function. For that, we will create a variable self.client, and that is equal to, and use the client function, and inside we'll pass two parameters. That would be from the console. That would be the account SID. We will copy that and we'll paste it in the inverted commas. And the next parameter we'll pass is the authorized token that would be unique for you. We will paste this, and that would also be in the inverted commas only. And next, we'll write the command self.client.messages. That is, we'll use the variable above, that was the client variable, and we'll create the messages. And here we will write our phone number, that yeah, 2 and equal to, and inside the brackets we will write the contact number you want to receive the message. So here I am writing my contact number and not highlight it, as I can get the spam messages or spam calls, so I would not highlight it. And we will write the contact number that we have got from that value. And that contact number is my Twilio phone number. We will copy that and write from. So from underscore, and here we will paste the Twilio phone number, comma, and then the body. What body we want to receive as a text message from this number. So the body, we want to receive an OTP. So for that, we will use the random module and generate an OTP. So first we will create a variable, store it in a variable n. For that, we should use the random module to generate the OTP. For that, we will just make a function and name it as OTP only. And inside, we will pass self, and in this function, we will return the OTP, and that will generate with the rand range function and pass the range. So this function will choose any number from this range and return to us. So we will ask this function to generate a 4-number OTP. Yeah. So we have made the function for the OTP, and now we will assign it to the variable we have declared above. So in this variable, we want that the OTP should be passed as a string, because body would take as number as a string only. So with that, we'll write the command str self.otp in the body. We'll get the variable, and only for that we'll write the command self.n. Now we will save it and run it. So there is an issue here, and it got successfully executed. So sometimes It takes time and to actually universe. Okay. And now we'll start with the GUI, and for that we'll create a function so that we can store all the widgets there, and we will name the function as labels. And first thing we will create would be the canvas widget. The canvas widget lets us display various graphics on the application. It can be used to draw simple shapes to complicated graphs. We can also display various kinds of custom widgets according to our needs. So first we will create a variable and name it as C, and inside we will make the canvas widget. And now we'll set its background color, and that I will use the hexacode only. You could just see that's the gray color. You could use the hexacode, or you can just write the name of the color, or if you want you can just search on the web. You would get the hexacodes and you would get the variations of all the colors in hexacode. And now we'll set the width for the canvas, and width would be equal to 400, as you can see that it is in the comments. We have to put the hexacode in the inverted commas. Yeah, so we've set the width, and now we will set the height. That is 280. And now we will place this canvas. For that we will use the place function, and that place function allows you explicitly set the position and size of a window, either in absolute terms or relative to another window. So for that we'll write the command self.c.place, and the x dimension would be equal to 290 and y dimension will be equal to 120. And now we'll just save this and run the file. So we have to call the labels function also. We'll save it and run it again. You could see that this is the canvas, the gray canvas. And moving on, now we will create a frame, and that would also be in the labels function. So frame is a rectangular region on the screen, and that can also be used as a foundation class to implement complex widgets. It is used to organize a group of widgets. So we will create an upper frame, and inside that we will place a small image for the OTP verification and the heading that would be to verify the OTP. So for that, first we will create a variable and we will name it as upper underscore frame, and inside we will create a frame and the F is capital for the frame widget, and inside we will pass self and set the background color equal to blue, and that would be the dark blue, and I will use the hexacode for that. Hexacode is 4682B4. That I know. Yeah, this is the color you can see here. And now we'll set its width, and before that we will get this into the inverted commas, and now we'll set the width. Width would be equal to 1500, and now we'll set its height. Height should be equal to 130, And now we will place it. So where should be in the tkinter window? For that, we'll use the place function. Write the command self dot per underscore frame dot place. Yeah. So we will place it at x equal to 0 and y equal to 0 only. So I will save the file and run it for you. So you can see the output side by side. Yeah, you can see that this is the frame and we have set the color as blue, and we have placed it at x equal to 0 and y equal to 0. We have created the canvas. So now moving on, we'll use the labels. And in the labels only, first we will place the image in the frame. For that, first I will choose the image. As I've already made the project, I have chose the images and I have pasted it in the folder. That is pics. And with these, I have pasted it in our project folder. So first I would be using the password1 image, and I will set it in the frame only. And in tkinter, like some widgets can display an image such as label and button, and we would be using label to display this image. And for buttons also, I have created the images as you have seen in the folder. So I will show you how to use these images and show them as a button. So these widgets take an image argument that allows them to display an image. So for that, we will create a variable and name it as picture, and the widget is photo image. And inside you have to pass the location of the file where the image is stored. So we have just placed it in the same folder. So we will just write the name of the image, and that was password1. There was no spaces, and that was the png file. Yeah. After creating a photo image object, you can use it with other widgets that accept an image argument. The image object is returned by the photo image function that we have used, and it's that easy to display a picture in Python. However, the photo image class only supports the GIF and PGM PPM formats, which is a concern. JPEG, JPG, and PNG are the formats that are most often used. So now we will place the image in the frame. For that, first create a label for that, and we will create a variable and name it as k, and create a label widget. And tkinter label is a widget that is used to implement display boxes where you can place text or images. So here we would be first placing the image and then the text. So inside the label widget, we pass the argument that was the variable for the upper frame, and then the image object that is equal to self dot picture, and set the background as the same as of the frame. For that, we will write bg equal to, and the hexa code that is same, that is 4682b4. and now we will place it. So write the command here only, that is dot place, and x would be equal to 200, not 200, that would be 220, and y equal to 35. And we will save this and run the file. You can see that the image has been placed here. So now we will write verify OTP, and we'll also create the label for that. First we'll close the deactivate window only. Now inside the label function only, we will create another label for the text, and first we'll create a variable and name it as j, and inside we will create a label widget, and inside the upper frame write a text that would be verify OTP. Set the font for it, that would be Times New Roman. You could also set the size as 38 and make them bold. And now we'll set the background color for that. That would be in the inverted commas, and that would be the blue only. For that we'll write the hexacode. That was 4682B4. And now we will set the foreground color, that would be the text color, as white. And here we will not use the hexacode. I would write the name of the color. For that we'll write the command foreground color, that is equal to white. And now we will place this label. The hex we will place it at 220, so we place it at around 270, and y would be same, and that would be 35 only. Now we'll save this and run the file. We have get the label verify OTP, but they both are coinciding, so we will just change the coordinates for this label, and we'll set as 320, 300. We'll save the file, close the previous decanter window, save the file and run it. I just got, so you can see that it has shown the verify OTP, but still it's not in the center. So we'll just again change the X coordinate for that, and that would be 400. We will save the file and run it. Could see that now it is in the center. Place it accordingly, like I would be creating the GUI, and if you want perfection you can do that by one. And now moving on, we will place a Simplilearn image just run the file and show you like where we will place the Simplilearn image. We'll place it just at the bottom right. So for that we will create the label again, and first we'll use the photo image to create the photo image object, and first we'll create the variable and name it as simply underscore logo, and inside we'll use the photo image and write the name of the file. Else you have to write the location of the file, as we have the files in the folder only, and we have the Simplilearn file with the name Simplilearn space logo. So we'll just use the file name. Just want to check that is the Simplilearn file or the file. Yeah, that's it. I'll write the name of the file. That is Simplilearn space logo, and the extension of the file is PNG. And now we'll create a label for the photo image object. For that, we'll create another variable and name it as D, and use the label widget. And we'll pass self and image equal to self dot Simplilearn space logo, and we'll set the foreground color equal to white, and for that we'll use the hexa code for white color. And now we will place this label at x equal to 870, that would be the bottom right, and y equal to 530. It's showing an error. Okay, we have used the image name here. We have to use the variable that is simply underscore logo. So now we will save this and close the previous taken to window and run the file. Okay, we got an error here, that is you click here. Written the wrong spelling for the image file. Now we'll run it. We didn't save it. Save it and then run it. Takes time to open up. You can see that the Simplilearn logo has been placed at the bottom right. Now moving on, okay, I will show you what we will execute next. So we will place an text widget here in which we can just enter the OTP, and after that we'll make the buttons verify OTP and the resend OTP. First we'll make the text in which we will write the OTP. So for that, we won't make it in the labels function. For that, we'll create another function and name it as entry. We will enter the OTP there, and we will make a variable that would be username, and use the text widget. So text widget is used where a user wants to insert multi-line text fields. This widget can be used for a variety of applications where the multi-line text is required, such as messaging, sending information, or displaying information, and many other tasks. We can insert media files such as images and links also in the text widget. And for that, to enter the OTP, we will create the text widget and we'll write text and inside pass self, and now we'll set the font size in which we would enter the OTP, and it would set it as Calibri, and the size for the font would be 20. And now we'll set the border width for the text, so it should have a border width so we could see on that canvas, and we'll use wrap. So if the word with the text it exceeds the width of the text widget, it would just wrap it and send it to the next line. And that will write word and set the width equal to 23 and height equal to 1. And now we will place it, and we'll place it in the canvas that was of the gray color. For that we'll write the command self dot the variable name user underscore name, and we'll place it make x equal to 330 and y equal to 200. Save the file and run it and see whether a text widget has been created successfully or not. And before that, we have to run this function. Entry. Save this and run the file. That taken to window. Oh, it's all window. It's new. Entry widget didn't appear here. Again. Okay, you got an error. Okay, and we will not the font. So font equal to Calibri. We'll save this and run again. Yeah, it has appeared. So this is the text widget in which we will write our OTP and verify it. Now we'll make the submit button and the resend OTP button and write the functionalities for it. So the button widget is used to add various types of buttons to the Python application. Python allows us to configure the look of the button according to our requirements. And for that, we'll create a function buttons, and we'll write all the buttons here. That would be 2 buttons only. That is submit and check. No, submit only will check the OTP. the second button would be resend OTP. And first we'll create a variable for the submit button image. We'll create the submit button first. We'll create a variable and name it as submit button. And first we will assign the image to that button. We already have the submit image in our folder. We will use this image, call the photo image. So we'll call the photo image, and inside we will pass the file address, and the file was submit.png. And now the photo image object has been created. So we'll create the submit button. We'll create a variable as the name of submit button only. And to make a button, we'll use the button widget, and inside we'll first pass self and then the image that should be appeared, and that would be equal to the variable name, that is submit button image. Okay, and now we'll set the command. So command is used to call the function. So what function does this button do? That would be stored in the command, and that would be equal to, we will name the function as check OTP, as submit button would check the OTP only. We will create this function after this button only. And now we will set the border, and we won't make the border, we will set it at 0. Now we will place the submit button. For that we will write the command self.submit button dot place, and x would be equal to 440 and y equal to 330. And now we will start with the resend button, resend OTP button, and after that we will create the check OTP function. So for the resend OTP button, first we will create the photo image object. That we will write a variable resend OTP, that be named as resend OTP image. And pass the file name, so it's resend OTP only, resend OTP.png. Now we'll create the button. For that we'll write the command self.resend OTP variable and use the button widget, and inside pass self and then the image that would be set as the button image, that would be equal to the variable name of the photo image object, that is resend OTP image. Okay. Oh yeah. So, it's showing an error. OTP image match. Okay. Just a comma. Yeah. Now we'll set the command, and that would be the function that will store the functionalities that this button will do. And we'll name the function as resend OTP only. And to call that, would also use self as pass the self there, and that would be applicable to check OTP also. And now let's set the border equal to 0 for the recent OTP image, and now we will place it, and we'll place it at 420, 430. So that would write the command self dot resend OTP dot place and set x equal to 420 and y equal to 430. So both the buttons have been made. We'll run it here into the buttons, save the file and run it. So it's saying that the check OTP, that's not the attribute here. So first we'll create those functions only, check OTP and the resend OTP. Yeah. So first we will create the resend OTP function. Self init, and inside we will paste the same as we just write the commands to get the OTP. These are the commands. Get it pasted. So this is the resend OTP function. Now we'll create the check OTP function. For that, we'll write function name, that is check OTP, and pass self to that. And inside we'll use try. So if any exception occurs, we would get it easily solved. And here we will create the variable with the name user input. And get it stored an integer value. So it will convert the text that was string, which I have passed as the body. So it will take the text and convert it into integer. And it would take that value from the user underscore name. We would be writing the OTP there only. Yeah. Now we will write some conditions to check if the OTP is correct. So we will get the message box popped out, and for that we'll write the command if self.user input is equal to integer value of self.n, then we will make the message box popped out, and we will import the message box class also, as we have already imported all the classes from the Tkinter, but again we will import it. And if this condition goes true, we want a message box to show info. And inside we have to pass the show info. And we will make it as verification successful. Or you could write anything like the OTP is verified. We'll write verification successful. And now if self dot n equal to done, so the OTP would be done there. Else we would also pop out the message box, and for that we'll write the command message box dot show info, and inside we will pass the variables show info, and we will get the indication as wrong OTP. Now we will make the exception here. As we have used the try block, we have to use the except block also, and here also we will use the message box only. Show info, inside we will pass show info, and it would tell us invalid OTP. And here we will import the message box class. For that we'll write the command from tkinter import message box. So as you can see that we have created both the functions, that is check OTP and resend OTP. Now we will save the file and run it. Stick out of time. Okay, now we'll save the file and run it. As you can see that the tkinter window has popped up and I have received the OTP on my mobile phone, that is 1856, and I will click on the submit button. So it's showing wrong OTP. Okay, we will resend it. And put the new OTP as 2851. Click on the submit button. It says that the verification is successful. So we have made the verification OTP GUI successfully, and you could add the timer also in it. For that, I will just copy paste the code for the timer. I will also provide the source file in the description. If you want, you can see there. Or if you want to know how the timer is made, you could just see another video in the description or on the I button. Just copy paste the code. So this is the runtimer function. So you can see that the timer has started and it's for the 10 minutes as Duelio. Default tokens are valid only for 10 minutes. And received another OTP. We will resend it again. And it's 7848. We'll click on the submit button. It says that the verification is successful. And if you want to make the first page, you can see the source code. I will make it available for you guys. I will make a file that would be program.py. Rename it as program1.py. And inside you can see that we have imported the tkinter class and imported the program2 module, and we have installed the module subprocesses and we are calling the import class. And here we have made the class generate OTP, and inside we have set the geometry and configured the color as white for the first window, and we have made it that the window could not be resizable. That's why we have passed the false and false arguments to the resizable function. And here we have created the labels as you would see in the first window, and the button generate OTP. So we will save the file and run it. First we'll close this. Now we'll save it and run the file. error for the Simplilearn logo. So the file name is Simplilearn logo. I will replace that. Save it and run it again. See the first window, that is OTP verification, and OTP is valid for 10 minutes, and click on the generate OTP button. Generate OTP. We'll click on generate OTP button and it would redirect to the second page, that is verify OTP. So we have done with the project.
Do you know, friends, that the average salary of Python developer in India is around 7,08,083 rupees, according to the Indeed.com. And in today's market scenario, there are 30 plus thousand jobs available right now as per to the job portals like Indeed, LinkedIn, and Monster.com. Choosing a career in Python can be a smart move for many reasons, because Python's high demand for data science, its versatility in software development, ease of learning, high salaries, and strong job growth has made it an attractive choice for switching career in this domain. With that keeping in mind, I have curated top 15 Python interview questions. So guys, let's get started. So here's our first interview question, that is, given two arrays, write a Python function to return the intersection of the two. For example, if we have x equals to 1590 and y equals to 3029, then it should return 9 and 0. So how you will approach this problem by coding in Python? You can take your time and then you can come to the solution. So guys, in order to solve this question, we will have to create a Python function that will find the intersection of two arrays. And this function is going to use the set data structure to efficiently determine the common elements between the two lists. So guys, first what we are going to do, let us create a function first. So we are going to say the name def intersect, and you can just call it as arrays. Okay, and then let us give the two argument AR1 and ARR2. Pretty fine till here. Now after that, convert both of the list and sets to remove the duplicates and allow for intersection. So what we are going to do, we are going to create set1, okay, and this is going to be set of array1, okay. Then next what we are going to do, we are going to create a set of 2, okay, and this is going to be assigned to set of array2. Pretty fine. Now what we have to do, guys, we have to find the intersection of both of the sets. So guys, we can give a variable name sets intersection. So sets, okay, and this is going to equal to set1, okay, dot intersection of set2. Very easy, guys. And then we have to convert the intersection set back to a list before returning this list. So what we can do, finally, we can just return. So return list, and here we can give the intersection of the same. So now we have done that. Let us take an example of the same. So for example, we can take, say, x equals to 1509 and y equals to, say, 3029. And finally, we are going to call this as result. So rest equals to, and finally, we can just call our function. So our function was intersect arrays. So we can just copy this and we can give the array's name, that it will be x, comma, y. Fine. And then we can finally ask to print the result. So in this way, we are going to find the intersection. Let us run our notebook. So we can see there are some errors coming up. So, okay. So we can see that the answer is coming 0 and 9. Pretty fine right now. So we have completed our first question. Now let us move to the next question. So guys, our next question is, given an array, find all the duplicates in this array. For example, we have 1, 2, 3, 1, 3, 6, 5, and we should return only 1 and 3. So we can see 1 and 3 are the only one which has been duplicated. So how you are going to approach this problem? You can pause this video for a while and then you can come to this video and then you can watch the solution. So guys, to find all the duplicates in an array in Python, you can use a dictionary or the collections.counter to count the occurrences of each element and then gather those with the counts greater than 1. So for example, I'm going to show you a dictionary. So what you can do, we can define a function first. Say, let's find a duplicate. So def find, say, duplicate. And in this, we are going to take an argument array. Define. Now, after that, let us declare a dictionary with name as counts. Okay. And let us create a list of duplicates. After that, what we are going to do, we are going to count each element in the array. So let us go to the for loop. So for num in array. Okay. Then if num in counts, okay, then what I'm going to do, I'm going to put this, that count num, or else what we can do, we can count on that num equals to 1. So finally what we are going to do in this code, that we are counting the occurrences of each element. So we are using the for loop and we are maintaining it with the count. Okay. Now, as you would have got the idea regarding this, so let me write this variable. Now I hope so till here you are clear with it. In the next, we are going to collect elements that appear more than once. So guys, for key and value in counts.item, if the value is greater than 1, what we can do, we can append that key. Okay, I'll show you right here what I mean. So here we can apply the for loop. So for key, comma value in counts, in okay, so for key value in counts.items, so if the value is greater than 1, okay, what we are going to do, we are going to append this list. So duplicates dot append with the required key. Okay, now what we are going to do finally, and finally we are going to return our duplicates. So finally this function is going to return duplicates. Now let us have the example usage. For example, we have this input array, say 1, 2, 3, 1, 3, 6, 5, and the result is equals to find slash duplicates, and we are going to put the input array. So now let us cross check the functions we have. So it is find duplicate. This is, we're going to exclude this. Now let us run this code. So it says there is an error. Okay. Now let us see what's the error in this. So it says for key and value in counts.item. Okay, so it says unindent does not match the outer end. So there is an indentation problem. Okay. So guys, as you can see all over here, we have given our duplicates 1, 2, 3, 1, 3, 6, 5, and we are finding the duplicates in this input array. And our result is 1 and 3. Very easy. So go through this question. This question has a high probability of being asked in the interview question, so don't miss it out. Now let us move to our third question. So guys, our next question is that you have to rotate a list to the right by k places where k is a non-negative number. For example, we have an input of 1, 2, 3, 4, 5 and k equals to 2. So your rotated array is going to look like something 4, 5, 1, 2, 3. Okay. So basically when k equals to 2, so 0, 1 and 2. So after this, all the numbers are going to come first, and then in the same process like 1, 2 and 3 are going to go back. So it's a rotation problem, and let us see how we can approach this problem. So guys, in order to solve this problem of rotating a list right by k places where k is a non-negative, you can use a straightforward approach. Then this involves slicing the list and rearranging the parts. But here's the another way you can try it, that is by normalizing. So guys, since the rotating the list by its length, suppose it has a length of n, it results the same list. So you can normalize by k by taking k mod n or k percentage n, where n is the length of the entire list. So what is going to do, this is going to handle the cases where k is greater than n. Okay, so let us try to see the problem. So we have created a function called defRotateList, and I have taken two parameters, nums and k. Now here I am defining n as the length of the given list. So if n is equals to 0, I want it to return the nums, okay, the given parameter which we have given, okay, the length of the given list. So now after this we have to normalize. So in order to avoid like where where k becomes greater than n. So k equals to k modulo n. So this is our normalization. And after this we are performing the rotation. So by rotation, by slicing, so rotated list equals to nums of minus k dot plus nums of k. So this means that till k you have to partition it, okay, and after post of k you have to do the partition. And after that we are returning the rotated list. So you can see in the input list we have 1, 2, 3, 4, 5 and here k equals to 2. So what it's going to return? So the given list, okay, so k dot means since 2 and post 2 and pre 2. So you have to take that into consideration. So guys, after post we are adding the pre. So for example k equals to 2, so 0, 1 and 2. So these comes, so 4 and 5 is going to be put all over here. Then after that pre of 2 are going to be placed. And finally we are concatenating it. So 4, 5, 1, 2, 3 is going to be our output. So let us run this program and we can see we are getting the output 4, 5, 1, 2 and 3. Very easy problem. Okay. Now let us move on to the next problem. So guys, the next question is, given an integer array, find the sum of largest contiguous subarray within the array. For example, given the array A equals to 0, minus 1, minus 5, minus 2, 3 and 14. So it should return 17 because of 3 and 14. So there is a note also that if all the elements are negative, then it should return a 0. So it has given the case study. For example, you have to consider an integer array and you have to find the sum of largest contiguous subarray. So this is a subarray problem. Let us try to approach this. So for example, we have the input list 0, minus 1, minus 5, minus 2, 3 and 14. So we have to take a case on this and it should return 17. So guys, to solve this problem, you can use the Cadence algorithm, which efficiently finds the maximum subarray within the time complexity of O of n. And this algorithm maintains the running sum of maximum subarray found so far and updates it as it traverses the array. Additionally, to handle the case where all the elements are negative, so such that you want to return 0 in such a case, you can initialize the maximum sum as 0. So here's the Python implementation of the same. So guys, here's the solution to this problem. Let us define the function def max subarray, and which is going to take nums as the parameter. Now we are going to initialize variables to track the current sum and the best sum found. So current sum equals to 0 and maximum sum is also equals to 0. Then we have to traverse through the array and update the current sum and max sum accordingly. So for example, for num in nums, okay, Then we have to update the current sum and reset it to 0 if it becomes negative. So if current sum is less than 0, then you have to put the current sum equals to 0. And then update it with maximum sum equals to max of, you can take a max function, then take max sum and the current sum. And finally we are returning the max sum. So this is very easy. So basically what we are doing, so we are taking two variables, current sum and max sum. And we are traversing through this nums array, and we are finding that if our current sum is equals to 0, okay, then we are updating our current sum such that current sum equals plus now. Okay, so we are adding the current sum with the given number, like the iterative number basically we are using. For example, if it is 1, so current sum will be equals to 0, so 0 plus 1 will be there. And then if it goes negative, so if current sum is less than 0, then we are putting it to 0. Very easy. Suppose if you have negative numbers in your array. So that covers this situation. Now I hope so you have got the idea regarding the same. And finally, we are taking the maximum of max sum and the current sum. Okay. So in this way, we are going to print the maximum part of it, which is 17. Now let us take this and let us try to run our application. So you can see we have printed 17. So this clearly covers the idea regarding this question. Now let us move to our next question. So guys, our next question is define tuples and list in Python and what are the major differences between them. So guys, this is one of the very basic question. So in Python, list and tuples both are sequence data types that can store collection of items. They are used to store multiple items in a single variable and have several similarities. But there are significant differences that affect how and when you should use each. For example, if you take a list. So a list in Python is a mutable or changeable ordered sequence of elements. Each element inside a list can be accessed, added, edited, or removed. And lists are defined by having values between a square bracket. For example, if we define a list, say list L, so which is equals to say 1, 2, 3, and also we can put hello. Pretty fine. And also we can add a boolean value, so let's add true. Now let us talk about the tuples. So a tuple in Python is an immutable or unchangeable ordered sequence of elements. This is very important, and once a tuple is created, you cannot change, add, or remove its elements. Tuples are defined by having values between parentheses, and this way we cover the definition of tuples. So for example, if we define a tuple, so it is going to look something like this. So t equals to, say, we take the parentheses and suppose we add 1, 2, and 3. So this forms our tuple. Now, if we talk about the major differences, we know that in lists are mutable, okay, and tuples are immutable. So that's a basic difference. Next, you can talk about their syntax. So like, if we talk about list, they use square brackets, whereas tuples uses parentheses. If we talk about performance, guys, then tuples are faster than list because of their immutable nature of tuples. Now, list being mutable, they are slightly slower as compared to tuple. Okay, and they also require additional operations for memory. So in this way, you can differentiate between tuples and list. Now let us move on to our next question. So guys, our next problem is on anagram. So it says, given an array of strings, group anagrams together. Okay, suppose we have strings like eat, tea, tan, ate, nat, bat. So our output should look like something like this. It should be ate, eat, tea, nat, tan, and bat. Okay. Now, to solve the problem of grouping anagrams together, forming a given array of strings, you can utilize a dictionary to help organize words by their signature. So guys, what's a signature? A signature can be formed by sorting the characters in each string, which ensures that all anagrams will have the same signatures. So for example, what we are going to do, we are going to create a dictionary. So you can use a dictionary to map each sorted version of a string such that the strings to a list of strings can be added, and when it is sorted, you can match that signature. Then you can use the sort each string. For each string in the list, you can sort the strings to generate its signature and add the original string to the corresponding list. And then finally you can collect the results. So basically here's a Python implementation of the same. So guys, as you can see all over here, we have defined the function named group anagrams and we have taken arguments words. So here's our dictionary, anagram dict. Then we are taking the for loop and finally we are sorting it, okay, with the empty string using the join function, okay, and we are using the sorted function. Then if sorted word not in anagram dictionary, then what we are doing basically, we are putting it into this anagram dictionary with the category of the sorted word which we have created. So this is the required variable, okay. Now this will be equals to and word dictionary. Now finally, if this does not happen, then else you can put anagram dictionary in the sorted words and you can append that it in the word. So these are the certain things where word is our iterator, okay. So this is equals to a number which we are basically storing. So now finally we are extracting the list. So we are presenting these groups into a list, okay. So finally the dictionary is converted into the list. So list anagram dict values and finally we are returning our result. So here is our input words and finally we are calling our function with this word as the parameter. So let us run this and let us see whether our output is coming or not. And we can see we are getting the output of the anagram words. So eat, tea, ate, tan, nat and bat. So we had this as the anagrams are certain things like suppose eat is there. So T is ending with T. So it is next word is starting with T. You can see the next word is ending with A and here the next word is starting. So similarly tan and nat are grouped and bat are grouped. So what we have to do all over here, the entire logic remains the same and it is here. So you have to create a variable all over here, sorted word, and let's say be empty, and you have to join it with the word. Word means in the given dictionary, whatever the word like suppose eat, tea, tan. So initially we are putting it in empty words. Now if this word, okay, if this sorted word is not in anagram dictionary, means it is not present in our dictionary. So we can just do what? We can put this in our dictionary. So we can take this parameter as sorted word, okay, and put that word in this. So similarly, like we are grouping in this case like eat and tea, okay. Now else if it is not present in our dictionary, so anagram sorted dictionary is appending that word, okay. So here the assignment is happening and here we are appending it. So finally what results are eat, tea, ate, tan, nate and bat. Very tricky question, has a higher probability to be asked in the exam. Now let us move on to our next question. So guys, our next question is, given an integer n and integer k, output a list of all combinations of k numbers chosen from 1 to n. For example, if n equals to 3 and k equals to 2, you have to return 1, 2, 1, 3 and 2, 3. So how is this going to happen? So guys, this is going to happen by generating all the possible combinations of k numbers from set of numbers ranging from 1 to n. You can use this. So there is a Python's itertools.combination function, and this function is designed to generate the combination without repetition based on the specified length. So how you can do this? So for example, you can import itertool, okay, from combinations, and then you can generate the given combinations. So let me show you. So guys, as you can see all over here, I am importing itertools from combinations. Then I am creating a function dev generate combinations, nk is a given parameter, okay, where I'm creating a range from 1 to n. So range function I'm using, and I'm putting this from 1 to n plus 1. And I'm storing this into the variable or assigning it into a variable called numbers. Then I'm using itertools.combinations to generate all the combination of the length k. And finally, we are converting it into a list and storing it in the result. So in this function, basically what we are doing, so we can see there is a range 1 plus n plus 1. So this is basically generating the numbers from 1 up to n. and the combinations of number comma k you can see. So in this line, so what this is basically doing, this is producing the combination of numbers in numbers, okay, taken k at a time. So each combination is returned as a tuple and all the combinations are stored in a list. So this output of tuples in the list represents the combination of numbers chosen. So if you need them in specific format like list of list instead of list of tuples, you can convert them accordingly. Now let us run our code and we can see we are getting it in the format as 1, 2, 1, 3 and 2, 3. So this is generating the same, and so we are getting an output of list of all the combination of k numbers chosen from 1 to n. So in this scenario, I have put n equals to 3 and k equals to 2. Very amazing question, has a higher probability to be asked in the exam. Now let us discuss the next question. So guys, our next question is pretty interesting, and it says write a function to generate n samples from a normal distribution and plot them on the histogram. So guys, in order to solve this question, you need to know about normal distribution. So to generate the samples from a normal distribution, you can plot them on the histogram. So you can use Python's library called as Numpy for the generation of samples and matplotlib for plotting the histogram. So here's the implementation. So guys, as you can see all over here, we are importing NumPy as NP and we are importing the matplotlib. Okay. Then finally we are defining a function plot normal distribution samples, and here we have to take the 3 parameters. The first one is n, second one is mean, and the third one is standard deviation. We have initialized mean equals to 0 and standard deviation equals to 1. Then we are generating n samples from a normal distribution with specified mean, standard deviation, and with that we are going to plot the histogram. So it's more of a mathematical problem, but if you have a little bit idea regarding normal distribution, you can achieve this. So we can see there is a parameter n where the n denotes the number of samples, okay, and mean is there for the normal distribution, and similarly we have included standard deviation for the normal distribution. Finally, here we are generating the samples. So samples equals to, we are using the NumPy library, so np.random.normal, okay, and I have given LOC location equals to mean, scale is standard deviation, and of the size n. So it is very standard, and after that we are plotting the histogram with plt.hist. So I have taken samples, then bins equals to 30, edge color we have given black, and alpha equals to 0.7. And finally we are putting the title as histogram distribution sample. On the x level there is a value and y is frequency, and we have put the grid as true, and finally we are asking it to show it. Now let us run this. So we can see it has generated the histogram of normal distribution samples. Very interesting question. I hope so you are clear with it. Now let us move on to the next question. Now guys, let us take a question from Pandas, a very popular library. So the question says that what is the difference between apply and apply map functions in Pandas? So guys, in Pandas, the functions apply and apply map serve different purposes. Although they both apply a function along the x-axis of the data frame or in Pandas series, but here you can use them. So for example, in apply is used to apply a function along the axis of the data frame. So it can be either a row or a column. It can be used to operate on the entire row or a column at once, and this function is extremely flexible and can return a single value or a series or even a data frame. Then if we talk about flexibility guys, it works on a complete row or column and can be used to implement aggregation, transformation and other operations that consider multiple elements at once. So for example, let me show you. So say we have this, import pandas as pd, okay, then we can define our data frame. So df equals to pd dot data frame, and finally here we can give as a all over here, and we can give the value as list as 1, 2 and 3. Similarly, we can change the given thing as b, and we can change this value as 4, 5 and 6. And finally, we have closing this. So by applying a function to each column, say default axis equals to 0, so we can store the result something like this. So let us create the variable called result, and this is equals to say df dot apply. Okay, and we can use our lambda expression. So lambda x, and here we can take x dot max, okay, minus x dot min. Pretty fine. So we are applying a function to each column all over here. And if we talk about like apply map, so apply map is used to apply a function to each elements of the data frame. So this method is available only for data frames, not for series object. That is the most important thing. And if we talk about element-wise operation, so apply map operates element-wise, and it is very suitable for operations that depend on the value of the single cell, and they do not need to consider other elements in the row or column. So guys, that was a basic difference between apply and apply map functions. Now let us move on to the next question. So guys, our next question is on strings, and it says, given a string, return the first occurrence character in it. So on none if there is no recurring character. For example, if the input is Python interview questions and the output is n. So as you can see, n is a recurring alphabet. So we have to find the recurring character in this given string. So guys, to find the first recurring character in a string, you can use a Python function that tracks the character you have seen as you iterate through the string. You can utilize a set to efficiently check if a character has appeared before. So for that, here's a simple implementation. So guys, as you can see all over here, we have defined the function first recurring character, and we are taking input string as a given argument. Now, here is the variable called scene, and it is stored as a set. Now let us iterate through each character in the string. So for char in input string, if char is present in this set, so what I want to do, I want to return the first recurring character. Then finally we are adding this character into the set if it is not already seen. And if it is not present, we are returning the none. Very basic for loop and conditionals we have applied. Okay. Now in this we are presenting the input string. Okay. And let us see what our output would be when we are calling the given function. So you can see we are getting output of n. So this is very basic guys, and I hope so you have got a brief idea regarding this. Now let us move on to our next question. So guys, as you can see, our next question is, given a positive integer x, return an integer that is a factorial of x. If a negative integer is provided, it should return -1 and implement the solution using recursive function. So guys, we have got a problem on recursion, and it is mostly asked in TCS or Accenture's interview question. So whenever you are having a technical round, so you are going to have a higher probability to be asked. Now let us see the solution of this question. So guys, to calculate the factorial of a given positive integer x using recursion and to return -1 for negative integers, you can implement a simple recursive function. So here's how you can do it. So you can see all over here, we have defined a function def factorial x. Okay. So if we are hitting our base case, means x equals to 0, what we are returning it as 1. And if the input is negative, we are returning -1 as indicated. And finally, we can see a recursive case. So if it is not hitting both of the cases, then we are basically returning x into x factorial x -1. So basically what it is doing, guys, so say if we put x equals to 0, so we know that we are getting its factorial as 1. Now we are getting factorial of 1. Now if x is greater than 0, say suppose we are taking 1, so 1 into factorial of 0. So factorial of 0 is 1, so 1 into 0 will be 1. Similarly, next if x equals to 2, so 2 into factorial of 1, so it becomes 2. So you can see we are going to get a series of multiplication. So in that way we can find this solution using recursion. So let us try to print the output. So we can see we are getting output as 120, -1 and 1. So we have finally completed this problem using recursion. Definitely try this problem, guys. One of the most frequent asked questions in the interview. Now let us move on to our next question. So guys, our next question is, given an m by n matrix with positive integers, determine the length of longest path of increasing within the matrix. For example, let us see. So guys, in order to find the longest increasing path in an m times n matrix of positive integers, you can use a technique called depth first search approach and combined with memoization. This problem is going to involve exploring all the possible paths from each cell and caching the result to avoid redundant computation. Now, so in this approach, we are using DFS with memoization. For each cell in the matrix, use DFS to explore possible increasing path starting from the cell. Then cache the length of the longest path starting from the each cell to avoid the recomputation. Then also go on the edge conditions, like you will only move to the adjacent cells that contain a higher value to ensure that the path is increasing. Finally, you have to implement these steps so you can create a DFS function that explores all the 4 possible directions like up, down, left and right. And it is returning the length of the longest path. And finally, use memoization table, a 2D list basically, to store the length of the longest path starting from each cell. Iterate over each cell in the matrix and you can initiate a DFS if the cell hasn't been explored. So here is the implementation of the same. So guys, as you can see all over here, we have created a function called def longest increasing path and we have taken an argument called matrix. So if not matrix or matrix is present, okay, then we are returning it 0. And finally, we are defining our DFS function with I and j as the 2 given variable. So if it is already computed, then return the cached value. So if memo of I and j is not equal to 0, we are returning the given memo. Then we are exploring all the possible 4 directions like 0, 1, 1, 0, 0 minus and minus 1, 0. So it is denoting the up, left, right and bottom. And say we have initialized our maximum length as 1, okay. So in order to find the di and dj, means the distance, what we are taking the 2 variables as ni and nj, okay, and we are incrementing it with I and j. And then finally, we are using if ni is greater than 0, it is less than m, and nj is greater than or equal to 0 and less than n. So finally, at the matrix is also we are seeing, in this matrix, we are seeing that ni and nj should be greater than the matrix of I and j. Then finally, we are printing the maximum length. So using the max function, we are finding the maximum length and we are returning this DFS. And finally, we are storing the memo of I and j equals to maximum length. So which is basically our cached length. And finally, we are returning the maximum length. So you can see later on what we are doing, we have taken m and n and we are multiplying the length of the matrix into length of the matrix 0. So later on, we have created the variable called memo all over here. And in this, we are multiplying it with n, okay, for element at 0th index and in the range of m. And we have initialized our result equals to 0. Then we can start DFS from each cell for I in range of m, for j in the range of n. We can result equals to maximum result of DFS I and j. So here you can see the matrix of 9, 9, 4, 6, 6, 8, 2, 1, 1. So let us see what is our longest increasing path. So this was the basic idea regarding the code. The code can seem a little bit more exhaustive, but if you try to do it with the concept, it will be solvable. Now we can see the longest path it's showing is 4. So this is the output of our given problem. So let us go again with this problem. So here basically in this, what we are doing is we are traveling from 1 to 2, 2 to 6 and 9. So that has become the 4. Okay. So this is our longest increasing path. So 1 to 2, okay, then 2 to 6, then 6 to 9. So this is our maximum path we can follow. So 4 is the given output. Now let me go through this problem once again. For example, here we have taken a DFS function. Okay, so this DFS function is called recursively to explore each direction. It checks whether a move is valid, stays within the bound, or moves a higher value. Then you can see we have taken the use of memoization. So memo of I and j stores the length of the longest increasing path from cell I and j. So guys, this reduces the time complexity by avoiding the recalculating paths of the same cell. Then we are doing the result calculation. So we are iterating through each cell starting a DFS if the longest path from that cell has not been computed. Then we are printing the maximum value obtained from all the DFL calls, and that is our result. So this approach is basically efficient for matrices where many values are not recomputed due to caching, thus making it a feasible for larger matrices. So that's the solution of this problem. Now let us move to our next problem. So guys, our next question is explain Flask, what Flask is and its benefits. So guys, as we all know that Flask is a popular micro-web framework written in Python. It is called micro framework because it does not require particular tools or libraries. It has no database abstraction layer, form validation on any other components where pre-existing third libraries provide common function. However, Flask supports extensions that can add application features. Like here we can say, suppose if you want to add simplicity, flexibility, okay, lightweight features, then you can use it. Flask is also extensible, that it can be extended with extensions available to additional functionality like object relational mappers, form validation, upload handling, and various open authentication technologies and several common frameworks related to it. Then you can also say it has a built-in developer server and debugger. So Flask also includes a built-in server and debugger, which makes it easy to develop and test your applications locally. So this is Flask and these are some of its benefits. Now let us move on to the next question. So guys, our next question is, what is the difference between list, arrays and sets in Python? And when you should use each of them? Very basic question, guys. So guys, in Python, list, arrays and sets are all container data types that store collection of items. Each type serves a different purposes and used in specific scenarios depending on the needs of the program. So for example, lists are one of the most versatile data structures in Python. They are ordered, mutable, and can hold a heterogeneous assortment of objects. Then if I talk about characteristics, lists are ordered, meaning that the items have been defined in order and that order will not change until and unless you change it. So guys, as you can see all over here, that lists are mutable, meaning you can change their content without changing their identity. You can also have a duplicate element in a list. So it is always advisable to use list when you need an ordered collections that can change and might include the duplicate entries. Suitable for the cases where you need to perform frequent read and write operations. Now if I talk about arrays, arrays in context of Python arrays module or the Numpy arrays are specifically optimized for numerical data and offer more storage efficiency and operations which are tailored to numerical processing. Like you can use Numpy's arrays in a situation when an extensive set of operations are for mathematical and logical based. Arrays are also mutable and ordered. So you can use arrays when you need to store large amount of numerical data for scientific computing or other operations that require efficient and compact storage with vectorized operations, like for data analysis, machine learning, or any task that requires efficient array computation. The next one is sets. So guys, sets are unordered collection of unique elements. They are like mutable and provide operations to perform common sets of operations like unions, intersections, differences, and symmetric differences. Sets are like unordered, so they do not record element in position or order of insertion. You can use sets whenever you need to ensure that an element appears only once in a collection. So ideal for membership testing, removing duplicates from sequence, performing mathematical set operations like union, intersection, symmetric, etc. So this was all about this question. Now let us move on to our next question. So guys, let us move to our final question. That is, what are some of the common ways to handle missing data in Python and which method do you prefer and why? So guys, as we all know that handling missing data is a crucial aspect of data preprocessing, especially in real-world scenarios where data incompleteness can skew or invalidate analysis. Python, particularly with libraries like Pandas and Numpy, provides robust methods for dealing with missing data. So here are some of the common strategies. The first one that is removing data. Okay. So like dropping rows or columns with missing values using dropNA function. Okay. So you can use when this data set is too large or when the missing data is not significant and it is not likely to introduce bias. So in that scenarios, you can use it. There are certain drawbacks to it, like you can use valuable data also that could be critical for analysis. The second technique that comes up to my mind is imputation. So guys, when you're filling missing values with either a test statistic like mean, median, mode, okay, for numerical data, or a frequent category for categorical data. This can be done using fillNA or a simple imputer from sklearn.impute. So you can use it when the integrity is crucial and you cannot afford to lose data points. A drawback of this is that potentially it is introducing bias or affecting the distribution of the data. So using algorithms is the third part. Repeat. So the third one is predicting the missing values. Using algorithms to predict missing values based on other data in a data sets. Techniques can range from simple linear regression to more complex approaches like k-nearest neighbors or random forest. So when the missing values are substantial and there is a reasonable hypothesis that other variables can predict the missing values, so you can use this. So it is computationally intensive and can overfit if not properly tuned. Next one is using a constant to fill the missing data. So guys, filling missing data with a constant is not present in the data, like -999 for instance, like to differentiate the real data from the filled ones. So often used in modeling competitions or specific algorithms that can handle peculiar values and interpret them appropriately. The drawback of this is that it can skew the analysis if not handled correctly. So guys, these were some of the common ways to handle the missing data in the Python. Now, for me, I would like to prefer the imputation because imputation combined with indicator variables, especially for data sets where missing values are informative.
And with that, we have reached the end of this session on Python full course. If you need any assistance or any other resources used in these sessions like PPTs, data sets, Git links, Jupyter notebooks and others, then please let us know in the comment section below and our team of experts will be happy to help you. Until next time, thank you and keep learning with Simplilearn.